Hey everybody, welcome. My name is Caleb, and this course will be about Oracle Database. So, if you don't know anything about Oracle Database, that's perfectly cool because we're going to explain it. This is a beginner style course. We're going to take it kind of slow, but we're also going to go in a lot of depth. If any of you have ever seen any of my other videos, you kind of know my style of teaching, so I'm going to keep it the same. Now, just to kind of start off, let me kind of explain. Oracle Database is a database, right? There's all kinds of different databases. You might have heard of MySQL, SQL Server, MongoDB. There's all kinds of different databases. The one we are going to be using, Oracle Database. Now, Oracle Database is known as an enterprise database, whereas MySQL is something, that's another database, that's open source. It's not an enterprise. They might have enterprise versions or something. But anyways, there are free versions, so that's probably what I'm going to be using. So feel free to join right in with that, because I know a lot of you don't want to pay for the software when you're just learning it or something like that. Yeah, so let's get started. If I already lost you on what I was talking about with databases, don't worry. Here's where it starts fresh, okay? So, what is a database? A database is designed, it's basically a program that's designed to store a bunch of information or data. So a database stores data. So data goes inside of the database, if that makes any sense. Well, what's data? Well, think of data very broadly. It's nothing too specific. It can be anything that you need to store for later use. For example, usually databases are used for businesses, so a business will need to store data so they can analyze that data and make business decisions, right? So if they're like it's a restaurant, right, and they're making two kinds of hamburgers. We got hamburger with extra tomatoes and then a hamburger with no tomatoes. I don't know, stupid example. But basically, they want to know which one sells better so they can advertise it on television or whatever they're advertising on. Well, then they can analyze that data and make a decision based upon that data. It's kind of like analytics or statistics. If basically like 80% of the people that come into the store buy the tomato hamburger, why would they advertise the one without the tomatoes when it's only a small fraction of their sales and no one values them? So they would choose the hamburger with the tomatoes, right? So that's an example. We could store the data in that situation would be the sales. And we would store information about those sales, such as when the sales occurred, how many, who bought it, what the price was, and so forth. And then we can put all that data together and get a final summation of what the sales are like, and you can make business decisions off of that data. Now that's just one use for a database. There's others. A very common use is for websites. They store all of your information in a database. Any kind of program or website that you put information in and it saves it and then you X out of it and then open it up at a later date, that is stored in something. 90% of the time, it's a database. You can store information in other things, such as a spreadsheet. There's comma-separated values. Just notepads. You could use a notepad. I made an application once where I had to take a URL, and I didn't want to create a whole database for it. So all I did was just make a little URL.txt or whatever, and then I just copied the first line of that, which had the URL in there. So if I needed to change the URL, I could just open that text file and change it. So that's an example of how I use Notepad. Comma separated value, that's pretty self-explanatory by the name. And a spreadsheet, well, spreadsheets are kind of like a very simplified version of databases. And you'll see why pretty soon. But I'm sure a lot of you have worked with spreadsheets. Spreadsheets have, like a table-like look with columns and rows. These are columns and this is a row. Well, a database is visually represented the same way. In a database, this would be known as a table. We got the columns this way and the rows this way. That's going a little, I just want to give you a taste of like what we'll be working with. But we're going to try and think of it a little more conceptually first, just so you guys can get a better idea of how we store data, what kind of data we want to store. So that way you don't get confused on if we should store it this way or that way or what. So let's try to do that now. So if you guys are wondering why you would want to use a database when you can use something like a spreadsheet or just a notepad or a comma separated value or anything like that, why would you want to use a database? Well, there are some really good reasons, but I also want you guys to understand there's not always a reason to use a database. For example, what I talked about earlier, how I made an application and I needed to pull a URL, that's the only thing I needed. So I can just make a text file 50 times easier in my opinion. So there's not always a really good reason to use a database, but oftentimes there are. If you have to analyze data, store a lot of information, and so forth, you might want to look into a database. By now. Right, so I'm just going to go over a couple of examples how a database is better than, for example, a spreadsheet. It's worse though because it's more complex, it's harder to learn, and you can mess things up if you don't know what you're doing. Whereas a spreadsheet, it's kind of like, grandma can do it, maybe. I don't know. So, what are the benefits of a database? Well, if you think of a spreadsheet, you have all or nothing. So, we got a spreadsheet here, right? We got our columns and our rows, and we can put information in that. Right? Well, what if I want this row, this column right here, which has people's social security number, I want that to be completely private. I don't want no one to see it. And then I'm going to share it out to all my employees. Well, that's not really going to work out too well because the whole spreadsheet is a whole, right? Another issue, there's not good support for multiple people working on the spreadsheet at once. Now there are some solutions that help with that, such as Google Drive, where you can use spreadsheets with multiple people. But in general, databases can support multiple users with multiple different rules. So this person can do this with this information, but this person, he's not allowed to do that. That's off limits to him. So there's multiple different things you can do with the database, different rule sets, so you can set kind of like standards. Alright, so like basic user, administrator, super administrator, you know what I mean? Whereas a spreadsheet, you're a little bit less flexible with that. Another good thing is like if you think of spreadsheets, you usually store all the information in one spreadsheet. So let's say we got people's information about themselves. So you got their name, their address, and their phone. But what if you only want the phone number and their name so you can go through and call them? Well, in a database, that's really easy. You can just select certain pieces of information. Whereas on a spreadsheet, we might have name, address, and phone. And if we wanted to take this address and hide it, that's not super easy. But with a database, that's a piece of cake. With the database, there's higher security. The data is protected better than a spreadsheet, and it's less likely to be hacked into or destroyed maliciously. So there's higher security. Also, on top of that, there's usually better recovery options if something was to go wrong, such as the power went out or your computer exploded. That's all I'm going to explain for this video. Next video, we'll be discussing basic design methods for databases, and then a few videos down the road, we're going to be installing Oracle Database, and be showing you around a little bit on that. Then we'll teach up here, program on there. It's going to be sweet. So be sure to subscribe. Also support me on Patreon. A Patreon place where you can support me month to month. I just got a patron for $10 a month, which is awesome. So, Chad Leon, be sure to send me your shirt size, because you never did. So you want a shirt, but I have no idea what size you wear. But thank you. Alright, peace. Yeah,
Were you recording?
I
I'm
was.
so sorry. I gotta finish this. As soon as I turned it on, I thought, oh, crap. Give me a minute.
Hey, what's up guys? I've literally been making videos for like 10 minutes today, and I already started making one, and I forgot to press record. But luckily I got it this time, so. Hey. Okay, it's working. Sorry. So this video, we're gonna be talking about basic design methods, or starting information, whatever you wanna call it. We're gonna be talking about entities and attributes. These are very, very important in databases, and I highly recommend you really understand the fundamentals before you start diving into database programming. Now, database design is a huge concept. I actually have like 70 YouTube videos over the topic. A whole series over database design that's like 50 videos. So it can get very complex and in-depth, but you don't really need all of the information. You can start off with just a little bit of few things and start designing your own databases. And the best place to start ever is entities, attributes. Now if you think of an entity, you might think of some like mystical creature or something, I don't know. But just think of an entity as something. Let's use a blow-up mattress, for example. Alright, so I got a blow-up mattress. Alright, that's the blow-up mattress. Now this is an example of an entity. Let's just worry about entities. I'm going to get rid of attributes right now. There's two really classifications, right? We have generic and then specific. Generic and specific describe how specific we're being when we're talking about an air mattress, right? We could be talking about a very, very specific air mattress with a serial number of like 10125 or whatever. That is very specific because we're talking about a specific air mattress, right? We could also be very generic, and we could just be talking about air mattresses in general. So it doesn't really matter which air mattress. In fact, we could have multiple air mattresses. That one looks pretty hard. Got a saggy one, you know. There's all kinds of air mattresses. One for everybody's likings of air mattresses. This is very generic. This is generic because we're not being specific on this specific air mattress. We're not talking about one individual air mattress. So that's the difference between generic and specific. Generic is just a classification of something. Specific is a specific example of that something. Let's talk about puppies. Alright, so I got a puppy here. This puppy, his name is Swag Dog. Alright, answer the question. Is this specific or generic? 5, 4, 3, 2, 1. It is specific. That's because we're talking about a specific dog. Because his name is Swag Dog. Now what about this? Alright, here's another dog, which kind of looks like some weird puzzle piece with like a hand. I don't know. This is just dogs. We're using this picture to represent dogs in general. No specific kind, just dogs. Is that specific or generic? I hope you guys guessed that one. It's generic. So you got specific and generic. Let's move on to attributes, and then we'll discuss why all this is important. So let's move on to attributes. There's also generic and specific attributes. So what is an attribute? An attribute describes something. So a generic attribute describes a generic entity, such as dogs. A specific attribute describes a specific entity. Specific describes a specific entity. So generic, I got dogs. Specific, Swag Dog, which is a specific dog. Now, what do you mean by describe? I heard you say that. I heard you ask me that question earlier, so I'm going to answer that. What do you mean by describing a generic entity? Well, if you think of an attribute of somebody or something or a dog, it describes that thing. So I could be like, wow, this dog, swag dog. See how fast I can draw a dog? Boom, dog. This swag dog, let's describe him. Well, he's ugly. Sorry, buddy. And he's about 25 pounds. And he is lonely. Poor buddy. Alright. That is example of specific attributes. Now let's talk about generic attributes. We have a dog, alright? It doesn't really matter what kind of dog. Boom. This is just a classification of dogs in general. We're just using this picture to represent dogs. Let's describe the entities of dogs. They might have a name, their weight, maybe their height. Height? I don't know it's about height. And their color. So these are generic attributes. They are basically groups of possibilities. Name, it could be swag dog, it could be puppy, it could be bubbles, it could be other weird names humans give dogs. Height, it could be 5 foot, 6 foot, 80 foot. You know, big dogs. I like big dogs. Color, could be blue, green, rainbow, indigo, violet, charcoal, onyx, clear. Those are generic attribute groups. So let's kind of make a chart here. Just trying to make it clear in your mind. Gotta get my eraser. Let's give a generic, and then let's give a specific example matching that generic, which would be a specific. So don't get confused. Just follow me. Let's use humans, right? So we got person. Very generic. That's an entity. It's a type of entity. That's another way. Entity type. It's the person. Alright, the person has a name. You know, maybe a phone number if they're from the modern world. You know, they might have a height. Which I still not sure if I spelled that right, but height, they might have a height, they might have an age. No, even better. A birthday. And yeah, so forth. These are generic attribute, basically categories. Right now we have this person. Let's draw a picture just to represent him. He's flying through the sky with a cape. Alright. This guy's name is Superman. His phone number is 1-800 You wish. His height, probably like 7'11". Birthday, well, I don't know. So let's just go with like June 5th, 1938. This is generic. This is specific. That's important to know because when we design tables, which is what we store our information in, we want the titles of the columns and the table itself to be generic, but the values that we put into the table need to be specific. So if we have a table, we can make this, I don't know, customer, alright? I know, if you guys have ever seen my other videos, this is like the only example I ever use, but doesn't matter. Now we can also give these columns. So we could put, you know, Superman. So this is basically the same pattern we're going to do for every single table. Here we have the entity type. Here we have the specific entity. Here we have the attribute types. here we have specific attributes. Now if we wanted to add another person in here, we could. We could put Batman, blah, 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 blah. And then I can't think of anybody else. So yeah guys, hopefully that makes things clear. Entities, attributes, specific and generic. That's pretty important, so hopefully that was helpful, and hopefully it clears up how to make tables in the best possible way. Peace and subscribe! Welcome everybody. This video will be basically an introduction to Oracle database, how we can install it, and how we can connect to the database. So, if you've never done any database configuration or setting up, it can get pretty confusing at times, but I'm going to try to break it down so it's simple. So first, you'll need to get on a web browser, which is Google Chrome, and we're going to go to Oracle. And just go to oracle.com, and then what you can do at the top, you see Downloads, hover over that, and find, you see there's two options here, Oracle Database 11G Express Edition. So the way it works on here is they have a primary edition that they sell, that's 12C. And then they have an Express edition that's 11G. So it's one number back, which means it doesn't have all of the features as the 12, which would be the most recent one. But it's Express, which means it's a smaller file size. It's for smaller applications, smaller purposes, but best of all, it is free. So this is the one we're going to be using. Now when you get to this page, there's a few things you're going to have to do. You're going to have to click Accept License Agreement, and by that, I mean you have to read the entire thing. Oh, it's such a good read. I read it like every night. Alright, then what you're going to do is have to figure out which operating system you will be using this server on. Let's click this, and you'll have to probably sign in. As you can see, it's downloading for me, but that's because I'm already signed in. So you can see it's right here, Oracle XE. XE stands for Express Edition, which is the edition that we downloaded. So this is a zipped folder, as you can see in the little pop-up. Open it, and I'll just click extract all files, and my downloads are fine. That's a fine place to do it. So downloads, and this is going to create a new folder with that name. Alright, here we are. So we can click this, and then there's this setup.exe. Click that. If a pop-up pops up, click yes. Alright, boom, there we go. It is ready to install. So let's just get rid of some of this other junk so it's not so cluttered. I'll probably need that later. I'll leave that open. Then click next. Make sure you read all that. Next. Looks good. Next. And we're going to make a password. This is going to be kind of like the administrator password, so it's like the main account. That account name is actually known as system. See, as you can see here, system. Something simple. If you want to follow along, you can put that, or you can use whatever you like. Install. Alright, now it's, creating and starting service. Oh, wow, that was fast. Okay. Okay, it just finished, so you can click finish on that. Now, after this, you might be wondering, how do I run the thing? Well, let me show you. Click the start menu, and click all programs. You can look for something gold, or find Oracle Database 11G Express Edition. When you click that, it's going to open up a bunch of different options. Sorry, I'm eating an apple. The first thing you're going to want to click is Start Database. You're going to get this little command prompt thing. Okay, great. Then you can just lower that and go back to the same place. And you're going to click Run SQL command line. If you're a beginner, you might not know what SQL means. Let me explain. SQL stands for Structured Query Language. It's basically the standard language we use to communicate with databases. It's kind of like how we tell people to do something in English, while we tell the database to do something in SQL. So yeah, that's pretty simple. Now this is where we actually use the database, and I know it doesn't look real pretty, but I'll teach you a cool solution in just a minute to make it more friendly. Alright, one more thing. If you go to All Programs, click this again, you can click Get Started. That's going to bring up a web page, right? And you can see it says 127.0.0.1. That's a loopback address, which is basically on your home computer. Then it says 8080. That's the port. If you have something such as Skype running or XAMPP, that might cause issues, and this might not work out right. So if that's the case, you'll need to disable those. Now this is where you can do some extra configuring of your database, but we're not going to get into super much details with all this right now, so we'll worry about that later. Just wanted to show you that. Alright, then one other thing, if you go back, click this, you can click Get Help, and then you can click Read Documentation. This is where you get the official documentation for the database, and it'll talk about everything you really need to know. So there's all kinds of information here. You can search and so forth. So if you needed help installing, you could click right here, and that's basically it. Now we can sign in to our account we created by saying connect, and then it asks for your username, and it's going to be system. The password, whatever you put in, mine was pass, and it doesn't show up. And press enter, and it says connected. Now you can start doing commands that are part of the SQL language, but we'll get into that later because I just want to show you how to set everything up in this video. So let's move on to one other thing I wanted to show you guys. Go to oracle.com, or I think it's .com, yeah, and then go to downloads and SQL developer. And then if you don't have the JDK, which stands for Java Development Kit, you are going to want to download that with the JDK. So I'm on Windows 64-bit and I'll need the JDK, so I'm going to download that. And I already have it downloaded, so I'm going to actually cancel that. So you run it, and once again you have to extract it, that's fine. Alright, it just finished, so you want to open this, and they're going to find sqldeveloper.exe. And yes. Alright, so would you like to import preferences from a previous, no. That's if you have a previous edition of this and you want to import data from that one, well then go right ahead, but I don't know why you'd be watching this tutorial if you already know what you're doing, so. Okay. So this is the main page. No! Alright, this is the main page, right? Now, I suggest before you start anything, go to Tools, Preferences, and then Database, and then Worksheet. These are just a ton of settings. This is just one that I think is useful. Grid in checkerboard or zebra pattern. That makes every other line of code a little darker background, so it's really easy to follow lines across rather than just being white text, black text on a white background, I mean. Now we can put a default path for scripts if we want, so we can browse, and I'll just put mine in my documents, create a new folder, and just name it whatever you want. Press OK. Alright, so now we need to connect to a database. By the way, the thing we're running right now is to make the database a little more user-friendly than just this. So that's what the purpose of this is. So we need to connect to a database by pressing that little plus. Just click it, and this will come up. You can name it whatever you want. Username, that would be system, password, pass. Localhost 1521 XE, looks good, and then you can click connect. Alright, and there we have it. You can see it right there, and if you give it just a minute, it will open. So we officially we've completed our task of setting up the server and connecting it with Oracle SQL Developer, and that gives us the ability to start running queries on this database, which is basically running commands and doing more things. I wanted to teach this early on in the series, so those of you guys who like to tinker around with things, you could start getting used to the layouts and the buttons and typing things out on your own rather than just writing it out on paper if I teach, you know what I mean. And I'll be going back and forth from the chalkboard to this, and we'll be learning both concepts and practical code. So thank you guys, and be sure to subscribe. Be sure to subscribe and support me on Patreon. Thank you, and goodbye. Welcome everybody. How do I start this, Aaron?
Do.
I don't ever know.
An issue with it.
Hello everybody, welcome back to your 4th Oracle SQL tutorial, right? This video and the next videos I like to call the 5 video database design primer, right? So I'm going to take basically my 50-part database design series, get rid of all the useless junk in it, and then I'm going to condense it down into like a 5 video power database design series within this series. So this video and the next 4 videos are all going to be database design relating to Oracle database. So get your pull-ups because you guys are big kids now. We're going to get started right now. This video is going to be vocabulary, so we're going to start off with SQL, Structured Query Language. This is the language that we use to communicate with the Oracle database. Right, so to illustrate this, we have us, these stupid little people here, that don't know anything about how computers work. Well, at least I don't. And then we have the database over here, right? And we communicate with this database using SQL. That SQL is able to be understood by humans. It makes sense. And the computer or the database can take that SQL and then convert it into machine code. By machine code, it's just lower level code that actually tells the computer to do things like retrieve files. We don't have to do any of this because SQL is able to do that for us because the database understands SQL and we understand SQL. So we talk in SQL to talk to the database to talk machine code to do the complicated stuff. Another thing about SQL is it's actually a standard language. So if you go from Oracle database over to MySQL, you probably notice that this also has SQL. That's because SQL is used for every single kind of relational database management system. And you're probably wondering, what's a relational database management system? I'm going to tell you. So a relational database management system is basically a really fancy word to mean the database. We talk specifically using SQL to the relational database management system. So Oracle database is an example of a relational database management system. If you're thinking what I'm thinking, you're probably wondering what in the world relational means, right? And if you've ever done research on this, you'll get a lot of answers that say it's because relational database management systems have relationships. But I'm going to tell you that's a load of garbage. That's not why it's called relation. The real reason is because it has what's known as relations. Relations is this fancy mathematical term that they use to basically describe tables. Right? So tables, you know, we talked about tables. They have a table name, columns, and rows. All you gotta know is relations equals tables. Alright, now if you're anything like me, you're probably wondering what happens when you have a table and someone doesn't put information in it. I know that's what you're thinking. Well, if that's the case, you get something that's called a null or a null. I don't care how you pronounce it. A null is basically the absence of a value. So if you have a table and you have a column name, and this person goes in your database thing and tries to put information in, and they forget to put their name in and submit it, well, for that row, for that person, there's not going to be a value there. So to represent the lack of a value, the database uses the term null. That means it's missing a value. You'll often hear the term null value, but that really doesn't make sense because null, by definition, means the absence of a value. So to have a null value is contradictory. It's like an invisible seeing. Now you're probably wondering, how in the world can I prevent null values from entering my database? Well, there's tons of different ways. For one, they're not always a bad thing, but we'll talk about that later. But a really good way is through database design. Database design is a process we do before we create the database and also while we have the database to improve it if necessary. Its purpose is to protect the integrity of our database. And what exactly do I mean by that? Well, let me give you a really good example. If we have two tables here, let's say this is a user table, or users. Whether you use plural or singular, we'll talk about that later, but let's say we have a users table, and then we have over here, we have a orders table. If we have an order from users, there's some kind of connection here, because the user places an order, and the order is placed by a user. So there's what's known as a relationship. So this is a relationship. The integrity right here is having this connection. We need to protect that. If we get rid of this, for example, and we have this guy over here, and he buys a hammer. Okay, I don't know what that is. But if he buys a hammer, and then this user gets deleted, and then it says this hammer was bought by this user and he doesn't exist, that's a problem. That's a fault in the integrity of the database. So we got to prevent that. So we design our database in a way that protects the integrity. And we'll get more into that as we go on. So we already talked about relationship. This is a connection between two tables. Now, there's something else that is important to know about tables. You're probably wondering, well, how do you keep every single row in a table unique? Well, that's something known as a primary key. You think about it, we have a table, we have all kinds of different entities in here. Let's say they're trees. We're keeping a documentation of all the trees that grow in our national park or something stupid, I don't know. And we have just multiple trees. Well, how do we keep them unique? Because we could have an oak tree, we could have another oak tree, this one could be 6 foot, and this one could be 6 foot. So now it looks like we have a problem here. Is this tree 6 foot and this tree 6 foot? Or is this a mistake in our database and we actually have duplicate data? One tree in there twice. That's an error. That's not good. So we need something known as a primary key to protect us from that. And generally, it's just a random database generated number. So we'll have something such as a tree ID. And that's just going to be like 1, 2, 3, 7, 12, 48. And basically every tree is going to have their own ID. So that prevents duplicate data. Continuing on that example, we could have that tree, right? And let's say we're running a tree store and we're selling these trees, right? So we also have a table for sales. And we sell that tree to somebody. That means we have a customer. The customer initiates the sale to buy the tree. Well, these are all connected. And the way they're connected is by the primary key being referenced in the other table. So these are all going to be tables. This will be a tree table, a sales table, and a customer table. And they're all going to be connected with relationships. How though? Well, we're going to have a tree ID, we have a customer ID, and we have a sales ID. To issue the sale, we're basically going to say this sale with the sale ID also has a customer ID because the sale had to be ordered by somebody. Now, also the sale is going to have a tree ID because the sale has to sell a tree. So basically, this tree ID and this customer ID is going to be replicated in the sales table. And this is known as a foreign key. Just to kind of illustrate that a little more, we could give a specific example of a sale. We could say the sale ID is 7. The customer ID is 743. The tree ID is 12. Now, we can basically take this and we can build the entire sale from this information. We're saying that the customer that has the ID of 743, let's say it refers to this guy, is buying a tree with the ID of 12. So that refers to this specific willow tree or whatever with the ID of 12. So that connects to that. The sale is talking about the sale itself. So this whole thing is labeled sale ID number 7. So we're going to have 3 tables in this situation. We're going to have the trees. So we're going to have the trees, the customers, and the sales. This is going to have a primary key. This is going to have a primary key. And this is going to have a primary key. That's because they all have primary keys. Every single table needs a primary key. The sales is going to have 2 foreign keys. It's going to have a foreign key to the trees, referring to their primary key, and it's going to have a foreign key to the customer's primary key. So now we have foreign key on the list. Now if you've made it this far through all of this information, I congratulate you because it's a lot really quickly. So don't get overwhelmed if you are falling behind. I have a 50-part video series if you want to go check that out over all of this information, but much slower. But if you're anything like me, you're probably wondering, when you have these primary foreign key relationships, how do you protect them from being broken? Well, I'm going to teach you that. That's known as a constraint. So in the tree example, a constraint would be the sale can't have a tree that doesn't exist. Another really good example of a constraint would be preventing somebody from deleting a tree or a customer if it's being referenced by a sale. So you have a sale and it says, oh, this tree was bought by this customer. Well, if someone goes in and deletes that customer, well then we have an issue because it's saying that this tree was bought by a customer who doesn't exist in the database, right? That is an issue with database integrity, which is part of database design. So when we design a database, we get constraints to protect the primary and foreign key relationships. That's getting pretty intense. Now if you're wondering, how in the world does the database keep up with all of this information and process it so quickly when you get all these sales of trees and stuff? Well, I can answer that question. You're wondering about indexes. Indexes are basically when you take a certain column in a database. A column would be a single attribute of multiple entities. So, like the name, you can take everybody's name and you can make an index for it. What that index does is allows the database to find that information faster. And we can talk more specifics of indexes in the future, but for now, that's all you really need to know, except that primary keys are going to get an index automatically. So I'm just guessing that you're probably wondering, how in the world does a database keep all of the different types of data organized, such as, well, we have phone numbers over here, we have names over here. How does it know what type of data it is? Well, that, my friend, is known as a data type. A data type is basically the kind of data you are assigning for a column. If we have this table and we have a column named name, well, you should expect that every single value within this column for every single person is letters. So we can assign a data type to this name of string, for example. That's just a kind of data type. That covers all of the basic vocabulary that I covered over the course of like a billion videos in my other courses. So if you need a slower version, check those out. Otherwise, write all these down, get the definitions figured out, study them a little bit, and then move on to the next video. Thank you guys. Welcome back to the second video in this 5-video database design primer. Ready to have your brain exploded for the second time today? Let's get started. So I'm going to try and take it just a little slower than the last video, but this is going to be about database integrity. And I talked about this a little bit in the last video, and this camera just looks a little too close, so I'm just going to back it up a little bit. So in the last video we discussed database integrity just a little bit, but in this video I want to go in much more depth. So let's talk about integrity. Database integrity is a thing we try to have in our database. Basically, it protects our database from breaking, having incorrect data, and so forth. So to make the whole concept easier and easier to discuss, they break it up into 3 categories. So the first one is entity integrity. The second one is referential integrity. And the third one is domain integrity. Now before we discuss the 3 categories of integrity, I want to discuss one thing you should always try to do when you're building a database. Always try to make things built off of singularity rather than pluralarity. I don't know. Like, so let me just, that made no sense. So let me just kind of describe it. If you have a table, you have a table name. So let's say it's user or users. And you're probably wondering, whoa, that is not singular. That's plural. Yeah, it's right. It is plural. But the thing it's talking about is one individual thing. It's users. That is one thing. It's not users and customers. It's not users and professors or whatever. It's just users. So this talks about one thing. So the primary goal is to make everything atomic. So if you're wondering what atomic means, think of an atom a long time ago when we were not able to split an atom. Well, that basically described what we were trying to do with a database, where we have chunks of information that aren't meant to be split. So you can't break this table up into anything more. You can't break it up. If it was like users plus customers, well, you could split it, have users and a customers table, have 2 separate tables. That would not be atomic. But since we have just users, it does make sense. It's atomic. It's only one thing. It's basically just a general. It's basically just a general entity. And then within here, we're going to have specific users. So that's one thing you need to know when we're making databases. So when we have columns, we make the column's title be about one specific thing. So phone number, a first name, a last name. We generally want them to be things that are atomic. For example, an address, that's usually more not so atomic. Because if you think of address, you actually have a city, a state, a street address. You might have an apartment number. Those are multiple things within that one column, and we want to avoid that. So that's the very first thing. Now when we're discussing entity integrity, that means everything needs a primary key. The primary key is used to keep everything unique. So you have basically an ID, which is a type of primary key that's known as a surrogate key. We talked a little bit about that in the last video. Surrogate keys are just random numbers that are generated by the database that have no real-world value. If you do pick a natural key, you want your natural key to be something that doesn't change. So the primary key doesn't change, and then we have a couple other rules. Well, for one, it's not null. If you remember from the last video, null means the lack of a value. So there is no value there. So you can't have a primary key that doesn't have a value. If the email is the primary key, every single person or every single account is going to need an email. The third thing is that it should be unique. You shouldn't have 2 entities with the same primary key. If we have a guy here and a guy here, and this guy's ID is 106, and this guy's ID is 106, the database will assume that these are both the same people. And that's not the case because there's two of them. So these are known as constraints. It's basically setting rules for the database that's saying, don't be null, or everybody has to be unique. And that's just some examples. There's more constraints you could add. For example, there are referential constraints, which is what we'll be discussing now. Referential constraints connects tables. So when you have two tables,
Call from Josh Parsons.
when we have two tables and there's some kind of connection, we'll have a primary key in this table, a primary key in this table, and then one of the tables will reference the other table. So if this is users and comments, well, the comments is going to reference this table. So we'll have a foreign key that references that primary key to say that this comment was posted by this user. And that's all done using the primary key. That's the connection. Now, if we want referential integrity, we have to protect that using constraints. Constraints are basically rules that don't let you do certain things to destroy the database. So for example, if we did not have constraints and we had this foreign key connection, well then we can make it to where if we delete this person, he's off there, and this comment still exists. That doesn't make sense because a comment can't exist without somebody posting it. So then we're going to have all these comments like, wow, and it's going to be by null. We don't want to see these kinds of things on a website or application because that's not good at all because you don't know who said it. It's just bad. So that's referential integrity. The final one is domain integrity. Domain integrity is basically giving a list of possible options for columns in a table. So if you think of a table, we could have a table for the users, just like this table up here, but I'm just going to draw so we have more room. And I'm just going to list the columns this way. So don't think of these as rows, we're just listing what the columns will be. So the table is a users table, and we might have a USR underscore, then user underscore ID underscore PK. So basically that long nonsense is the prefix of user table, the user ID, and then it's the primary key. That's one column we might have. Then we might have the name, username, and if you wanted, you could break name up into first name, last name, so that way it'd be more atomic, if that's something you would like to do. User password. So these are just some examples of columns that you could have. And if you notice, I did this a little differently, because normally I'll draw a table out like this, and put the columns up here, and then rows across this way. Well, this design is actually pretty common. So basically we're just setting all the rules of what the rows are going to have, but we don't actually write them in. This is known as basically an entity relationship diagram. So that's ERD. Entity relationship diagram. And you'll see these connected to other tables. So you might see something like this. And you'll see big charts where it'll have the table and the columns for that table and different types of relationships between tables. That's an entity relationship diagram. But in this situation, we're going to implement domain integrity by preventing certain entries into these columns. For example, the username. We can make domain integrity by saying that everybody's name should be characters. It shouldn't be a data type that is not a character. So if we wanted to do that, we would give it the data type of string, for example. When we make it a string, it's not going to allow people to put the data type that's numbers, or the data type of dates, or the data type of true and false. It might be able to store those values if you don't put enough constraint. For example, it can be a string, but that string might say true. Whereas when it's in quotes, we're running out of space here. When it's in quotes, it's known as a string. And we'll get more into the specific types of data types really soon. But for now, just know string is with like the quotes. But this very well could also be true without the quotes. And if that's the case, then this is not referring to a string, but this is a Boolean, which is either true or false. So that's what I'm saying. You want to make sure it's the right type. You don't want to allow number data types or Boolean. You want it to be string. A couple other things you can do is you can say how many characters you want it to be and so forth. So for an email, you should be able to check like, well, is it at least 3 characters or whatever the shortest email length is. You can try to go in more depth and make regular expressions with software to check your email. You want to add domain constraints that prevent people from putting garbage in your database and making your database all messed up. You can also do conditional statements to test data. So you can say if the sex that the person enters is either M or F, then insert it. But if it's something else, like I like cats, well, you don't want to put that in there, so you can say, well, don't insert it. That's an example of just some different types of integrity that you can put in your database. You're a dork. So yeah, guys, that's all I have to say about integrity. So thanks for watching, and I will catch you guys in the next video. Peace! And be sure to subscribe. Ow, my ankle. I just kicked the wall. Be sure to subscribe. Hey, what is up, everybody? Welcome back to your 6th Oracle SQL tutorial. This video, we're going to be talking about relationships. Alright, so this is a straight up dating advice tutorial. Alright. This will get you all of the ladies. By all ladies, I mean probably 0 or less. And yeah, it might get you a programming job though someday. So, alright, so let's begin. We're going to start talking about relationships. And if you don't know anything about database relationships, this is the tutorial for you. Well, everything in a relational database has relationships. And when we say relational database management system, you guys remember that? I think I talked about that. Relational database management system. Well, this R does not mean relationships. It means relational, which deals with the concept of relations, which has to do with tables. So basically a relation is just a table. So when I say relationship, just want to make sure you guys are clear that don't be going around saying relationship database management system or something like that, because then you won't get the job or the ladies. Yeah. So before we go about designing these relationships, let's just talk about some conceptual information that you should know before you start diving into the whole diagramming stuff. Alright, so the first thing are the 2 words you need to know. Entities and attributes. These are basically 2 kinds of information in your database. An entity is anything we store data about. An attribute are the things about that entity. That means an entity has attributes. Okay, so in this example, you can see this entity right here has an attribute, an attribute, an attribute, and an attribute. So basically the attributes describe the entity. So how do you know if something is an attribute or an entity? Well, if you can think of a bunch of information about this, okay, just think if you have an object, right? Just something you want to store data about, or something you want to store in a database. And you're asking yourself, okay, is there a bunch of stuff I can store about this object or this thing? if there is a bunch of stuff you can store, then there's a high possibility that it is an entity. If you can't think of anything that you need to store about it, then the likelihood is that it's an attribute. Now, sometimes you can make it work either way, and I'll be explaining that. So don't get so caught up like, oh my goodness, I don't know if this is an entity or an attribute. Usually, once we get into database normalization, that'll kind of work its way out. But when you start off with just some basic entity, attributes, and relationships designing stuff, then when you get into normalization, it's like a piece of cake because you basically already have it done. All right, so let's kind of just go through some examples, right? If you have a database for a college, and this college has a class. This class would be a specific class, so we could say it's Math 4070. Now this would probably be our entity. That's because there's going to be related information that's going to describe this class. So we could have, a professor, student, have room number. So that's going to say where the class is located in the school. And if it's a big school, you might have building and room number. But we'll just go with room number for now, for simplicity's sake. And you also might have a time. So we could just say Tuesdays at 4:30 to 5:30. It's a pretty short class, only once a week, and it's only an hour. There's a whole bunch of information here. I just want to try to go through this and try to figure out what would qualify as an attribute and what would qualify as an entity. So you look at this and you kind of just ask yourself, all right, can we store information about each one of these? For example, a room number. Can we store anything extra about a room number? Not really, it's kind of just a room number. It might be 432, right? What about a student though? Well, a student, that's like kind of important. It's like a human being, and human beings are pretty important, So the chances are you can store information about a student. So, you could have what's their name, what's their student ID, what's their major, what class are they in, stuff like that. So this would probably be an entity. Professors, same thing. Those professors, they're people sometimes. Now, what about this time of the class? Well, can you say anything about the time of the class? Not really. That would probably be an attribute. So when we break this off into entities and attributes, let me clean off the board a little bit, we get something that looks a little bit like this. We have a table, and we can place the entities over here and the attributes over here. So for the entities, we have the class, the student, and the professor. We also had some attributes that were specific to the class. We'll just put these over here now. So you can kind of see how this is working. We're separating the entities from the attributes. And yes, these attributes are very specific to just the class. But that being said, we could add more attributes that describe the other entities. A name. Well, that could describe a student or a professor. Birth date, same thing. That could describe a student or a professor. What about a major? Well, professors could teach in a specific major. For example, we could have a nursing professor, but generally when you're talking about a major, you're talking about students. And I don't know why I decided to do those ones in black. Let me clean that up a little bit. Oh, I think I just made it worse. But you guys follow. Well then, what does this mean when it comes to database design? Why did we do this? Why did we waste our time making this graph? Well, we actually didn't waste our time. The way this works is you will take the entities and you will make them have their own table. So each entity is going to get a table. Attributes, on the other hand, are only going to be a column within that table. Without worrying about all the details, you can get a basic database design by following this concept. That means we have three tables. We have the class, the student, and professor. As for the attributes, such as the time of the class and the room number, those are just going to be a column within this class table. So within this class table, we're going to have those two columns, room and time. As for those other attributes we were talking about, such as name, Well, those are going to go in both of these tables. You can get a very basic database design starting point using this method. Now we talk a little bit more in depth about the concept of relationships, because these tables relate to one another. For example, a class is taught by a professor. Students attend the class. You could also maybe say that the professors teach the students, or the students learn from the professors. So we're going to talk about the 3 types of relationships right now. The first kind of relationship we're going to talk about is a one-to-one relationship. And if you're a visual learner and need some kind of picture to visualize this, think of marriages. Alright, I probably wouldn't be cool if my wife went out and married another dude, right? And I don't think she'd be happy if I went and married out some other chick, okay? It's a one-to-one relationship. Like, we have exclusivity in that we're not allowed to go marry other people. And if you're not a visual learner and that is just the dumbest thing you've ever heard, then forget it. One-to-one. This is the relationship of an entity and an attribute. So when you have an entity such as a class, the attributes would be the time of the class and the location of the class and the class name, the class ID. Stuff that is unique to that class. Just wanted to mention that there is a little bit of flexibleness allowed in this. For example, when we say one-to-one, we're basically saying this class has one name, and this one name is assigned to this one class. Now, like I said, that's not always generally true, because we could potentially have another class with that same name. But if you think about the purpose of a class name, it's an attribute to describe an entity. I'm really not trying to make this too complex, right? So I'm trying to give you the most technical, correct definition of this, right? A one-to-one relationship is essentially a column within a table, and that column is unique to that entity, even though the value of that column could be repeated in another row. Did I lose you? I think I just lost myself. Let me give you a picture, right? We have this dude, and we have this dude. There's a couple different ways we could store this in a database. First, we can put them both in one table, and we could make them both have their own row, which would be the way we would want to do this. And now this person has a name. So we have a Caleb, and we also have a Caleb. This would be the proper way to design this. One-to-one relationships, you put the attribute as a column within the entity table, which will be people. Sorry, my neighbor's parking his car, making a bunch of noise. What a noob. Attributes are a value within the name column, and they are unique to each entity, but there's a repeating one. So an alternative way to design this, which you should not do, is to make another table known as names and have Caleb in here once with an ID. So let's say this has the ID of 1. And then we could reference that. That's a total possibility, and in fact it would work. But it's unnecessary strictness. Just because there's a possibility that the attribute could be repeated doesn't necessarily always mean that it's a one-to-many relationship. If I haven't lost you yet, good. If I have, let's just slow down a little bit. The only thing you really need to remember or think about is that a one-to-one relationship is an entity and an attribute. That's all you gotta know. Just ignore all this stuff, you know. The second example of relationships that you need to know about are one-to-many relationships. Now when we're talking about one-to-many relationships, we're starting to talk about relationships between two entities rather than one entity and one attribute. In this example, we had an entity and an attribute. But in this one, we're actually going to have a relationship over two tables. And if you remember, I was talking about entities. I said each entity gets their own table. So the example I got for this one is you got like a gym, right? Generally, gyms will have some kind of membership, right? Some gyms have a tiered membership system. You can find the same thing on websites. You can pay $10 a month for the good version, and then you can pay $10.99 per night for legit version, right? So those are like a tiered membership. So let's say in this theoretical gym we got 3 tiers. We got bronze, silver, and gold. So over here we have the membership table, and we have 3 entries or rows. So these are basically going to be 3 rows in our membership table. And over here we have customers. And don't worry too much about my spelling or anything. We'll get into all that later. I'm just using for theoretical design. I'm just writing what I'm talking about. I ain't following no standards. Well, in this table, each customer is going to get a row. So we have 3 customers. Each one's going to have a membership status. The way this works is with an ID system. Each one of these is going to have an ID. And with these numbers, you can basically correlate it. So this guy, he is the gold membership. This guy has the silver. And this girl has bronze. Or let's say she has gold too, right? That's how that works. And just so you know, you don't have to use IDs, but you need some kind of primary to foreign key relationship, which we'll talk about that in a couple minutes, if I got time. This is an example of a one-to-many relationship because one membership status, gold for example, goes to many other entities. So we have 1 to this guy and to this girl. To follow this, you got 1 to many. Many being more than 1. It doesn't have to be like hundreds, it can be 2, for example. So that's the way this kind of works in a one-to-many relationship. There's a connection between the customer's entity and the membership entity. So in a one-to-one, you have an entity and an attribute, but in a one-to-many, you have 2 entities. And once again, for your visual learners, this would kind of be like if my wife was like, yo bro, I know we're like married and such, but I'm gonna have multiple wives. I'm gonna have multiple husbands, but you're not allowed to have multiple wives. That's not cool, and if you do, we're done. That's kind of what a one-to-many relationship is, because you'd have one husband has 1 wife, but the wife can have multiple husbands. Sorry for all the details, but getting on to the final, and probably your future least favorite of them all. Many-to-many relationships. I can talk. The way many-to-many works is that one entity could have a relationship with multiple other entities, and each one of those entities could have relationships with any number of other entities. So kind of be like, yo, wifey poo, I know we're like married and all, but I think we're gonna be allowed to have as many wives and husbands as we want. Or that would be full polygamous marriage. But to put that into a data perspective, let's use a different example. We have people, and then we have classes. So students and classes, essentially. One student can take 20,000 classes, and one class could have tons of students. So if you think of you have like one student, and that student has a relationship with multiple classes, it'd be like, poof, poof, right? Like pointing to 4 classes, for example, you get like this effect. You know? And then on this side, you have one class which has 30 students. So you get like times like a lot, right? And then you just get these lines going all over the place, right? And at the end, you just got this big mess, right? So this is one of the harder ones to store in a database, and it requires what's known as an intermediary table. You may also hear this as a junction table or a many-to-many table, or who cares? There's all kinds of different names for it. But basically, the way this is going to work is you're going to have 3 tables. And this here, this intermediary table, is right here, smack dab in the center of them, separating them. You know, you don't want all those lines crossing over each other, so that'll just be bad. And then you're going to put all of the relationships in this table. So within this intermediary table, let's say this table here is students and then classes. So we got students, classes. Within this table, you're going to associate a student with the class that that person's taking. So you would have Caleb, math, Caleb, science, Caleb, geology. And then once you go through all the classes that Caleb has, you go on to someone else. Jimmy, math. But Jimmy doesn't have a science class. So you just go straight up to geology. And these names are going to be replaced with IDs or foreign keys to the students table. Did I lose you? But basically, you're going to have, let's say Caleb has the ID of 27. Instead of having Caleb, you're going to have 27, 27, 27. And that's going to link the tables. So that way you don't have them break apart. So there's still that connection, links, but they both come to the intermediary table and stop there. For you visual learners, think of like two tables shooting out laser beams. Boom! And then it hits this magical force field of this intermediary table and it absorbs all the electrical energy juice and then puts it in a beautiful display of students to classes. And right now you don't need to understand all the details of how to make an intermediary table perfectly. If you want to know more about that, I have a 50-some part database design series that you can go watch for days, okay? I'm just trying to get the basics, and this video has been way super too long, so let's just end with that for the relationships, but I still have one more thing I need to talk about, which first we'll summarize this, and then we'll talk about primary keys and foreign keys. So many-to-many is also entity and entity connecting multiple entities, but with an intermediary table. So entity and entity with intermediary table. That is how we would memorize that. And if you like to think about tables, like how many tables do these things take up? This is 1, this is 2, and this is 3. Okay, now let's talk about primary keys and foreign keys, and then we'll talk about one more thing regarding relationships regarding those keys, and then we'll be done. So there are two types of keys in database design. There's primary keys and foreign keys. So these are the kinds. Now there's also categories. So those two categories are natural and surrogate. These are basically the way the keys work. So natural would be something that has real world meaning. So something like an email address would be a natural key because it has real world meaning, like I just said. A surrogate would just be like an ID of 743, which is just a random number, computer generated, doesn't mean anything in real life. And the fact that it's just a random number, that's it. But I guess I skipped a step. What are keys? They're basically things to keep things unique. The keys are used to basically make every single row within a table unique, and also they're used to make connections across multiple tables. The difference between natural and surrogate is minor, and it's kind of a conflict between database designers as, oh wow, you should use natural, or oh, you should use surrogate, or oh, you should mix them. It's not a super huge deal in reality. I tend to prefer surrogate, but I'm not completely against natural, so just for those of you who are wondering, natural or surrogate. But that doesn't matter. So let's just talk about primary keys and foreign keys. The primary key is the key column within a table that makes that table, which makes every row in that table unique, right? So if you have a users table for a website, every single user is going to have, in this case, a surrogate key of a random generated number. That makes every single row unique. So that way, if you have a person with the same name as someone else, you can tell that they're different things, right? So if you didn't have these keys and you just had Caleb and Caleb, well then you have to ask yourself, okay, is this a duplicate or are these two separate people? And you don't really know. But if you have a key, one of them is named Caleb with the ID of 72 and one of them is Caleb with the ID of 483, well now you know they're two separate entities. One's Caleb with this ID and another one's Caleb with this ID. So let's just draw faces to represent people, and we're going to give each one of these people an ID. This face here, you wouldn't store that inside of a database. I mean, you could store a picture, but that's not what I'm trying to do. I'm just trying to give a visual representation of what each one of these rows refers to. It refers to this person. You know, it's like, how do you talk about the person? Well, it's this person. Got these three people. We'll give them some hair so they have some confidence. This one's a squid. Alright, so these three people each have a row in the database, in the table of the database. The table is whatever is what you're storing, so in this case, users. Now a foreign key is a reference to a primary key in another table. So if this is that gym we're talking about, we would have a column foreign key, which would say membership status, for example, and you would have, let's say, 2, 2, and 3. These are foreign keys, and they reference primary keys of another table, which in this case would be membership status. Each one of these is going to have a primary key. Every single table is going to have a primary key. If we're using IDs, well, we could just say 1, 2, and 3, just computer-generated numbers. Now there's a link between the foreign keys and the primary keys. See this number here? Well, this is a foreign key, and it has to match a row with the same primary key. So this foreign key references the silver. This one also references silver. This one represents gold. And you have these links, and you can enforce those links with something known as foreign key constraints, which we'll talk about in a future video. That is basically how this works. Primary keys, foreign keys. Foreign keys reference the primary keys. Every single table needs a column that has a primary key to make every single row unique. Then you can enforce that with foreign key constraints. So when it comes to those database relationships we were talking about, the way we design our primary keys and foreign keys are very important. So we're going to go through them real quick and describe how this works. The first one being 1-to-1 is the easiest. You guys will love it. All right, you don't even need to worry about multiple tables. You have a table, and then one of the columns is going to be the primary key, and then you put the relationship in another column. It's simple, entity and attribute. The entity might be users, everyone has their own ID, and then an attribute would be like the user's name. Caleb, for example. That's all you gotta do. You make a column. Boom, done. Simple. I know, it's awesome. I wish it was all like that. For one-to-many, it's a little different. Let's use the example of the membership again. You're gonna have two tables, and this one it's going to be the users. So you're gonna have a primary key of the user ID, and then you're going to have a foreign key which references the primary key of the membership. The foreign key goes in the child relationship, which we never even discussed really that much, children and parents, but you can think of it like this. You can have one entity, such as gold, which can be used or whatever by other entities. For example, Caleb and Sarah and Samuel. Right? This will be the parent, these will be the children. Well, these people are all stored inside of a table, each with their own row, and then the foreign key, each one of these has a foreign key. So this is going to have a foreign key of 3, foreign key of 3, foreign key of 3, because they're all gold members. It makes sense. So for one-to-many, the one side has a primary key, the many side, which would be the children, has a primary key and a foreign key referencing the one side. Great. All right, let's go over many-to-many. In this situation, we get 3 tables. And let's say it's books and authors. One book can be authored by many people, and one author can author many books. So you got this many-to-many relationship. Well, we can put books over here, authors over here. The foreign keys are going to go in here. So you're going to have a foreign key to the book and a foreign key to the author. Now there's one small thing of debate that some people have as to whether you need a primary key to describe the whole group. So if you did, you'd need 3 columns. If you don't need the primary key, then you just use both of these as the primary key. I'm just going to say up front it doesn't really matter, but in this situation we'll just keep it as this. You can interpret it however you like. But basically, the foreign key is going to reference the book, and the foreign key is going to reference the author. So you could have one author, this person over here, with the ID of 47, who authored 3 books, 38, 27, and 19. Those are the IDs of 3 books. The way it'd look in here, you would have 4738, 4727, 4719. That is how a many-to-many relationship works. Well, congratulations. If you've made it this far, you officially got through the database relationship section. One of the most fun and interesting sections, but it can also be very time-consuming because it's very conceptual and, you know, kind of annoying, and you kind of just want to, like, take the whiteboard and smash it on something to help you think or something. I don't know. But hopefully that was helpful. Sorry, this is probably one of the longest videos I've ever posted. But anyways, thank you for watching. I'll see you in the next video, and hopefully you guys are learning and enjoying this. Thanks, and I'll see you then. Peace out, guys. Peace. Peace. Hey, what's up, everybody? In this video, we're going to be covering database normalization. So this is your 4th video in the 5-series database primer. Essentially, my goal here is to kind of give you like a rough overview of everything database design. But naturally, you can't learn everything about normalization in just one video. So this is going to be something that continually shows up in future videos and throughout your database career. So don't blow this off. It's pretty important. So database normalization is basically a set of rules that you can optionally follow, and it will help you get a better, more protected database design. It protects your data integrity, it prevents redundant data and contradicting data. Like, oh, here's John, his phone number is 123 whatever. And then, oh, here's also John, his phone number is 457 something else. And then you don't know which one's right. So these are the kinds of things we want to avoid. And the main ways we design a database is 1, with relationships, and then 2, once we kind of got those relationships designed, we start doing normalization, which is kind of like a check that looks through your database and catches anything that might not work the way you want it to. But you guys got to realize that a lot of these decisions, like, oh, should we design it this way or should we design it this way? These are things that are decided by the business rules, your assignment, what you need for the project. You can't always look at a table and say, what's the correct way to design this? Because it depends upon what the requirements are. You can choose on certain things. But I'm kind of getting off topic, so let's get started. The 3 normal forms are first normal form, second normal form, and third normal form. There are a couple other ones after that, but who cares about those? Let's start with the beginning ones. So we're going to start with the first normal form. Now the first rule of first normal form is that all of your columns need to describe something that is atomic. What does it mean if something is atomic? It means that it is in its lowest form, like the most you can divide something up. The reason being is that one time these science people believed that atoms were the smallest thing, and they assumed that, oh, you can't split an atom, right? Pretty helpful. How's that apply to database design? I don't know, but we're using that word. So essentially, we want the column headers, or whatever the column is about, to describe one individual thing. But don't make it so small that it loses the meaning of what it is, right? So there's like a fine balance. So like, for example, we have a phone number, right? So here's my phone number, And this is something that is atomic. It's the smallest indivisible thing that can describe a phone number. If I wanted to split this up, like let's say I split that, now you have to do some extra combination like, oh, the area code and junk, but I would say that the full number qualifies as being atomic. When it comes to names, I would say first name is atomic, middle name is atomic, and last name is atomic. If you just combine all of those into a column like name, I personally think that's not very atomic. You can do that though. It's up to you. One reason that might be good is for different countries, names are separated different, so people don't always have first, middle, last. They might have like first, second, middle, second middle. I don't know. I don't have an eraser. Don't worry, t-shirt to the rescue. So as a reminder, the first part of first normal form is that the columns are atomic. The second part is that the data for each row is one thing. So it's similar to things being atomic, but now it's the number of items that are not divisible. So if we go back on the phone number, so if this is my phone number, this whole entity is atomic. You wouldn't want to split it. That puts you at risk of making a nuclear bomb. So we're just going to keep it at that. But what if I have two phone numbers? So now in our database, we have a column phone number. And within an individual row, for me, I have one phone number and then I have another phone number. How do you go about storing this? Are you just supposed to put them both in there as one giant string? No. That'd be stupid. You don't want to do that. So this is an issue. Databases are designed to be atomic. We don't want to put a bunch of junk in one thing of data. Because if you wanted to go through here and grab phone numbers, you might say something like, oh, select the phone number from this table, and it returns this. And then you try to like automate a phone calling system or something. This isn't going to work because these are two things. But how do you actually fix this? Whenever you have the situation where you might have multiple entries for one person, you need to create another table. Now when it comes to phone numbers, some people will just put phone 1, phone 2, and leave it at that. And if they don't have a phone 2, then they'll allow you to put nulls into that field. But some people prefer to have no nulls in their database. And if you don't know, nulls are just the absence of a value. So no phone number. But if you want to force, we want you to be able to have unlimited phone numbers, and if you don't have two phone numbers, we don't want you to even have a second phone number, because that's just wasted space, right? The way you would do that is you create a new table for phones or phone numbers. And then within this table, you're going to have two columns at least. The first column is going to be a reference to the person. And the way you do that is with a foreign key. So this might be an ID of a person. And then the other column is going to be the phone number. So let's say we have a person over here, and he has an ID of 7. We're going to put an entry over here, 7, and then we're going to put one of his phone numbers over here. Then if you had another phone number, you would make another entry into this table with the same foreign key referencing this dude, and you would put his second phone number. This solves that problem of having phone number 2, null, 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 null for like everybody. So the way it works, the way it prevents nulls is if we have another person and her ID is 8 and she only has one phone number, you only need one entry in this table. Problem solved. So to conclude first normal form, every column is atomic, and then every entry for that column only has one value. Let's move on to the second normal form. Second normal form deals with something known as partial dependencies. So before we dive in and talk about what partial dependencies are, let's just talk about what normal dependencies are. Essentially, dependencies are when an attribute depends on an entity, or basically it describes the entity. So this goes back to like the very basics of databases where you have attributes and entities. So if we had a person, this would be the entity, and an attribute would be the name, phone number. I was looking back at my old videos, and one of the attributes I used was their pH level. Really? So let's go with it, their pH level. All of these attributes depend on the person, meaning that if you change the person, these are also going to change. So usually this entity is described with a primary key. So usually it's an ID, but not always. That's called a surrogate key, meaning the database just generates some random number to represent an individual person. So that's what we're going to go with. But if you don't want to use random generated numbers, you can look into natural keys. But those are complex, so forget that. So let's go with person, and we're just going to make this a person ID. So everything depends on the person ID. That also means that this person's name does not depend on something else. Like an order, this order is placed by a person. So we could say the person with the ID of 46. But this name is kind of unrelated to the order. So you got to be able to tell where a dependency is and where a dependency is not. The easiest way to think about it is usually the columns in a table all depend upon the primary key. But occasionally we run into something known as a partial dependency, which is bad stuff. So we're going to teach you how to get rid of it. So as you may have guessed, partial might imply meaning like part of something. So in order to have a partial dependency, you need to have what's known as either a compound or composite key. Essentially, two keys combined to make one key. The reason that is you can't have a partial dependency if you only have one key, because you can't split that. You'll see what I mean. So we always need a compound or composite key when we are dealing with second normal form. So where do you find such compound or composite keys? One example is when you're designing a many-to-many relationship. The table in the middle, it's known as an intermediary table, it's going to have two primary keys. And the combination of those is going to qualify for something that might have a partial dependency. So let's dive in that a little bit more. So in the previous Oracle video, we talked about books and authors and book authors. And essentially what we did is we set one table as books, one table as authors. Because books and authors are a many-to-many relationship, essentially what we're going to do is split this off into into two tables with a one-to-many to a third table and a one-to-many also from this side. So essentially, one many-to-many is split into two one-to-manys. Hopefully that makes sense. It's basically this rather than, because this is not a good design for databases. So over here we're going to have books, over here we're going to have authors, and in between we're going to have, you guessed it, book authors. So in this table we're going to have a book ID and an author ID. And the combination of these two need to be unique. For example, if we had the book 47, like the ID 47, and the author 47, and then we had another entry, 47, 47, this would be describing the same thing. It'd basically be saying, hey, this guy wrote this book, and the same guy wrote the same book. It's redundant, so we don't need that. So essentially we put a, kind of like a, oh, drop my chalk, kind of like this overarching key on both of these. So these as a whole need to be unique. So we could have 47, 43, these don't have to be unique, but both of them together have to be unique. Alright, now let's say we have some super meaningful data, like the author's favorite food, because that's relevant. And you're like, I wonder where I'm going to store this. Yeah, let's put it right here. So we have the author's favorite food here now, but we just introduced a partial dependency because the author's favorite food only depends on one of the two keys that make the overarching key. So it only depends on the author. And the way you can kind of think about that, or basically prove that, is you can change one of these and see if this changes. So if we change the author, the food that that author likes is going to change. Because if we had an entry in this table and it was like, oh, John, he likes tacos. And then we had another one like, oh, Hannah, she likes mac and cheese. We basically looked at the difference from John to Hannah. The food could potentially change. I mean, they could both like the same food, but we're just talking could change. But if you go through the books and you change them, this is always going to stay the same. The food is not going to change. So, oh, John, he wrote Three Little Pigs. His favorite food is tacos. Oh, John, he wrote Mary Had a Little Lamb. Is that even a book? I don't think so. But his favorite food is still tacos. You can see that it really has nothing to do with the book. So the appropriate place to put this, as you guessed it, is over here. That would fix the partial dependency. But this also brings up the question, when is it appropriate to put something in here? And the only time is if it depends on both of the keys. So a good example is the author's position on a published book. So you know, authors, they get all like mad because they want to compete for like the #1 author, right? Like the first person. Because then basically they kind of get most of the credit for the book. So that's something that might be important if you're a publishing company, is what position that author is for a specific book. But as you can see, it kind of depends on both, because it depends on who the author is and what book you're talking about. If you were over here and you said, oh, John, he's position #1, but that doesn't tell you position #1 for what book. But if you put it over here, you can say, oh, Three Little Pigs, position #1. Doesn't really make sense. But if you go in the middle and you say, oh, John is position #1 on the Three Little Pigs, now it makes sense. So in that situation, you would not have a partial dependency, and the correct location would be is to store it in here. So hopefully that kind of sums up second normal form. It's one of the more complicated ones. It's taken me a couple years of my life to really meditate and grasp all the details of second normal form. But one day, young sir, you will get it. Or ma'am. Moving on to third normal form. This deals with something known as transitive dependencies. These ones are a little easier, so relax. So what in the world is a transitive dependency? Essentially, it's when you have a column that depends upon 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 a key. You have like this weird hopping thing going on. And it doesn't have to be that many levels. It could just be like a column depending upon a column that depends upon the primary key. Yeah, I know that's like really conceptual, so the easiest way to show this is to go through an example. So let's say you are a publishing company and you have this beautiful website where people can go on there and put their ratings for all of your books. And you know, these websites usually have some sort of star system or like, dislike. We're going to go with a star system, so that way people can go on there and rate their book. And it's generally accepted that like 5 stars is like, wow, this book is incredible, it made me win the lottery, it's awesome. 3 is like, yeah, this was okay, and then 1 is like, wow, this book gave me Lyme disease. Okay, so we kind of understand that, but let's just say you wanted to store what those stars meant in a database for some reason. You might try something like this. Inside of a rating table, you might have the user's comment, their star rating, and then you're going to have the star rating meaning. Now you may already see the problem here. The problem is that the star rating meaning does not belong in this table. We have a transitive dependency. That's because the star rating depends on the comment, and then the star rating meaning depends on the star rating. It's kind of like this bouncing thing. So the way to fix this is to create another table. You could just name it whatever, stars. Now within this table you could have the ID, and then you could have the rating. So you could say rating 1, 2, 3, 4, 5, and then another column for the rating meaning. And then inside of this table, instead of having both of these, you would just have a star rating that would be a foreign key to one of the rows inside of the stars table. So let's just go over an example. So here is a row in this table, super great, and then a star ID of 5, which could conveniently correlate to like 5 stars, but it doesn't have to. And you might also have like a user. Now, I'm gonna kind of comment my opinion on this. Putting the star meaning in a database is probably unnecessary, mainly just because 1 through 5 stars is kind of universally known, like 1 is bad, 5 is good. So do you really need to put the meaning in here? Plus, programmatically, in like whatever programming language you're using to make an application, you could put that phrase like, oh, this is 5 stars, great. You could put that on the application, but you don't necessarily have to store that in the database. You could just put it in HTML or whatever you're using. So that was a pretty simple example, but it wasn't the most practical example. But there are plenty of other examples. For example, you could have a person table, and one of the columns in that person table could be the person's driver's license number or something. And then another column could be the state in which they got their driver's license. But does that actually belong in the person table? Is the state that the person got the license in related to the person itself, himself, herself? Not really. That would be an appropriate situation where you could break it off into like driver's license table or something like that. Now that's with a compromise, because now you have an extra table, you have to do more joins, and the database design becomes more complex. So the lesson learned from this video is that the whole normal forms and database design is very subjective, and it really depends on what you want. So if it was me, I'd go on like the more simple side and don't normalize it too much. But if you do that at work and get fired, I said nothing. Nothing. Thank you guys for watching. I've been trying to give these videos in a very conceptual way, so that way this stuff applies to every single relational database you guys use, whether it's Oracle, SQL Server, MySQL, etc. The concepts are what's important. If you know these concepts, you can design a database in whatever database management system you want. Keep that in mind as you go on to the next video, which is the last video in this 5-video database primer. But in that video, I will try to give you some more information on what we're going to study relating to just Oracle database design. For example, different data types and all of that stuff. That stuff's going to come a little later, but this is the foundation for it all. So thanks guys, keep at it, keep with it. See you in the next video, and I'm hoping you're enjoying this series. Thanks, bye. Hello there! Welcome back to your Oracle database tutorial series. This video we are going to be discussing indexes. Now the easiest way to understand indexes is, let's just imagine you have a book, right? And you want to find something in this book. What do? Well, you could, go through it one page at a time and try to find what you're looking for, right? And eventually you're going to find something, but maybe not exactly might not be the fastest way of doing things, because it's going to take you a lot of time. So you use something that's known as an index, which basically you just pop to the back, and it's going to be like, oh, you're looking for this? You need to go to this page, and so forth. So that's the easiest way to think of an index when it comes to database design. Essentially, an index is going to take a column, and it's going to sort it in some way that you want to sort it, either ascending or descending. And then it's going to basically have a reference to where that data is. So that means if you're going through your table of users and you're looking for a specific username, as long as that username column has an index on it, you can just type in the username, it will alphabetically find it, and then it'll have a reference to wherever that data is, even if the table is not organized alphabetically. Another way to really grasp how useful indexes are is to imagine life without indexes. If you don't have an index on a column and you need to find a column using the select statement, for example, your database is going to have to do what's known as a table scan. This is kind of similar to looking through a book for something page by page. It'll essentially just go one at a time through all of your rows until it finds that data. That's not the way to do it. If you have it alphabetically, it's already going to know about where your data is, so it's a whole lot faster. Now we need to answer a question. What should you index? Well, thankfully, Oracle Database is actually going to index some stuff automatically for us. One thing that it will do that for is the primary key. The primary key is something we're often going to search for. We're often going to join tables using the primary key. And yeah, so we always want to have an index on the primary key, basically. Oracle's going to do that for us by default. There's another thing that it will automatically create an index for, and that's when we use what's known as a column attribute, unique. So kind of like how you can tell a column to be not null or what data type it is, you can also say unique. And that's basically saying every single row has to have a unique value. It's kind of like a primary key, but it's not the entity, it's just an attribute of the entity. Think of like an email for a user account system. The chances are your email is going to have to be unique. So you might throw the unique column attribute on that column. Now, I don't think Oracle does this by default, but another thing you should consider having an index for are your foreign keys. And the primary reason I suggest you do foreign keys is similar to why we have it for primary keys. It's because we use these keys to join data. So what is a join? Let's go into that a little bit so you have more of an idea of what I'm trying to explain here. Let's say you have two tables here. One is like a user account table and another is a comment table. You might have an individual comment that has the inside of the column of who posted it an ID of 7. But you don't have the ID of 7 memorized. You don't know who that is. So what you can do is do a join on these tables, and you can essentially turn them into one table. Now, it doesn't actually store it as one table, it only presents it as one table. And the way it works is it combines the tables based on some kind of similarity, basically. So for example, we might have a user up here with the ID of 7, and we might have a comment down here from the user with the ID of 7. Then, instead of having this as our table, we can have this. As you can see, this is a much better way to present this data because we know who the comment is from. You could also have the username here or whatever. You can combine things in so many different ways, and you could literally make an entire series on just joins. So that's all we really need to talk about for now. But essentially, anytime you're going to be joining two tables very often, you might want to consider indexing the columns that they share. So this one has a user ID and this one has a user ID, and you use those to kind of combine the tables. You're going to want to index those. The one up here in the user table, that's going to be a primary key, which is probably going to be indexed by default, but the one over here is going to be a foreign key. So you're going to need to index that if you so desire. Let's go through an example that's a little bit better. Let's say we have this website, and basically the point of the website is to send people good deals that are going on the internet. So we might send them some links to Amazon or to eBay or some Black Friday sales, whatever's going on at the time. We essentially want to kind of get some revenue share from them buying stuff. So we have like literally 5 trillion rows of emails. So we might want to consider indexing these. Well, we can actually index these as a group and index this entire thing, and this is going to make the query run at the optimum speed. This, my friend, is known as a composite index. These are going to be very important when you're making your queries because you're going to want your queries to be as fast as possible. So you might be wondering, well, if indexes are so great, why don't we just index everything? Well, indexes have their downsides too. Just like when you take a book and you change the contents of the book, you're going to have to update the index. So for databases, every time you update data, delete data, or add data, the indexes also have to be updated. Now the database does this automatically, so it's not something really super manual labor that you have to do, but it does slow things down. So you have to kind of balance. Do you want faster queries, or do you want faster inserts, faster updates, and faster deletes? It's kind of a hard challenge. So basically what you want to do is you want to get all of the indexes that you're going to need, but not any more, because literally every index is going to slow your database down more and more. That's why I've kind of given you this as a guide If you're not entirely sure, this would be a good place to start. Make sure you have indexes on these, and anytime you're doing a specific query that you're going to be running numerous times and it's very slow, you might want to look into a composite index or just indexing whatever column you're looking for. It doesn't have to be unique to have an index. You can literally index any column. That basically wraps up our 5-video introduction to database design. There's actually some more database design topics that are really relevant to Oracle, and we're going to get into those as time goes on. But I didn't want to spend like years going over database design when we really just want to get into actually making a database and all that fun good stuff. So some things that are probably going to come up in future videos are data types. Data types are the type of the data. That was super unhelpful. Every piece of data has some sort of type. Usually if there's quotes, it says this is a string. If it's a number without quotes, such as 12, it's usually an int or numeric or something like that. So we'll just go with int for this case. So that's an integer, meaning there's no decimal point. You can also have dates and other kinds of data types, and we'll be getting into those as we start creating our tables. Another super really important thing when it comes to database design is naming conventions. Essentially what a naming convention is a rule that many people have agreed upon on how we want to name things. Now this is probably something I've neglected the most in this series so far. We haven't really talked a whole lot on proper naming conventions with Oracle. In fact, I've just been writing them basically as English, no naming conventions. But there's different kind of naming conventions you're going to come across in programming, in computer science, and database management systems. There's something known as camel case. There's Pascal. I'm not even sure how to pronounce that. There's two types of Hungarian notation. There's all caps or all lowercase, and so forth. So you can see there's tons of different ways we can style things. And this just describes one word. But if you look at Oracle as a whole, there's a lot of different things that you need to consider. And that's one very big thing that's important, because if you look at other people's code and they follow a different naming convention than you're not going to be able to read it very well. So that's why I really recommend that you figure out the most popular, the best naming convention, and follow that one. There's sometimes conflicting naming conventions, and if that's the case, you can pick the one that you like. Now, there's also a whole lot of database design when it comes to presentation. Depending on your role, you may or may not be working a lot with presentations. Basically, presentations are how we present the data to the user or to the programmer or whatever else. So this includes things such as views. Views are basically a saved select statement, kind of. There's also joins, which we talked about a little bit. You're also going to have to deal with things such as stored procedures, stored functions. I had another one, but I forget it. Security. These are all things that are going to need to be designed. Now, you might be the kind of person who manages the whole database as yourself if you're doing a project on your own, or you might just be working with one thing, like, oh, I only do the data definition language, or oh, I only do data manipulation language. That all depends, but in reality you should try to know as much as possible, so having a rough idea of all of these things is very, very good. So as you can tell, this is kind of just an intro. Hopefully, guys, it was helpful. I really, 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 really super appreciate you watching these videos. If you like them, please click like, subscribe, and of course, share them with all of your friends. Thank you. I'll see you guys in the next video. And I'm excited because we're finally going to be starting something new. So, prepare yourself. Hey guys, welcome back. This video is going to be an introduction to queries. And I apologize ahead of time if my audio is not the best. I'm in the process of kind of setting up a studio, so I don't have all my equipment set up right now, and this is the best I can do for now. So hopefully it's okay for you guys. I think we'll be able to get through it. So let's dive right in. I'm an Oracle SQL developer, which is the app we use to connect and communicate to our Oracle database. And I have my subscribe database open. Now, if your window layout looks any different than mine, you can always go up to here to Window, and then reset Windows to factory settings. So what is a query exactly? Well, a query is how we get data from a database. And literally, people can have an entire career just from writing queries. So this topic is stinking huge. But we're going to start with the very basics. In fact, we're not even going to get data from a table. We're just going to start with what's known as expressions. Expressions are these things that can be evaluated to something. So think back to like math class. You might have something like 5 plus 5. Oh my goodness. Let's try this again. So you might have something like 5 plus 5, and that can be evaluated to 10. So this right here, this is an example of an expression. But we can also have expressions with other things, such as strings. So that is a string. In fact, we're going to put hello world. And essentially, we're going to try to create a hello world program, which is basically the first program you usually try to write when you start a programming language, just so you can get it set up, type something small, and get it running. So that's what we're going to do. It's going to be a little bit different than other programming languages because this is a database, but the end result is going to be pretty similar. So how do we go about telling the database that we want it to tell us hello world? Right now, we're telling it hello world, but we want it to respond. Well, the way we get data from a database is using what's known as the select keyword, and that's going to go at the beginning of your query. So now we're saying select this string, and it should give us the data back, but not quite. There's a little thing we have to do, and I'll explain that in a minute. But in most database management systems, this right here would work, but let's run it and see what happens. You can run it by pressing this button here or pressing F5. And you can see we get an error, and it's basically saying that it requires the from keyword. So where do we put the from keyword? It's actually right after the expression, so we put it right here. And what do we take this data from? Well, Oracle has this magical table. It's called dual. And this is going to allow us to basically do this, but in Oracle. So when we do this, it's going to respond with hello world. So let's run it and see how it works. And you can see the output right here, hello world. So it works. You guys just created your first hello world application. It's very, very simple. Now, I ain't trying to make Oracle sound much simpler than it is. Oracle is like a beast. It can do anything. In fact, it can even do addition. So instead of putting a string here, we can pass in some addition. Let's run this. There we go. 5 plus 5 equals 10. You can also throw things in here known as functions. So a good one we can try is sys timestamp. Let's try that. And you can see it gives us the exact time of our machine. So that's pretty sweet. When you're working with select statements and tables, usually you're going to want to have multiple columns. So in this situation, all we're doing is selecting one thing, but I want to select multiple things. So the way you do that is you just add a comma, and then you say the next thing you want to grab. So we could throw in a string here, say hello world, and then we could throw in another comma, and we'll actually do another math problem. Let's go 5 times 5. Now the last one does not require a comma, so you can keep it that way. So let's try this and see if it works. So we basically have a generated table. Here are the column headers, and here are the values. Although we only scratched the bare surface of the select statement, I think that's a good place to end for now. And in the next video, we'll begin dissecting this and learning a little bit more about how we structure our SQL. So thanks guys, please be sure to subscribe. I really appreciate that, and if you like this video, please click like, and I will see you in the next video. Peace! You thought I wasn't going to say it. Yo, yo, yo! Welcome back, everybody. This video, I'm going to be breaking down this statement a little bit, just to kind of explain some of the rules when we write queries, so that way you guys can intuitively know what to do with, like, this capitalization and all of that stuff. So the first thing I wanted to point out is white space. So here's an example of white space. It's a space. You need to know that Oracle is not white space sensitive. What that means is we can literally just sprinkle white space basically wherever we want, and things are still going to work the way we want. So for example, if I'm like, hey, this looks stupid, let's put like 40 spaces here. You're welcome to do that. And just to prove to you that I'm not lying, let's run this thing and see how it works. And you can see it outputs the same exact thing. Now there's one gotcha to this, and that's when it comes to strings. So you see here, we have a string of hello world. And anytime we have a string surrounded by these single quotes, Oracle does care about white space. So right here I have a space. If I have 2 spaces here, it's going to change the response from Oracle. Let's run it. And you can see here it actually outputs an extra space. So spaces inside of strings can change the output. So you need to be aware of that. The other thing that you need to know is that you can't separate keywords. So this is a keyword, right? And you can put as many spaces after it and before it as you like, but you can't put spaces between it, or it no longer remains a keyword. And then you're not going to be able to run your script. Boom. Error. Alright, so let's put this all back how it was. There are 2 other forms of white space, and that includes the tab, and also the new line. So this should still work. Yep, works fine. So I'm going to put that back. Now the next thing you might have noticed when you first looked at this is like, what in the heck is going on with all this random capitalization? Like, how are you supposed to know what's capital? Like, this is capital, but this string here isn't capital. What's going on with that? Well, this is a convention. And the convention is that whenever we have a keyword, we're going to put that in all capital letters. So this is a keyword. This is another keyword. This string here, though, that is data that I put myself, so it's not a keyword. We can keep that lowercase. And once again, this is purely a convention. So that means I can actually change this. I could say select in lowercase, run the thing, and guess what? It works just the same. This rule actually still applies when we're talking about objects we create in our database. For example, tables. Here we have a table, dual. We can change the capitalization of this, and it should still work. I'm going to capitalize every other letter, because that makes me cool. Right, so now let's run this and prove to you that it works. It works. So, I guess this brings up the question. Should you follow the naming convention? The answer is yes. Literally, almost everybody follows the convention of capitalizing the keywords. And that's not just for Oracle database, but SQL Server, MySQL, and many other database management systems. So I it's a tongue twister. Highly recommend that you follow the naming conventions. This too has the gotcha with the string, because the string is basically whatever data we want it to be. So if I make this all caps, when I output it, it's going to be all caps. So it pays attention to that. So you can see down here, it's outputted in all caps. So to show this a little bit better, let's write a more complex query that is going to prove that when you have a string, one of them being uppercase and one being lowercase, they are not considered the same thing. So let's go down a line, and what we're going to do is we're going to select a string, and we'll just make it say true. And where are we going to select this from? You guessed it. We're going to select it from dual. But now we're going to add another keyword in here, and that's the where keyword. And this is where we can put some kind of restriction or qualification on what the data needs to meet in order to be returned. So if you had a table that had bills, for example, you could return all of them that were greater than $500, for example. But in this situation, we're going to do something a little bit different. We're going to make a string, and we're going to put in here caps. And you can see the first letter's capital. And then we're going to see if that's equal to caps. Same exact capitalization, same exact spelling. So this is a comparison. Keep that in mind because in some programming languages, they will have 2 equal signs. But here we just want 1. There is not any kind of assigning going on here if you guys have practice with other programming languages. So what exactly is this entire thing going to do? It's going to return the string true where caps equals caps. And when is that? All of the time. So this is literally just going to output the string true. But this brings up another good question. How can we run just this section? There's some things barking. I'm gonna see if I can shut them up. Quiet! No, I think I just made it worse. So let's output this. So to run just this, we can highlight it, and then we can run it now. And you can see it returns true. And literally it just outputted this string. Yes?
What's going on?
Oh, I'm just making a video.
What are you yelling at?
I was trying to shut those things up. It didn't work. But now let's change one of these strings to lowercase caps. And now let's run the thing. And just to make it clear, I'm going to clear this out and then run it. Wow, no rows selected. It's broken. Ha. Yeah, so you guys get it. So this is not the same as this. Now another way, rather than having to highlight everything and then clicking one of these buttons, there's something known as comments. And comments can be used to kind of tell the database engine to ignore certain parts of our code. So right now I'm not using this line, so I can tell it, hey, ignore this. And the way you do that is with two minus signs. And you can see it changes colors. It's pretty. Yeah, so now I don't have to highlight this. I can just press this button and you can see it runs. That's one type of comment. Another type of comment is known as a multi-line comment. And the way you do that is with a /*// And then anything between these is commented out. So if I wanted to comment out this entire section, all I'd have to do is throw it inside one of these comments. So I could go like this and paste that up here. And then I could work on this one over here. So there. Now you guys understand spacing, capitalization, and comments. I think that's enough for this video. Let's move on, and I think the next thing we're going to do is start creating a table. So that's going to be pretty exciting, so be there or be square. And also, if you like these videos, do me a favor and subscribe and share them with all of your friends. Thank you, and I'll see you in the next video. Hey guys, welcome back to your Oracle SQL tutorial series. And I have a story for you. Well, I have been planning these videos for quite a while now, and I have been planning to record them tonight, and my family decides to watch a movie. So if you hear a bunch of people having fun in the background without me, I apologize. But it's okay, I'm not bitter or anything. Well, let's get started. This video is going to be about creating tables. And the way we do that is we use the create table command. Create table. After the table keyword, we give the table a name. So we're going to say users, because we're going to create a table where we can store people's names, usernames, and all of that good stuff. After this, you put parentheses. Inside of these parentheses is where you're going to put all of the columns that we want inside of this table. The columns are just the headers, so the first name would be a column and so forth. So the way my brain works is I like to do things in sections. So rather than doing one column at a time, I kind of do the name as a group, and then I do the data type as a group, and so forth. So what I'm going to do is just put all of the columns we hope to store in this table, and we're just going to give them a name. So the first thing I would say is a user ID. This is going to be the primary key once we get that far. And then on the next line, I will give the person a username. Following that, I will put first name and last name. Now this is not valid as is, but I did it this way so that way I know exactly what columns I need to put in this table. But we're not done, because every single column needs a data type. Data types are basically the kind of data that we store inside of this column. And there's a bunch of different data types, and it's a very extensive topic. But for this video, we're just going to focus on two very important data types that we're going to need to know to start working with Oracle. The first one is number. Number is often used for primary keys and generated numbers. The next data type is what's known as varchar, and that stands for variable character, I believe. Basically, it means a sequence of characters that varies in length. So, if I go down here and make a comment, within here I could put a string, such as Caleb Curry. I could make that my username. And I could also make it Caleb Curry, or Caleb Curry. The length varies. But what we do need to do is tell Oracle a max. So to do that, let me get rid of this. Come up here, and within parentheses, we can say how long we want to allow the string to be. So we'll put 50 in there. And we're also going to do that for the rest of them. Now, there's something weird about this data type, in that it actually ends in a 2. So you got to remember to put a 2 after the data type name. You may be able to work with varchar without the 2, but from what I've read, it's really recommended that you use the 2. And if you want to do some more research on that, I would encourage that. Now, I have a question for you guys. What does this 50 mean? Yes, I know it means how long the string can be, but 50 what? Is that 50 words, 50 characters, 50 bytes? Well, that's something we should actually tell Oracle. So after the 50, I'm going to say char, which means 50 characters. So that includes anything from a space, to a letter, to a number. In this situation, we would have 1, 2, 3, 4 characters. If you don't specify char there, it actually defaults to bytes. And a character can take up multiple bytes. So I always like to use char. We're going to add those into the other ones too. Now you can see we're getting some kind of error here. And the reason that is because when we have multiple columns, we have to tell Oracle where the different columns are separated. And the way we do that is with a comma. So when you put a comma, you're telling Oracle, I'm going to give you another column. So we do that for all of the columns except the last one, because the last one doesn't have a column coming after it. This here is a very good start, but it's really missing a lot of information. For example, how do we tell Oracle which column we want to be the primary key? What if we want to give it some indexes? There's just a lot of things missing in this create table statement. That being said, I don't want to overwhelm you guys with a bunch of new information all in one video, so we're going to break all that information up over a couple videos and just continually add to this and make our database bigger. One thing that you really need to try to take away from this video is to remember that the varchar data type ends in a 2. I know, it's stupid. Why would they end it in a 2? I don't know. Just a random 2. It's so dumb. Well, thanks guys. Once again, this is Caleb from Caleb the Video Maker 2. Thank you for watching, and I'll see you in the next video. Hey, what's up? It's Caleb from Caleb the Video Maker 2 in my spanking new attire. Hey boy, how are you? I know you guys are dying to know what we're going to talk about in this video. Well, we're going to talk about the details of Oracle constraints. I know we've spoken of constraints, but we haven't actually gone into detail of what the keywords are to make constraints. And we only really talked about foreign key constraints and a couple other things. So this video, oh, drop my chalk. Oh, got chalk on my brand new shirt. The goal of this video is to go over most of the constraints you're going to run into when you're working with Oracle Database. So what is a constraint? A constraint is basically a rule of what data we allow in a column. Another way to think about it is it forces the database to work or allow certain things. So foreign key constraints force a column to reference a row of another table or of the same table. There's also other kinds of constraints though, not just foreign key constraints, although that is one type of constraint. The first constraint is not null. This is when you command a column to always require a value. A null is the absence of a value. And something that kind of bugs me is when people say a null value, because it's like saying a nothing something. What? The second on the list is primary key. But you better not forget about that foreign key. Now these two you kind of get how they work because we've talked about it. I swear, my dog is silent all day until I make a video and then she's just like all over everything. You kind of already get how these work, but these are keywords you're going to have to use to tell Oracle that, hey, this is a primary key, or hey, this is a foreign key. The next constraint is called a check constraint. And if you haven't heard of this one, you should really check it out. There is another one we're going to talk about, and that's the unique constraint. Now another keyword you're going to run into, and I don't think this is technically a constraint, but I'm going to write it anyways. It's default. Now all of these should be in uppercase, but I didn't realize I was writing them in lowercase until I was already like here, and by then it was too much to have to rewrite. Now we're going to go through some of these and talk about some details so that way you know what each one of these means. We discussed not null, and unique should be pretty obvious. When you put unique on a column, it's saying that every single row has to have a unique value. So you couldn't have one row with a value 5 and then another row with a value 5. That would not work out. Primary key, is essentially the combination of not null and unique. That's because a primary key always needs to be unique so we can uniquely identify that row, and it always needs to have a value. Another thing for the primary key is that it shouldn't change. If you can design your database that way, that is a huge plus. The foreign key constraint tells the database that every value in this column has to match a value of another column. Oftentimes, the foreign key is going to reference the primary key, meaning every single row in that column has to have a value that exists in another table's primary key, or that table's primary key. So if you have this table and we have a couple values in it, such as 5, 6, 7, 8, and over here we have another table, and we need to put data into this, but we label the column as a foreign key, that means the value 5 would be acceptable, 6, 7, and 8 would be acceptable, but if you put something like 10, that's unacceptable. That's because this value doesn't exist in the column that we're referencing. This would likely be the primary key, and this would be the foreign key that you would tell it to reference this column. Now moving on to the check constraint. This one is actually really super cool, and I'm excited to get into this one in more detail in future videos. The check constraint allows us to restrict more specifically on what data we allow or don't allow. Think of it like this. The unique says, hey, they all have to be different. The not null says everything has to have a value. But what if we want to be more specific, like the value has to be between 10 and 100? That is where a check constraint might be useful for you, because you can say things like that. Essentially, we're going to give it a Boolean expression. A Boolean expression always evaluates to true or false. An example of this is if you had a banking application, you could make a minimum transaction, right? So let's say you're allowed to transfer money from account to account, but you have to do at least $5 or $1, it doesn't really matter, and no more than $1,000. So you could say something like between 1 and 1,000. And then you have to say what column, so you could say something like transfer amount. So I kind of running out of space there. But this is a Boolean expression. Is the transfer amount between 1 and 1,000? The options are yes, and if that's the case, it'd be true, and the data would be inserted. Or it could be no, which is false, and that's just not going to work out for you. Now the default keyword can be used very similarly. To continue on with our banking application, you could have it so when you create an account, the default balance of that account is 0. Now that you kind of get a gist of what all these do, how do you actually implement these in a database? Well, that's what we're going to start diving into in the upcoming videos, so be sure to check those out. Hopefully you guys are enjoying the series. It's a lot of fun for me. I'm really enjoying it, so please stick along and be sure to subscribe and, like all the videos and all those good things. It means a lot to me. So thank you, and I'll see you in the next one.
Hey, welcome back everyone to your Oracle SQL Developer tutorial. And where we left off in the last Oracle SQL Developer tutorial was we were creating a table. And we basically set up this structure, but we haven't done anything with it. Just to prove to you that it works, let's run it. Oh, I actually didn't run that ahead of time, so I was hoping it would work. Okay, so it's created. But let's say you want to go back here and, change something. Maybe you want this to be called user_name. Well, this is going to cause an issue, because when we run it, it says, oh, this already is used. So how do you get around that? Well, as you get into some more advanced SQL commands, you can actually edit tables that already exist. That's probably the recommended way once you really get into things. But when you're just learning, you can actually just delete this table and then create a new one. So to do that, I'm going to go up here and space this down. I'm going to use the command drop table and then put the table's name. Now, please don't try this at work. Okay, let's run it. Alright, so looking down here at our results, we see table users dropped, table users created. So you can see I actually ran 2 commands at once. And the way I did that was using this semicolon. This is known as a delimiter. It's the way we tell Oracle that what comes before it is a command and what comes after it is a command. If we had more commands, we could put a delimiter here and keep writing. Come on, of all times. Now that we have the ability to drop the table and re-add it, we can reconsider the table structure. Now, once you actually have data in your table, you're not going to want to do this because it's going to delete all the data and start you fresh. But for now, since we're just learning, it's totally okay. The rest of this video is going to focus on constraints. And just for simplicity's sake, I'm going to get rid of some of these columns just so we can focus on what's really important. So right now, we're just creating a table with one column, and all it is a user ID with the data type number. Now, if we want to add a constraint to this, we can just put a space and then put whatever the constraint name is. So we could say not null. That is an example of a constraint, and that one is going to force every single row to have a value for the user ID. But what if you want to add another constraint? For example, what if we want to make this user ID unique? Well, it's simple. You just put a space and you put unique. And there's actually not even any kind of order that you have to put these in. You could make it unique, not null. That's totally up to you. Now, when you throw constraints in after the column like this, a lot of people call these attributes. So these are attributes of the column. And in this situation, we are applying the not null and the unique attribute to the user ID. Well, this might be a good candidate for a primary key, because primary keys are always not null and they're always unique. So if we didn't want to do it this way, we could make it a primary key. But just let's try it and make sure it works. And you can see no errors are thrown. It works great. And we can go over here to our database, open it, click tables, scroll down to find our table. Ignore all these random tables that I was working with. Double click users, and you can see that we're forcing it to not be null, and it has to be unique. So that's kind of a way you can look at a table and see what constraints they have. Let's go back though. Instead of having the not null and unique constraint, I'm going to make this a primary key. And it's super easy. All you gotta do is say primary key. That's it. There we go. There's another attribute you might want to use for some columns. That's default. Now, I'm not going to give the primary key a default because primary keys, by definition, are all supposed to be unique. So if we defaulted to a value like 12, that would be stupid because then multiple rows would be trying to insert the value 12. So we're going to create a new column. I'm going to name this account balance. And you can just imagine this being for some kind of website that you have to pay money or something. It doesn't really matter. And we're going to make this a number as well. And then we're going to set a default to 0. So by default, the person has no money in their account. This is a good column to add the default attribute to. And you can see when we run this, it should work. Awesome. I confess, as I was studying constraints, I went to the Oracle Docs page, and I noticed that default is not one of the constraints listed here. And if you go back to this and go to your table and do a refresh, it doesn't show up as a constraint either. I'm not entirely sure why, because it seems to work the same way. My first guess is that it's not a constraint because it doesn't actually prevent you from putting any certain kind of data in. All it does is help you put data in case there's no data put in, if that makes any sense at all. But I'm not sure, so if anybody knows, maybe you could shed some light on that and let me know in the comments. What we've done in this video is actually really cool, but some people like to name their constraints. They want to be able to reference a specific constraint by name. Now, when you do this, you actually get a default name. If you go back to this table here, you can see that this is the constraint name, but that's not very user-friendly. So you can actually give it a name yourself. With the way we have things set up here, we can't do that. So in the next video, I'm going to be teaching you how to create named constraints. Be sure to check that out, and if you love these videos, please be sure to subscribe and share them with everybody in the entire world. Thanks guys, and I'll see you in the next one.
What's up everyone, welcome back to your Oracle SQL tutorial series. In the last video we talked about constraints, and I kind of gave you the simplified, easy version. It only takes a couple keywords, but it has its downsides. And one of the biggest downsides is that with that method you can't name your constraints. And a lot of people like to name their constraints, that way they can refer to them by name. So that's one goal of this video. The other goal is just to kind of think through the different ways of creating constraints. Because when you make them, it seems like there's so many different ways to do it. I'm going to piece it out very simple so that way you can know exactly what the different options are. Yeah, just got a $5 donation. Veronica, you are very sweet. I really appreciate it. We are going to start with a create table statement that looks a little something like this. So we have a table users and it has a column user ID and a data type of number. Now this doesn't actually have any constraints here, but we want to create a primary key. So the way you did that in the previous videos is you just add the keyword right after. Primary key. Pretty simple. So this is what it would look like. Now if you want to name the constraint, you have to type 2 extra words. I know, it's crazy. I can't believe they're asking that much of us. So within here, you're going to write constraint and then you're going to give it a name. So it'll look a little something like this. And we'll give it a name of users underscore PK for primary key. And I'm just going to continue this line on the next line. Yes, guys, I know my handwriting has not gotten any better over the course of these years. Probably never will be. So as you can see, it's basically the exact same thing, except it's totally different. You have these 2 new words here, constraint, and then the title or the name of the constraint. So far, we've learned 2 different ways to make constraints. These were both made at the column level. That means right after the column. And we had 2 different possibilities, one named and one unnamed. The other possibility is actually not at the column level, it's at the table level. And what that means is we basically take this entire constraint and put it in the table as if it was its own column. Now it's not actually its own column, but syntactically that's the way it looks like. We put user ID, number, comma, and then we put the constraint on a new line. So you can say that is created at the table level. I really recommend you take a look at this and memorize it so that way you can kind of understand 3 main different ways of creating constraints. From simple to complex, this is the easiest, unnamed, then this is medium, and then table level is the most complex. But a lot of people like to do it at the table level, so it really just depends on what you prefer and if you work for a company, what they prefer. So to do this, it's really simple. All you gotta do is take the command you have, bring it, you don't have to bring it down to the next line. Theoretically, we could just put a comma here since white space doesn't really matter. And then put parentheses after it. And you have to say what column you want this primary key to be on. Because we moved it down to the table level, it's no longer associated with one column. So we have to tell it so that way it knows. Because we can't just say, hey, make a primary key, and it's just supposed to know which column we want it to be on. So this is how you do it with a primary key. With different constraints, it's going to be slightly different, but you guys get the big picture of how there's mainly 3 different ways you can do things. So that's it, guys. We've broken through the conceptual gap that's needed to really write good constraints. In the next video, we are going to make a named constraint for our user table. That's going to be sweet, so we're going to get some more programming experience or databasing experience, whatever you want to call it. And that's just going to be fun, so if you really enjoy this series, please go on to the next video, click like, subscribe, share it with your friends, and all that good stuff. Thanks, guys. Really appreciate it, and I'll see you in the next one.
Hey, welcome back everyone to your Oracle SQL tutorial series. This video we are going to be talking a bit more about constraints, but I'm going to try and be a little bit more specific and a little bit more practical by actually applying these to a real table. So we already have this users table down here with a user ID column and a username column. And just for fun, we're going to go over the SQL to create this table. So we start with a create table command, and then we give it a name, and then inside of parentheses is where we put the columns. So we have a user ID, which is of data type number, and then we have a username, which is of type varchar2, and it has a total of 50 characters. So literally, we just created a table in like 20 seconds. Now, if you already have this table created, you're going to need to remember to run the drop table command. And what that's going to do is delete the table and all of the data in it. So be careful with this command. But for us, it's fine because we're just learning. So let's run this and see if it works. And it says table users created. But the problem is here, we literally don't have any constraints on this table, which that's bad. So let's go in and add some. We'll start with the username. We're going to add the constraint not null and also unique. And usually that's fine for those, just adding them in as attributes. It's when we get to the primary key and foreign key when people start to be a little bit more picky. And specifically, we often want to name our constraints. So we'll start without naming our constraint, and the way you do that is just saying primary key right after the column. This will work, but when we create this, and let's go to our table, do a refresh, and we'll go to constraints. Oh, it's gross. Look at those names. Oh, it makes me want to puke. That is just hideous. We do not want that. So to name our constraints, all you have to do is add the constraint keyword here and then give it a name. And by convention, we'll name it the table name and then underscore PK. Okay, so you can see here, there's the user's PK constraint. That is beautiful. Now there's a third way to do this, and usually this is the preferred way, and that's to add all of the constraints at the end of the table almost as if they're their own column. So the way you do that is just take all of this, and then you can just cut that, come down here, and literally add it as if it's its own column, but then inside of parentheses after primary key, you have to say what column you're talking about. That is the most complex way of adding a primary key, but often that's the way people want to do it. It's really up to you guys, but that's what I'm going to go for in this video. So let's run that and see how it works. So that was a quick rundown on how to add a primary key. In future videos, we'll get on to foreign keys, but for now, primary keys will do. So thanks guys, please be sure to subscribe and click like, and I will see you in the next video.
Yo, what's up everyone? Welcome back to your Oracle SQL tutorial series. This video, we are going to be talking more about foreign keys. Now I know we've discussed these a lot, but I really want to make sure we really grasp how to design these, and I also want to introduce a new topic to you guys, which is known as parent-child relationships. So that's the goal of this video. Hopefully by the end, we'll understand foreign keys, and hey, maybe they won't be so foreign after all. So as a reminder, a foreign key is just a column that forces every row to have a value for that column that matches a value in a different column. Often these will point to a primary key, but they can also point to a unique constraint column. So to best walk you through this content, we're going to think of a little example. We've been using a user table a lot just because it's really easy to conceptualize. Essentially, it's a table that stores information about different user accounts. And let's say we're building some kind of platform where people can make service requests. Now, what the heck is a service request? Doesn't really matter. Let's just pretend like it's for a software company, and if something's not working right, they can make a service request. That means we're going to have some kind of structure that looks like a table here for users and then a table here for service requests. And you can think of these as blueprints. These are kind of the formula on how to create instances. So the table has columns, and when you create an instance, you have to provide a value for each one of those columns. So an instance is essentially a row within a column. Now with foreign keys, if you have a row, like a service request, and it points to a user who created that service request, that's a great example of a foreign key. So just for clarity, I'm going to write the tables in here. What this all means is that a particular service request, it'll have something like a user ID column, and that column has to have a value that exists in the user's user ID table. Essentially, the service request needs a creator. That means it has to be someone in the user table. That's all that means. So what should we use for the foreign key? Well, it has to be either the primary key or a unique constraint. So just for fun, let's use a username. So let's say this is a system where every account gets a username, and that column has a unique constraint. So then we have a user, and we'll just give them a super mature, nice username. YOLO Swagman. So if we had a service request, and it had a username that referenced the users table, that user would have to exist. So we could have YOLO Swagman in here. And this would point to this username. This is the perfect example of a parent-child relationship. The foreign key is the child, and what it references is the parent. It's often helpful to draw this in like a up-to-down illustration. Here's the parent, and here are the children. Oh, how cute! What a family tree that is. So these are all service requests, and this is the user. And we're talking about specific instances. So this would be like YOLO swag, and this would be his 3 service requests. Now, I have a question for you. Looking at this picture, does the username column of the service requests table have to be labeled unique? I'll give you a second to think about it. Alright, second's up. The answer is no. That would not make sense, because that means we could only have 1 child per parent. And in this picture, that's not the case. These would all reference YOLO Swagman. That wouldn't make sense in this situation. Now we can do that if we want. If we did do that, we would only allow 1 service request. I have another question for you. Do children automatically have the not null column attribute for the foreign key? Think about it for just a moment. Okay, time's up. The answer is also no. Essentially what that means is that we could have an orphaned child. I know, it's sad, but that's how databases work. So in this situation, we have a service request from nobody. Nobody made this service request. In this application, this does not make sense. Any service request would need someone to post that service request. So even though we can have orphaned children, doesn't necessarily mean we should. We don't want to in this situation. So for that column, we have to think about what attributes we want to apply to that column. What constraints does it need? Well, we don't want it to be unique, but we do want it to be not null, because that means every single one has to have a parent. This seems very conceptual and maybe not super practical, but this actually does come in a lot. For example, if you try to break the rules of foreign keys, Oracle might yell at you and tell you you're trying to make a child to a parent that doesn't exist or something. I don't know like the exact words they use, but this will come up. All you gotta really remember is that the foreign key is the child. And I always try to think of it in this family tree kind of way, so it goes along with the whole family idea. But if you have a better way of thinking about it, go for it. It's all about what works best for you. So now we got the concepts down, let's apply this stuff practically in the upcoming videos. Thanks guys, please be sure to subscribe. I really, really appreciate that. See you guys in the next video, and don't forget to click like. Ahoy there, everyone! Welcome to your Oracle SQL tutorial series. This video, we are going to start designing a what's the goal of this video again? In this video, we are going to be designing a miniature database with the primary goal of applying what we know about foreign keys and how to design them. So we're going to start with, this is a simple thing, 3 tables, and we'll make some connections with some foreign keys, and we'll go from there. So what is the goal of our application? This database is going to power an application where people can create an account, sign in, and then they can make projects. So this is like a project management software. Imagine like Jira, if you know what that is. Essentially, you create an account, you make projects, and then you add people to those projects. So that's all it's going to do for now. So we're going to put the projects on this side. And we'll put the users over here. Can you guess what goes here? Yeah, it's going to be an intermediary table between projects and users. We'll get to that in a minute. First, let's talk about the projects table. This is just going to have information about the project, including a project ID, a reference to the user that created it, all that good stuff. And the way I'm going to be designing this is following the ERD pattern, which stands for Entity Relationship Diagram. Essentially, what that fancy word means is we're going to make tables as boxes, and we're going to list the columns down this way. And we basically just ignore rows. We're not going to care about what data is put in, because as long as we put the column and what's allowed, that's all that matters. So in the user table, we'll have a user ID, a username, first name, and last name. I'm not going to worry about data types for now. All you need to know is that if you have a foreign key, it needs to match the data type of the column it references. Now over here on projects, we'll have a project ID, we'll have a creator, which is a reference to the user. Now, this brings up the question, do we reference the ID or do we reference the username, I think? Yeah, do we reference the ID or the username? And it's ultimately up to you. I think it's kind of important to get experience with both referencing primary keys and referencing things that just have the unique constraint. So for now, I'm going to use the username, and I think that's going to improve our readability. But as we go on, I think what we choose will change. I'm just trying to get us all familiar with everything here. So creator is going to reference username. We'll also have a project title, and if I wanted to get real fancy, you could put in like a creation date and all kinds of junk like that, but that's really good for now. Now, what about this table? Well, the only other table we need is a table that lists what users are part of what projects, and that is a many-to-many relationship. That's because we designed it that way. A lot of this stuff you get to choose. For example, in this situation, a project can only have one creator. That's because it's a column inside of the table. If we wanted to where a project can have multiple creators, we would need to take that out into a separate table and name it like project creators, for example. But when it comes to the users that can join a project, I'm making that a many-to-many relationship. So what that means is one user can join multiple projects, and an individual project can have multiple users. The way we design that in database design is using two one-to-many relationships. That calls for an intermediary table. Now the intermediary table name, by convention, is just a combination of this table and this table. So you can pick one to be singular and the other one's going to be plural. So we could have project users or we could have user projects. I think it makes more sense to have project users, so that's what I'm going to go with. And this is going to have two columns, a project ID and a user ID. And these are both going to be foreign keys. Now you see in this situation, I decided not to use the username, but I could have if I wanted to. In fact, I could have used the project title here instead of the project ID. But then that gives you the limitation of that they have to be unique. Now let's figure out which tables are the parents and which ones are the children. The users table is going to be the parent. That's because it has no foreign keys. You see all the arrows point to the users table. Now the projects, that's the child of the users because you see it references the username. Now the project users table, that's a child of both of these tables. So I guess if you had to draw it out, you'd have this being the users table, this being the projects table. That's a child of the users, and then we'd have project users down here, which is a child of both of them. The next thing we want to do is ask the important questions about the foreign keys. Let's look at all the foreign keys we have here. We have 1, 2, 3. So we need to ask at least 2 questions for each one of these. So let's start with the users table and kind of move down the family tree. So we'll go to its child and we'll start at the projects. And we'll look at this foreign key, creator. Should it be unique? The best way to think about this is to ask, what would it be like if it was unique and what would it be like if it was not unique? If it's unique, that means within our table, we have a column and it's a creator. We can only reference a specific creator one time. So if it's 7, that means that's the only time that creator can be in the projects table. Personally, I don't think that's a great idea because essentially what that is saying is that a person can only create one project. That's up to your business decisions on whether that's a true statement or not. But in this situation, I'm going to make it to where a user can create multiple projects. So it's not going to be unique. Now, is it going to be not null? Well, if it is null, that means a project can exist without a creator. And I don't think that makes a whole lot of sense. So I'm going to say not null. And we can look at these IDs, and if you want, you can go through the whole process. But I've come to the conclusion that this is going to be the same for all of the foreign keys here. Because we're not going to want to make it to where a person can only join one project, or a project can only have one user. That stuff doesn't make sense. And it also doesn't make sense to have a project with no user inside of the project users table. So obviously you want it to be not null. Hopefully that wasn't a little too quick for you guys, but hopefully you guys get the point, and just it's really important to really think through this stuff. Like, a lot of effort can be saved now by working harder on the design and the engineering of the entire solution rather than rushing through it and just pooping on a database and trying to get out good data. Structure it, and then your data is going to work out. I know it's a lot of extra steps, but it's worth it. So thanks, guys. Really appreciate everything you guys do. Thanks for watching these videos, liking them, and ultimately, I really appreciate you subscribing. Hey, welcome back, everyone. This video, we are going to be starting a small project for projects. So I really highly recommend you watch the previous video, but if you're stubborn, essentially what we're gonna do is create a small database where you can have users and then projects that these users create, and then they can add users to those projects. So essentially a project management software, but very simplified. So to start off, this is the table we have. It's just a user ID, a username, and a primary key of user PK. This video, we are going to be creating another table and creating a foreign key on this table that references the users table. So to begin, we just follow the same pattern we have up there, create table, and we'll name this projects. And then open up some parentheses, and this is where we're going to put our columns. So first, let's put all the names of the columns we're going to use. I think this one will have 3 columns: a project ID, a project title, and then a creator. And the creator is going to be the column that references the users table. So let's start. Project ID, project name, and then creator. Now we need to give them data types. So I'm going to give the ID the number data type. The project, I'm going to give varchar2, and then that'll be 50 characters max. And the creator, this one actually has to match whatever we're going to reference. So if we decided we wanted to reference the user ID, we would want to make it of data type number. If we want to reference the username, we would have to make it varchar 50 characters. And that's what I'm going to go with for now. So I'm going to say varchar2, 50 char. Awesome, so we have our columns. Now we just have to worry about what constraints we want on these columns. The first one I would say is we're gonna make the project name unique, and that's just to kind of prevent confusion. That way there's not 2 projects with the same exact name. Now the creator column, that's the one where you have to think a little bit more on whether it's going to be not null or unique. And we talked a little bit about this in the previous videos. For unique, if we said unique, that means there could only be one instance of a specific creator in that table. That means one person could only create at max 1 project, and we don't want that, so we're not going to put unique. But we are going to put not null because we want to make sure every single project has a creator. Obviously, that would make sense. The next thing we're going to want to add is the primary key, of course. So let's do that by adding it as a table level constraint. And then we'll just name it projects underscore PK, primary key, and then in parentheses, we'll just put the column name, which is project ID. Also, don't freak out if you don't have all of the keywords memorized. It comes with repetition. Oh, and it's also right up here, so, you know, I may have cheated a little. Now, the real question is, how do I tell Oracle that I want this column to reference the username column of the other table? And just like with the primary keys, there's different ways of doing this. We're going to go over all 3 so that way you get a full picture, but then you can choose whichever one works best for you. The first and the easiest is doing it at the column level, unnamed. So to do that, we're going to go to the creator column because that's the one we want to mess with. And then in here, all you have to do is say references, and then say the table you want to reference, users. There's only one problem. It doesn't know intuitively which column you want to reference. So you have to tell it inside of parentheses. So we're just going to say username. And make sure you spell it right too. So let's run this, make sure everything's right. Okay, we got an issue. What is it? I think it's because I forgot a semicolon. All right, let's try this again. There we go. We created the table. We're going to edit it though because I don't want to do our constraints that way. So for future, I'm going to add the drop table projects up here. So that way I can just continue to create the table over and over again until I get it perfect. The next way we want to learn how to create constraints is at the column level, but we want to name it. And if you remember when we made the primary key, all we did was after the primary key column was say primary key, and then we added into here, we said
constraint and we gave it a name of users underscore PK. It works very similar with foreign keys. So I'll show you. Let me get rid of this and we'll come down here to our foreign key column right here and we'll just add in the keyword constraint and then we'll give it a name of projects underscore users underscore FK. And you can pick up your own naming convention, but essentially what I did here is said the original table and then the table that it's referencing, which works for now, but it is problematic. For example, if we have 2 foreign keys referencing that table, but you know, that's for another day. We'll run this, make sure it works, and you can see it was created. And we are getting some issue up here, so let's look at that. So I believe the issue is that we are referencing the users table from the projects table. So it's not going to let us drop the users table. So the trick to this is we just need to switch these around. Boom. Then we'll run that and boom, there you go. The third way is a little bit different than the way we did with the primary key, but it's not a substantial difference. We are going to take this entire thing and we're going to cut that and put it as basically its own column in this table. But we're not going to add parentheses after the name because they're already there. We have to go back here and say what column we're starting with and telling it that it's referencing this. We also need to add the foreign key keyword. So as you can see, there's a couple differences between the two and you're just going to have to become more familiar with them over time. I too am still learning these. And then we're going to throw in the column that we're starting with. So that would be the creator column. So let's go creator. All right, let's run this, make sure everything works, and now I didn't break anything. Okay, all the tables are created, and it seems to be working just fine. Now, as for creating the table, it seems like we know our way around pretty well. But what happens when we put data inside of these tables? For example, we add a user, and then we add a project that references that specific user. And then we want to go back and delete that user. Well, now what happens to the project that references that user? That is a big thing we have to learn about, and essentially that's going to bring up the command on delete. So you can add the on delete command to our foreign keys to tell it what to do in those awkward situations when stuff like that happens. That's what we're going to be talking about in upcoming videos, so please be sure to subscribe. I think you guys will really appreciate the new content, so thank you so much, and I will see you all in the next video. Hey guys, welcome back to your Oracle SQL tutorial series. This is Caleb from Caleb the Video Maker 2, and in this video we are going to continue our discussion of foreign keys, constraints, and what they are supposed to protect us against. So the first thing constraints are supposed to protect us against is incorrect or invalid insert statements. So for example, in this users table, we have a unique constraint. So that means if you try to put a username in there that already exists, you're going to get an error. So let's just show how this works. So I already have both of these tables in existence, and we're going to run an insert statement. If this is your first time learning about inserts, congratulations. But it's really simple. All you got to do is say insert into, and then say the table. So let's say projects. And then all you do is say values, and then in parentheses, you pass in the values separated by commas. So we just have to make sure we match the data types. Numbers are always just plain, no quotes or anything like that. So we could just say 24, 23, whatever. Then a comma, and then inside of quotes, the project name. And then finally, we need to say the creator. And that's going to be the creator's username because that's what the creator column references. So that means we need to pass in the username inside of quotes. So in here, I'll just say created by Caleb Curry. And then we'll highlight this entire thing and run it. And you can see we get an error. You see it says integrity constraint violated, parent key not found. And what that is saying is that we tried to make a project and assign it a creator, but that creator does not exist. These constraints work really well at protecting us from invalid inserts. But the other thing they need to protect us from is invalid deletes. Now, how does that work? Well, by default, you're just going to get an error if you try to delete something that violates a constraint. And let's go through an example that shows this. We're going to keep this insert statement for the projects, but first we're going to create a user. Insert into users values, and then we'll just fill in those columns. The first one, the user ID, we'll go with 1, and then we'll give them a username of Caleb Curry. Put a semicolon so we can run both these at the same time. Hover over all of it and run it. And you can see in here, both rows were inserted. So if you wanted, you could go look in the table and see the data. So I already have the users table open. You can click data, and you can see we have user ID of 1 with the username Caleb Curry. But we don't need this for right now, so I'm just gonna drag that back down. Now, let's be mischievous and delete stuff. So to do that, we need to use the delete keyword. So we're gonna try to delete the parent, Caleb Curry. We need to use the from keyword, and then we need to say what table. Users, and then we need to use what's known as a where clause to specify which users we want to delete. So we'll say where, and then we'll say, let's go with the user ID equal to 1. So that's going to delete the user who has the ID of 1. Let's run it. And you can see we get an error. It says attempted to delete a parent key value that has a foreign dependency. So you can see it's not even going to let us delete the content from the table. And that's pretty good by default. But what if you want to configure some stuff? You can actually do that. And to do that, you need to use the onDelete keyword when we define our foreign key constraints. So we're done with this insert and delete. So let's just get rid of that. Let's go back to this projects table. And after the foreign key constraint, let's add the keywords onDelete. Then you need to say onDelete, what do you want it to do? The first option I'm going to explain is set null. Essentially what this is going to do, that row's creator column is going to become null. That might work in some situations. In this situation, it's not going to work super well because we have it labeled as not null. So when would you want to do that? The best time to make it set null is if the long-term survival of projects is important to you. If that user deletes his account, well, the project is still going to exist, it's just going to be creatorless. What is the other option, though? The other option is called Cascade. What this is going to do is also delete the child. And yes, this can get very dangerous because 10 years from now when you're working with your data, you try to delete something and that delete cascades through your database like a virus, deleting all kinds of stuff. So you need to be very, very careful with the onDelete cascade. In all honesty, the default is probably the safest route because it's basically going to prevent you from deleting anything because everything's connected. But that gets really frustrating because then you always have to find the child of the child of the child and then delete up the tree until you get to the parent. So it can get a little frustrating. In this situation, we're going to go with Cascade because we want it that if the user deletes his account or he gets banned or something stupid, then the project is just deleted. We don't want it to be in existence anymore. Whether you want your app to do that, that's up to you, but that's what we're going to go with in this situation. So first, let's delete that table. So we'll hover over this and run that. And then finally, let's create that table again. So it's created. Everything seems to be working. And now when you delete the parent, that change will cascade down and delete the project. So hopefully that was useful for you guys. If you guys have any questions, be sure to leave them in the comments. I will try to help you out, or if anyone else knows the answer, I'm sure they'll try to post something. If you like these videos, please be sure to subscribe, click like, and continue watching. Thanks, guys, and I will see you in the next one. Hello, everyone. Welcome back to your Oracle SQL tutorial series. This is Caleb from Caleb the Video Maker 2. We are going to be continuing our little project that we're working on. So far, we have two tables created. We have a users table and a projects table. This is great and all, but it's very limiting. That's because you can only create projects, but you can't add anybody to these projects. How useful is that? Not at all. So if you go back a couple of videos, you'll find a video where we talked about the design for this project. And we were going to have a project users table. So essentially it's a table that says what users are a part of what projects. So if you're thinking of the workflow for our project, a person would create a project, invite all their friends, and then those friends or whatever could join the project and be a part of it. Or they could be assigned to it. So since I have all of these other tables, I'm just going to comment those out by going to, I don't even remember, source, toggle line comments. Now let's focus on creating that other table. So let's say create table and we'll name it project users. And what columns are going to be in this table? it's literally only going to be 2 foreign keys. So the first one is going to be the user ID, and then the second one is going to be the project ID. Now, in the previous videos, I talked about naming the constraints, but we're actually going to put a giant primary key on top of both of these combined. So I'm going to be a sinner for a moment, and I'm not going to name these, but don't tell anyone. It's a secret. So to do that, we're just going to say references, and it's going to reference the users table, and the column it's going to reference is the user ID column. Beautiful. We'll do the same for the project ID, but it's going to reference the projects table and the project ID. And I should probably learn how to spell references. I thought I got an A in spelling one time, but then I realized that A is actually an F, which makes sense why I got that grade. Okay, sorry, that was really, really lame. So here we have our extremely unprofessional, unnamed foreign keys. But now we're going to add a primary key on top of these. But we're going to do that at the table level, so that way we can, make up for our unprofessionality. So to do this, we need to use the constraint keyword. And now we're just going to name it the convention we've been using, the table name, followed by an underscore, followed by PK. So it'll be project underscore users underscore PK. We need to say that it's a primary key, and then we need to say what column that primary key is on. Now, this is one of the benefits of using table level constraints, because you can actually pass in multiple columns here. So the first one, it can be user ID, and then the second one can be project ID. And what that is saying is that the combination of these have to be unique. So multiple rows can repeat the user ID, for example, and multiple rows can repeat the project ID, but the combination has to be unique. This is also going to index the combination of these columns. So we're getting like 2 great things in one line. Wow. So let's run this command, see if it works. Okay, there's something broken, and I forgot to add a comma right here. So always remember, when you add the constraint at the table level, you need to throw it in there as if it's another column and add a comma to the previous columns. Let's give this another try. Okay, you can see down here that the table was created. So we got this table created. It's nice, it's beautiful, but the thing is, if we ever try to delete a user or a project, Oracle is just going to bark at us and tell us, no, it ain't happening, man. That's because by default, when you try to delete a parent that is being referenced by a foreign key, it's going to throw an error. And what that means is we need to add the onDelete keyword. So to do that, we need to go over here and say onDelete, and I think I'm going to use cascade. And while I'm at it, I'm also going to add the constraint not null. That's because there should always be a value for this column. Same for the project ID. And onDelete, we'll make this one cascade too. Essentially what that means is if a user gets deleted, it's going to delete all of the rows in this table that reference that user. And the same for projects. If a project's deleted, it'll delete all the projects in this table that reference that project. And you can see how this gets pretty dangerous when you're always cascading things, because it'll just delete everything, as I mentioned in the previous video. So please be careful with this. So before we can rerun this command, we're going to have to drop the table. So we'll say drop table project users. Add a semicolon, and we can just run it. All right, so you can see the table was created. Now real quick, let's insert some data and see what happens when we delete things. I'm gonna write out the SQL and you can copy it if you want. That's because I don't really want to distract from the purpose of this video. So first off, I was messing around with this, and to clear out the tables, I run these commands. But we're not gonna need those for now, so I'm just gonna get rid of those. The first thing, we're going to insert 2 people into the users table. We're going to insert a project, and then we're going to insert a project user. So we'll start with the first one and we'll just run these one at a time. So we got that row inserted, got that row inserted. All right, so this one caused an error. What's up? Oh yeah, that's because we referenced the username, not the ID. So I need to pass in the username here as Caleb Curry. There we go, we got that one. And finally, let's create a project user. Okay, we also got an issue here. Let's see what this is about. Oh, that's because I put the columns in user ID, project ID. I'm going to flip those just to make things a little bit more clear. It makes more sense to have project user since the table's project users. We'll need to drop that table and then recreate it. So let's try this again. Oh, finally, we got that working. Now, if you want to actually see that data, you can run these select statements. And I'll extend this so you can see everything. So here's the first table, the user table, the project table, and then the project users table. And now, the moment we've all been waiting for. Let's delete a project and see what happens. Done, done, done. Oh, there's an error. Okay, let's add the project underscore there. Totally didn't make that mistake. Done, done, done. One row deleted. No errors. But now if we go back to this project users table, let's run this command. And you can see there's no rows to return. So it just deleted it. Doesn't even care. So overall, we have a pretty good structure for our database. The only thing we should consider is adding some indexes. And that's what we'll be discussing in the upcoming videos. Please keep at it. Click like, subscribe, and I will see you in the next video. Welcome back, guys. In the last video and throughout this series, we've been working on this database. Essentially, we have 3 tables that allow us to have a very miniature project management database. Now, what's wrong with this database? Well, overall, I think it's pretty beautiful, but there are some things we could improve, specifically indexes. As we've spoken about before in the past, the only columns that are indexed by default are the primary key and any columns with the unique constraint. So each table here has a primary key, the user ID, the project ID, and the combination of the user ID and project ID down here. As for unique constraints, only the username and I think that's, nope, the project name too. So those are all going to get indexed. But I also mentioned before that a column you should consider indexing is any foreign key constraints. That's because they are not indexed by default, but they're so commonly selected and used in joins that you should almost always index them. So the creator column is a foreign key that references the username up here. But the problem is it's not indexed. So this might become a bottleneck when we're doing select statements. So in this video, we're going to take that column and add an index to it. Now this is actually separate from creating the table. So we don't actually have to have all this stuff here still. So to create an index, yeah, it's pretty crazy, but we use the create index command. I never would have thought of that. And then you give it a name. We'll name it the table underscore column underscore IX for index. So we're doing this on the projects table, and we're going to grab the creator column, and we'll just use IX for index there. So we create this index, but we have to tell it what column and what table we want it to be a part of. Because this is not part of the create table statement, it's not just going to know by default which table we want to put it on. So we need to say on and then specify a little bit more information. So the first thing we want to give it is the table. So we're going to say projects. And then the next thing inside of parentheses is the column. And this is going to be on the creator column. So let's run this, see if it works, make sure I got all my syntax right. And you can see we created the index. Beautiful. Now this doesn't apply in our situation because our column is not labeled unique. But if it is labeled unique, you can actually create a unique index and you just add the keyword unique right after the create keyword. But once again, that's not needed, so I'm just gonna obliterate that. And now I'm going to move on to teaching you how to actually delete these indexes once they're made. So if you want to delete an index, it's super easy. Kind of like dropping a table, you just say drop index instead. And then you just say the name of the index. There you go. So let's run this, and you can see it'll officially delete our index. I thought giving you that little extra information might be useful in dropping the index in case you need it. But for now, I'm actually going to recreate that index so we have it. That's how you add an index to a column. Unfortunately, I still think there's a potential problem with our database design. To show you that, I'm going to go back to the create table statements and I will point it out to you. So I'm just going to undo it all. So here we are, back at our create table statements. The problem here is in the projects table. We have a creator column, and this creator column references the user's username. Well, in this situation, the username has to never change. And if you're wondering why, that's something we are going to dissect in the next video. So everyone, please be sure to go watch that video. Click like on this video and be sure to subscribe. Thanks, and I will see you in the next one.
What is up, everyone? This is Caleb from Caleb the Video Maker 2, and we're going to be learning something new today. We are going to be learning why primary keys should never change. So with the database structure we've been using, we've had a user table that has a username column that is referenced by other tables. But it's important that nobody updates their username. Why is this? That's essentially what I'm going to try to answer in this video. First off, what does happen if you have a username column and someone references that as a foreign key and you try to update your username? Well, it's simple. Oracle just throws an error and doesn't let you update it. Not a problem. Nothing breaks, nothing explodes, it just doesn't run. The problem in this, though, is that now you can't change your username. This really depends on what your application does, what its purpose is, but maybe not changing your username is a good thing. Some applications allow you to change your username, others don't. But if you're referencing that username as a foreign key, you want to design your app to where you cannot update your username, because it will cause errors. For those who appreciate a visual, this is what it would look like. We have a username column that references the username column of the users table. Now, we have a user who tries to change their name. Now, some database systems have something called onUpdate, and then we could say cascade, and this works very similar to the onDelete. Essentially, if the person updates their username, the username in this table is also going to update. Unfortunately, Oracle does not have this. So there's not a real super easy way to do something like this in Oracle. That's why I'm stressing it so much that if you do this, you need to make it to where the username does not change. But just to tickle our brains a little bit, let's imagine Oracle does not care and doesn't throw any errors. Let's figure out what would happen. So in the projects table, I actually named this wrong here. The table that references the username is the creator table. The name actually doesn't matter. It doesn't have to match the column, so it's not a big deal. But let's say we have a creator, and his name is Seeker7. And that obviously has to match a user in the users table. But then Seeker7 is all like, you know what, this name's stupid. I'm gonna change it. And he changes his name to Seeker7. But this one doesn't update. Now we have the issue that we have a project created by some mysterious user who doesn't exist, because there is no such thing as a Seeker7 inside of the users table. Even worse, there might be another guy who realizes this Seeker7 is the creator of this group or this project. And then he updates his username to Seeker7. And now he has admin rights to do whatever he wants in this project. See the problem there? That's why a lot of people lean on the side of using surrogate primary keys and only referencing those with foreign keys. So if we wanted to do that, all we would need to do is have a user ID, and instead of having a creator, we'd have a creator ID. And instead of having a username here, we just have a number. And then this Seeker7 with the ID of 7, he can update his name to Seeker7, but his ID still stays the same, and this connection isn't broken anymore. That is something we can do in Oracle, and this is no longer in our imaginary world where Oracle doesn't care. This actually does work. That's why you often see something like creator ID referencing another column in another table. As a rule, primary keys should never change. So don't make a primary key that's going to change. The username, if you can change it, it would not be a good primary key. The user ID is perfect because it's just an arbitrary number that the database picks. It doesn't have any real world meaning. So primary keys never change. Now I'm going to ask you a question. Is it appropriate for foreign keys to change? I'll give you a second. The answer is yes. Why though? Well, in this situation we reference the user 7. If we were to change this, let's say to 8, the only thing now is it no longer points to this person, it points to someone else. So this is actually a good thing because it allows us to change things in our child table. So for example, if this person wanted to give off the project to someone else, he might assign some other guy as the creator, and then he could delete his account or whatever. You know, it's really flexible on how this applies, but yes, it is appropriate for foreign keys to change. But if it's talking about one person or one entity, then it should never change. So let's go back to 7, for example. In this situation, as long as we're talking about this person, this should never change. The only time this should change is if we change the entity we're talking about. So from what I've said, it seems like it's always the best idea to have foreign keys that reference an ID. But there's also a lot of downsides. If we have a project's user table, which just lists all the users in specific projects, it might look something like this. The way we would get this data is something simple like select everything asterisk from, and then put the table name, which in this case would be like project users, for example. This is super easy to get this data. But if we get rid of the foreign keys that are nice and easy to read and replace them with IDs, this is going to say something like 5, 5, 12, 83, 72, 83. And we're no longer going to have this. That means what we're going to have to do is join these with the other tables and say, where do these go? And then we're going to have to create a really complex select that has joins. So that's the biggest consequence in my eyes. So the question is, which one do you choose? Choose wisely, my friend. The ultimate decision is up to you, but please choose wisely. Thanks, guys. Please stick around for the next video. Be sure to subscribe, and I will see you next time. Hello, and welcome back to your Oracle tutorial series. Now, it has been quite a while, so let me just kind of give you a refresher of what's going on my channel. Well, I decided I'm going to make Oracle videos, MySQL videos, and SQL Server videos, and kind of turn it into a competition. And the competition starts with video 23, which is this one. So if you like Oracle, be sure to click like and watch all of these videos in this series, because the winner is going to get an extra 50 tutorials. Woo! Alright, so let's get started. What are we going to be talking about now? Well, we are going to start talking about Oracle data types. All of the data that we store in our tables has to have a data type. Now when we create the table, we put the data type after the column name. What is a data type though? Why do we have to put that information there? Well, put simply, just look at the name here. A data type is the type of data. Rather than just saying data, we classify it into a certain type. That way the database has a better knowledge of how to work with it, how to store it, how to optimize storage and speed and all of those things. So by having data types, we're able to improve our database. In addition to improved performance, data types also help us reject incorrect data. For example, you might have one column that has a data type, and someone might try to insert some data into that doesn't fit that data type, and it will get rejected. By telling a database what type of data we want for a column, we're able to restrict garbage and keep that crap out of our database. Onyx, can you chew later? Chew. That's so gross. Now, to help us study databases, they are often categorized. You know, we always got to make categories. There are 3 main categories. There are some additional ones, but the 3 that I'm going to discuss with you now are the most important and the most common ones. Then the other ones are used occasionally, so we'll discuss those later. So let's start with the main 3. Numeric, string, and temporal. If you are not super familiar with these words, you could say numeric is numbered data types. String is alphanumeric, which means characters and numbers. And then temporal is time spans and dates and times. So these ones have to do with numbers, something you would do math with. String has to do with characters or a sequence of characters, so anything inside of quotes. And then anything dealing with time is temporal. Now in each one of these categories there are some different data types, so in the upcoming videos we're going to discuss those in more detail, but this video is kind of just to get you a rough overview, so when we start talking about them you're not like, what? What? An important thing to know is that each one of these is known as a character. So this is a 5-character string. Other examples of characters are numbers, symbols, as well as letters from other languages. So characters go inside of string data types, but numeric data types only take numbers. So these are pretty good categories, but there's one extra thing that I wanted to mention before we move on to the next video, and that has to do with storage. That's because one thing that all of the data types are going to have in common is they all take storage space. They take up space on our computer or our server, and us as database people have to figure out the best way to store these so they take up the least amount of space. I'm not going to go over all of the details on how to do that right now, but just something to kind of keep in the back of your brain is to use the amount of space that is enough to store what you need, but don't store any more than that. So for example, if you're storing a string, make the size of that string column as small as possible to store what you need. For example, if you're storing a phone number, there's no need to make the column able to store 300 characters because a phone number is only like 10 to 11 characters or something like that. You'd think it wouldn't make such a huge difference because we're talking about character data, it's not huge file sizes. But when we're talking about the difference of 1 byte across millions of rows, the difference becomes substantial. If you are unsure on how to size something, size it on the larger side of your unsurety. You wouldn't want to make it too small and then later have to figure out, oh crap, how do I change this? So yeah, aim bigger than smaller if you're unsure. That's all for this video, guys. Hopefully this next section of videos is going to be real helpful for you guys. Thank you for watching, and as always, I'll see you in the next one. Hello world, this is Caleb from Caleb the Video Maker 2. Last night I had this great idea on how I was going to grow my YouTube channel, and I could not sleep for the life of me. So I'm a little cranky today, so you better not get on my nerves. You understand me? You understand me? Okay, where was I? Data types. Now I decided I'm going to cover data types in some pretty good depth for Oracle. The reason being is that data types are foundational to creating good quality tables. In addition to that, I am trying to go in a lot of depth with this series so that way you have a more deeper understanding of Oracle and not like, super shallow. I know how to create a basic table and blah blah blah. That being said, I'm not going to bore you with all of the details. If you want to know super depth, you can read the manual or get some books or something like that. My goal is to teach you concept. So I want you to understand concept in depth. Because I'm teaching you in depth, there's a chance the important stuff gets lost in the details, and because of that, I decided I was going to create this video. So this video is your shallow overview of the most important data types. Why though? Why don't we just go in each one in depth? Well, that's because I want to give you the most important ones you're going to be using, and then if you know like, oh, this is the data type I need to use, then you can go in the upcoming videos and you can learn more details about them or research it online. By the end of this video, you're not going to master data types, you are going to know the bare minimum required to create basic tables. The first data type, one we've actually already discussed, is number. Oh gosh, that was disgusting. Oh, now, number. It's used to store numbers, as you may have guessed. We have been using it to store integers. So when you have integer data or just int data, this refers to whole numbers. That means no decimals. But numbers can actually store decimals too. So number is the data type you want to use if you have whole numbers or numbers that you need very good precision with in math. For example, if you're working with finances, the chances are you are going to want to use the number data type. There are two other data types that work similarly, but they're a little bit different. And these ones are used for data that have numbers, but not numbers that have to be exact. So for example, if you're working with math of money, you want it to be exact. You don't want to gain a couple pennies or lose a couple pennies or whatever currency you're in. You want it to be exactly the number you're expecting. Well, sometimes it's not that important. For example, you might have a number 5.98734 and the farther you go this way, the less important the exactness of the number is. For example, if you're measuring the distance from here to over there and your answer is this many feet, do you really think it's going to be any different if the number turns out to be like this? The chances are probably not. That's because the difference between this and this is so small. So if you're working with that kind of data, there are two data types that'll fit your situation perfectly. Binary float and binary double. You can use either of these data types if you're in the situation where you don't need absolute exactness when you're talking about far down the fractional side of the number. What are the difference between these two though? This one is going to have more precision than the float. So if you need high precision far down, you will want to use binary double. If you don't need quite as much precision, binary float might work just fine. We'll go into the depths of how many decimal places will work for each of these and all of that in a video in the future. But just know what data types you need if you need something like this. All of this is great if you're storing numbers, but you don't always want to store numbers in a database. Sometimes you need to store string data. The first two data types we are going to cover in the string category are char and nchar. These are both what's known as fixed length data types. That means if we make a column of char that allows for 50 characters, every single value for that column is going to be 50 characters, even if you store less than 50 characters. So if you put something like hi inside of a 50 character char data type column, it's actually going to store 2 characters, 1, 2, and then 48 spaces. And you can see how that could be a bad thing. The two data types for variable length are varchar2 and nvarchar2. The difference here between the previous two data types is that these are variable length. And what that means is you could make a column varchar2 of 50 characters, and if you only store something like hi, it's only going to store 2 characters, not 50. There are a couple more data types I want to give you, but I'm not going to talk about these ones in a ton of depth. That's because there's a lot to them, and that might take another video in the future, but I will still introduce both of them to you. So I'm going to erase this and then we'll discuss those. These can both be used to store a date and time. For some database systems, date will only store the date, but for Oracle, date actually can include the time as well. As for the difference between these, I decided we'll cover that in another video, but just know if you need to store something that has to do with dates or time, you can use one of these. There's also interval data types, and this will allow you to store data like 2 weeks, so an interval of time. So once again, those are some of the most important data types you are going to come across when you're working with Oracle. Hopefully that was helpful. If you've liked this video, please click like and help the Oracle videos win the competition, because right now they're losing. Be sure to like this video and watch the next video, and I'll see you then. Hey, what's up everyone? It's Caleb from Caleb the Video Maker 2. This video we are going to be talking about UTF-8 and UTF-16 for the Oracle Unicode character sets. Now these are examples of encodings. There are multiple options for Unicode character sets when it comes to the encodings. These are just 2 of them. There are a couple of other ones, but these are 2 of the most commonly used ones, especially when it comes to Oracle database. Now the very first one I'm going to be talking about is UTF-8, which is an example of a variable length encoding. What this means is that when we are determining how much room a character takes up on a computer, it depends on what character it is. An individual character, at minimum, will take up 1 byte. A bit is the smallest thing a computer can store, and a byte is 8 of those. Now, some characters are going to take up 1 byte. That's because we can only store so many characters in 8 bits. After that, the characters are going to take up 2 bytes, which means it takes 16 bits to express that character, and so forth. So it's going to go to 3 bits when it runs out of room for that, and then 4 bits. So to give like a 30-second crash course on storage, a bit has 2 states. You could say on or off, and some people will say 1 or 0. So if you have 8 bits, you would have something like this. You can see 1, 2, 3, 4, 5, 6, 7, 8. And then this can be interpreted as some character. Now if you want to know how much storage that really is, you can compare it to some storage sizes you know of. So for example, 1,024 bytes is 1 kilobyte. 1,024 kilobytes is 1 megabyte. 1,024 megabytes is 1 gigabyte. 1,024 gigabytes is 1 terabyte. 1,024 terabytes is 1 petabyte. So when you buy a 1 terabyte hard drive, you can store a crap ton of bytes. That being said, when you have a string, it can store a lot of characters. You could put thousands of characters within a quote, and that can actually add up to a lot of space when we're talking about millions of rows. That means optimizing storage when it comes to strings is pretty important. Not so important when you're working with a small database, but when you're working with huge databases, the difference between 1 byte per character can make a ton of difference. And what I mean by 1 byte per character is that some encodings will always take 2 bytes per character. In that situation, even if you have a character where UTF would only use 1 byte, it's going to use 2 bytes. So imagine something like this. It might not be exactly like that, but essentially we have 16 bytes, but only 8 of those are being used, and it's a waste of space. Now, if you think back to when we created a table and we had data types, we did something like this. And then inside of parentheses, we put 50 char. The reason we put char here is a little bit more clear now that we've talked about encodings. That's because some characters could take 4 bytes, for example. So if you're expecting something like 50 characters, but each character takes 1 to 4 bytes, you're not going to get 50 characters in some situations. Some situations you may if all of the characters only take up 1 byte. So for example, if you're using English, the chances are you're getting 50 bytes, but the chances are that's still going to be 50 characters. But if you're storing an Asian language, the data is not going to take up 1 byte per character, and you're not going to get 50 characters out of this. Other database management systems will always default to characters. So for example, in MySQL, you could say something like this. And in this situation, I'm not specifying char. That's because by default, this is 50 characters. But Oracle is different in that you can specify char to force 50 characters. That's because the default here is actually bytes. Okay, so moving on to UTF-16. Now UTF-16 is also a variable length encoding. The difference here is that it's variable between 2 or 4 bytes. That means if we're storing a character like A, it's still going to take up 2 bytes even if that's not needed. So UTF-16 can take up a lot more storage when we are working with English. That being said, these do not line up exactly the same, and in fact UTF-8 will usually take 3 bytes for Asian characters, whereas UTF-16 will take 2 bytes for Asian characters. So if you're working with a lot of Asian characters, UTF-16 might actually save you space. So it really depends on your situation. So that's a perk for UTF-16. But UTF-8 is what's known as a superset of ASCII. And what that means is if this was UTF-8, ASCII is right here. If you're working with an application that's using ASCII and you want to convert it to Unicode, UTF-8 is going to be your best bet because the characters of ASCII directly correlate to the characters of UTF-8. But UTF-16 works better with Java programming and Microsoft.NET. So which one are you supposed to use? Well, you just have to weigh the pros and cons and think about what situation you're using it for, and that'll help you make a decision. If you're just working with small applications, generally it doesn't really matter that much because the size differences are small unless you're dealing with a whole lot of text data. So yeah guys, that's all I have to say about Unicode for right now. Hopefully that was helpful, and in the next video we are going to be talking about char and nchar. And now that we know all this crap, it'll be a little bit easier to discuss the differences. So thank you so much everyone, I really appreciate you guys watching my videos. If you liked the video, please click like and subscribe to this channel to help me out. Thanks, I'll see you in the next one. What's up guys, welcome back to your Oracle tutorial series. This video and the upcoming videos we are going to be discussing data types in much more depth. So we're going to start with char and nchar. Specifically, this video will cover char. So char is short for character. This can hold a string of characters. And the thing about this is that it's a fixed length data type. That means every single string is going to be the same size. And if for any reason we don't give enough data to fill that whole length, it will pad it with extra spaces. So for example, if we have something like this, char 10 char, but we only pass in hello, well hello is only 5 characters. That means it's going to add 5 spaces for us. Now this keyword here, char, this is known as a qualifier. You can think of a qualifier as something that describes something. So kind of like an attribute describes an entity, this qualifier describes what this 10 means. Specifically, this is known as a length semantics qualifier. Lots of big words here, especially that one. That's funny. So what does semantics mean? Semantics describe the meaning of something. So if you wanted to put this in English, you could say that this char describes the meaning of the length. So the describes would be the qualifier, the meaning would be the semantics, and the length would obviously be the length. But if that doesn't make any sense or you just think it's a bunch of useless information, all you got to think of is that this char describes how we interpret that 10. In this situation, we are saying 10 characters. Now, if we don't put this char here, the default is actually byte. If you want, you can throw in that byte keyword. That way you can be very specific. Or a better word would be explicit. So if you explicitly do something, you are putting it there even if it's not necessarily needed. You're giving extra information. You're being very specific in what you want. But if for some reason you don't put either one, just like this, you no longer have 10 characters, but you have 10 bytes. And remember, one character can take up multiple bytes depending on the encoding. Now, if the default is byte, why do we even need that bytes keyword? Couldn't we just leave it out? Well, some people like to be very specific so people know. And additionally, there is actually a default setting. So you could change the default to char, and then in this situation, this would be 10 char. And then if you wanted to change it back, you would throw in that byte word. And then you're no longer following the default, and instead you have 10 bytes. You can see how it can be pretty complex. Generally, what I would recommend is just go the extra effort and throw in that keyword regardless, even if it already is the default. For example, let's say the default is byte, but you want it to be in bytes. Throw in the keyword byte, that way there's no confusion. In addition to always throwing the byte, there's another way you could do it, and what that would be is to just change the default and then never use one of these qualifiers. So if you never put something here in any of your create statements, then you know all of your database objects have used the default. The benefit of this, though, is for consistency. If you have some columns using byte length semantics and then others using character length semantics, it's going to be very confusing. Regardless of which one you decide to use, you want to be sure to be consistent. If you want to change the default, go ahead and look up NLS _length _semantics. And then you can learn how to change that and also the downsides of changing that. Now, last question. What values are actually allowed in these parentheses? That's what we are going to be discussing in the next video, so be sure to subscribe, click like, and as always, I'll see you in the next one. Hey, welcome back everyone to your Oracle tutorial series. In this video, we are going to continue our discussion on the char data type. But this video is going to talk about only one small thing, and that is what value is allowed inside of this parentheses. What is the range that is acceptable? Well, the lowest is actually char 1, and this would allow up to 1 byte of data. What about the maximum though? The maximum is actually 2,000, and this would allow up to 2,000 bytes of data. Yeah, I know, that seems pretty simple, but there's a reason I thought it'd be good to separate this into its own video, because unfortunately it's not that simple. Yes, these are the values you can use, anywhere from 1 to 2,000, but using these values can introduce new errors. For example, if we declare this as char 1, and we don't specify the keyword char here, it allows only 1 byte. What happens if we try to put an Asian character into that column? Well, we are going to get an error. These kind of problems increase what's known as runtime errors, and these are very bad. So for example, if you're working with a programming language like Java, and you type something incorrectly, you might get what's known as a compiling error. That means we can't even compile the program. But runtime errors is when the compiling works, but the program itself does not work. We get an error when we run the program. And the bad thing about these is that it can happen anywhere. For example, in our code, if we have even one if statement, the path divides into 2. And then if we have, let's say, a switch, it might divide into 5. Same over here. And you can see that all of these endpoints would have to be individually tested for runtime errors. And what that means is runtime errors are very hard to find. For example, in our application, we might only talk to the database at this endpoint. And now we talk to the database and we insert an Asian character into this char1 and we get an error. So that means part of the time on this case are we going to get an error. If we put an English value, it's going to work because English characters only use 1 byte. So you can see how finding this thing can be pretty rough. The same thing goes for char 2000. That's because this is 2000 bytes. And if this is 2000 bytes, what happens if we do this? You can see here we're specifying 2000 characters. Well, Oracle was actually going to be okay with this. But in my opinion, this is not okay. That's because with certain encodings such as UTF-8, certain characters can be multiple bytes, and either way, the maximum is still 2000 bytes. So even though we put 2000 characters, if we, for example, put 1001 2-byte characters into a value of this column, that would total 2002 bytes, which would actually break the thing. So just because you can specify char here does not mean we go past the limitation of having only 2000 bytes. And it's just very important that you guys are aware of these limitations so they don't come back and bite you in the butt. That's all I have to say for this video. Hopefully that was helpful. Please be warned on these issues. Always be careful when you're going to the edge cases of the lowest or the highest, because that's when the issues usually start to show up. If you like this video, be sure to click like and subscribe, and I will see you in the next one. Thanks. Hey, welcome back everyone to Caleb the Video Maker 2. This video... I swear my dog dehydrates himself all day just to drink water when I'm recording videos. I swear he does it. This video is going to be covering nchar. Now this data type works very similar to the char data type, so make sure you refresh on that data type. There are some key differences though. This data type is also known as the national character set data type. Whenever you see a data type with something like national in it, this is referring to Unicode. It is highly recommended you go review the videos I created over character sets and UTF-8 and UTF-16 just a few videos ago. That's because they are foundational to understanding the benefit of this column. Additionally, in order to understand why we would benefit from a data type like this, you need to understand how character sets are applied to an Oracle database. So let's say this is an Oracle database, and we have available to us multiple character sets. The thing with Oracle is that these character sets are applied at the database level. That means the entire database gets this character set. This is in contrast to other database management systems where you can often create a character set at the database level, at an individual table level. So if we had an individual table, we could say this is of a certain character set, and even column levels. So we could take this individual column and say this is of a certain character set. Oracle doesn't work the same way. Oracle only has character sets available at the database level. Now there is something available to us that's similar to having a character set at the column level, but slightly different. And that is where the N data types come in. The N data types allow us to store Unicode in a column, even if the database character set is not Unicode. So let's say this is not Unicode. We are allowed to have a table within our not Unicode database that stores Unicode inside of a column. But it's slightly different than actually defining a character set for this column because we're limited to just Unicode. In what situation would something like this be practical? Well, let's say we are working with a database that we know is going to work with applications that use ASCII. ASCII is a character set that uses 1 byte per character. It might be easier for us if everything uses ASCII, including the database. So we might set the database character set to ASCII. But what happens if it comes up where we actually want to store Unicode in our database? If we don't have this data type available to us, we're not able to do that in Oracle without changing the database character set to something like Unicode. Unicode has many more characters available to us and allows for different languages, whereas ASCII limits us to just English. So if 99% of our database is ASCII, we might have 1% that we want to be Unicode. So in order to get this 1%, we can label the column as nchar. Now let's talk about the practicality of this data type. Is this a data type you should be using? That's a different subject. My goal is to introduce you to the different data types. That doesn't necessarily mean they're always useful. Now, I'm not saying you should never use nchar, there might be a good time to use that, but in general, it's almost always recommended to have a Unicode database. And in this situation, the nchar data type becomes a lot less useful, especially since in Unicode, one character can also take up 1 byte. That's because, as we mentioned before, Unicode is a superset of ASCII. So this here is Unicode, ASCII is right here. That means if we use ASCII characters inside of a Unicode character set, they are only going to take up 1 byte. So there is not an obvious benefit of making your character set ASCII. Because of that, we are not going to get into the specifics of ASCII character sets. That's because they're not very important to us. The Unicode character sets are important to us. So because of that, in the next video, I'm going to be talking about some specific Unicode character sets that you need to know about. It's not simply called Unicode or ASCII, they have fancy names that you need to know. Of course, nothing can be simple, right? In addition to the end part of this not being super useful because of our database character set being Unicode, a lot of people wonder whether you should use char data types at all. Yeah, you probably wish you knew that before I taught you all about them. But there is some controversy whether you should ever use char data types, and that's something we will talk about in an upcoming video. But essentially, there is not really a huge benefit in using char data types in Oracle. That's all I got for this video, guys. Thank you for watching. If you've enjoyed it, please click like and subscribe to Caleb the Video Maker 2, and that will really help me out. Thanks, guys, and I'll see you in the next one. Hey, what is up, everyone? It's Caleb from Caleb the Video Maker 2. Welcome back to your Oracle series. This video is going to be covering UTF-8 and UTF-16 character sets. Now, I know we already talked about UTF-8 and UTF-16 a couple of videos ago, but this video is going to be talking about character sets that use those encodings. So we, as database people, don't deal so much with encodings as much as we deal with character sets. That's because specific character sets are going to use certain encodings. So the only time we deal with encodings is through character sets. Now, I've mentioned before that UTF-8 and UTF-16 are examples of encodings for the Unicode character set. But it's not quite that simple. We don't just have a character set called Unicode. There are a couple of different options that use UTF-8 or UTF-16. And that is what we are going to be talking about in this video. So we're going to be talking about the very specific names that we need to use in Oracle database. The first character set is AL32 UTF-8. And this uses the UTF-8 encoding. In this character set, each character can take up to 4 bytes. Now, there is another character set, and this is where it gets super confusing, called UTF-8. Of course, it had to name it. And the encoding that this character set uses is UTF-8. So wait, hold up, what is going on here? Well, notice here that this one does not have a hyphen, and this does. So UTF-8 without the hyphen in Oracle is talking about the character set. With the hyphen is talking about the encoding. So here is a good question. If both of these are using the UTF-8 encoding, what could possibly be different between the two? Well, the difference is that UTF-8 is using an older version of UTF-8, that is. Overall, they work about the same, but the primary difference is how things are stored. Specifically, things known as supplementary characters. Supplementary characters are the characters that take 4 bytes in this character set. The difference with this character set is that each supplementary character takes 2 sets of 3 bytes, totaling 6 bytes. So the way they are stored is slightly different. Overall, it's about the same, but since this one is using an older version, almost always are you going to want to use this character set. This is the default for new databases, and it is the character set you are going to want to use 99.9999999 repeating percent of the time. The next character set we are going to talk about is known as AL16 UTF-16. And this uses the UTF-16 encoding. Now, we discussed this encoding a couple of videos ago, so I'm not going to be redundant and explain that all again. If you want to learn more about the UTF-16 encoding, go watch that video over UTF-8 and UTF-16. There is a fourth character set known as UTF-E. The encoding this one uses is known as UTF-EB. B, C, D, I, C. And this one is super archaic and you're almost never going to want to use this. But I thought I would mention it in case you run across it because there is a chance you might. In general, these are the two character sets that you're going to use the most. It's important to understand this character set, and this one when we start talking about nchar, which we are going to discuss a little bit more in the next video, because these character sets are going to come up. This one, it might exist, but you can basically pretend that it doesn't. So yeah guys, that's all I got for this video. Hopefully that was helpful. If you've enjoyed this video, be sure to click like and subscribe, as that will really help my channel. Onyx. Hey, what's up everyone? It's Caleb from Caleb the Video Maker 2. Welcome back to your Oracle SQL tutorial series. And I know I'm overdue for a haircut, but you're just gonna have to deal with it for a little while now. So this video is going to be a continuation of the nchar data type. That's because I just had a few more little things that I wanted to explain before we move on to the next data types. The first thing is that when you declare an nchar, for example, nchar 50, this is always going to be talking about characters. That means the char and byte keywords do not apply for this data type. Now we've mentioned that the nchar data type uses Unicode, but remember that Oracle has multiple Unicode character sets. So what character set does nchar use? That is a very good question, and I'm going to answer it. So when you declare a database, you give it a character set and what's known as a national character set. The national character set defines what character set all of the N data types are. But fortunately for me, as the teacher, there's only two options. And those options are AL16, UTF-16, and UTF-8. And I'm talking about the character set, not the encoding. So which one of these do you want to use? Well, I'm actually not going to go in a whole lot of detail with that. That's because if you want to know all of the details, you can go to the Oracle Docs page and find tons of articles on globalization of your software. I will tell you though that this one is the default. And usually the default is the default for a reason. It's because it's the one you're going to want to use most of the time. Now in a previous video, I mentioned that the char and nchar data types are sometimes not recommended for use. Why is that? And the reason is, for example, char, it's actually just stored as a varchar2 with padding. There's not an underlying difference differentiating char from varchar besides the fact that if you make it char, all of the things are going to be the same length. So what I mean is that the varchar column is not going to take up extra space or be slower, and because of that, it's not very beneficial to use the char data types. And the same thing works for the nchar data types. Now I also mentioned that the N data types, so that includes nchar and nvarchar too, are sometimes not recommended. And that's just because some software systems do not work with them quite as well. But a good situation when you would want to use the nchar2 column is if your database is of some character set other than Unicode and you have to store Unicode characters somewhere in your database. In that situation, that's exactly what the nvarchar2 column would be used for. But the char and nchar data types, they are not really recommended or needed for any really good reason. Now before you get mad for me wasting your time teaching about these useless data types, you have to realize that most of this information is foundational for the varchar2 and nvarchar2 data types. So that's really all I got to say about char and nchar. Hopefully the last few videos have been helpful. In the next video we'll be moving on to something new, so thanks guys for sticking with it, and I'll see you in the next video. And as always, please be sure to subscribe and click like. Sup yo, welcome to Caleb the Video Maker 2. This video we are going to be talking about the varchar2 and nvarchar2 data types in Oracle. Now over the last 5 or 6 videos I've discussed a whole lot about the char and nchar data types as well as character sets and encodings. Because of that, I really don't have that much to say. Good for you, right? No, but really, I'm not going to be super redundant and repeat everything I've said. I'm going to share with you the key points just to make sure I don't neglect 2 of the most important data types. But if you want to know the foundation of it all, go back to when I started talking about the char data type. The first thing is the primary difference between the varchar2 data types and the char data types. That difference is that the varchar data types do not pad the data to fit up a certain length. Char data types do. So if you say something like this, every single value in this column is going to take up 10 characters. Even if you only put in 7 or 8 or 9 or 1 or 0, it's going to pad that value to take up 10 characters. and that is a waste of space. Now in other database systems, the way char and varchar data types are stored is different. So the char might be stored one way and varchar might be stored another. For example, in MySQL, varchar takes up extra space because it has to have an extra byte or two to keep track of how long that data is. Oracle doesn't work that way because the char and the varchar2 column data types are stored exactly the same way. The only difference is the padding. And what that means is you should almost never use the char data type and always focus on the varchar2 data type. And the same goes for nvarchar2. You want to use that one rather than nchar. Unless you have an absolutely perfect, beautiful case of why you would want to use char, then you could use it. And in that situation, please leave a comment so I know of a good example. One other difference between the char and the varchar2 data types is the number of bytes it can store. Char is limited to 2,000, whereas varchar is limited to 4,000. So by using varchar2, you automatically allow for double the storage. Once again, this is bytes, so if you have single byte characters, you can store 4,000 of them. But if you're using Unicode, you want to be careful because if you put in, for example, 3,000 2-byte characters, Oracle is going to bite your head off and not work. By that I mean it's going to throw an error. Now, 4,000 bytes is definitely more than 2,000. In fact, it's double. But 4,000 is still not a whole lot of bytes. If you need to store more than that, you need to look into the large object data types. Hopefully that is something we can get into in an upcoming video. So that's all I got for this video. I know it was short, I didn't have a whole lot to say, but you know, I don't want to be super redundant. So thanks guys for watching. If you like this video, be sure to click like. If you have any other useful tips or notes about these data types, leave a comment. I'll be sure to look at it and consider it, and future videos might say something you had to say. So thanks guys, be sure to click like and subscribe. Welcome back everyone to your Oracle SQL tutorial series. This video we are going to be talking about the number data type. So, what is so stinking special about the number data type? You know what it is? It's that it can store whole numbers and decimal numbers. So it can store integers and real numbers. Both! In one data type. So that means we could store something like 2, or we could store 2.2. I know that doesn't seem like a big deal, but it is. It's really super cool. Oracle attracts my liking because it has fewer data types that are more versatile, rather than some other database management systems that'll have like 4 data types to do the same thing. Now, number can be used to store huge numbers. It can also be used to store very small numbers. And I'm not talking like 1 or 2, I'm talking like 0.00000 whatever, 9 or 5 or whatever. Something smaller than 1. Now the Oracle docs, you can get the specifics on the range of acceptable values, but in general you're not going to have to worry a whole lot about it because this can store pretty big numbers. Now the thing with this is that it's stored in scientific notation. Now the chances are when you learned this in like 3rd grade, you were sleeping. I mean, I was too. I had to relearn all this stuff. So let's do a quick recap. It's essentially a way to express a number using a power of 10. So we could say 2.2 times 10 to the 0. 10 to the 0 evaluates to 1. So 2.2 times 1 equals 2.2. Now you could, theoretically, take this dot and move it. So we could move it this way, or we can move it that way. Generally it's supposed to be right there, so this is a really crappy example. But let's say we had the number 37. That's a good example. 37 dot. Now, we could take this dot and move it. And that will change the power of 10. So now we have 3.7 times 10 to the 1, which evaluates to 10. So 3.7 times 10 equals 37. You can see we represented the same exact number 2 different ways. Either 37 times 10 to the 0th, or 3.7 times 10 to the 1st. Now, we really don't have to worry a whole lot about the scientific notation part of this. That's all kind of done behind the scenes. So what we need to worry about is significant digits. We could represent this as 7.7 times 10 to the 4th. I had to think about that one pretty hard. And the way we get that is we start here with a decimal. 1, 2, 3, 4, which leaves us right there. And you can see we really only have 2 digits that are important to us, 7 and 7. You could say that these digits are significant. So we really don't care about zeros. I mean, don't take it offensively, 0. I personally care a lot about you, but in general, no one really cares about the zeros because in this situation, they're not considered significant. The actual number of significant digits is our biggest limit. Now, the limit from this data type comes from either the significant digits or from the total size. We can only store so many significant digits, and at some point our number is not going to qualify. Or we could just be trying to store a number that is way too stinking huge, like 2.2 times 10 to the 3,000th, or 3001. And in general, that's just way too stinking big. Now, when you declare this data type, you have the option of specifying 2 extra options. So many options. It's like Subway. Oh, that was so cheesy. So we can specify the precision and the scale. And these are defined in parentheses when we give the data type. So something like this. This is the precision, and that's the scale. If you decide to set a precision, you have the options of giving a value 1 through 38. And what this number refers to is the total number of digits in your number. So for example, this number has 1, 2, 3 digits. So we could say that the precision is 3. Scale, on the other hand, is the number of digits after the decimal point. So in this situation, the scale is 2. And note that the precision includes the scale. So the entire number is considered for the precision, but only the number after the decimal point is considered for the scale. So to quiz you a little bit, think about the maximum and the minimum values for something like this. To figure this out, you can subtract the scale from the precision, and that'll give you the number of digits before the decimal. So we're going to have 4, and the biggest numbers would be 9999, and 2 of those are going to be reserved for after the decimal, 99, and also the negative of that, so negative 9999.99. The scale is a little bit interesting because the actual acceptable values for the scale is negative 84 up to 127. And I'll explain how that makes sense of having a negative scale and also having a scale that's bigger than your precision, but that is a topic for another video. The biggest thing to take away from this is that if you're going to specify the precision and scale, the scale affects the size of the biggest number. Because if we have, let's say, a precision of 6, like this example, and we say a scale of 2, well, we are cutting the max size of our number by 2 digits. So if we had 6 for the precision and the scale was 0, we could store this, and this would allow for a much larger number. So if a bigger number is what you want, then you are going to want to keep the scale as low as possible and the precision as high as possible, because think you can only store up to 38. But if you want a lot of numbers after the decimal point, you can make the scale very big and the precision very big. So that is your introduction to the number data type. We will be discussing it more, of course, because there's still a lot of more information we need to cover. But this is a great introduction for you guys. So thanks for watching. If you've enjoyed this video, please be sure to click like. And as always, be sure to subscribe, and I'll see you in the next video. Welcome everybody to your very first video over MySQL. Now I know what some of you are going to be saying. What? This ain't your first video over MySQL. You actually did an entire series over this. Yes, this is actually my second series over MySQL. The reason being is that MySQL has changed a lot over these last few years, and it was just many years ago, so I think I've learned a lot more about MySQL, and I'm prepared to make an even better series. Ha! So that's what we're doing now. Hopefully this series will satisfy you guys who've been wanting some more of MySQL, because this series is going to be more in-depth, more techy and cool and up-to-date and stuff. Alright, let's do this. So what is MySQL? MySQL is a relational database management system. Essentially, a database is a software that allows us to store tons of data or information. So data can be really anything. Think of something you want to store that you can use at a later date. Often, databases are used behind an application. So an application might say something like, hello, and then say the username. This section right here has to come from something. All of this information is stored inside of a database. So this allows us to make apps that are dynamic. What does dynamic mean? It means changing, but only certain parts. So often we'll have an application, let's say this is our application, right? And we might have some kind of code that presents this information here. But it's dynamic in that this username can change depending on who is signed in or what your username is. This allows sort of like a separation between the application and the data that the application needs. So you have the application here and the database. The code itself is going to get information from the database to present to the user. So let's say this user uses this application, does something on it, and that information is stored inside of the database. Well then later, when he wants to use the application again, we can get that data from the database and present it in the application, and then that will be delivered to the user. So this is kind of the key word of it all. We can make dynamic websites, websites that change, websites that render content. So you could make an application that renders your most recent blogs, and you don't have to go in there and update your recent blogs every single day or whatever. It'll do it automatically. That's because you can code it and it will do it dynamically. Now the other part of relational database management system is the keyword relational. And this word right here, relation, actually means table. You can use that at a party and impress all your friends. Okay, so we have a table, and the way things are organized is that we have columns going this way, and then we have rows of information going this way. So for example, we can have a column of a username, and then all of the data in this column is going to be everybody's username. But the way this data is entered into this table is by row. So a specific user, let's say this guy, signs up for an account, he puts in a username, he might put in an email, a phone number, a first name, last name, whatever it is, doesn't really matter. All of this is stored tabularly. Tably? All of this is stored inside of a table. But it's not just an ordinary table. The table is just the way the data is presented. A different way we can think about it is with the keywords entity and attribute. So an entity would be the user or the person. The attributes would be the username, their email, first name, last name, phone number, all of that good information. Now these attributes that describe the entity, these are stored as columns inside of the user table. Now don't freak out if you don't understand how to design all this stuff yet. That's not the point of this video. The real point of this video is to give you a rough introduction to what databases are and what MySQL is. So now that we kind of understand what a relational database management system is, which if you just need like a one-sentence summary, it's a way to store data in tables. Really simple. But now we should move on to figure out what MySQL is. Now as I mentioned before, I have that other MySQL series, and that content is still pretty relevant, so if you want a slower introduction to MySQL, go ahead and watch that. Now MySQL is a management system. That means it allows us to store data in tables. And the way we do that is using what's known as SQL. Now, MySQL is just a software system that adopted the SQL standard. This My here, I'm pretty sure it was like the maker's daughter's name or something. But essentially, it's just a software that allows us to type SQL and store data in tables. So SQL stands for Structured Query Language. Structured Query Language. And essentially, this is kind of like a language that's between computers and humans. So here's where SQL goes. That's because a computer can interpret SQL and a human is smart enough to write SQL. So we can communicate with the computer using this language. And that's really what this video series is going to be about. We're going to be learning SQL, but we're going to be learning the MySQL dialect of that. Essentially what a dialect is that it's the way this database system adopts the SQL language. For example, there's other database management systems. There's SQL Server, there's Oracle, and there's a plethora of other different database management systems. But they all have the commonality of using SQL. There's just some minor differences, and that's where this whole dialect thing comes up. So for example, writing something in MySQL is going to be very similar to writing something in SQL Server or Oracle, but there's going to be some minor differences. That's because MySQL has adopted its own dialect. For example, there's extra features in MySQL that are not specified inside of this standard, and those extra features are not going to be the same as SQL Server and Oracle. But even so, if you know MySQL, it's very easy to pick up another database management system such as SQL Server. That's because they're all based off of a standard, structured query language. Now hopefully that kind of makes sense. Don't be overwhelmed with all of the details. What's really important to know is that MySQL is built off of a standard known as SQL. SQL is the language we use to store data and retrieve data from our database. Now there are a lot of ways you can store information. For example, why don't we just use an Excel sheet? Or a text file. Well, there are a lot of benefits of using these, but there's also some really serious downsides. And we'll learn all of those as we go on, and you'll see why databases are so important. But to start off, I'll just give you a couple. For one, Excel is just a way to make spreadsheets. And the thing with spreadsheets is that they are all or nothing. That means if you have a spreadsheet and you want to get data from this, you have to look at the entire spreadsheet. You can't just select certain columns. With a database you can. That's because you have what's known as a select statement. And you can specify which columns. So you could say, I want this one and this one, but not this one. Along with that is security. For example, in a database, you can prevent certain people from doing certain things. In a spreadsheet, you can do that a little bit with file system rules, but it's very limited in that if someone has access to a spreadsheet, they can basically do whatever they want. You could make it read-only, but let's say they had read and write abilities. They can do anything. But with a database, you could say, here's some things they can do, and here's some things they cannot do. So you can have a little bit more flexibility, and you can make basically a entire system that allows many users, but you're not going to open up your data to be destroyed by certain people, right? So you can prevent big disasters using a role system. In addition to security, databases also allow us to store much more information. Databases can be expanded to tons and tons of data and still run efficiently. That's because we can separate data very easily, we can index data, and the database management system is optimized to work with a lot of data. Spreadsheets can work with a decent amount of data, but when you are talking like millions of rows, things might get a little clunky and not very organized. So if you're a very small business and you just need to store a little bit of information, I tell you, a spreadsheet will do just fine. A text file might even do just fine. But if we're talking about an enterprise application that's going to have tons of information, In that situation, I know you're going to want a database. So we've talked about what a relational database management system is, we've talked about what MySQL is, but now let's talk about why MySQL. Why would you want to choose MySQL over some of the other database management systems? One reason is that MySQL is open source. That means you can go and view the code that actually makes the database. In addition to it being open source, I think it has one of the most flexible licensing systems, meaning you can do the most with paying the least and being restricted the least. Because of this, MySQL is often used for smaller projects, such as websites. Claire! Websites often use MySQL. Literally, almost every website that has a content management system, think of like WordPress, Joomla, Drupal, all of those, they're almost always powered by MySQL. In addition to this flexible licensing, there is a small learning curve. So you have to learn a lot to use a database, but once you figure it out, your efficiency goes much faster. Whereas a spreadsheet, it doesn't really require much knowledge, but it takes a lot more work to maintain. It's a lot less efficient. You end up losing more time upkeeping and all of that nonsense. But MySQL, compared to other database management systems, the learning curve is small. So for example, Oracle might have a learning curve like this. I'm just drawing random charts, but the learning curve in Oracle, in my opinion, is much higher. It requires more knowledge to get started with Oracle. So for small projects, most people pick MySQL because it's really not that hard to adopt. It just has a small learning curve. SQL Server, well, that's kind of somewhere in the middle. It has a steeper learning curve than MySQL, but it's not too bad. So if you really support the open source community and you like flexible licensing, if you're that kind of person, I'd go for MySQL. But if you're looking for a world-class, 100% reliable, has to work all of the time, like a crazy application kind of thing, I would go for Oracle. And if it's somewhere in the middle, maybe SQL Server. It also often depends on what code base you're working with. For example, PHP, people almost always use MySQL. C#, people will often use SQL Server. And the reason why is just that certain languages work better with certain database management systems. Most websites built with PHP use MySQL. Does it have to be that way? No. Does every website that uses PHP use MySQL? No. It's just the way people do things. So it ultimately depends on your goals, what you're trying to accomplish. But either way, I think MySQL is a great database management system to start with. So that's what we are covering in this series. If you like this video, please click like, subscribe, and go through this series. I promise you won't be disappointed. Thank you guys so much, and I will see you in the next video.
What's happening, everybody? Welcome to Caleb the Video Maker 2. I'm Caleb, and in this video we are going to be downloading and installing MySQL database. So we go to the mysql.com website and click Downloads. Now there's a couple different things you're going to want to download. The first is the actual database. And if you scroll down here, you can find MySQL Community Edition, and that's the free version we're going to start with. So what we are going to want is the community server. Now, if you need in-depth information on how to install this, you can click the installation instructions right here, or you can just follow my video. Now, you're going to want to scroll down and install one of these. So either one's fine. I'm just going to go with the first one. And it's going to look like you have to log in or sign up, but actually you can just click this no thanks, start my download. Click that. Yes. Make sure you read this delicious novel. It's very awesome. So intense. Now I'm going to go custom on this one. Under this one, I'm going to add the server itself, and we're going to go with the 64-bit one. And then under applications, I'm going to go with MySQL Workbench. There's a bunch of other stuff you might want to download. If you're not really sure, you can just install the full package. For example, if you want to work with C++ or .NET, you might want to install some of these things. But honestly, this is all I'm going to need. If you're unsure, I would go back and click the full installation. But I'm trying to save as much space as possible, so let's go with this for now. Execute. All right, next. Next. All right, this stuff's important. What kind of machine are you going to be using? I'm going with development. TCP/IP, port number. This is important. If you have something running on this port, you can have conflicts. That's probably good. We can click advanced if we really want, but that sounds scary, so let's not. Next. Now we need to set a password. Now this is for what's known as the root account. It's kind of like the super admin administrator. So if this is a production environment, you want to make sure you have a very secure password. And you can actually create user accounts that are allowed to do other certain things. Now obviously, this situation, I'm going to go with the root account because why not? This is my machine and this is just for learning. So let's go with root. Now it starts talking about services. And services are applications that run in the background when your computer is running. You can find those by going to your start menu and typing in services. Here is a huge list of services that are running on my machine. This is talking about configuring MySQL as a service. So I'm going to have it to where I'm running MySQL as a service and it's going to start up automatically when I turn my computer on. Oh, come on, Claire. This one's fine here, so let's click next. Now this page talks about all these extra features you can enable by checking this box. I decided I'm going to check that, and now we are finally ready to finish this whole process. Now I'm going to check private networks and uncheck public networks. And there we go, we have MySQL installed. Now how do we actually use this? Well, if you go to your start menu and go to all apps, you can scroll down to the M's and find MySQL. And inside of here, we are going to have MySQL Workbench and the command line client. We'll be talking about MySQL Workbench in upcoming videos, but just for fun, let's start with the command line client. Now when this pops up, it's going to ask for your root user account password. And I'm just going to type mine in. And now we can start writing our SQL commands. So I'm just going to start with select 5 times 5. And if you press enter, it'll keep going down to the next line. That's because you have to put what's known as a delimiter, which in this case is a semicolon. There you go. We just wrote our first select statement. So that's that, guys. Hopefully that was enough information to keep your brain working for the next few minutes. We'll be continuing and we'll finally start learning about different SQL commands. If you like this video, please be sure to click like, subscribe, and as always, continue on to the next video. Thanks, guys. See you then. Welcome back, everyone, to Caleb the Video Maker 2. That's my new official theme song. So this is where we left off, in the command line. But I don't really want to use the command line. So we're going to learn a new tool called MySQL Workbench. So to open that, you need to go to your start menu, and I know mine's cut off a little bit, but that's okay. And you can just search Workbench. Now when you open this, there's already something listed here, and this is the default connection, your local host. That's exactly what we want to use, so it's nice that it already has that there for us. But we can add connections clicking this little plus button, and you can type in all the information you want. But for us, we're going to go with this local host, so double click that, and it's going to bug us for a password. Now this is the password that you gave when you installed MySQL. If you have no clue what I'm talking about, go watch the previous video. And then I'm going to click Save Password and Vault. Because I want to make sure I'm using the most powerful account and have the password saved so that anyone can go in and delete my stuff. No, but in all reality, this is a development environment. I don't really want to have to worry about forgetting my password and all that junk. So let's click OK, and voila, it opens up our database server. So just like in the command prompt, we can type in SQL, well, we can do that here. So we could say select 5 times 5, and then execute it. And you can see it returns 25. So that's how you run SQL commands inside of MySQL Workbench. There's a lot of stuff you can do to customize the view here. For example, there's these buttons over here you can press. And as you can see, that makes things happen, and you can hide stuff. There's also this button up here, View. And you can go to panels and basically do the same thing. I'm going to enable all of those just so we can see everything. And if you look down here over on the left, you can see here are our schemas. So it's kind of hard to see, so we have to drag this down a little bit. But essentially this is going to be our databases. So here is a database and it has these tables in it. So when we create a new database, it'll come down here. One interesting thing you can do is press this little button here, and essentially what that's going to do is hide all of this other junk. So let's click that, and you can see it's all gone. Boom. And if you need to see it again, you can click it again, and there you go. Also, when you click that, you can go down here and click this button to get to the other tabs. So for example, we can click this button here, and it will bring back the schemas. That's kind of useful because a lot of this junk I don't really care about right now, so I'm going to maximize that and just keep it like that. Now, if you need to go back to the home page that opened when we first started, you can go up here and click this little house, and there you go. MySQL Workbench is a very popular program for designing databases. So to do that, you can go down here to the model section and click plus, or you can dork around with the one they already have on there. One thing that might come in useful for you is this MySQL Utilities thing. I never actually installed that, but you can download that. That'll give you some extra stuff you can do with MySQL, but we're not going to need that for now, so I'm not going to download that. So yeah, guys, that is a very rough intro to MySQL Workbench. Now, I actually have an entire video over MySQL Workbench that I went into detail on how to do different things and design databases, and you can watch that if you want. Just check it out. Oh, God. Claire! Sorry, guys. There's a stalker on the loose. Anyways, you can check that out if you want, or you can just go through the series and we'll be covering some of that information in this series. So thanks, guys. Hopefully this worked out for you. If you have any comments, please leave them below. Click like if this video is helpful. And as always, I will see you in the next video. Be sure to subscribe. Oh, it's still recording.
Hey, what's up everyone? Welcome back to your MySQL tutorial series. Now, as we go through this series, I'm going to be throwing words at you and key terms, and if you don't know what these terms are, you're going to get lost. That's because when you start with databases, there is a ton of terms that you need to become familiar with. And if you're not going to be able to keep up with the important information where those terms are considered prerequisites. Because of that, I'm taking a couple videos just to talk about terms and go through them all, so that way we're clear on what is what. So the very first term is data. Now data, my friend, is just information. Don't make it too technical or fancy or, data. Oh, we collect data. It's fancy. But really, it's just information. When you take a bunch of information and put it all together, you get what's known as a database. So data gets put into a database. Now, how do we work with this data? We need something known as a database management system. This is essentially a software that allows us to work with all of this data. Now, MySQL is an example of a database management system. Now, if you took every single database management system, a subset of those would be called relational database management systems. So think, this circle represents database management systems. Inside of that, we have relational database management systems. Now, MySQL is also an example of a relational database management system. So if we had MySQL right here, not only is it a relational database management system, but it's just a general database management system. And that's pretty clear from the name because they both have DBMS in the title. But not all databases are relational database management systems. We still have all of these databases over here. But what's the difference? Well, we're not going to focus a whole lot on these databases right now, but these ones, they are what's known as relational. And all that means is that they present our data in tables. A really cool word for table is relation. Now, what is a table? You can think of a square, and within the square you have what's known as columns. Columns are the headers of the table. The table will also have a name. So we could say this is the membership table. Then the columns are going to list the data we want to store about memberships. We are essentially going to make a table that lists possible memberships for a gym or for a website or anything like that. So we might have, an ID, a title, and then a price. So that's what the columns of this table are. ID, title, and price. Now the other term you need to know is row. Rows are data that we put in to match these columns, but we give actual data, not just categories of data. So we give an actual ID, we give an actual title, and we give an actual price. So for example, we could have the ID of 1, the title could be silver, and the price could be $30 or 30 whatever. That is an example of a row, and we often have multiple rows inside of a table. You can think of the rows as instances of whatever the table is describing. So each row is an example of a membership, and the data it has is the ID, title, and price. You'll often hear a couple of other terms when we're talking about tables. One of those terms is a record. A record is just another name for a row. You'll also hear the term field, which that usually describes one value inside of a column. Or you could also call it a cell. Now some people, when you say field, they think of the whole column. So that can get a little confusing, so I'm not going to use that term a whole lot. But I will use record, and I'll also use the term entry, which is the same thing. You can just think of entering this data as an entry inside of this table. Now when we have a table, sometimes it is appropriate to leave some information out. In this table, we don't really have a good column that we can do this for, but let's just go through it and see what that would look like. We could have another membership with the ID of 4 and the price of $200. But the title has no value. As you can see, it doesn't make a whole lot of sense in this membership table because it's important that every membership has a title. But if we had a column such as description, it might make sense to leave some of these blank. So we could say this is the ultimate title, but we could leave the description empty. In this situation, you could say this is a null. A null is just an absence of a value. So continuing our list, I'm going to put that down here. Sometimes that's appropriate, sometimes that's not. It's often a decision you have to make. Does it make sense for this to be null, or should we force every single row to have a value for this column? All of these things are part of what's known as database design. Database design makes us ask questions like, what tables do I need? What columns do I put in that table? Do I allow them to be null, or do I force them all to have a value? How are these tables connected to one another? How do I enforce the way they're connected? All of that information. Essentially, database design is all about what's known as data integrity. That is actually the term we are going to start with in the upcoming video. So you guys better go check that out. Hopefully all this information was helpful. Thank you for watching. Please be sure to subscribe, click like, and as always, I'll see you in the next video. Thanks, guys. Hey, what's up everyone? Welcome back to your MySQL tutorial series. I'm Caleb from Caleb the Video Maker 2. In this video we are going to be continuing our discussion on database terminology. Two terms you need to be familiar with are entity and attribute. An entity is just a thing we store data about. Attributes are the things we store about that entity. Now I'm going to continually bring up the concept of data integrity. Data integrity means that the attributes we are storing about the entity are accurate, as up to date as possible, not redundant, meaning duplicates, and there's no conflicting information. There is a lot of stuff we do inside of a database to enforce data integrity. It's one of the most important things to have when it comes to database development and database design. So if we have an entity, and we have a couple attributes that describe this entity. Let's say we have another entity. So two instances of an entity. Let's just say these are users, and each one of these is an attribute that describes the user. What if, by chance, this matched this matched this, and this matched this? It would almost be as if we had duplicate data. That's because both of these would look like the same thing. That's because all of the attributes about it are the same. So we could have like the first name, last name, and email, for example. And we have two users with the same first name, last name, and email. That's confusing. How do we prevent this? Well, we need to introduce something known as a primary key. Now, a primary key is something that is unique and not null. So for example, if this third one was the email, right? We could make this the primary key, and if that was the case, we would be able to distinguish these users because we would force the email to be unique. And that would mean two users couldn't use the same email. This is an example of a natural key. That's because the key is something natural. It's the email. It's something that exists in the real world. Another type of key is a surrogate key. A surrogate key is just a value that's generated by the database, generally an ID. So we could say this user has the ID of 7 and this user down here has the ID of 8. We can use that to distinguish the two different users. That way we know that there's actually two users and not one user entered into the database twice. That's because we have this to distinguish it, the ID. Now what do you do if you want to reference this primary key in another table? Or if you want to reference another column? For example, we might have a comment table. And this comment table might reference a user. How do you do that? That introduces the concept of a foreign key, and that's the word we will start with in the next video. Thanks guys for watching. Hopefully that was helpful. As always, I ask that you please click subscribe to support this channel, and if you like this video, give it a like. I will see you in the next video. Welcome back everyone. It is Caleb from Caleb the Video Maker 2, and this is your MySQL tutorial series. We are going to continue our discussion of beginner terms, and the term we're going to start with is the foreign key. A foreign key is a column that references another column in another table. Often this will point back to a primary key. It does not have to reference a primary key, it could reference a unique column. Essentially, it's just a way to reference another entity, and that entity has to be labeled unique, or else it's not going to know which entity you want to reference. For example, if you have these two people, and you want to reference the person from over here somewhere, how do you tell it which one you want to reference? There has to be a way to uniquely describe these people, so often it'll be an ID. And then you could say, oh, the person with the ID of 7 is being referenced in this row. All of these rules, including primary key, unique, and foreign key, these are all known as constraints. Constraints are something that are very important to protect our data integrity. That's because they force relationships to hold true. If we didn't use constraints, we could still use the value 7 over here, but we're going to get rid of this reference. And that means if this person gets deleted or something, that this 7 is no longer meaningful for anything. In that situation, our data would be outdated. We don't want that. That would violate data integrity rules. So to force those integrity rules, we use constraints. Another way that we force integrity is using data types. That's pretty bad. MySQL has a plethora of data types, and we are going to discuss many of them in upcoming videos. Every column is going to have a data type. That way the database knows how to interpret that data. The way the database works with data depends on the data type. One area where this is important is if we have a numeric column. That means numbers, and we try to store a string in there, that's not going to work. And by that not working, we are taking another step to protecting our data integrity. So this here would be a string value, and we are trying to store that in a numeric column. That's not going to work. There is one situation where you need to be extra careful with the data type that you give a column. When you have a foreign key, or right here, and it references a primary key, these both have to be the same data type. That's super important. If you're having problems creating foreign keys, that might be part of the problem. The primary key might be a different data type than what you were trying to make the foreign key. One other keyword I got for you is index. You can tell the database to index important columns, and in fact, it's going to index certain columns automatically. Primary keys are automatically indexed, unique columns are automatically indexed. Foreign keys, on the other hand, are not automatically indexed, but oftentimes you will want to manually index them because we use them so much. What an index does is increase the speed that we can work with these columns. So when we are doing a select statement, if we are selecting the columns that are part of an index, we are going to have a much faster query. Now the last thing I got for you guys is that when you have a foreign key referencing a primary key or a unique column, this is known as a relationship. And that is what we will be discussing in the next video. So thank you guys for watching. Hopefully this was helpful. As always, please click subscribe if you want to support this channel, and if you've enjoyed this video, please click like. If you guys got any suggestions at all, leave a comment and maybe I can make a video about it. Thanks guys, and I will see you in the next video. Hey everyone, welcome back to your MySQL series. We are going to be moving on to one of my favorite topics, relationships. Relationships are created when we have a column that references another column in a database. This is what's known as a foreign key. A column is a foreign key if it references another column. And that column it references has to be either a primary key or have the unique attribute. When we do this, we create a relationship. This is a relationship because we have multiple tables and they are related in some way, really. Now there are actually 3 types of relationships. Now we can only store these 2 in a database. This one we actually have to manipulate into, you guys want to know about that? I'll make you wait till we start talking about many-to-many relationships in the upcoming video. In the meantime, we are going to focus on one-to-one relationships. One-to-one relationships are actually very easy to understand. All it is an attribute that describes an entity. Now, if you don't remember what attribute and entity is, go watch the previous videos where I talk about terminology for databases, because that's all foundational to what we're talking about here. An example of this might be a user and a username. In this situation, the username is the attribute that describes the user. And then if you want to get more specific, we could give an example of a user and a username. So here's a user, and his username might be Caleb123. That specific username exclusively describes that specific user. If we have this other guy over here, he's not going to get that sweet name. He's going to have to come up with something on his own. Good luck though, because you cannot compete with Caleb123. Now that we understand that a one-to-one relationship is simply an attribute that describes an entity, how do we store this? Well, how do we normally store attributes? It's simple. We just store it as a column inside of a table. The table is designated for that entity. So we would have like a user table, and one of the columns would be whatever the attribute is. In this case, the username. So we could have a user with the ID of 7 and the username Caleb123. You're not limited to just doing this over one table. You can have one-to-one relationships over different tables. You just have to remember that you need to use the unique constraint. So if we had another table over here, we could reference the user ID, for example, and then what we would do is label this as unique, and that means this column is exclusive in that each row references only one ID. For example, 7. We could not have another 7. That would be against the rules. So that kind of sums up how to design one-to-one relationships. You either have it as a column inside of a table that describes that entity. The user table would be that entity right here. And the column would be the attribute describing that entity. Or you can have it over multiple tables. You just have to remember you need to use the unique constraint to force a one-to-one relationship. If you don't use the unique constraint, you create what's known as a one-to-many relationship, which we will talk about in the next video. So that's all for this. Thank you guys for watching. As always, please support the channel by clicking that subscribe button and clicking like. That really helps me grow my channel, and yeah, that's about it. So thanks. Peace. What's up, everyone? This is Caleb from Caleb Video Maker 2, and we are going to continue our discussion on relationships. We're going to be discussing one-to-many relationships. Yeah. We briefly discussed one-to-many relationships in your last MySQL video. And really, the concept is not that hard. All it is when there is a foreign key that references another column. To learn about one-to-many relationships, let's go through a simple example. Let's say we have a bidding website like eBay. I didn't say it. Where you can post stuff on there and people can bid on it to buy it. Now, the business rules of this application are that a user can create an account and they can create as many listings as they want, but one listing is owned by only one user. So you get this kind of setup. This is how you would draw a one-to-many relationship if you had to draw how everything was connected. That's because one user can have multiple listings, but a specific listing is not allowed to be owned by multiple users. So this situation it's okay, but this is not okay because now this listing is owned by this user and this user. That's not okay. So we're just going to erase that. When you have this kind of setup, the thing that is being referenced multiple times is going to be put in its own table. So you would literally just create a listings table. It's pretty simple. This listings table is going to have a foreign key column that references the user. So let's draw this out with some actual data. That way it's a little bit more concrete. Here we have the users table. We'll keep it simple. We'll just have ID, first name, and last name. Here we have a users table, and I've conveniently pre-inserted some data for us to use. So we have 3 people, Caleb, Amy, and George, and these are the users that are going to create listings on our bidding website. So this will become our listings table, and the columns will be the ID, and then a reference to the user ID, and then we can just say title, for example. If we wanted to get really in-depth with our bidding website, we could have a description and quality and all of that good stuff, but this is plenty for now. So let's put some data in here. We'll give the first one an ID of 1, and then we'll give it a title of pizza rolls, and now we just need to give it a user ID. Now the thing with database design is that we try to keep everything atomic. If you haven't heard of that word, it essentially means the smallest indivisible piece that still makes sense. So a user ID, we only want 1. We don't want to have 2 user IDs, and we don't want to have a half a user ID. And we only want to store user IDs in this column. We don't want to store user IDs and the user's name or anything like that. Everything has to be atomic, the smallest piece that makes sense. So in this situation, the column is atomic. That's because we're only storing one thing in this column, the user ID. But now the rows have to be atomic too. They only store one value for each column. So we already have one value for the ID, we have one value for the title, and we have one value for the user ID, and we'll make that 9. That was a hard choice. Now if we wanted to have a one-to-one relationship, all we would do is make this user ID column unique. That would force every single row to be unique, so a user could only have one listing. But we don't want to do that. We want it so that a user can have multiple listings. So we don't make this unique. Now we can have another item by the same person, and we can say this is, give me a weird item, hurry, Slinkies. I don't know how to spell Slinkies. Now you can see we have 2 rows that point to one user, but we don't have any rows that point to 2 users. In fact, it's not even possible with this setup if we're following our atomic rules. Only one user ID can be given for a single item. So this is how you properly design a one-to-many relationship. It's very similar to storing a one-to-one relationship across multiple tables. The only difference is you do not use the unique keyword. We can also have other data in here. For example, we could have another item by the ID of 8, and it could be, give me an item, hurry, dog treats, yum. And that would reference one individual user. So yeah guys, that's how you design one-to-many relationships. Hopefully that was nice, crispy, and crispy? No, not crispy. I don't know what I was trying to say. Probably like crystal clear maybe? Yeah, hopefully that was nice and crispy for you guys. I will see you in the next video. And as always, if you've enjoyed this, please click subscribe and give this video a like. Thank you so much, and I'll see you in the next one. Hey, welcome back everyone to your MySQL tutorial series. I'm Caleb from Caleb the Video Maker 2, and this video is going to be about many-to-many relationships. Now, I highly recommend you watch the previous video, which is one-to-many relationships, because this video is going to build off of that video a little bit. The reason I'm telling you that is because this is the exact same setup we had in the last video, and I'll describe this just a little bit. Essentially, we're trying to make a website where you can make auctions and people can buy stuff, right? So we have listings, and a user can post as many listings as they want, but one listing can only be listed by one person. So for example, this specific listing is only allowed to be owned by the user with the ID of 9, or the user with the ID of 10, or 11, but not more than one, only one. If you think of some popular auctioning websites, it's generally considered normal that an item being sold is owned by only one person. Now, there might be a couple out there where you can joint ownership something or joint list something, meaning this item could reference two people, for example. In that situation, there's kind of like a co-ownership, meaning when the item's sold, the revenue earned is split amongst people. That might not be common on an auctioning website, but it might be common on a website where you sell courses or something along the line of that, because a course might be authored by multiple people and the authors might split the revenue. So this might not apply directly to an auctioning site, but ultimately that decision is up to you or the business telling you to design this thing. That's because if you want to make an auctioning website where you can have multiple people own a single item, you go ahead and do that. It's your website, it's your application. There's not rules saying you can't do that. So that being said, that's what we are going to do in this situation. We are going to make it to where a specific listing can be owned by multiple people. Right now we have it set up as a one-to-many relationship. But as you can see, we're talking about many-to-many, so we need to alter this a little bit. Now, I want you guys to think about this really hard. If you're going to try to force a listing to be owned by multiple users, you're going to run into some serious database design problems. How would you even go about doing that? Let's think of some ways. Let's go with the pizza rolls. We could throw in another user in here. We could add a comma and throw in the user with the ID of 8. But this is going to break our atomicity or atomic rule. Now we have two values for one column. That is not okay. So you might think, let's add another row. So now we have the same item with a different user ID. But there's a problem here in that we have a repeating primary key, which is not acceptable. The other problem we are going to have is that now we have this pizza rolls in here twice, and that's redundant. Now this column is probably not marked as unique. If it was, then we couldn't even do this. But the chances are it's not, so therefore we're just going to have duplicate data. And just by chance, let's say we could do this, and one time this was updated, this one might not get updated, and then we have conflicting data. So bad design like this leads to conflicting data, and that's really bad. Nearly any time you have a problem like this, the solution is to add a table. I know it sounds like it could cause problems just adding tons of tables, but I'm serious. So let's add a table and see if it works. What kind of table are we going to need? The table is called an intermediary table. And this table is going to go between these tables and just be like, whooshah, and it's going to separate them. This is going to allow us to store a many-to-many relationship in a database. So what we are going to do is put a new table here that's going to be in between the users and the listings. Now this table, by convention, is going to have the first table singular, so user underscore the second table plural, listings. And this is going to make associations from the users to the listings. So the only columns we really need in here are the user ID and the listing ID. Now let's fix up this crap. First, let's get rid of that row. We don't want that at all. And then I'll put this up here so we know that we want to put two of those over here. So the first one, let's just go row by row and we'll show how to convert this data. Now obviously you're going to want to design this right from the beginning so that way you don't have to move data from tables to tables. That's just bad. So the first thing, we're going to grab the listing ID 1 and associate that with some user. Let's go with 9. Now you can see this is going to allow us to have multiple users because we can just add a new row and have the same listing ID and a different user ID. Now these columns are not labeled unique, but actually the whole combination of both of the columns can be labeled unique. That means we can have 9-1 and 8-1, but we can't have 9-1 again, because that would mean both of these as a group are not unique. So that means in this table we can just get rid of this. And then let's add another row. We'll have 2, user 9, 3, and user 8. As you can see, we're not going to need to store the user in here anymore because all of that information is found in the user listings table. So we can just get rid of this entire column. Now let's draw lines just to show how these are connected, and that will help us visualize this. So 8 goes to 8, and to 8. And then 9 goes to 9, and 9. Then on this side, 1 goes to 1, 2 to 2, and 3 to 3. Now this will help you visualize how we broke up this many-to-many relationship. We actually broke it up into two one-to-many relationships. For example, look at this ID. On this side we have one ID that's referenced twice. And it kind of goes in multiple directions this way, like this. And that is actually how you draw a one-to-many relationship when you're designing tables. It'll look something like that, except prettier. You will never have it where you have an ID breaking off like this. Because you can see here now, it's backwards. And we have many-to-many. Again, so that will never happen. We fixed the problem of many-to-many by breaking it up. So this is a pretty good summary of how you design a many-to-many relationship. You just need to break things up into 3 tables. In the next video, we are kind of going to conclude all of the relationship stuff and just go over a quick overview of how to design each relationship. Thanks guys, hopefully this is helpful. If you enjoyed it, please click like, and as always, click subscribe, and I will see you in the next video. Welcome back everyone to your MySQL tutorial series. My name's Caleb from Caleb the Video Maker 2, and in this video we are going to be summarizing our discussion on relationships. Now I'm not going to do a whole lot of drawing just because I wanted to talk about it. I want you to understand conceptually what you need to do when you have one of these 3 relationships. And you will always have one of these 3 relationships when you're storing data in a database. If you don't remember all of the specific details, that's okay, you can always come back to these videos and watch it. But I want you to think through this, try to memorize the content of this video because I'm not going to give you any specifics. This is going to be a rough overview and a rough summary. So the very first one we talked about was a one-to-one relationship. This is an attribute that describes an entity, and you can just store it in the same table. You don't have to create a whole nother table for it. You can though if you want that separation for some reason. For example, if you want some data of the user stored in a different table, that's fine. The only thing you're going to need to remember is to mark the foreign key as unique. That's because we don't want to have multiple entries relating back to one entity. That would break the rules of one-to-one, and that is actually how you set up a one-to-many relationship. In a one-to-many relationship, you can store as many rows as you want, referencing back to a single entity, and that foreign key is not going to be labeled unique. The parent table, that's the table being referenced, doesn't need to know about this other table. You don't have to put any foreign keys in that table. That other table doesn't exist. It's just alone by itself, but that table that references it knows of the parent table. So the foreign keys reference the table, but there's nothing in the other table to reference it back. There is a layer of separation, and you can do that to separate one-to-one relationships like that, or you can do it to make one-to-many relationships. Now the third option is many-to-many relationships. And we actually can't store these in databases very easily, so the way we do it is to break it up into 2 one-to-many relationships. In this situation, you are going to need 3 tables. One to store one entity, one to store the other entity, and then an intermediary table to kind of break that many-to-many tension between the 2 tables. So kind of think of like the 2 tables fighting because they're both trying to reference each other and they want to be the one, I don't know. Imagine them just kind of trying to reference each other and one wants to be in the lead or something like that. Something to imagine conflict. And then this intermediary table steps in, cuts that tension in half, and separates the 2 entities and fixes all the problems. In that situation, you are going to have one-to-many relationship facing this way and a one-to-many relationship facing this way. Now inside of that intermediary table, the combination of the 2 IDs or the foreign keys are going to be unique. That means the entity over here can be in there multiple times and the entity over here can be in there multiple times, but not the combination at the same time multiple times. That's because it's an association. If you associate a row from over here and a row from over here, they're already associated. You don't need to associate them multiple times. That would not make sense. You can actually use the combination of the 2 IDs as the primary key. So in summary, one-to-one is just 1 table. One-to-many is 2 tables, and many-to-many is 3 tables. Hopefully that was helpful, guys. Please be sure to click like if you've enjoyed this video, click subscribe if you want to support this channel. And as always, go check out the next video because that's when we're going to introduce a new topic, and that's going to be great. So I'll see you then. Welcome back everyone to your MySQL tutorial series. I'm Caleb from Caleb the Video Maker 2, and in this video we are going to start talking about data integrity. Now there are three categories of data integrity. We have entity integrity, referential integrity, and domain integrity. Each one of these is going to get its own video. So this video is going to talk about entity integrity. Entity integrity is very simple. All it says is that every table needs a primary key. When you label something a primary key, it's automatically going to be unique and not null. Sorry, my dog is feasting right now, so if you hear nom, 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 nom in the background, it's him. I apologize, he could not be stopped. In addition to this, a primary key should never change. These are the three things that need to happen for something to be a primary key. Now there's actually two classifications of primary keys: surrogate keys and natural keys. Surrogate keys are simple. They're just computer-generated numbers that have no real-world meaning. So this is often the ID column in a table. Natural keys, on the other hand, are a little bit harder to work with because these have to have real-world meaning, such as a username or an email or anything that can be unique. Okay, Onyx, quit licking the floor. Now this is not something we tell the database. We don't say, yo database, this is a surrogate key or this is a natural key. Onyx, drink water, drink it. Drink your water. These are just terms for us to help understand the different kinds of keys. And these are terms people are going to use, so you need to understand them. Why is having a key so important? Well, if you have a table, and it doesn't matter what the columns are, let's just say that's a row. And then we have another row, and you can see this is duplicate data. And this brings up the question, do we have 1, 2 entries that are supposed to be different, or is this the same entry in there twice? It's kind of confusing. But if we have a primary key, we can always assume that they're two different things. So for example, if we have here 8 and 9, and this would be like the ID, we know that this describes an entity and this describes an entity. So these are unique. Check. They're not null because every single one has a value, and it has to never change. Let's see what would happen if it did change. Let's say this changed to 19. Now we're confused because it was 9 and now it's 19. So does this 19 refer to a new entity or the same entity with a new ID? It's confusing. If we were following the rules of primary keys and that they never change, I would assume that it's a new entity. And since people assume that, we don't want to change our primary keys ever. So if you're using a natural key, you gotta make sure it's something that's not going to change. And that's kind of hard to figure out. Like an email, that's pretty good because it might not change, but what if someone wants to change their email? Well, then they have to change their account information, and then it's no longer a very good primary key. So you'd have to restrict people to not being able to update their email. Well, a username might work because in that situation, it's not going to change. You can restrict people from updating their username. That's just for like a user table example, but you're gonna have those kind of problems with any table that you use natural keys. Because of that, I think more people are starting to use surrogate keys. Are surrogate keys better? I don't know, that's up to you. There's downsides and upsides to using either one. For example, natural keys are much more readable. Instead of having this number here, we could have a string that actually has a value in it. And this allows you to do less joins, which we haven't really discussed, but essentially when you have multiple tables and you want to get data from both of these tables, you have to join them. Natural keys allow you to use less joins, but in general, I'm probably going to go with surrogate keys. I think they're easier to work with and I think they're more common. If you want to use natural keys, I'm totally cool with that. Just make sure that they're unique, not null, and they never change. Never. So yeah, everyone, that's your introduction to entity integrity. If you've enjoyed this video, please click like and subscribe. And as always, I will see you in the next one. Woo! Hey everyone, welcome back to your MySQL tutorial series. I'm Caleb from Caleb the Video Maker 2. This video is going to be discussing referential integrity. This has to do with foreign keys referencing other columns. So when we have a foreign key, we could say it's a reference to another column. And we need to protect our references' integrity. What does that mean though? It means we have to tell the database that this is a foreign key. So this is something we have to explicitly do, meaning there's no conventions that go on that automatically connect columns or anything like that. Any kind of connection across tables or across columns, we have to tell the database explicitly. If you don't tell the database, you might think that's fine. We can just pretend there's a connection, right? Let's say you don't want to use foreign keys for some reason. So you have this number over here, this ID, for example, and then you reference that ID. But you don't tell the database that there's a reference, then these are separated. You can't draw the line between the two. And what that means is that there's no restrictions on the data you're allowed to use. So for example, I could make a reference to 198, and even though there's not a 198 over here, that's okay. That's because the database doesn't know any better. To the database, it's just a number. It also means we can just get rid of this row, and the database isn't going to care. This 37 is still going to exist over here. This throws our references integrity into question, because we can have a reference, but we don't know if it actually points to anything. For example, this one, it points nowhere. So how are we supposed to know which ones point somewhere and which ones don't point anywhere? That's what I'm talking about with integrity. If you don't have data integrity, you can't trust your own data. And if you can't trust your own data, your database is not worth anything. That might be a little harsh, but seriously, get your data integrity. We need to tell the database explicitly using the foreign key constraint. We'll get into the syntax on how to do all that soon, but just know for now that when there is some kind of reference, you have to do it manually. You have to tell the database what column from what table you are referencing. In addition to just telling it what is referencing what, you can do stuff such as on delete and on update. Essentially what these mean is what happens if we delete the parent or change the parent to a different ID, which by the way should never happen, but in theory, let's say it happens. These are things you can configure with your foreign key constraint, and we'll get into how to do all of that in an upcoming video. But for now, I think that's good. I'm sure you guys understand what referential integrity is. It's when your reference can be trusted. You know it references something, you know it's up to date, and you know it's referencing the correct thing. That's what we strive for. It's impossible to have perfect integrity in a database, but we can get pretty darn close. So that's what we're going for. Thank you guys. If you like this video, please click subscribe and like. And as always, I will see you in the next video. Yeah! Oh! Hey, welcome back everyone. It is Caleb from Caleb the Video Maker 2, and in this video we are going to be talking about domain integrity. Now, I'm fairly confident in you guys. What we've studied about MySQL is probably enough to where you already have domain integrity. The reason I'm making this video is so that we cover all the details of integrity, for one, and for two, when someone says domain integrity, you're not like, duh, I don't know what you're talking about. Just because you might understand all of the pieces of domain integrity doesn't mean you understand that those pieces build domain integrity, if that makes any sense at all. So once we start talking about it, it might make a little bit more sense. Domain integrity is essentially when our data fits what is appropriate or what is expected for a certain column. This requires us to define what's allowed and what's not allowed. That whole concept is known as domain. The proper data inside of a column contributes to domain integrity. So if we have a column and we're expecting a phone number, we want to make sure all of that data in that table for that column stores a phone number, not just random text or a few numbers but not the whole thing. We want to ensure that the data is as close as possible to what's expected. So the domain establishes what's not allowed and what is allowed. So we want to make sure all of our data fits inside of here, and it doesn't go too far this way or too far that way. This might make sense with numbers, like not too low or not too high, but I'm just kind of drawing this generally. We got to make sure we fit within the rules. So we don't want to make something too long, we don't want to make it too short, we don't want to make it too high, we don't want to make it too low, everything like that. So another way to think about it is this entire thing would be the possible values, but we are only going to accept some of the values inside of this area right here. That is domain. Now with MySQL, there are a few ways we can enforce domain. The first is with a data type. This is by far the easiest way to get some level of domain on a column. That's because if you have something such as a numeric data type, that's automatically going to reject strings like string. That's because this is not a number, it's a string. It doesn't go inside of a numeric column. So data type is one way. Obviously the two constraints we talked about, not null and unique. These can also be used to help with the domain integrity because we can force every single row to have a value or for every single row to have a unique value. That further restricts the data. All of these are the simple way of protecting our domain. Now, some database management systems have what's known as a check constraint, and these things are pretty cool, but unfortunately MySQL does not have these. That's when you can say something like, we want a value to be between 5 and 50, for example. There are ways to mimic this in MySQL, but that requires more advanced MySQL knowledge, so we're not going to dive into that right away. That means if we want to be very specific on what's allowed, like if we want to say, oh, just this data, so we could say something like any phone numbers that fit a certain format. That's all going to have to be done with advanced MySQL or application logic. What does that mean though? Imagine a website, right? And you're signing up and you have to put in an email. And you just put some garbage in there that's not an email, clearly. Well, you can do things to make sure that that data is an email. For one, on the client side, you can make the input an email, which with HTML5, that's already going to bark at you and tell you you're doing it wrong. Then, even if someone bypasses that by modifying the HTML, we can have server-side code, such as PHP, check the data and see, is this really an email? And if it is, then we can store it into the database. If it's not, we can return an error. So all of that goes outside of the database, into the application. It's a separate thing, but just know that we can restrict data to be very specific. Not so easily with MySQL, although it is possible. So thank you guys. Hopefully this was a good overview of domain integrity. Obviously, we're not supposed to dive in and conquer the whole concept of domain integrity. We're not going to get into this stuff or how to mimic check constraints in MySQL for a long time. So let's start slow. Let's go with this. Hopefully that was helpful. And as always, I will see you in the next video. Also, one more thing. If you guys want to support this channel, please click subscribe and like this video. Thanks, guys. See you in the next one. Guys, look. There's deer in my yard. What's up, everyone? It's Caleb from Caleb the Video Maker 2. Welcome back to your MySQL tutorial series. This video we are going to discuss primary keys. And we've had some primary key information kind of sprinkled throughout the series, but we never actually devoted an entire video or two to just primary keys. I think this is going to be useful because it's going to take all those chunks and kind of piece them together so you can get the big picture of primary keys. So let's discuss primary keys. What are they? A primary key allows us to uniquely talk about an individual entity or a row. So imagine we have a table and we just have, millions upon millions of rows, and we want to talk about a very specific row, one row out of millions. How do we do that? Well, the primary key makes this very simple because it allows every single row to have a unique identifier or an ID. An ID is essentially a number that's generated by the database. It doesn't mean anything in the real world, but it allows us to uniquely talk about a specific row. So imagine you're walking down the road and some guy comes up to you and he's like, bro, can you give me information on the user in your users table for your database? Because, databases are forgetting data, so this is a potentially real situation in the future. And you're like, wait, which user are you talking about? And he starts describing him. He's like, oh yeah, he created his account somewhere in January or July, or January or February. And he's a premium member, and all these criteria. And essentially what you do is you start searching through your table and getting rid of anything that doesn't match that criteria. So you get rid of all the users that didn't create an account in January or February. You get rid of the ones that don't meet any of the other criteria. But you're still left with like a couple hundred users, and you can't talk about that individual user because you can't define that individual user. Wouldn't it be a lot easier if that guy came up to you and he was like, psst, give me some information on the user with the user ID of 3072. And then you'd be like, oh, okay, well this username has this and this and this. It allows you to uniquely identify that user. That's just one example. You can use IDs for other types of tables. It's not always a user table. Almost every table you work with is going to have an ID. And if it doesn't have an ID, it's going to have something to uniquely define it. The ID is known as a surrogate key. That is different than a natural key. A natural key is actually used for something. So he could have came up to you and said, hey, give me information on the user with the username of whatever the username is. And as long as that username is unique, it would work. So what do we need in order for a primary key to work the way it's supposed to work? Obviously it has to be unique, like I just said. So the data has to be unique. In addition to this, it has to be not null. That means every single row has to have a value. Finally, the data should never change. Now these two are pretty easy to enforce with MySQL because these are constraints. You can literally just say unique right after the column definition when we're creating a table. Same with not null. Unfortunately, the whole concept of the thing never changing is not quite as easy. In order to help the data never change, it's helpful to use either an ID or a natural key that is not likely to change. For example, an ID will never change because why would it? The only use is for the database. There's not going to be a situation where the user asks to change their user ID. That's because they don't even know what their user ID is. A username could be a natural key, and that might be a good one to use because the chances are you could restrict users from changing their username, and they'll be fine with that. That would work as a natural key, and it probably will never change. So it's pretty simple to think of a natural key for a user table, but when we start creating other tables, it might get kind of complex and complicated trying to figure out what do we need to force every single row to be unique. That's why I think more people are moving towards surrogate keys. I think they're more commonly used because they're just easier to work with. That's because these three things are automatically very easy to get. These two can be easily enforced, and the data changing is not likely. Now when you actually insert data into your table, and you have a primary key that is an ID, every single row is going to have a different value. So we might have 1, 2, 3, 4, and you might get annoyed with having to figure out what's the next number. Fortunately, MySQL has a very easy way to figure this out and get this to work, and that's by labeling that column as auto increment. Kinda ran out of room here, but that's okay. I think actually that's where I'm going to start talking about in the next video. That's just because I don't want this video to run too long and bombard you with too much information. So be sure to check out the next video where I'll discuss auto increment and a couple of other things. So thanks guys, and I'll see you in the next video. Welcome back everyone to Caleb the Video Maker 2. This video we are going to be talking about the auto increment attribute. Now I mentioned the word attribute, and these are the things we put after the column when we create our table. So we might have something like user ID, and then we could say primary key, and then add auto increment. These are both examples of attributes, and this would all be inside of a create table, which we'll discuss create table in detail in an upcoming video. So let's not get distracted, just know that auto increment is an example of an attribute. Now what is auto increment though? It's automatically going to increment a value. What does this mean practically though? It means that when we do an insert statement, we're not going to have to figure out what ID number to put in. It will automatically do that for us. So once we get into the insert statement, it'll make more sense, but essentially what we're going to do is say insert into, and then say some table, let's say users. And then inside of here, you can put what columns you want to put, and you can leave out the ID, so you don't have to put the ID, but you can put everything else. And then you put all those columns there, and then you say values, and you can leave out the user ID. You don't even have to worry about it because it's not even expecting the user ID up here. It'll automatically take the highest value that's in the table for the user ID and add 1 to it for the new value. So that way we don't have to worry about adding 1 to our value all of the time. That's super useful because that basically just allows us to ignore the IDs. It's only for the database. We don't even have to think about it. That's one thing I was going to talk about in this video. The other thing we are going to talk about is compound or composite keys. A composite key is a key that consists of multiple columns. And the reason you would do this is if you need to figure out a way to make the table unique, and one ID or one column is not enough to do it. You will often see this inside of an intermediary table. So if you don't remember what an intermediary table is, it's the table in the middle of a many-to-many relationship. So we break up a many-to-many relationship into 2 one-to-many relationships. And in this situation, this table is going to have 2 IDs. An ID for this table and an ID for that table. And one ID, for example, if we have an ID over here, 7, it can repeat as many times as it wants. But the thing is, the combination of that ID with an ID of this ID needs to be unique. So it's a little confusing, but let's say we have 7, 6, 7, 8, and 7, 9. So this is a little small, so let's blow this up a little bit. We could as well have a row such as 6, 9. So in this situation, the 6 is repeating, and the 7s are repeating. So we couldn't just use 1 as the primary key. That's because it's not enough information to force every row to be unique. So what that means is we need to actually make the combination like this the primary key. In that situation, that is an example of a composite key. Now, if both of the columns are keys themselves, in this situation foreign keys that point to these tables, it's known as a compound key. But the distinction is small, so I wouldn't get uptight about it if someone says composite or compound. Just think of them as the same thing, a key with multiple columns. And remember that the time you need to do that is when one column is not enough to make each row unique. This table in the middle here is basically an association table. You only want a specific association to be in there one time, but not a specific ID over here or a specific ID over here. Because then think about it. That means this one here could not be associated with any other IDs except 6. That'd be stupid. We want to be able to repeat the 7 as many times as we want, but we don't want the combination of 7, 6 to be repeated. In that situation, you would want to use a composite key. And you can do that when you create the table. At the bottom, you can say primary key, and then you can say what columns you want it to be. And you can throw in 2 or more columns. This is often a lot more common with natural keys, which is just a column that has actual meaning. That's because it often takes a couple columns to make the rows unique. So that's just a rough overview. If you didn't grasp everything in here, that's okay, because once we start creating this information and putting this into an actual database, it's going to make a lot more sense. This is more concept stuff, so when we get there, you're not completely lost. But don't worry about the details of, oh, how do I create this? What's the syntax and all of that stuff? Worry about that when we get to the create table statement. Thanks, guys. Hopefully that was helpful. If you guys like this video, please click like. And as always, click subscribe, because that really helps this channel, it helps my channel grow, and it helps other people know that I make good content. So if you want to help my channel, click subscribe, and I will see you in the next video. Be sure to check the next video out though, because we're going to be talking about foreign keys, which are very, 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 very useful. Thanks, guys. I'll see you then. Merry Christmas, everyone. It's Caleb from Caleb the Video Maker 2. This video we are going to be discussing, for some reason I forget, foreign keys. Just like in the primary keys video, I said we kind of sprinkled this information throughout the series, but this one's kind of just going to put it all together, but mostly we are going to be discussing column attributes related to foreign keys. So, foreign keys reference primary keys. When you make a column a foreign key, you are saying every single value in this column has to be a value that exists in whatever column we're referencing. That's essentially what a foreign key is. Now, a foreign key has to reference a column that is unique. Kind of goes back to that example I gave you of some guy coming up to you on the street and asking you for some information. If you don't have a specific way on how to identify a row, it's hard to reference that data. Same thing applies for foreign keys. The foreign key needs something it can reference that is unique, so that way it knows exactly what row you are talking about. This would also include primary keys, because primary keys themselves are unique. Now when you create a primary key, I'll put that over here, it is automatically unique and not null. What about foreign keys? Well, foreign keys are not these by default. This is something you have to choose. Do you want the foreign key column to be unique? Do you want the foreign key column to be not null? And that requires some thinking on how we want these databases to be designed. So the easiest way to think about this is, rather than having tables referenced this way, it's to rotate the whole thing and create parents and children. So the foreign key down here is the child. PK up here, the primary key, is the parent. This allows us to kind of think about things a little bit differently. Put this into like a family tree kind of thing. So when we do this, rather than thinking of a column referencing another column, think of an individual row referencing an individual row. Because when we make a foreign key column, that's essentially what we're saying. We're saying a row for this column has to reference another row. So to make that a little bit more concrete, let's use some actual data. Here we have a row, and it has a column with the value of 7. And here we have a child row that has a value of 7 pointing back to that 7. So this here would be inside of a foreign key column. So if you wanted to draw that out, we'd have a table, probably an ID for this table, and then an ID for the other table. And this would be a foreign key. So we could have like 2, 7, for example. We could have 3, 7. We could have 4, 8. This individual row references this parent. So does this row. So we actually have 2 rows that reference this parent. So that's kind of the way this design works. This is how foreign keys work. So we're just going to write parent and then 2 children. Now we need to ask ourselves, what is the unique and not null constraints going to do to these rows? So first, let's draw these out. The first one, unique. That means if we have a child with like the ID of 7 referencing the parent, we cannot have another child referencing the same parent. That would not work. This is basically the way you design a one-to-one relationship over 2 tables. That means this child is going to have to reference a different parent. So here the child references the parent, and here the child references the parent. But we can't have 2 children referencing one parent. That's what the unique constraint will do. And I call these attributes. That's another name, but there's a slight difference, and we'll discuss that in a future video. But essentially, an attribute can be a constraint. These are both examples of constraints, but not all attributes are constraints. Sorry, kind of off topic, so don't worry about that, but that's what the unique constraint is going to do. So if we have 2 tables, and we'll draw each row as a line, just for simplicity, and let's say this is the primary key, and this is the foreign key, one row can reference one parent, but that parent cannot be referenced by another column. That's not allowed. That means there's exclusivity between this child and this parent. That's the only association. We can't have it like this or anything like that. Now what about the not null constraint? What that's going to do is basically force every single child to have a parent. So if we have another child over here, we could theoretically have a null for the value of what the parent is. And in that situation, there would be no parent. But if we say not null, we're basically saying every single child has to have a parent. But if we're using unique, we couldn't do that. We'd have to point it to a different parent. So whenever you have a foreign key, ask yourself the 2 questions. Should it be unique, and should it be not null? Would it make sense for the child to exist with no parent, just orphaned all by himself? Or does it make sense that it has to have a parent? It really just depends on what you're working with. More often than not null is going to be applied, but not always. So that's a rough overview of unique and not null for foreign keys. Hopefully that was helpful. I know we didn't discuss everything in foreign keys, and because of that, we're going to talk about them a little bit more in the next video. So be sure to watch that, because we are going to be discussing the onDelete and onUpdate clauses. These are 2 more things you need to consider when you're creating foreign keys. So that's all for this video, guys. Thanks for watching. Please be sure to subscribe and click like on this video, and I will see you in the next one. Yeah. Hey guys, welcome back. This video we are going to be discussing onDelete with foreign keys. My name is Caleb from Caleb the Video Maker 2, and I hope you guys enjoyed the video. OnDelete is essentially a way we can configure the way our foreign keys work. And it kind of goes back to the last video, so I really recommend you watch that. We are going to discuss parent and children. So we're going to have a parent row, which is the row being referenced, and then we're going to have the child, which is the row referencing that parent. And we need to discuss what happens when we delete the parent. What happens to the child? Well, there's actually 3, kind of 4 options with MySQL. And the options are restrict, cascade, and set null. And we are going to be discussing each one of these. Now, there's also no action, which is just another name for restrict, but it's not always the same thing in different database management systems. So if you ever use a different database, know that there might be a difference between no action and restrict. But in MySQL, they're the same thing. So restrict, that's the default. So if you just make a foreign key and you don't say anything, like you don't put on delete something, the one that's going to be applied is restrict. Overall, these are pretty easy to understand. It's more important that you just know that they're there in case you need to use them. So the parent and then the child. The first one, restrict, is literally just going to prevent us from deleting the parent. That's the default, so if you go and delete the parent row, you're going to get an error, and MySQL is not going to let you do that. Cascade, on the other hand, will actually send the same command down to the child and delete the child. So if we delete this parent row, the child row will be deleted as well. Now if we go to set null, what that means is that the field within this child row that references the parent. So let's say this is all the information. We have maybe an ID of 7, and it depends on what the table's about. But let's say it's a user's table. We might have a user's name, and then we'll have a column that references that parent. And if we, for some reason, delete this parent when onDelete is set to set null, what that'll do is replace whatever value that's here, referencing the parent, to null. That might be useful if you want to be able to delete the parent, but you don't want to also delete the child. Because if you did restrict, you couldn't delete the parent. If you did cascade, it would delete the child. But finally, set null will allow you to delete the parent without deleting the child. A lot of words there, it kind of gets complex, but I think once we go into actually creating tables, this will make a lot more sense, but it's really good to go through the conceptual stuff first, so then when you get there, you're not completely lost and we can just kind of do a little bit of refreshing. The important thing to remember here, though, is that this column cannot be set to not null, because you couldn't put a null inside of a not null column, so that's not going to work. And actually, there's another setting you can do, which is on update. This one is used a little bit less, but it essentially works the same way. But instead of deleting the parent, what we do is we actually change the value that's being referenced. So let's say we have the value 7, and we have the value 7 here, and we reference the 7, and then we change the 7 to 8. With restrict, it's just not going to let you change it, and it's going to force it to stay at 7. Cascade will send that change down to the child, and they'll both be changed to 8. Set null will literally just erase this value here. So that's kind of how all of those work, and the reason onUpdate is used less is because primary keys are not supposed to change, so it's really only useful when you're referencing unique data that's not a primary key. So a foreign key can reference a unique column, but a unique column does not have to be the primary key. So this could reference a column that's unique, and theoretically that data could change. So that's where the onUpdate comes in. Now, where do you actually put this information? Well, when you create the foreign key, you will just append onDelete, whatever, onUpdate, whatever, and right there in the create table statement. But we'll get into all that when we get to the create table statement. So thank you guys. Hopefully that was helpful. If you like this video, please be sure to click subscribe, as that really helps my channel out. Click like, as that lets other people know this video wasn't a total piece of garbage. And that's all. So thank you guys for watching. I will see you in the next video. Hey everyone, it's Caleb from Caleb the Video Maker 2. Welcome back to your MySQL tutorial series. This video we are going to be covering normalization. This is going to be an introduction. That's because the next few videos are going to talk about each of the normal forms. If you have no idea what I'm talking about, don't worry about it, we'll get into it. But essentially, normalization is a process we go through when we're designing a database to help make sure our database has the right structure. Normalization! Now, everyone makes normalization way too stinking complicated, so I'm going to try and explain it in English. But essentially, normalization has 3 main steps, and they're called normal forms. We have first normal form, second normal form, and of course, third normal form. There are a couple others after these if you want to research more, but I think once you get to third normal form, you can say that your database is pretty well normalized. Normalized is kind of like the finish line. So if you've learned about normalization and it doesn't really click with you, essentially think of it as pouring dirty water into filters, okay? The dirty water is your database, the filters are the normal forms, and you have 3 filters. The top filter has very big holes, so this just gets rid of like the obvious things you shouldn't drink, like rocks and snakes and scorpions and explosives. It gets rid of all of those ones. The second normal form has a little bit smaller holes. So this is going to get rid of, dirt. And then finally, the third normal form has like really, really, really small holes. So that's going to get rid of like bacteria, viruses, all of that good stuff. Now, this is an illustration, so it doesn't apply directly to databases. But essentially, after you get through all of those filters, you're going to have nearly pure water. If you want, you can add more filters by adding more normal forms. But there's a consequence in that the database becomes more complex. Just like if you add 20 filters to a water filter, things become more complex and more disorganized. So when we use the normal forms, we are going to look at our database with a certain pair of eyes, or think of like glasses, and we're going to look for certain things that are wrong with our database structure and then fix those. Each normal form has to have the previous one done in order to do it. So second normal form requires that first normal form is already complete. Sort of like if you have these filters in the water filter, the second one is going to be hit after the first one is already done. Third normal form, same thing. It requires that second normal form be done. And obviously, if second normal form is done, first normal form is also done. So you have this chain. Now, when you study normalization, you are going to run across the term dependency. This is when something depends. No, not like the diapers. This is when something depends on something else. Essentially, think of a column describing whatever the table is. So a users table, every single column inside of the users table describes this user. You could say the user is the entity, and each thing describing it is the attribute. We can talk about a specific user using a primary key. So for example, we could have an ID. And that ID, for example, could be 7 for a specific user. Now when we describe this user, we might have something such as an email. This is an example of an attribute. This email depends on the user. That's because if we change the user to someone else, the potential of this changing is very high. That's because every user doesn't have the same email. So that is an example of a dependency. And there's different types of dependencies that we're going to talk about when we're going over these normal forms that are not okay. So for example, second normal form talks about something known as a partial dependency. Third normal form addresses something known as transitive dependencies. That being said, I'm not going to bog you down with all of the details because when you study this stuff online, people talk about dependencies more than they talk about databases and how to design them. So you end up reading an article and you have no idea what they're talking about. At least that's how it is for me, but I'm not a super genius unlike all the other people who do this kind of stuff. So hopefully because of that, I can explain it in English. A question we have to ask now is, how do these normal forms work? How do they actually improve our database structure? The primary way they help us is by getting rid of redundancy. Redundancy is when we have something in a database more than once. For example, if we have a comments table, we might have a comment ID, poster ID, the actual message, and if applicable, any replies. So we'll store one reply in here. Now this is not the best way to design a table, and you'll see why in just a moment. Let's go through some example data. So the comment has the ID of 1032, just some random number, and this points back to a user with the ID of 702, for example, and the message can be anything. And this is the original comment, therefore it's not a reply, so we'll just say null. Then someone comes back and replies. And because this one is a reply to this message, all we gotta do is say our reply. And this person says, nope, I disagree. And the message we're replying to is the one that says great. And you can see that this is just an awful way to design this. That's because we have this message in here twice, and also this message cannot uniquely define a row. There could be 50 comments that have great. This here, though, is an example of redundancy. That's because we have the same data in here twice. And now let's say in our application, this person goes back and edits their comment. So he grabs his comment, the guy who posted this one, great, and changes it to, okay. So to do this, we would use an update statement and say, update the message of the comment with the comment ID of 1032 and change it to whatever we want to change it to. But this is dumb because it doesn't update this one. This is an example of an anomaly. An anomaly is when something does not work the way it's expected to work. It's out of the ordinary. With database normalization, though, we can prevent anomalies. But do keep in mind that this builds off of relationships. So that's something we talked about in previous videos. I highly recommend you remember how to design a one-to-one, a one-to-many, and a many-to-many relationship. Because just doing that alone would help us to understand how to design tables pretty good. We also need to have a foundation in primary keys and foreign keys, because that alone would help us understand that this is just a dumb way to design this. We'll get into the good ways to design things in the upcoming videos. But that's all I have for you guys for now, so thanks for watching. Sorry if I rambled in this video, I just wanted to make sure to give a good foundation for the upcoming videos over each of the normal forms. That's because this stuff is super important. So thanks guys, and as always, please click like, and if you enjoy this channel, please click subscribe. Thanks guys. Hey, what's up everyone? It's Caleb from Caleb the Video Maker 2, and welcome back to your MySQL tutorial series. This video we are going to start our discussion on first normal form. Now first normal form is our first layer of normalization. It gets rid of the most obvious, most simple mistakes in our database design. And first normal form really focuses on things being atomic or singularity. If you want to make sure your database adheres to first normal form, you want to make sure that every single column in a table is single. So if we have, let's say, we'll go off of this example we've been working on, an auctioning site. So this site people can sign up for and they can put items on there and sell them and make some money. And on this website, let's say you can put your social network links on there. So you can link to your Facebooks and your Twitters and your MySpaces and your LinkedIns and your Twitters, oh I already said that, and your YouTubes and your Google Pluses and your other social networks. So how do we set this up? Let's say we have a users table and we'll add some columns. We'll say user ID, email. Now this is where the first example of singularity comes in. Each column describes only one thing, an email. We don't have email and social networks. We split that out. In addition to that, we want our column headers to be singular. So we could have in here, I'm going to break the rules and say social networks with an S. This is breaking the rules because this implies that you're allowed to put multiple social networks in one row, which you're not. That's also breaking the rules of singularity. So each column has to describe one thing, and it has to describe only one of that one thing. So one email. In this situation, how would you put data in here? Well, you might have a user ID of, let's say, 10, an email, and then you could put your social network links on here. So you could say, you know, Facebook, comma, Twitter. But this is not single because we have two values for that column, which is breaking first normal form. Now that we broke the rules, how do we go about fixing it? There's two ways we can fix this. The first one is in the column header. Don't make it plural. When we do that, we would imply that we only want one value. The downside to that is that you can only have one value. So we'd say our Facebook. So you could have your Facebook link, and you're limited to just one value in that column. If you wanted to try to put two, you'd have to figure out another workaround, such as adding a row. But the downside here is that we have this email repeating, and we have a primary key repeating, which is not okay. So this too is not going to work. So how do we fix this the other way? How do we allow us to be in first normal form, but also allow multiple social networks? The only possible way is to add a table. So we could have another table up here, and we can name it networks. Now it's going to have a couple columns. We could say ID, so each row is going to get an ID, and we could say user ID, and then network. So now each network is going to get an ID, so we could say 1, and then we could have the user ID of 10, and this is a reference, so this will be a foreign key to this column right here. And then we'll add the network in there. Obviously we would put the whole link to their Facebook, but that's fine for right now. Now that we have this, we can alter the original table. We actually don't even need this social networks column anymore. And we don't need this row because that's redundant information and it's not allowed. So the final result is just going to be a user ID and email, and then any other data that's related to the user goes in here. Any data related to the network would go in here. This is essentially making a one-to-many relationship. And you can go back and watch that video about one-to-many relationships. But essentially, this is going to have a foreign key, the user ID, and the parent is not even going to have anything referencing back to the children in the main table. So the users doesn't even need to know about the networks. Now this column here, you could potentially get away without having it, because you could have this as the combination for the primary key. But in this situation, I think this way makes a little bit more sense. And that's how I'm going to go for that one for now. The last thing with first normal form is that every column needs to describe the entity. So in this situation, we have a user table. So that means we couldn't have a column over here like listing details. That's because this doesn't even describe the user. So everything inside of first normal form, you could summarize it as every column describes the key, the user ID in this situation. And every column describes it singularly. So each column is individual, and there is no repeating rows. So if you make everything singular, I'm sure you will do just fine with first normal form. Now you might be asking, what about this here? Users. That's plural. Well, that's because it's a table for users, but each row describes only one user. You can't store 2 users in one row. So yeah guys, that's first normal form. Hopefully that was helpful. If you like this video, click like, and as always, be sure to subscribe because that really, really helps me out, and I appreciate it. So be sure to watch the next video, and I will see you then. Yo, what's up homies? It's Caleb from Caleb the Video Maker 2. This video we're going to be talking about second normal form. Now before we discuss second normal form, we need to remind ourselves of what a dependency is. Essentially, a dependency is when something depends on something else. And in databases, that would be like an attribute describing an entity. So if we have an entity, we have attributes that describe this entity. This is a dependency. The attribute depends on the entity. Now when we're drawing this, you often see it as like, let's say, the ID, right? So the ID describes the entity. Then we have the email, for example. The email depends on the ID. Even though the arrow's drawn this way, this is saying when we change the ID from, let's say, 7 to 8, the email is going to change because it's talking about a different user. So if I lost you already, don't worry about that. I'm going to go through an example to make more sense. But essentially, you have to know that a dependency means when the thing we're talking about changes, the data describing it will also change. It's a very simple concept, almost so simple that we don't think about it, and then we get confused when we start talking about different types of dependencies. The reason it's important to kind of refresh your brain on this is that second normal form discusses a type of dependencies known as partial dependencies. Now, partial dependencies come in when we have compound or composite primary keys. Now, a composite key is a key that consists of multiple columns. So let's say this over here is a column, and this over here is a column, and these are in a table, right? And we could say that the combination of both of these columns are going to be the primary key. This other column is in here because it depends on the primary key. But when we have composite keys, it actually has to depend on both of the columns. If for any reason it only depends on one of the columns, we have what's known as a partial dependency. You will most often see second normal form come up when we have a many-to-many relationship. And let's go through an example now. In the previous videos, we discussed a database for a website where you can list items and sell them. And when we discussed many-to-many relationships, we made it so that a user could list something and share that listing with another user. So basically joint ownership of this item. So let's say I go on there and list the laptop and I want to split the profit with me and somebody else. So we have joint ownership of this listing. We had a many-to-many relationship. Let's draw that out and kind of refresh our brains. Over here we had the users. Over here we had the listings. And to amend this many-to-many relationship, we broke it up into 2 one-to-many relationships. So it looked like this. And this intermediary table was called user listings. So let's label the tables. Now the primary key in this table is actually a combination of a user and a listing. That's because you can think of this table as an association table. Once you associate a user with a listing, you're not going to have to do it a second time. So over here we'll have a user ID and a listing ID, and then the combination in here. Now, just for fun, let's say we have another column in this table. And we're running out of space, so let's just kind of blow it up down here. So this here is this table, just expand it a little bit more. So we added this column here, listing date. This is essentially going to record when the listing was created. The problem is that this listing date only depends on half of the primary key. Remember that the combination of these two are the primary key, but listing date is dependent only on listing ID. This is an example of a partial dependency. This kind of information does not belong in this table. It actually belongs in the listings table. That's because you could say what date and time the listing was created once for one individual listing. The reason you don't want it in here is because it's not relevant to the user ID as well. So what kind of data would you put in this table then? So second normal form would tell us to get rid of this column and put it in a different table that is relevant to just this part. Whenever you have something underscore, it's a good giveaway of what you're trying to describe. The listing. It doesn't say listing user, it doesn't say user, it just says listing. Therefore, the chances are it's supposed to go in the listings table. But what kind of data would be appropriate in this table? I want to put data in this table to show you guys what would belong here, but I don't want to break second normal form. Well, we need to find some kind of data that depends on the listing ID and the user ID. That means the data in here only describes the association between the user and the listing. So an example of a column might be the percentage of income when the item is sold. So let's go through some specific data so you can see how this works. Let me clean this up a little bit. Percent share. This would not go inside of the listing table. That's because it depends on which user. If an item, let's say we have a bicycle, and this is being sold by two people, we couldn't say a specific percentage inside of the listing table. For example, if we said 80%, is that discussing this user or is it discussing this user? We don't really know, so that's not very clear. That's why you wouldn't want to put something like the percentage share inside of the listing table. At the same time, you wouldn't want to put it in the user table though, because you might have one user selling multiple items. So he is selling a cheeseburger and some pizza. Yeah, I'm from America, don't judge me. And if you just gave a number, such as 80% share, well, does that describe the hamburger or the pizza? It doesn't belong inside of the user table. That means this data actually belongs to the association of the user and the listing. So let's say we have the user ID of 7, the listing ID of 13, and a user ID of 12. We'll make them both owners of a bicycle. So the user ID would be 7, the listing ID 13, and then user ID of 12, listing ID of 13. So going back to the picture I just erased, this bike would have the ID of 13. The users would have the IDs of 7 and 12. Now we can give it a percent share. We could say that the guy with the ID of 7 gets a 40% share. That means if the bike sells for $100, this guy is going to get $40. And we can give him a percent share of 60. And totaling, this adds up to 100, which would make sense. Unless, obviously, we're going to add fees, so this percentage, we could say it describes the income after we subtract the fees. So this kind of data is appropriate for this table. Hopefully that makes sense for you guys. That is second normal form. Just remember to get rid of any partial dependencies, and whenever you have a composite primary key, go through all of your attributes and ask yourself, does this belong here? Does it describe all of the columns inside of the primary key? If it does, it's appropriate. If it doesn't, it's not appropriate and you need to put it somewhere else. So thanks guys, that's all for second normal form. Be sure to check out the next video because we will be discussing third normal form. Thanks guys, and I will see you then. Oh, and if you want to help me out, click like and subscribe. Welcome back, it's Caleb the Video Maker 2. This video we are going to discuss third normal form. Now make sure you watch the previous two videos because these build upon each other. In order to be in third normal form, you have to first be in second normal form. In order to be in second normal form, you have to first be in first normal form. So it's kind of like this chain. Third normal form is going to be the most strict. That's because second normal form and first normal form have to be done, and it's going to have some of its own rules. So let's talk about those. Once again, this brings up the concept of dependencies. We discussed dependencies in the last video and a couple of other videos, But essentially, when you have a column, that column depends on the primary key. So on our bidding, selling website, let's say we have a listings table. And inside of this table, we're going to have the primary key of listing ID. We'll also have some other data. We might have a price and a category. And we'll also say what that category is about. So we have a category description, and that's going to describe the category. You could also have a column in here, item description, and that could be something custom to the user. So let's say you're selling a bicycle, you could say, hey, this bicycle's brand new, I've only driven it like 8 times. It's not very brand new, but that seems how people list things. It's super legit, it's autographed by this person, whatever. But the category description is something exclusive to our website. So for example, the category might be transportation. And then the description of this category is going to be the same for every transportation. So we could say stuff to get places. And that describes this category. So we'll add this bike on here. We'll say it's $100 and it has the listing ID of 1. Now let's say someone else gets on here and adds a car to the website. Listing ID of 2, its price is $3,000. Its category is transportation, and it has the same category description. Now let's talk about what columns depend on the primary key. The price depends on the primary key because if you were to change the listing ID, you're going to be talking about a different item, and the price will likely change. So this depends on what listing you're talking about. The category also depends on the listing ID. That's because every single item can have its own category. So if you change the listing ID, it'll be a new item and the category is able to change. Category description, believe it or not, actually describes on listing 2. That's because if you were to change the listing ID, let's say we had another item in here and it cost $10,000 and the category is toys. Now let's look at this value in relation to the primary key. If we change the primary key from 1 to 3, so we stop talking about the entity with the ID of 1 and we start talking about the entity with the ID of 3, you can see that the category description does change. So it does depend on the listing ID. That is in contrast to a column that's completely irrelevant. For example, you could have a column of the top selling items for that day. That's completely irrelevant to the listing ID, and even if you change the listing ID and go through all of the different items, the top selling item for the day is always going to be the same. So that would not depend on the listing ID. The odd thing though about this column is it's a type of dependency known as a transitive dependency. And what that means is it depends on the primary key through another column. So it actually depends on this category, which depends on the listing. So this arrow can be erased, and you can see that the category description is still connecting to the listing ID. So you get this kind of hop. These are bad, and third normal form says you're not allowed to have transitive dependencies. The solution to fix this is actually very easy. So you start at the primary key and follow the arrow back one time, and you grab this column here, category, and you break that off into its own table, categories. And now, all we have to do is have a category ID, and then we can put all of our categories in this table. So the category ID, category description. Then we take this category and move it down here. So we could give it a category ID of 1, and then the category would be transportation, and then the category description would be stuff to get places. And now you can replace this with a reference. So the category is going to be 1. Same for this one. And you can see it reduces redundant data by adding another table. 1. And this is redundant too because we have all this information in here twice that we don't need. We can actually just get rid of this column altogether. And we also need to add this row though. So we'll say 2 toys fun for all. And then when we need to reference this row, we can just put a 2. And that means this column is no longer needed. That's it for third normal form. Hopefully you guys understand that whenever you have a transitive dependency, all you have to do is grab what the closest to the primary key. So you could have multiple jumps, for example. You want to grab this one and put it into its own table. And the chances are you'll have this problem again and you'll need to put that into its own table. If you like this video, be sure to click like. And if you're new to this channel, click subscribe because that'll help you get notified of all of my upcoming videos. And on the bright side, it's free. Yeah, it's free. So thank you guys. I'll see you in the next video. Welcome back everyone to Caleb the Video Maker 2. The goal of this video is to summarize the 3 normal forms. Now I'm not going to go through and discuss all of the same information I just talked about because that's redundant. And as you learn from database normalization, redundancy is bad. But who am I to say that, because I've made normalization videos for Oracle, MySQL, and SQL Server, and database design. So talk about redundancy. Anywho, let's get on with this summary. So we have 3 normal forms. And if you had to summarize all of these, they all talk about how data relates to the key. So first normal form, the goal is to make sure every single column is singular. So each attribute is one column, and every column relates to the key. So when we have a table, we want to make sure all of the columns in there are singular or atomic, and every single column is relevant to that primary key. So if it's a users table, we want to make sure all of the data is relevant to a single user. The second normal form deals with partial dependencies. Essentially, we could word this that every single column has to describe the entire key. If we have a partial dependency, the data only describes part of the key, so that's not allowed if you want to follow second normal form. Finally, third normal form deals with transitive dependencies. That is when a column does depend on the primary key, but through another column, so you get that bouncing with the arrows that I drew in the last video. Third normal form says that all data depends on only the key. So the solution to all of these is to make all of the columns atomic. That's a pretty simple solution. For second normal form, take any partial dependencies and move them to a different table, or just get rid of them. For third normal form, you find all the transitive dependencies, take them and move them to their own table, and then in the original table, you reference them with a foreign key. So if you want to make this correct, every single attribute or column describes only the key, which means we have to get rid of transitive dependencies. To sum up everything, all of the data depends on the key, the entire key, and only the key. A lot of people word it saying the data depends on the key, the entire key, and nothing but the key. And now you could say our data is normalized. Hopefully you guys grasp normalization. If you like this video, be sure to click like. And as always, if you want to study more on this, I have other videos in different series. Also, you can look it up online and learn about some of the other normal forms. But for now, I think third normal form is more than adequate for what we are trying to do. So I would consider our database to be normalized if we got to third normal form. Thank you guys. Once again, be sure to click like and subscribe to this channel if you want to support Caleb the Video Maker 2. Hey, what is up everyone? It is Caleb from Caleb the Video Maker 2, and welcome back to your MySQL tutorial series. Now this is video number 23 in the series, and starting with this video, we are doing a competition between MySQL, SQL Server, and Oracle to see which one you guys like the most. So the winner is going to get 50 extra videos in the series. So if you're liking MySQL the most, be sure to click like and watch the rest of the series. In addition to watching the rest of the series, it's very important that you go back and watch the beginning of the series. Now, I know the content is so last year, but everything from video 1 to 22 is foundational to the rest of the series. Once you got that down, it's time to move on to data types. What? I don't even know what I said there. It was like, what? Mixed with woot? I don't know. Data types is an extremely important topic when we're talking about creating databases. That's because every single piece of information we store in a database has to have a data type. So when we create a table, we have to give the columns right here. And let's say we say food ID. This is not enough for the table. Following the column name, we have to put the data type of the data that's going to be stored inside of this column. So think of us having a table. One of the columns is food ID. Every single value for this column, every single row is going to have data of a certain data type. What is the benefit of this though? Well, if the database has all of the same type of data for a column, it's able to work with that data faster, it's able to optimize storage, and it's able to restrict incorrect data, data that doesn't fit that data type. But I might be jumping ahead. Did we really figure out what a data type is? A data type, put simply, is the type of data. I know that totally wasn't helpful, but think of the type of data. And we can categorize the types into 3 main categories. These are like the 3 categories we start with, and then later hopefully we'll learn some more. The 3 categories include numeric, string, and temporal. Now within each of these categories, there are specific data types that we are going to learn about. But if we're just talking about categories, what determines a numeric data type? Well, it's actually anything dealing with numbers. And generally, these are numbers that we can quantize? I don't remember the word, but any number that has actual numeric meaning. So for example, this column here has numeric meaning because we are going to be storing an ID here. But if we had a phone number, which I know doesn't really go well with a food table, but let's just say, well, those numbers don't actually have numeric meaning. Essentially, the important thing to know is that numeric data types deal with numbers. So think salaries, IDs, prices, discounts, etc., Moving on to string data. This is anything within quotes. So think of like something like this. This is a string. Now in databases, it's generally approved that we want to use single quotes for strings. Now each one of these is known as a character. So there's 5 characters, Hello. And other characters would include numbers. Yeah, you can actually store numbers in a string. So you could say that strings are alphanumeric, meaning alpha for alphabet and numeric for numbers. But the database interprets that data differently because we say it is of type string. Other data that you could put in quotes include symbols. You can put spaces, new line characters, and even symbols from different languages. And lastly, we have the temporal data type. This is anything dealing with dates and time. So if you think you want to store a date or the time that something was done, you will want to use a data type that is of the temporal category. And as always, the categories kind of just help us out, but we don't actually have to tell the database what category we are using. For example, in this create table, if we put something here, such as int, that's enough for the database. We don't have to say int numeric or something. It's redundant because that's all the database is going to need to know how to treat this column. Now one last thing with data types is to consider storage. So Onyx, bless you. So with storage, certain data types allow us to change how much data we can store in that column. And the general rule is that you want to store the minimum that is enough to store what we need. For example, if we know that we are going to store only maybe 20 rows in this ID column, there would be no benefit of grabbing the largest numeric data type. The same thing goes with strings. If we know we are going to be storing strings that are never longer than 15 characters, for example, let's say we're storing phone numbers, there's no need to make a string data type that is like stinking huge, okay? Just keep it to the smallest that is needed and no extra. If you're unsure though, be sure to go on the larger size because it would be better to be on that side than to be too small and have to go and change things. Overall, that's a pretty rough introduction to data types. Hopefully in the next upcoming videos you will learn more data types in more depth, and that will allow us to create our tables really super good. See you guys. No, dang it. Oh. Look at it. So yeah guys, see you in the next video. And as always, please sure to click like and subscribe. Yeah, I don't have anything else to say. See you then. Hey, what's up everyone? Welcome back to your MySQL tutorial series. This video we're going to be covering data types. Now, it's going to take a couple videos to talk about data types and go through all the stuff we need to go through. So I decided that I'm going to just create one video to introduce to you the most common data types. That was good. I like that. It's pleasant. Now, the very first data type you need to know about is char. Char is a data type that is known as a fixed length data type. And what that means is every single value for a char column is going to be of the same length. So if you have a table and one of the columns is of type char, and let's say it's char 10, every single value for that column is going to be 10 characters. What does that mean practically though? That means if you put something like this, which only has 5 characters, it's actually still going to store 10. It's just going to pad it with space. So it'll be, and you can see all of this wasted space right here. So when would you want to use a char data type? You would want to use it when all of the data is going to be of the same length. For example, zip codes, phone numbers, state abbreviations, anything that is consistent in length. If this is not what you want, and you want to be able to store a variable length of characters without having to pad it with a bunch of spaces, you will want to use the data type varchar. Varchar works essentially the same way as char, but it doesn't pad your strings to fit a certain length. That means when you declare a varchar, you declare the max length, not the total length for every single value. So if you said varchar 50, every value can have a maximum of up to 50 characters, but it doesn't have to have 50 characters. You would want to use this if your data changes, for example, names, emails, product codes, anything that has a variable length. These are the data types you're going to want to use when you are storing string data. But what if you are storing numbers? Well, we don't want to use these character data types. We want to have data types specifically for numbers. So let's talk about those now. The first numeric data type is int. Int stands for integers, and integers are whole numbers. That means there cannot be a decimal point in fractions of a number. These are often used for IDs. If you do want to have data after a decimal, you can use the designated decimal type. This data type will allow for data after the decimal, and it can be used for perfect math. So that means if you're doing math with something like money, now you can also use int for math, but the thing is, int does not allow for anything after a decimal. So anytime you have numbers like 10.5, and you want to add that with another number, you will want to use the decimal data type. But you're only going to want to use that type if you need perfect math, meaning you can't gain fractions of a penny or lose fractions of a penny. If it is okay to kind of waver on the precision a little bit, you can use the double type. This is the preferred data type when you're working with numbers that you don't have to be perfect on precision. For example, if you had the number 10.1457638, and it's okay if it's a little bit different, such as 1457639. Well, you can see here that there's a very minor difference between these. And in some situation that's okay. For example, if you're measuring something to 5 significant figures, then it's okay to lose a little bit precision at the very far end of the decimal. So if your data does not have to be completely exact when you're doing math or trying to store very precise data, it is okay to use the double data type. But once again, if you need perfection when you're doing math, you will want to use the decimal or integer data type. And if that was a little overwhelming or too much information, we're going to go more in depth with this and kind of explain everything I mean. This video is just designed as an overview to introduce you to the different data types. Now, numeric data types can have two options, signed and unsigned. The difference between these two is that signed will allow for negative numbers, where unsigned will not allow for negative numbers. The reason you would want to use unsigned is because it allows you to have higher positive numbers. So for example, if you're working with IDs, the chances are they'll never be negative, so you could make the data type unsigned, and then you can store more IDs in your table. In addition to numeric data, we will often want to store dates, so that's what we are going to talk about now. The first three data types I'm going to teach you are date, time, and date time. And it's pretty obvious what each one of these can store. You can use each one of these to store a specific moment in time. There is also another data type known as a timestamp, and there are some differences between these three data types and this one, but they can both be used to store some instance in time. So we will discuss the differences in the upcoming videos, but for now, know that if you need to store a date or a time, you can use one of these four data types. So that's all the information I have for this video. Hopefully it was helpful. I just wanted to give you a good intro to the data types, so then when we discuss them, you already have those synaptic connections and things that go on in your brain. So once again, click like on this video and please be sure to subscribe to my channel to help me out, and I'll see you in the next one. Hey, what is up, internet? It's Caleb from Caleb the Video Maker 2. This video is going to continue your MySQL tutorial series. Now we are going to be talking about data types for the next few videos, and the ones we are going to start with are the character data types, or string data types. We've discussed char and varchar, and I'm going to discuss those in more detail in this video and the next video. Specifically, we will start with char. So when we have a column in a table, we have to specify the data type. One of the available data types is char, and this is a fixed length data type. And what that means is that every single value for that column is of the same length. And we actually specify that length in parentheses when we declare that column. So something like this. This 50 here refers to characters. Now I'm going to go off topic just a little bit because there's something I wanted to introduce to you. How do we know what kind of characters we are allowed to put in there? Can we use English? Can we use Arabic? Can we use Chinese? So forth. Well, this is determined by the character set of that column. And the character set that this is going to use is known as Unicode, which is one of the most common and most popular character sets. That's because it supports multiple languages. Now, the way this character set is actually interpreted by the computer is called the encoding. And the encoding that is used is known as UTF-8. So when you see UTF-8, think of Unicode character set. Now you don't need to know all of the details of this, I just wanted to introduce you to it so then when you hear it, you're not dumbfounded. When a column is a fixed length, that means if you put something in shorter than that length, it's going to pad it with spaces. So something like hello only takes up 5 characters, but it's going to it's going to pad it with 45 spaces. You can see that that's a problem. So you only want to use char when the data is fixed length or very close to that length. So for example, if we're going to have data that's always 10 characters long, we could say char 10. And because MySQL knows that every single value is going to be 10 characters, it doesn't have to keep a working knowledge of how long each string is. When we are talking about varchar though, which is the data type we'll talk about in the next video, this is a variable length character string. And what that means is MySQL has to keep track of how long that string is. So it actually takes up more storage. But if for some reason you're not storing 10 characters here, let's say you're only storing 7, that means there's going to be 3 characters wasted. Because 7 plus 3 equals 10. That means char is only going to save you space if you are using the total number of characters. Now, what values are allowed in here? As of this video, the lowest value you can give is actually 0, and the highest is 255. So if you had 0, the only thing that would be allowed is null and empty strings. So an empty string is just a string with no data, not any spaces, nothing. 255, where does that number come from? Well, this has to do with binary, which there's a lot of information in this video, so I'll try not to overwhelm you with binary now. But this is the maximum number for an 8-bit number. So in binary, you could have zeros or ones. So if we have 8 ones, this number represents 255. 0, on the other hand, would be this. But the goal of this video is not to teach you binary. I do have other videos over that if you're interested. Bless you! Now, like I said, if you put a string in here that's shorter than 50 characters, it's going to pad it with spaces. But the thing is, when you take that data back out, MySQL is going to strip those spaces, so it doesn't look like it's padded. Now I'm going to introduce you to something known as an SQL mode, and one of those is pad char to full length. It's a pretty long name, but you can actually turn this on, and I'm not going to discuss how to do that in this video. If you want to know, you can look it up on the internet. But when this is turned on, MySQL is no longer going to strip those spaces out when it's returned. So if you do a select statement on a column of 50 characters and it only has 5 in there, it'll look something like this. And you can see that space. So yeah guys, that's all I have to say about char in this video. In the upcoming video, I'm going to be discussing varchar. So I'll be sure to see you guys then, if you go watch that video right now. If you like this video, please be sure to click like and subscribe to support my channel. Thanks everyone, I'll see you in the next one. What is up, guys? It's Caleb from Caleb the Video Maker, and it is so stinking cold. I have ostrich bumps. That's like negative 30 degrees. I really don't know what that means, but everyone says goosebumps. What's so special about a goose? This video we are going to be talking about. What are we going to talk about? I swear something's wrong with me. We're going to be talking about varchar. Make sure you watch the previous video which discusses the char data type, because a lot of that is foundational to the varchar data type. Now the special thing about varchar data types is that it doesn't pad our data. That means if we make a varchar of 50 characters and we put in something like hello, in a char data type it would pad it with 45 spaces, but varchar is literally going to store only 5. But there's the downside in that since all of the strings aren't the same length, MySQL is going to have to keep track of the length of each string. And that's going to make it mad, and because of that it's going to punish you by making each string take up an extra byte or 2. So this would be 5 characters plus 1 byte. Now in this situation each character is probably 1 byte each, but do keep in mind different encodings. So I haven't talked a ton on encodings, but UTF-8 is a very common one that allows for multiple different languages. English is going to be 1 byte each, but once you get into like Asian characters or some other languages, you are going to have up to 3 bytes each in MySQL. So this 5 character string could be up to potentially 16 bytes. It'd be 15 plus 1. Now we'll talk a little bit more about this 1 in just a little bit because I said 1 or 2, but we'll worry about that in just a moment. Now the maximum size for a varchar column is 65,535 bytes. Now this is a per value measurement, so if you have a table, each row can have up to 65535 bytes. You also once again have to consider the encoding. For example, some characters can take up to 3 bytes. That means you automatically need to divide this by 3. And each row stores up to 2 bytes to keep track of how long that string is. So you need to subtract 2 from that. Additionally, MySQL has what's known as a row limit. The row limit is also 65535 bytes. That means if we try to make the max varchar, the row limit is going to be hit, and we're not going to be able to create any other columns that store any data. Now when you're using a character set such as UTF-8, each character can take up to 3 bytes, and MySQL takes that into consideration because it needs to know how much space to allocate for this column. So when you create a varchar and pass in something like 65,000, but you're using the UTF-8 encoding, that's not going to work because it's going to do the math and say 65,000 times 3 equals a ton. And it's going to pass that row limit. This is a little bit different than how char works, because if we say char 255, which is the max for char, you can store 255 characters regardless of whatever the size is. For varchar, since we have this row limit, we can't go all the way up to the max. That means you're limited to a little bit less than a third of this. So to be on the safe side, I would never go past like 20,000. And that being said, you should never go over what you need. What I mean by that is if every row is only going to have 2,000 characters, there's no need to create a column that can store up to 20,000. Now I mentioned earlier that MySQL has to keep track of the length of the string, and I said it takes 1 or 2 bytes. Well, if the number of characters is 255 or less, it only takes 1 byte. If there's any more than that, it'll take 2 bytes. So if we talk a little bit more about storage, if you have an 8-bit number, which I know we haven't discussed binary a whole lot, but an 8-bit number allows for 8 zeros or ones. And we have the maximum for that. It would look like this. And if you take this binary number, that represents 255. We can't represent any more than 255 with this number. And if we need to go above 255, we actually add a byte. So that's an overview of varchar. Hopefully that was helpful. In the next video, we are going to be talking about another character type that you should know about. So be sure to check out that video. I will see you then. And if you've enjoyed this, be sure to click like and subscribe. Welcome back, everyone, to your MySQL tutorial. It's kind of confusing. Is it yours or is it mine? Anyways, this video we're going to be talking about the text data type. The text data type has actually not been discussed yet in this series, so something new! Ooh. Now, the text data type is a little bit different than the varchar data type, because the varchar data type, you can fit all possible range of values using one data type. But with text, it's actually split into 4 different data types depending on the size that you want. So we have text, and then we have tiny text, so that'd be smaller than text, but I'll just put it here, since this is kind of like the what they all have in common. Now the max size for these is 255, 65535. This one's about 16 million and about 4 billion. So as you can tell, these things can store a ton of data. Now this is measured in bytes. Now working with a text data type works exactly the same way as working with a varchar data type. The easiest way to explain text data types is to compare it with a varchar data type to see the primary differences. So that is what I'm going to get into now. The very first difference is that the text data types are not limited by the maximum row size in MySQL. So in the previous video we said that the max row limit was 65535 bytes. But you saw that some of the text data types allowed for much more than that. So how is that? Well, with the text data types, the data is actually stored elsewhere. So let's say this is our table. We will store our data over here and then reference that data over here. That's all behind the scenes to us though. It doesn't look any different. It's not used any different. This is all just the magic behind it. And what that means is that over here, there's only a maximum of 12 bytes used. So if you continually find yourself hitting this limit, it might be useful if you implement a text data type, so that way our data can be elsewhere and we save some space. That being said, there's also text data types that are larger than the maximum of varchar. So if for any reason varchar does not give you enough space to store the string you want to store in it, you can use a text data type and store way more. And lastly, a text column does not allow for a default other than null. So the only option for the default for a text column is null. But for varchar, we can do anything we want. So in summary, if you need more data in your rows, you can use text to separate it. Or if you need more data than the maximum varchar, you can use text. And finally, you can set a default in varchar that's not null, but you can't do that in text. So if any of those situations fit what you need, then you would know that you need to switch over to text or to varchar. In general, if you're not overly convinced you need to switch to text, then varchar will probably do just fine. Another thing I wanted to mention to you is that these text data types are sometimes called CLOBs, as stupid as that sounds. So a CLOB stands for Character Large Object. There's other types of large objects which we may discuss in the upcoming videos, but this is one. So if someone's talking about CLOBs, now you're not going to sound like an idiot. At least you'll know what they're talking about. So thanks guys, hopefully this video was helpful. If you liked it, be sure to click like, subscribe, and I'll see you in the next video. Hey, what's up World Wide Web? It's Caleb from Caleb the Video Maker 2. This video we are going to be talking about the MySQL enum or enum data type. Now this is short for enumeration. An enumeration in computer science is a data type where you can give a list of values and then whoever uses that enumeration has to pick one of those values. In MySQL, this is considered a character data type. We can list available options for a column and then whoever uses that database, when they do something like an insert, they are going to have to insert one of those available values. Do you remember when we were talking about integrity a couple videos ago? Well, this could have been something added to the integrity list on how we enforce integrity, but I didn't think of it at the time. But this can enforce integrity by requiring certain data in a column. And it just started snowing. Now the secret behind enumerations is that everything is actually stored as a number. So let's go through an example and I'll explain how this all works. So let's go to our bidding website and let's say we can add an item on there to sell and we select a condition and there's only so many options. So let's say these are the available options on our condition drop-down list and the user gets to select one of these. That is an important thing when it comes to enumerations, is that they only get to choose one. These are all going to have what's known as an index. And this is not the same kind of index that a database table would have where we can index certain columns to improve speed. This kind of index is just a number. So new would have the index of 1, 2, 3, 4, and 5. And note that the index here starts at 1. This is interesting because in a lot of programming languages, the indexes start at 0. And actually, this thing does have an index 0. And that is actually going to point to an invalid value. So you could say that the index starts at 0, but the actual values that we created, these ones, start at 1. So this invalid is actually going to be stored as an empty string, so no data. There is also an option of null, so let me move this over. Null would be another option, and the index is, of course, null. So here are all of our options for this data type. Now within our table, this data is stored as numbers. So rather than storing, for example here, 1, 2, 3, 4, 5, 6, 7, 8, 9 characters, we can store one number and save a lot of space. But the important thing to know is that when you work with this column, it's not that odd. It's not like you're inserting a number. You still insert the string data, and the database does all the work for you of figuring out what number it's going to be. So a lot of this stuff goes on behind the scenes. Working with this data type is very similar to working with just a normal string data type like varchar or text. It's slightly different when we declare it. That's because we have to give all of the available options, but using it isn't a whole lot different. Now when you get into more complex things, this kind of stuff will come up, but when you're just working with basic inserts and selects, you don't have to worry a whole lot about this kind of stuff going on right here. Now a lot of people question the usefulness of the enum data type. That's because a lot of the stuff you can do with the enum data type can be done with database design. For example, we could create a table, condition, and the columns in here could be ID, condition, and maybe description. And now in another table, we could just make a column that references an ID. An ID is also just a number. So it would work essentially the same way, but we don't have to work with this confusing data type. There are a lot of other pluses and downsides to the enum data type. I'm not going to go into all of them because that's just out of the scope of this video, and most of them are out of the scope of this entire series. But just look up enum and you will see there are a lot of hard sides saying, no, you never want to use enum data type. It's non-standard, it's confusing, and it's just added complexity. And then the other people who embrace it. But I would say generally more people disagree with using the enum data type and prefer something like database design. In this situation, you could replace this with what's known as a lookup table. I have videos over these, so you can look up... That was totally unintentional. You can look up the lookup table and find my videos on it. Now how do you actually use this data type? Let's go over that now. Within whatever statement we are working with, let's say a create statement for example, and then we put the data type, all you have to do is say enum and then in parentheses list the values that are available within single quotes. So we could say new, very good, and these are separated by commas, and that's it. So for example, if this was in a create table, it would look like this, where we just have the column and then the data type, and then we end the create table. So once we got that, it's good. But how do we insert the data? It's very simple. All you gotta do is insert a string. And if the string matches one of these, then it will be inserted as that. If it doesn't match, then it will be inserted as an empty string. And that's it. Very simple. So thanks guys for watching this video. Hopefully it was helpful. In the next video we are going to be talking about another data type that is very similar to enum, but it might be more useful for you in certain situations. So be sure to check that video out and be sure to click like and subscribe. And as always, I'll see you in the next video. I'm gonna go this way today. Welcome back everyone to Caleb the Video Maker 2. This is your MySQL tutorial series and we are going to be covering the set data type. Oh, it's already written there. Oh wait, you can't see it. Now, set. It's so similar to the enum or enum, however the heck you want to say it, data type. So make sure you watch the video over enum. If you have enum figured out, figuring out set is a piece of pie. Looking back at enum, it allows you to pick one of many options. Set, on the other hand, allows you to pick many of many options. So literally, you are going to pick a set of data, a group. One of the primary differences between set and enum is that with set, the number of available options you're allowed to have is much lower. In fact, you're only allowed to have 64, whereas with enum you can have thousands. Practically, you should never have more than 3,000, but even with that many options, I mean, that's a crap ton of options. You might not even need that many. 64, on the other hand, is a pretty small number. You might hit that. As with the enum type, the importance of the set data type can be thrown into question when you start talking about database design. I mean, think about it. Let's say we make a list of options, and we'll just make a couple here. And over here we have some rows. So let's say this is a row from a table, this is a row from a table, and this is a row from a table. And these can all be in the same table, that's fine. And one of the columns in that row is of the set data type. So let's say this row picks this one and this one. And this one picks this one and this one. And this one picks all three. You can see that an individual entity over here can pick multiple things over here. And an individual option can be picked by multiple things. So this is a many-to-many relationship. In database design, it is well known that you should never use sets. Now the set data type is a little bit different because it's designed to work as a set, but even so, you can avoid the set data type by having database design. We've discussed how to design many-to-many relationships when we were talking about relationships. All you would need is a table for this, a table for these options, and then an intermediary table to list the associations from one of these rows to one of these. So to go through an example, let's give these some IDs. 1, 2, 3, 1, 2, 3. Our intermediary table would look something like this. 1 goes to 1 and 1 goes to 2. So it would be like this. 1, 1, 1, 2. 2 goes to 1 and 2 goes to 3. So it'd have 2 to 1, 2 to 3, and then finally 3 to 1, 2, and 3. 3 to 1, 3 to 2, and 3 to 3. You get the point. So the set data type is really not needed, and a lot of people see it as a non-standard way of creating a database. That being said, I'm not a database expert. If you know there is a genuine reason to use the set data type, go for it. I won't tell anyone, except maybe your boss, and then I'll get you fired. I'm just kidding, but seriously. Now, let's talk about how to actually use this data type in case you do decide to use it. Let me clear off this board for you. You declare this data type just like you would the enum data type. So within a create table statement or an alter table statement, for example, you would give the column and then you'd give the data type. And it would look something like this. Now, in order to show this, let's think of an example. In our bidding website, we can add items on there. We also have categories on this bidding website. So an item can be added to a category. But it's not always so that an item fits a category exactly. An item may fit multiple categories. So on our website, in this situation, rather than having a drop-down box where you can select one, you might have check boxes where you can select multiple. And in this situation, you could have all of the available options within a set data type. And you would literally just put the options in here with single quotes separated by commas. Now let's say we have an old antique car. The categories for this thing might be automotive, or automobile, transportation, and antique. So we are going to list these in this set. Now you normally would put all of the available options here, but for simplicity I'm just going to put the convenient 3 that we need. And that is how you would create the set data type. Now the difference between set and enum shows up when we are inserting data. So let's say we are inserting this data into the listings table. So we have one listing for this car. Insert into listings, values, and then once we got to that column, what we would do is we would quote and then put all of the values separated by commas. And there you go. Now notice the difference here. In this situation, we quote every single value. But for this situation, we quote the entire thing only one time and then separate each value by commas. Because of that, you don't want to use words that have commas in them because it's going to confuse MySQL. Now, if you were to add the same value in here twice, it would be ignored. And when you select this data back from the database, it's going to be organized in the order that it was declared. Additionally, something you need to be concerned about is what's known as a collation. And what this is, it has to do with character sets. It's how things are compared. And some of these are case sensitive. Some are case sensitive. If you're using a case sensitive collation for a column, you need to be careful when you're inserting data, because if you put something lowercase when it's supposed to be uppercase, you're going to cause some problems. So yeah, everyone, that is your introduction to the set data type. Hopefully that was good for you and nice and helpful. If you've enjoyed this, be sure to click like, and in the next video, we'll be talking about something new. So, well, I guess not that new. We're still gonna be talking about data types, but we're going to be moving on to numeric data types. So thanks guys, I will see you then, and be sure to subscribe. Welcome everyone to Caleb the Video Maker 2. This video is going to be talking about the integer data types in MySQL. Now int is short for integer. This data type is broken up into multiple data types, similar to how the text data type is broken up into multiple data types. But it's a lot different than the text data type, so don't use that as a reference. But I am going to break this up into all of the parts now. Here are the other available sizes. As for comparison to the int data type, it would go right here in size, which is kind of confusing if you're thinking about the text data type, because the text data type looks like this. So the text is in between tiny and medium. There's no such thing as a small text, and the biggest one is called long, not big. So there's literally no correlation with naming when it comes to int versus text. So don't associate sizes between these two. So I'm going to put that int in its right location so we can see it more clearly. The integer data type is a data type that is used for exact numbers. What that means is that the numbers do not lose precision. When you store a number and do math with it, you will always get the expected result. This is in contrast with other data types, which are for estimates, which we will discuss those very soon. Now each one of these has a maximum size of a number that they can store. If you want to know the exact numbers, you can look those up, but roughly I think this one's 255, 65535. This one's about 16 mil, and then this one is about 4 billion, and then this one is like thinking a ton. And these three are just estimates. Now, these values are for what are known as unsigned integers. And unsigned integers do not allow negative numbers. The benefit of that, though, is that the highest number you can store is much higher. That's in contrast to signed integers, where half of the range of values goes in the negative. So imagine this. Here is a number line. Here is 0. And let's say the range of values that are allowed is the size of this piece of chalk. If we had a signed integer, half of it would have to go in the negative and half of it would have to go in the positive. If it's unsigned, we can put all of it in the positive and get a higher number. Now the last thing I want to mention about the integer data types is that they are used to store whole numbers. Probably should have said that at the beginning, but you know, whatever. So that means 10 is allowed, but 10.5 is not allowed. If you want to store a decimal, you need to use either the decimal type or float or double, which we will talk about all of these in the upcoming videos. So thank you guys for watching this video. Hopefully it was helpful to you. If you've liked it, be sure to click like, and as always, be sure to subscribe. I'll see you in the next video. Welcome back to your MySQL tutorial series. This video we are going to be talking about the decimal data type. The decimal data type is similar to the int data type in that when you use it for math, it maintains its precision. The difference between decimal and int, though, is that the decimal data type allows numbers after a decimal point. So for example, we could store 10.5 inside of a decimal data type column. When you create a decimal column, you are going to define a certain number of digits that are allowed. So within here, you're going to put two numbers. The first number is the number of digits you can allow inside of that number. So let me erase this to not cause any confusion. And let's say the number is 5. That means within one row for this column, we can store a number that has up to 5 digits. The next number after the comma is the number of those digits that come after the decimal point. So for example, we could use the number 2. Now if we use these numbers on a column, the lowest number we could store would be negative 999.99. There's a total of 5 digits, 2 of which are after the decimal point. The highest number would be 999.99. Now this number here is known as the precision. This number is known as the scale. Now the max values for these, this one is 65, and this one is 30. And obviously this number is going to have to be bigger than this number. There are actually a couple of different names for the decimal data type. For example, it can also be named des or dec, I guess, I don't know, numeric, and fixed. But in general, you're going to want to use this name. I think these are more for portability when we're talking about working with other databases. Now, why would you want to use the decimal data type? Mainly, it's for mathematical stuff that you need to maintain precision. So for example, if you were working with money, you're going to want to use the decimal data type. This is in contrast with the data types that are used for estimating, which we will be discussing very soon. So hopefully that was helpful for you guys. If you've appreciated these videos, be sure to click like and subscribe to the channel. Thanks guys, and I'll see you in the next one. Noob face. Sup everyone, it's Caleb from Caleb the Video Maker 2. This video we are going to be covering the floating point data types, specifically float and double. These data types are used to store estimated values. The numbers that they store can only be so precise. They are well known for causing problems when doing math problems. We will get some weird numbers and some odd results. And the reason that is because these data types are only capable of maintaining a certain level of precision. That means you only want to use these data types when you don't need exact values. If you do want exact values, you will want to use a fixed point data type is what they're known as, and that could be decimal. If you're using whole numbers, you could use int. And even if you're not using whole numbers, you could still use int and then do some kind of math on it. For example, if you wanted to store money in an int column, you could store it as cents. And then you could divide that number by 100 to get a dollar amount. But I'm getting off topic, so let's get back to the topic of floating point numbers. Why exactly are they called floating point? It has to do with the fact that we can present a number in multiple different ways. For example, let's say we have the number 150. Another way we could present this number is some number multiplied by 10 to the power of something. So for example, 1.5 times 10 to the second power. And if you work this out, you would get 1.5 times 100, because 10 to the second power is 100. And then 1.5 times 100 is 150. So you can see these are two different ways to present the same value. And if you think of where the decimal point is, in this situation it's here, and in this situation it's here. So you can kind of see it as floating across the numbers. I am probably going to butcher this entire explanation, but if you want to know tons of detail, look them all up online. For now, that's a pretty good explanation. Essentially, with this data type, behind the scenes, we are going to store some number, and then store what we are going to multiply it by. This is known as scientific notation. Another way to present this would be 1.5 e2. That's just another representation of this same thing here. This e means times 10. So 1.5 times 10 to the second power. That means when we store a number in one of these data types, we're not just storing the number. We are storing the sign bit, whether it's positive or negative. We are storing what to multiply the number by, and we are storing the number itself. So when we have a certain size for one of these, for example, float takes up 4 bytes, not all of the bits within those 4 bytes are used to store a value. That's kind of a good thing, but it's also kind of a bad thing. It's a good thing because since we're storing some number to multiply by, it's going to allow us to store much larger numbers in a smaller amount of space. The downside though is because, let's say this is the number we are storing our data in, and this much is taken with this and a sign bit, well, this is all that's left for the actual number. Because of this, we have lower precision. So in summary, we have the benefit of storing larger numbers at the cost of having lower precision. Lower precision than what? I guess it'd be lower precision than if we stored the entire number as an exact value, such as using the decimal data type. Now you have to ask yourself a question, should I use this data type? Should I use either one of these? It really depends on the type of data you're storing, and sometimes it's perfectly fine. For example, let me clean this mess up. Let's say you have the number 15 trillion. I believe that would be this. You can see we are storing a huge number, but the actual two numbers that are most important to preserve are these two right here. That's because we can represent this number as 1.5 times 10 to the 13. In this situation, we don't need a whole lot of precision because we're only storing two numbers that are going to really be important to us. The length here is going to be preserved. What would change though is if we had like a 6 here, well, it would be hard to ensure that this 6 is always going to be a 6. Especially when we get into doing math, you can get all kinds of funky results. So if we had some crazy number, as we go this way, we have less assurance of precision. Now, I said both of these are floating point numbers, so what exactly is the difference? Well, it just has to do with the size. Float is 4 bytes, as I said earlier, and double is 8 bytes. And because the double has more bytes, it can maintain a higher level of precision. So how much precision can you expect from these numbers? Well, a float, you should be able to maintain around 7 digits, and then with double, you can maintain around 15. The actual number you can store, though, is much stinking huger than 15 digits. So if we were trying to store something like this, we would be wise to pick the double data type. Now, in what situations do you want to use float? Well, in general, if you have the option, you most of the time are going to want to pick double. That's because, for obvious reasons, it has a higher level of precision, and MySQL does its calculations using the double data type. So with float, you can get some odd results. Now with double, you can get some odd results too, but you can get more odd results with the float. So I would bank on the side of trying to store all your data as the double data type, although that is not required. The ultimate decision is up to you, just be sure you understand the differences between these two data types. That's all I have to say about float and double. I know I didn't go in tons of detail, and honestly, this is a topic that is pretty confusing. I'm reading it online, I'm like, what? So I covered the bare minimum of what is required to understand what the float and double data types are, but if you want to know the exact specifics, go to Stack Overflow or Wikipedia or something like that. In conclusion, float and double are data types that can store tons of numbers, including numbers after a decimal point, but they don't maintain precision. If you're unsure whether you should use float or double, just remember this: prepare for trouble, make it double. I'll see you guys in the next video. Yo, what's up? It's Caleb back on the YouTubes. How you guys doing? This video we are going to be talking about date time, and time. So these are 3 data types that MySQL has to store dates and times. Yeah, I know. As you can tell, MySQL likes to really, separate things out, make a lot of extra data types for us simple-minded who like complexity, right? I'm kidding. It was a joke. Anywho, there are 3 data types used to do basically the same thing. So we have datetime, date, and time. And the difference between these are very obscure. I'm just playing, guys. Obviously. Okay, so let's start with datetime. Datetime is separated into date and time, which are essentially the same as these data types. So you can store 2 in 1 using datetime. Now there's something particularly special about labeling a column one of these data types, and that is that MySQL can work with that data specially. It knows that it's working with a date. You could, in theory, not use these data types. For example, you could have a varchar column, and within here you could say something like this. And this works fine. That's one way you can store dates, but overall it's just pretty craptastic. I need to become a little bit more professional here. This is a very unprofessional approach to doing things. Of course, I'm sure there are certain situations when you'll want to store a date as just a sequence of characters in a string, but in general, you are going to want to use a data type like datetime, date, or time. There's also timestamp, which we'll be getting into that in an upcoming video. So if you have a column that is of one of these data types, how do you give it the data? Is a date a number, or is it a string? Well, we just discussed that it wasn't a string, it works a little differently, so how do you do it? Well, you actually pass it as a string. So you quote it when you give it data. Now, what goes in this quote has to do with conventions. So as we've discussed, conventions are just an agreed upon something that everyone uses just to make life easier. So for example, if I give you something like this, and I say it's a time, well, you would say, yeah, the time is 6:30, and you know what that means. You automatically know that the 6, well, this is how it works in the USA, It works differently elsewhere. I apologize. I am uninformed. Anyways, this is the hour, and this is the minute. The colon here is just convention. We decided, hey, let's put a colon here. We could just put something else. You know, we could have said 6-30 or 6#30. It's a convention. Well, MySQL has its own way of representing dates and times, and we need to become familiar with how MySQL does that, or else we might think something else. For example, someone who doesn't know this convention might look at this. This is a bad example. Let's say it's like this. It's the 12th hour of the day, and it's the 6th minute. And then it's all confusing. So let's learn how MySQL represents dates and times. First, let's discuss dates. I will give you the way MySQL stores them, and then I'll show you some common ways that we as human beings express dates. So this is an example of a date that we could pass to MySQL. And it's very clear from this example which one is the year. Obviously that one because it has 4 numbers. But here's where ambiguity shows up. Which one of these is talking about the month and which one's talking about the day? You can, by this example, figure it out because 22 only makes sense in the context of it being a day. So in summary, this is the year, this is the month, and this is the day. This is in contrast to some ways we express dates as humans. Some people would represent this as this. Others would represent it like this. Some people would represent it like this. So you can see it's very important to understand what is what when we are working with dates. Now MySQL can be a little bit lenient in how you give it a date, and we'll be discussing that in a future video. But for now, understand that this is the standard format for a date. Now let's move on to the time. This is an example of a time where 22 is the hour, 54 is the minutes, and 30 is the seconds. And you can see that the delimiter or the separator is different. We have colons for the time and hyphens for the date. Now the hour, this might look interesting to some of you. This is in 24-hour time, or as some people would say, military time. So if you're not used to that, you can take 22, subtract 12, and we figure out that it's 10. So this would be the equivalent to 10:54 p.m. Now a cool thing with MySQL is that we can actually have fractional seconds. So we can put a period right here and add fractions up to 6 decimals, which I believe would be microseconds. But it's not very often I've worked with time that small, so in general, I don't really need any of this data and I don't really worry a whole lot about it. But this is something that can set MySQL apart from some other database management systems. Now, in order to do this, when you specify the data type, you have to give it some kind of precision in parentheses. So for example, we would say time 6, which would allow up to 6 decimal places. If you want less, you could do something like 3, which would limit you to just that many. Now let's say we have a column that is of the data type date time, and we'll say precision of 6. How do we pass data into this? So let's go through a very concrete example of what we would give it. Everything is going to be inside of a quote, and we start with the date. Now after the date, we put a space, and we start with the time. And then after the time, we can put a period for fractional seconds. And there you go, that is an example of a date-time value. That is all I have for this video, although I do have more to say about date time, and also some of the other data types we're going to come across. So please stick with this series. If you've enjoyed it, please click like, subscribe, and as always, I'll see you in the next video. Thanks, guys. Hey, what's up everybody? It's Caleb from Caleb the Video Maker 2, and I am going to be doing a miniature series over MySQL stored routines. Just so you guys get an idea of what the series is going to be like, I'm just going to try and do a video by video. I have a rough outline of what I want to do, but I'm not planning every single video out, so we'll see how this series goes. If I make 10 videos and I have some more ideas, I might throw some more in there. The level of difficulty for this series is beginner. It's basically a continuation of my 67-part MySQL series, and we're just going to continue where we left off, go over some more topics, but it's all going to be introductory level. So to get started, what is a routine? Well, if you think of the word routine, and we're not talking computer science here, a routine is something you do continually. You wake up and you have a routine for your day. Well, it's very similar in MySQL. With MySQL, you can make a routine, and then you can call that routine multiple times. So let me just illustrate this with some boxes. Also, I just thought I'd show you guys my sweet decal. My dad drew this. Alright, so let's say this is a routine, and you have a bunch of code in there, and you want to execute that a number of times. Like it might calculate something, or it might be some kind of algorithm or something like that. And you have a couple of options. First, every time you need to run that algorithm, you could just write it out yourself. And then you'd have to memorize all that code or go reference the file of where you saved it. And then once you need it again in the future, you could write it out again. And clearly you could see why this is a problem, because you have a lot of repeated code and you have to memorize a lot of things, and it makes your life as a programmer, a database developer, or database administrator a lot harder. So an alternative is to just have one routine, and then whenever you need to execute this stuff, you just reference it and you call it, you invoke it. There's a bunch of different words you could use for that. And then if you need, you can pass some data in. So let's say this is an algorithm of like calculating a discount or something stupid. I don't know. Well, you could pass in the price. So let's say you pass in $100, and then the stored procedure does the magical calculations, and then you get the new discounted price. That's just an example, and we'll be getting into the details of the different kinds of stored procedures and all that good stuff. So hopefully you guys are excited. I'm excited. As you go through this course, you're going to get a rough overview of all of this stuff. I'm not going to go super in depth. We're not going to make this reference material, really. This is more for education's sake. So by the end of this series, this little miniature series, you're going to have a rough idea what all of these things are, and it's going to help empower you in your database development. But it's not going to make you an expert. This is to get your hands dirty, get you started on stored routines, functions, variables, and some more programming-like things like procedural programming and all that good stuff with MySQL. So, continuing the 67-part series that everybody loves, this is the next level, a little bit more difficult stuff. We'll see how it goes, and let me know what you guys think of this series, and if you have any suggestions for videos, leave them in the comments, because I'm kind of open for ideas. So thanks guys, and I'll see you in the next video. Welcome back to your second video in this MySQL Stored Routines series. And my dog's over here making a bunch of noise, so I apologize if you hear him eating some food or whatever else. Anyways, the way this series is kind of going to work is I'm going to introduce topics and not exhaust all the details of that topic. This isn't supposed to be designed like an in-depth advanced course. The reason being is I want you to get the rough overview, so that way you can look at the big picture rather than getting lost in all the details and not really understanding why. To begin, we're going to start with the topic of variables. And just the word probably makes some of you cringe because it brings back memories of math class in high school. I think math can be fun if it was taught right, which it probably wasn't. So I'm going to try and teach it right. And this video is going to look at variables from a mathematic standpoint. What is a variable? Well, it's something that holds data. X. Everybody knows X. It's basically a variable that stores some number or some formula. So then if you do 2x, whatever x is, you multiply it by 2. It basically allows you to simplify your math problem. So for example, x could equal 5. And then you could either do 2x or you could do 2, 5. And these are essentially the same thing. So wherever x is, you can basically take that data and replace x. Now, you might be wondering, well, what the heck is the point of this x here? Why don't you just put the 5 there? And I know that's a very valid point, and that's why a lot of people don't understand variables when it comes to math. You could put it in line like that every single time, but what if x is something like 5 squared times 42 divided by 32? Well, you could take all that and put it in for x, but this is much simpler. It looks more appealing to the eyes. Sometimes we use variables simply for the sake of making things easier to read. So one use for variables is simplicity. The second reason is to store unknown data. So what do I mean unknown data? Well, it's not all of the time you can type in the data inline. And when I say inline, that'd be essentially what I wrote earlier, 2 times 5, where instead of writing x, you put the data inline in whatever you're writing. For example, if we're working with a database, we might take a value from the database and assign it to a variable to use later. If we wanted to hard code that in and put it inline, we'd have to know what that data value is up front. And sometimes that's just not reasonable. Let's say we have a classroom and we need to calculate who's going to pass and who's going to fail. The grade's over, so it's not like we have to predict the future. Everyone already has their grades in. All we have to do is take all the people who passed a certain class or whatever. So we might have a score that's considered passing. So let's say 66 is considered passing. We could store this in a variable. So we could call it x, but just to make it more simple and more readable, we can name it passing. Now, in our SQL, we could do something like select. Then you could say something like all of the students' first and last names. And then you could put a where clause. Then all you got to do is take the column for their grade, probably named grade, and do something like greater than or equal to 66. And you might be wondering, what's the point of this variable? Well, we're actually not using it here. We could very well just put passing here. So what's the benefit of putting passing here instead of 66? Why not just put 66 in here? Well, this is a very simple example. In some situations, it might be about something else, and this is some kind of huge algorithm, and we don't want to put it in line in our SQL because it makes it sloppy. Another thing, if you come back 3 years later and you read this, you know exactly what the heck it's talking about. Because if you read it in English, you're selecting everything where the grade is equal or greater than passing. But if you just put 66 in here, and you don't have this up here, you might come back and be like, I know I'm selecting something, but I don't really know what, and I don't remember what the significance of this number is. That's an example of simplicity. We're assigning useful names to data, and then we can use that name in place of directly using that data. So instead of using 66, we should definitely use passing. So that's kind of a summary of the start of variables. In the next video, I'm going to be giving you the syntax. Like I said, this is kind of just from a math perspective. Next video, we'll get the syntax on how you declare variables and give them values. So we'll see you then, and catch you then. I already said that. Peace. Subscribe. I'm so bad at this, Aaron. If you have something like... That scared me. My light just fell. Yeah. Welcome back, everybody. In this video, we're going to be discussing user-defined variables. And this is one of the kinds of variables that MySQL has. I think there's actually 4 different kinds. But just to get started, we're going to start with this, and maybe after we get over all the good main stuff, we'll go back and go over in more detail all these different things. But just for now, I just want to get on to what's important. So, user-defined variables, they are a type of variable that have a very small scope. So whenever you study variables, I can guarantee you this word will come up. It talks about the lifetime of the variable. So when you make one of these user-defined variables, it doesn't last for eternity. It's not like a table or a database in your database management system. It's just within your, I guess you could say, your client, the place where you're typing your SQL commands, whether it be the terminal or whatever, the lifetime is that session. So if you open your MySQL terminal and then you create this variable and then you do some commands and then you X out of it, well then that variable no longer exists. You can't reopen it and reference that variable. So different variables have different scopes. This one is a session scope. There's two more terms you're going to need to know, and that's declare and initialize. Essentially, declaring a variable is telling MySQL, hey, here's this variable. I don't exactly know what the data is going to be inside of this variable. I just know that this variable needs to exist because I'm going to use it in the future. Initializing is when you give that variable a value. So you can actually do this both at the same time. You can declare and initialize a variable in one statement. And that's usually what we're going to do. I just want you guys to be clear that when you're studying this, there's a difference between declaring a variable and initializing the variable. And if you're not clear on the difference, you can come up with some weird bugs in your SQL statements or whatever, because you might be trying to use a variable that needs to be initialized, but it's only been declared, and so forth. So now, enough of this vocabulary garbage. Let's get on to the MySQL syntax for declaring a variable. Making a variable is super easy. All you gotta use is the set keyword. Oh, Onyx, did you fart? Oh, Aaron, was that you? Set. And then you put an @ sign, and then whatever the name of your variable is going to be. That's all you gotta do. Set, the variable name, and then the value. We just initialized this variable, and now we can use it in all of our other SQL statements. So that's all for you guys. Thanks for watching this series. I'll see you guys in the next one. Ha, I'm kidding. It's not over yet. For now, we're just going to go over a little bit more theory in the next couple of videos, and then we'll start getting on the computer and typing some junk out and making some cool SQL scripts. But for now, memorize the syntax. Set, @ sign, variable name, no space there, equals value. Semicolon is optional if you only have one statement, but you probably have more if you're declaring a variable. See you guys in the next video. Be sure to subscribe. Welcome back, everybody. In this video, we are going to be discussing a different way you can make variables in MySQL. And these are still user-defined variables, so they have the same scope as the way we talked about in the last video. And I'll be getting into the reasons why there's different ways to do it in just a minute. But the way this is going to work is using a select statement. So first, let me write the way we made a variable in the last video, and then I'll compare it to the new way. This was the first way I taught you how to make a variable in MySQL. You use the set keyword, and then you give it a name. In programming, this is known as an identifier. Whenever you have an identifier, you can change it with whatever you want. So you don't have to make this @ passing. You can make it @ whatever. It doesn't matter as long as you put an @ symbol so MySQL knows it's a variable. So that's the identifier, and then you use an assignment operator and you assign the value 66. So in this situation, this is the assignment operator, and this can be different than the comparison equals operator, which we'll be discussing in just a minute. So this is kind of like an overloaded operator. In this situation, we're using it to assign a value to a variable. But later, we'll see how this can also be used to compare things in a comparison situation. And that'll make more sense once we go through that, but just be aware of that for now. Finally, we give it the value 66 and use a semicolon to tell MySQL this is the end of the statement. The new way to create a variable is within a select statement. The very first thing you need to do is replace set with select, and then you use the identifier just the same. And then you need to assign it a value. And in this situation, the assignment operator looks a little bit different. You are going to use a colon and then an equal sign. Once you have that, you can give it the value. You can also see here you can use different data types with your variables. So to summarize, the only two differences is this change in keyword from set to select, and then this change in the assignment operator to a colon equals. But what's the main difference here? Well, this one up here, this is just going to create the variable. But this one is going to actually return that value of whatever that variable is. If you guys have watched my other series, you'll know that select is what we use to get information. It's not always selecting something from a database. So if you know this, you can put a from statement and you can say what table you want to get that data from. But you can also just put an expression in there. So an expression is something that is evaluated to a value. An example is 5 plus 5. If we were to do something like select 5 plus 5, we are going to get back a result table that says 10. So normally when we have a result table, the column name is up here. Instead, it's going to be the expression, and then we'll get the result under that. So this is what this is going to return. So if you go select 5 plus 5, you're going to get this result table. A very similar thing happens when we use the select command to create a variable. When we run this command, it's going to take this, and it's going to put it as the header of that column in that result table. And then the result is going to be whatever the value of the variable is. So that's one of the big differences between using the set and the select command to create variables. In the next video, I'll be explaining why we have to use this colon. Onyx! Can you drink your water when I'm not making a video? In the next video, I will be explaining why you have to use this colon equals. In that one, we're actually going to be getting on the computer and using this pretty cool tool to run SQL commands. I think you guys are going to like it, so we'll see you then. Be sure to subscribe, and yeah, that's about all. So, yeah, bye.
Like me down here.
And go away. I'm making a video. Come at me.
Ow! Oh, that hurt really
Did
bad.
it?
It hit my tailbone.
I'm sorry. Love you.
No, you don't.
I didn't mean to hurt you.
Welcome back, everybody, to your MySQL Stored Procedures and Functions series. And just so you guys know, me and my wife are just chilling at my parents' house where I make my videos, and we forgot every essential that we'd ever need, including our suitcase and my microphone. So if the audio is a little whack, I'm sorry, but we'll try to get our microphone sometime soon. But for now, I'll just get started. Hopefully it's not too bad. The very first thing, guys, is I wanted to introduce you to a very awesome tool. This is called SQL Fiddle, and you can find it at sqlfiddle.com. And what this does is it allows you to type SQL commands and use multiple different database types. But you don't have to download anything, and it's really cool because once you type something up, you can actually save it and you can send it as a link to somebody to show. So to start, we're going to build a simple database over here on the schema panel. So to begin, we're going to create a table, and with SQL Fiddle, you don't have to say create database or anything, you can just start with your table. So we can just say create table, and then give it a name, and we'll just call it pets. We're going to make a little table for pets and list their names and their owners and cool stuff like that. Now within parentheses is where we put all of the columns that we want in this table. So the very first column you're going to want is an ID. We'll also have a name, owner, sex, birth. That's going to be the day they were born, and then we're going to have a death. And this is not the correct way you're going to want to do this. I just wanted to write out the columns. So next thing we're going to need to do is put the data types. So we're going to have an int, varchar, and then you can give an amount, so how many characters you want it to be able to store. Let's go with 50. And owner, in a more complex database, you might have another table that has a list of owners, and you might have this as a foreign key. But for now, this is okay, so we're going to have that as varchar as well. Sex, we're going to make that a character, just one character, so we're just assuming either M or F. Birth, that's going to be a date. Same for death. That's not quite all we need to do, though. We need to go back, and we need to go a little bit more in detail for this ID. We need to tell it that this is going to be a primary key, and that's going to keep everything unique. It's just going to be a generated number. The auto increment keyword is going to make the database automatically increase the number of the ID without us having to worry about it. So when we insert data into this database, we don't have to worry about giving it an ID explicitly. It'll just do it itself. So a couple other things I want to add. I think I'm going to throw in a species here. Let's do it after the owner. and we'll make that varchar as well, or varchar, however you want to pronounce it. And another thing, I'm just going to put some of this stuff on a new line so it's easier to read without having to scroll over, and it should work just fine. So that is our table, and just so you guys can see how SQL Fiddle works, we create our table and we can just click Build Schema. So we've created our database, and now we actually want to insert data into our database. Well, where do we do that? Do we do this on the Schema panel or the Query panel? Well, I can tell you ahead of time that we're going to want to do it over here on the Schema panel. That's because in SQL there's two types of languages. Here, I'll just write them out here so you can see them. There's DDL and DML. And that's data definition language and data manipulation language. I think I have some videos over this in my database design course. But for now, data manipulation language includes insert statements where we put data into our table. And all of data definition language and data manipulation language is going to go over here in our schema panel. And it's really easy to figure that out because here, like if we build this schema and then we do an insert over here, you can see down here DDL and DML statements are not allowed in the query panel for MySQL. Only select statements are allowed. Put DDL and DML in the schema panel. So that needs to go over here. So we're going to create some data and put it inside of our table. The very first thing you're going to want to do is give this semicolon so that way we can put multiple statements in this schema window. So to put data into the table, we use an insert command. And because this is a new command, I'm just going to put that at the beginning. And then you can say into and name the table that you want to put the data into. And that's going to be pets. Then what you're going to do is put parentheses, and here you're going to define all of the columns that you want to put data into. So we could put an ID here, but like I said, the database is going to worry about that for us. So we are going to go ahead and put every other column in here. And in this situation, I didn't mark any of these as not null, but if you want to force somebody to put data in one of these, you can just put a not null keyword there and it should work just fine. But it's really not that big of a deal because we're just kind of playing around with some SQL here. So we're going to put name, owner, species, sex, birth, and death. And then what you need to do is put values, parentheses. And here is where we pass in the values. And sometimes it's helpful if you get confused on how many, is just to kind of put the commas in ahead of time. So first let's look at the data types. We have name, owner, species, sex, birth, and death. Those are all going to be stored as strings, or we're going to need to give it strings. So that's going to be the name, that's going to be the owner, that's going to be the species, sex, birth, and death. And yes, you do pass in dates as strings. As I mentioned earlier, this owner might be a foreign key to another table. And if that's the case, you're probably not going to use a string, but an integer. And if that's the situation, you just leave that like that, so you know you need to put an integer in there, because you put the ID of whatever owner it is. So to begin, let's give it a name. Let's say Snowflake. The owner, just a little girl named Ewin, because she can't say her R's yet. Species, let's say it's a robo hamster. And for the birth, the format you're going to want to use is year, month, date. Same for the death, but we'll just leave that null. And for nulls, we don't want to put that in a string, or it'll be stored as a string that has null, which isn't going to work for the date data type. So that should be good for that. But how do you give it another row? Well, you can just put a comma, and then you can give it another parentheses. Cuddles, owner Frank. This is going to be a kitty. Oh, poor guy. He only lived one day. Oh, I think that's everything. I don't think I screwed anything up, so let's give it a try. Okay, unknown column, birth, and field list. What did I screw up? Biff. That would explain it. And there you go. We made our database. That's why SQL Fiddle is really pretty cool, because we don't have to worry about actually creating that database and making a table. If I want to change something, I can just type it in here and then build a schema, and then boom, you're good to go. But obviously you need to make sure you have correct syntax. So now over here we can give our commands, and that's what we're going to be doing in the next video now that we have our database and table created. So thanks guys, be sure to subscribe, and I'll see you guys then. Thanks, bye. Welcome back, guys. In this video we are going to be creating our MySQL variables. And something awesome about SQL Fiddle that I wanted to share with you guys is that when you create something like this, it has a unique identifier. You can see up here in the URL bar we have this code here. And what you can do is you can take this code, and I'll show you guys. Let me open a new tab and paste that, and wow, it opens up to exactly the same thing. So that means as I code stuff, I can put this little identifier in the description, and you can open it and jump right to where I am if you get lost or can't seem to figure out what I'm doing, and then you'll be right up to speed with me. So that's really cool. So be sure to check the descriptions for these, including this one, to get right where we are right now. For the rest of this video, we are going to focus on the query panel. Let's create some of our own variables. We start with the select command, and then we give it a name. Let's call it variable 1, and we'll give it a value 5. The other way is using the select, so we can say variable 2, and then we can give it a value using colon equals hello. Make sure I put that as a string. And now let's run this SQL. So as you should have expected, the set did not return anything, but this one did, and it returned the value of the variable. Perfect. Now let's just go over a little more in-depth example. Let's create a couple variables. Variable 2, we'll assign it the value 10, and then let's create another one. Variable 3, and assign it the value -7. We can reference multiple variables within a select. So let's try select variable 1, variable 2, and variable 3. And now we can see all of our values down here. And we can actually add those together. So let's say we want another column, and we're going to say variable 1 plus variable 2 plus variable 3. Awesome. Seems to be working just fine. Another thing, we can even assign this value to another variable. So we're going to make it variable 4. Colon equals. Let's run that. Yeah, and it's still 8, so everything seems to be working good. And then later I can reference variable 4 again. Gotta remember to put my semicolon. Now we get 2 responses. 8, 8. Great, so everything's working out. Now let's go over an example of what can happen if you forget this colon. Let's just start from scratch here. Let's say we have a variable, and we're going to name it ID and give it the value 1. And we're going to select everything from the pets table where ID is equal to ID. Let's run it. Great, so we're getting back this row, and that is the row from this table over here that we want to get. Well, let's say somewhere in our SQL we want to change that ID. So we make a select and we put ID colon equals 2. This should work out just fine. Make sure we put that semicolon, and let's run it. Perfect. We are now getting the second row in our table. Well, you could see if we forgot to put this colon and we ran it, the response is still the first row. So that might confuse you if you don't know what you're doing. Another thing, the response from this select here is a 0. What does that mean? Well, this is actually being evaluated as true or false. So we're asking, is ID equal to 2? And if it's false, it's going to return 0. If it's true, it's going to return 1. So let's turn this to, let's say we set this to 5, and we check to see if the ID is equal to 5. Let's run it. And the response is 1, so it is. And that's awesome here because we can check the value of a variable. But it's not always awesome if we're trying to assign it a value such as 50 and then we get a 0 as a return result. That's not what we're expecting. So make sure if you're assigning to use the colon equals. And also, even in set, you can still use a colon equals. And a lot of people will do this just for consistency's sake, so they always think colon equals as the assignment. That will prevent them from accidentally leaving it out in the select, just because they know anytime they need to assign a value to a variable, they have to use a colon equals, and then they won't get funky results, which this isn't going to do anything because we're selecting a row that doesn't exist, the ID of 5. Another thing, guys, I wanted to show you is you can always search things on Google and find the MySQL reference, and it is really cool. So here is an example that's very similar to what I showed you, where we're creating some variables and then we're selecting those variables and then making an assignment within that. It also talks about using the colon equals and just the equals. And it says how the one without the colon is treated as the comparison operator. But for now, that's all I have to say about variables. Thanks, guys, and I'll see you in the next video. Bye!
Welcome back, everybody. This video we are going to talk about stored routines. There are two classifications of stored routines. There's stored procedures and stored functions. We are going to be discussing both of these in this series, but we're going to start with stored procedures. They have a different purpose, but the way they work is very similar. So once you get stored routines, learning stored functions is really not that big of an issue. Eventually, we're going to do a video comparing the differences between the two so you have a clear distinction of when you need to use a stored procedure and when you should use a stored function instead. What is a stored procedure? A stored procedure is just a section of code that we can call. We put all of this code in here, and then later we can run the call command, and we don't have to put all of that code inline. And we talked about all these things in the first video, and I think a little bit with variables in the second and third video. But essentially, we want to avoid putting things inline as much as is necessary. So if we can take a lot of code and put it in its own stored procedure, we can then call all these different stored procedures as needed. So if we need to do one thing with our database, we could call this one, or we could call this one, or we could call this one. And sometimes these take what's known as arguments and parameters. And what that is basically passing data into the stored procedure. So we could pass in like a number that's needed, and it's going to do something with that number. Starting off though, you can make stored procedures without parameters. For those of you with more programming experience, you can think of stored procedures as creating an API to your database. And if you have no idea what I'm talking about, don't worry about it, we're going to discuss it in a future video. But just keep that in the back of your mind if you guys know what an API is. There's a couple of different ways you can work with a database. As you get more experience with MySQL, you begin to do more things when it comes to interacting with the database. Just starting out, you usually just open a client, type in some basic select commands, and get results. But after doing it over and over again, you're not using your time optimally. As you get more experienced, you start to think about ways you can save time. One way is saving SQL scripts. An SQL script is just a file that you can run, and it's going to give back your result. So we could make an in-depth select statement and then save it as an SQL script, and any single time we need to run this command again, all we got to do is find that file and run it, and we get the results that we need. This is useful, but it's not optimal in all situations because now we have a bunch of SQL scripts, we have to organize them, put them on our file server, and then open them, and they don't take parameters. That means we can't just pass data into them. We might have to open the script, edit some things, and then run it to match that certain situation that we need. This is different than a stored procedure because with a stored procedure, you can just find it, pass in data as an argument, and you get the result you need for that situation. So I would vote that stored procedures are better than SQL scripts. I ain't saying that you should never use SQL scripts, but it's always better to lean on stored procedures. That's because they are actually connected with your database. So let's say this box here is your database, and you can have all kinds of tables in your database and all kinds of goodies like that. Well, one thing you can put in here are stored procedures. SQL scripts are a separate file. With stored procedures, when you open your database in your database management system, you can find all of your stored procedures and call those from your code. And that's just really super useful. SQL scripts are great for some situations. Specifically, when you're setting up a database, you can just save the way you set it up and reference that later, but they're not always the best in every single situation. You can also think of stored procedures as extending the MySQL language. That's because once you have your stored procedures made, you can call those, say the procedure that you want to run, and it will do something. So you can basically make these SQL commands that do in-depth things that you couldn't do by default with just MySQL. You're using MySQL to do this, but you end up with commands that are much more useful to your database. So in your SQL, when you actually want to create your stored procedure, you are going to have to worry about something called a delimiter. A delimiter is a fancy name for the character you use to tell MySQL that a statement is over. So right now, by default, it's a semicolon. And that's kind of like the standard when it comes to programming. There are tons of programming languages that end all of their commands or their statements with a semicolon. We are going to have to change the default delimiter when it comes to stored procedures. We can do that with the delimiter command and then put, for example, // And now when we go through here and make a bunch of commands, MySQL sees this as being part of your stored procedure. It's kind of weird. It kind of makes you think, they probably could have made a way where you don't need to do that. But that's just how it is. You're going to have to remember to put delimiter and then whatever you want. A lot of people also use $signs, but it doesn't really matter. And then when you're done, you can put the end keyword, whatever your delimiter is, and then say delimiter again, and then follow it with a semicolon. That'll tell it to go back to the normal standard semicolon to be the delimiter. That's all I'm going to discuss in this video. That'll give you a rough overview of everything you need to know to begin working with stored procedures. In the upcoming videos, we'll discuss the API thing I was talking about and also show the code for creating a stored procedure. And then eventually we'll be getting on the computer, typing up some commands and showing the results. See you guys then. Be sure to subscribe, and I'm hoping you're enjoying the series. If you have any suggestions, leave a comment below and we'll see what we can do. Thanks. Bye. Welcome back everybody to your MySQL Stored Procedures and Functions series. In this video, we're kind of doing a part 2 to creating stored procedures. To begin, we had to change what was known as the delimiter. That's what separates statements in MySQL. The default is a semicolon. To change that, all we have to do is say delimiter, and then you just say what you want the new delimiter to be. So we'll go with 2 forward slashes. And then eventually you're going to have to change this back. But before you do that, you okay, boy? Before you do that, you're going to want to start your procedure. So to do that, you use the create procedure command. And then you give it a name. And then you just put parentheses. So this is where later you will give it parameters. But for now, we'll just keep it at that. And then you say begin. That is how you start the definition of a stored procedure. We have a stored procedure with the name friends, and it takes no parameters, and we can use the semicolon within the definition because we use this delimiter here. That way the semicolon can be passed to the server rather than being interpreted by MySQL. The next part is what I mentioned in the last video, which is the end keyword, followed by your new delimiter. So basically we're passing the end command and then we're ending that statement. Finally, we can change the delimiter back to the semicolon. Perfect. You just made a sweet procedure that does absolutely nothing. But this is the shell of what your procedure is going to be. Earlier when I drew that box that represented a procedure, that was this. So think of this as a giant box. And now we are exploring the innards of this box object thing. Now, where do you actually put your code? Well, I'm assuming you guys can realize that the code goes right here. So you can put whatever the heck you want right here, and that's what's going to run when you run this procedure. So since we're having this procedure called friends, we'll just say select everything from friends. So let's just say we have a friends table, and that's what it's going to do. Kind of ran out of room there, but it's okay. So this is a procedure that is going to return everything from the friends table. Another thing I wanted to mention is that this delimiter thing, that's only going to be applicable for some situations. For example, if you're using the MySQL command line client, you're going to need to use this. But if you're using something like phpMyAdmin or this SQL fiddle tool I've been using, there is a different way you need to tell it that we're using a different delimiter. And we'll get into that when we're starting to create some stored procedures, and it'll make sense when the time comes. But I thought I'd let you guys know if you're typing this stuff in phpMyAdmin, for example, and you're getting errors, that's probably why. Now that you have this procedure created, how do you go about actually using it? It's very simple. You use the call command. Call friends. I bet you none will answer. Kidding. This is much simpler though than actually doing whatever the procedure code is. Even though our procedure was so simple and it only had one line of code, this is still much shorter than writing out the code yourself. You can see this only uses about 2 words and this uses 4, kind of. So if you're working with a team and the team doesn't exactly have lots of SQL experience and you want them to be able to write SQL, that's exactly what you want, all you gotta do is create a procedure and then they can just call it and they don't have to worry about writing out the code like this. And that is a perfect exit to introduce the next video. So I will see you guys then. Be sure to subscribe. Welcome back, guys. This is where we left off in the last video. We were comparing calling a procedure to just typing the code that was within the procedure. And we came to the solution that just calling the procedure was a whole lot easier. But there is an extra layer of why this is way super cooler than just doing this. And that has to do with security. And now, please do keep in mind this is an introduction course, so we're not going to dive deep into security and user roles right now at least. But this is important to know from the start, so I'm going to briefly explain it. And then if you find that this material is useful, you can take the extra step, research it, and figure out what you need to do in your situation. This might just be a good starting point. So this video is going to be about APIs. API is an acronym that is thrown around way too much in programming, but it's very important, so I would recommend learning it if you don't already. It stands for Application Programming Interface. So what in the world is an application programming interface? Well, let's first talk about interfaces. And you could describe interfaces in like 50 different ways. But let's just kind of think of a couple of them. So here we have this beautiful city. We don't just want strangers walking in and looking around and stuff. We want to build up this crazy wall that only lets certain people in. This is such an awful drawing. Plus, this isn't even applicable today most of the time. Anywho, people come in and just pretend this is in 3D space, so it's like all the way around the city. So people are coming in, they're like, hey bro, let me come in. I have cool things like weapons, and I want to take over your village. And you're like, nah bro, that ain't gonna happen. So this wall is a separator from the city. And the only way to communicate with the city is through this wall. So if you're actually a good guy and you're bringing in some transports and with some goods and stuff, you can get in the city. But if you're a bad guy, you can't. It's an awful example of an interface, meaning that you interact with the city through the wall. You know what? This example is awful. Let me give a different one. Alright, so you have a car, right? Because that's what cars look like. And in here you have like an engine and other junk. But how do you drive this car? There's only like 2 or 3 things you need to worry about. And that's the steering wheel, or the beach ball, the gas pedal, or the brake, the seat belts, and a couple other things. That's about it. These tools act as an interface between you and the car. The only way you interact with this engine is through the interface of the steering wheel, the gas, and all of that stuff. And now that I gave you 2 useless examples, let's talk about programming. In programming, it works the same way. So you can have this legit, tight, awesome application, right? And over here, there's people, and they're like, hey, we want to use your application, but we're probably going to break it. Well, in this situation, an API would be useful. And what it does is it allows you to allow people to do certain things, and it allows you to prevent people from doing certain things. So the only way they can communicate with your application is from certain endpoints that you allow them to. So since this application is so legit, let's not even draw it as a square. Let's draw it as like some crazy shape, right? This is kind of like an interface layer. And the only way these people can talk to your application is using these certain points that you allow them to use to communicate with your application. And this is like very basic explanation, and the way you apply an API in different situations is going to be different. But you can think of it as this extra layer that you add on to your software that allows people to communicate with certain parts of your application. A couple examples of interfaces in programming are operating systems. Operating systems are a layer between your hardware and your software. The job of the operating system is to act as an interface between these two, filling the gaps so the operating system can meet the needs of both the hardware and the software. Without the operating system, you would have to program directly onto the computer hardware, which we don't want to do that, because then if you have different hardware, you're going to have to make a whole different application. Another example are applications that work with a database. You can think of a database over here, and then you have the application that you use, and then here's you. You don't get access to the database. The only way you can get access to the database is to type on your application thing. So whatever the application is, whether it be an accounting application or whatever, you are very limited in what you can do. You can't be like, LOL, delete database, because the people who made the database don't want you to do that. Well, in the MySQL context, procedures are an API over your database. So here we have the database, and then here we have procedures. Here we have programmers. Here we have the software they develop, and here we have the users. So by adding this extra layer of procedures, you are creating an interface between the programmer and the database. And that's good for two reasons. One, it simplifies what the person needs to know about programming in database languages. And two, it's a security measure, because if you have multiple programmers, you can allow certain ones to access certain different procedures. So that way they can't just be like, yeah, I quit, and by the way, I deleted your database. So yeah, you guys get the idea. And you can think of procedures as an extra chain in this link to the users. And it just allows for easier application development in some situations. If you got like SQL pros, having an extra person just to create procedures might just be a big waste of money and time. It really depends on what you're doing, the security of what you're doing, and everything else. Now there's one thing you need to know, that when you're giving these people user permissions, you have to do some definition within the procedure. So you can say, this person is allowed to use this procedure. If you want to know more about that, just go on Google and search SQL Security Invoker. And that's something you can add into your procedure definitions by just putting one of these people's usernames, for example. And you can find that in the MySQL docs. Another thing, if you're looking for the term that describes simplifying things by creating an interface, it's known as an abstraction. Operating systems, for example, are an abstraction over the hardware layer of computers. That way we don't need to know every single thing about the hardware. Same thing for databases. This layer of procedures is an abstraction over the database, preventing us from having to know every single thing about the database to write our commands. So yeah guys, that was a pretty awful video over application programming interfaces. And those who actually create them probably are laughing at me right now. But that's all I got for you guys for now, so hopefully that was useful, and I will see you guys in the next video. Thanks for watching.
Hey, welcome everybody. This video, we are going to be creating our first stored procedure. If you want to get the exact setup here, you can go back to our last on-screen video, and in the description there will be a link that'll take you right to this point. Now we're going to be continuing our work on our, we'll just say this is a pet dating site, because that's not weird at all. So the very first thing I want to do is add a new row into our table. So I'm going to add a comma there instead of a semicolon and just enter some new data. We'll give it an ID of 3. I'm going to introduce you guys to a pretty cool function here, which is now. That'll just give us the current date. So that'll work perfectly in this situation. And then for this, I'm just going to put null to say that this horse is still alive. And now the semicolon is going to need to go here. In the last few videos, I talked about the delimiter keyword, where you say delimiter and then you can say // for example. And what that'll do is change the delimiter so anything within the stored procedure gets sent to the server rather than being interpreted. Well, it works a little bit differently for SQL Fiddle. In SQL Fiddle, there's this little box down here, which by default it's on semicolon, but I changed it. And you're going to want to change it to something else. And I'm pretty sure the way this works is that whenever it comes across a stored procedure, it'll automatically just interpret it that way. So we don't need to say delimiter here. All we need to do is say create procedure. And we'll just say pets underscore female. And what this is going to do is get all female pets. And the reason I kind of name it backwards rather than female pets is because when you have a bunch of procedures, it's probably easier to see them alphabetically by the object. So we know right from reading this that this is working on pets, the pets table specifically. So after this, we just say begin. And then when we're done, we can say end and put our new delimiter. So you can see how this is a little bit different than the MySQL client, because with the MySQL client, we would have to go up here and say delimiter // and then down here we would say delimiter semicolon. But that's not going to work in SQL Fiddle, and I think PHPMyAdmin as well. So all of our procedure code goes in here, and I'm just going to press tab just so it's clear where the code actually begins. And we're just going to select everything from the pets table, and we'll use a where clause to say sex equals F. Let's build our schema and see if everything works. There we go. Now to call it, all I have to do is say call pets underscore female. And the semicolon actually is not needed when you only have one statement over here. So let's run it and see what happens. Snowflake and Princess are returned, which is exactly what we wanted because those are the only ones where they are female. So all you male pets out there, if you're looking for a hot lady, this is the procedure that you're going to want. Let's create another procedure. And in this situation, we're going to show how we can use variables and execute multiple statements within one procedure. So that should be capital. This is going to be pets female with birth date. And this is more just to show you that you can run multiple statements within one procedure. So what we're going to do is we're going to create a variable and we'll just name it birth date, and we'll set that equal to a string of 2015 0328, and then we're going to say select everything from pets where sex is female and birth is equal to birth date. Then we can end that procedure. Let's build it. Boom, it works, no errors. So it seems to be working, and you want to look down here at the second result table. It returned back Snowflake, which is in fact the row that we did want to return because that is the one with the birth date that we specified. And this might show you just how useful parameters could be. In this situation, we are hard coding the date in here. Wouldn't it be cool if we could just over here say 2015 0328 and then it would return all of the females with that birth date? That would be a lot more useful. But we'll be talking about parameters pretty soon. But just for now, understand that this is not the best way to structure our procedures. And we'll get into that more as we go on. So thanks guys. I will clean up this code a little bit and then I'll put the new URL in the description for you guys to get. So if you're having any issues, just go to that URL and it should be working fine. Thanks guys, and I'll see you in the next video.
Hey, what is up everyone? It's Caleb from Caleb's Video Maker 2, and welcome to your first video in your series over SQL Server. Now, we are going to be covering a lot of information in this series, but to start, let's just talk about what SQL Server is. SQL Server is what's known as a relational database management system. There are many different kinds of relational database management systems. The one we are going to be talking about in this series is known as Microsoft SQL or SQL Server. Now, SQL Server is a database management system that can cost money, but there are free versions. So that's great. I'm going to be using that one, so you guys are welcome to join me on that. Now, what is a database? A database's job is to store data. Now, I know that's pretty obvious from the name, but let's get a little bit more specific. What is data? Basically, data is anything we want to store and use at a later date. Oftentimes, databases are used for businesses. That way they can analyze data and make business decisions off of that data. For example, if you're talking about sales, right? You can calculate what items are selling the most, how much is selling, what price are they being sold at, who's buying them. All of that information can be calculated from data that is stored inside of a database. So using data within a database, we can get a summation of how our business is going. There's other uses too, not just for analyzing data, but often databases are used to power applications. So if you have an application here, often there will be a back-end database. And then when the user puts information into this application, it will get stored in a database. Then the next time that user uses the application, it's going to get the data from the database and present it to the user. So databases are often used for websites, when you sign in, when you create user accounts, when you purchase stuff. All of that data is stored inside of a database. That's because the application itself does not change. The code used to create this application stays the same. You can run this application over and over and over again, and the only thing that changes is the data. So there's a separation between the application and the data that powers that application. So hopefully that gives you a pretty good summary of what a database is. Now as we go on, obviously we're going to get a little bit more specific, but this is just a good overview. You can think of a database as something that stores a ton of information, then we can analyze that data, and we can use that database to power an application or to just make our lives a lot easier with storing information. So we covered the DB inside of this acronym, Relational Database Management System. But what does the R mean? That means relational. What does that mean? Well, a relation is basically a fancy word that means table. Quite fancy. So a table is drawn as a square, and then we have columns listed across this way. And we'll often give column headers. So for example, we could say first name, last name, phone, email. Then an individual row will fill out that information. So one person will put in his first name, his last name, his phone number, and his email. And you can continue to store more and more and more people inside of this table. So it's kind of like an Excel spreadsheet. But there are a lot of differences between a database and Excel. So now we need to discuss, why would you want to use a database over something like an Excel spreadsheet or just a text document and so forth? So there's many different ways we can store data. For example, there's Excel. There's something known as comma separated value, and that's just values, comma, values, comma, values, comma. There's text files, and then there's things like databases. Now each one of these has an application. You don't always have to use a database for everything, but there are some specific situations when you want to use a database. One of the first reasons, if you're comparing databases to like Excel, for example, is that spreadsheets are usually all or nothing. And what that means is if you have multiple columns inside of this table, inside of an Excel sheet, you can't say, oh, we're going to let this column be viewed and this one, but I want this one to be private and this one to be private. That's not something you can easily do with an Excel spreadsheet or any kind of spreadsheet. But with a database, you can select just certain columns from a table, and then these ones can be private. Along with that, SQL Server supports roles. So a role is essentially a title you give a group of people that says what they are allowed and not allowed to do. So, you can have administrator and then some other roles in there. And that's going to allow them to do certain things with this database. That's contrary to Excel, where you would have to make different files and edit the file permissions. It's a whole lot easier with databases because you can just say, oh, anyone with this role or this person can do this, but anyone else is not allowed to do this. It's a lot more intuitive. It's a cool word. Intuitive. So back to this table. If we're in an Excel sheet and you just want this column to be presented, that's not something you can easily do. But with SQL Server, that's a piece of cake. All you have to do is say something like select, and then say, let's say this is the phone number, for example. Then you could say phone number, and then say from, and then say whatever the table name is. So we could say users. And then the only thing that's going to be returned is this column. So these ones are not even going to be shown. Along with all of this, databases are more secure. They're easy to back up, they're easier to recover, and overall, it's just a better way to protect your data. If you're just working at a small little company and you need to store a little bit of information, an Excel sheet might be fine. But if you're talking about enterprise applications, there's no way you will ever use a spreadsheet for that kind of stuff. Nearly any time you're working with an application that needs to work with data, you're going to want to work with a database. And finally, the last reason I could conjure up is that you can store a lot of information inside of a database. We're talking terabytes, petabytes, a lot of information. You can have a table with millions of rows and still have a functioning database. Where if you try to store that much information in a spreadsheet or a text file or a comma-separated value file, you're gonna have really, really bad performance and probably mess everything up. That's one of the biggest reasons people use databases, is they're designed to store a lot of information. Now there's so many different types of database management systems out there. Why would you want to pick SQL Server? Well, there's a couple of reasons. One is that SQL Server is owned by Microsoft. Now I know some of you people absolutely love Microsoft and some of you hate Microsoft, but regardless, if you're working with, for example, the .NET framework, which that is basically the infrastructure you build apps on when you're working on the Microsoft platform, it's very easy to integrate with SQL Server. You can use other database management systems when you're working on the .NET framework, and you can also use SQL Server for other applications, for example, Java applications. But in general, when you work with a company that works with the .NET framework, they will use a SQL Server backend. That's just so everything is owned and managed by the same company, Microsoft. Now there are some competitors to Microsoft. For example, there's MySQL, there's Oracle Database, and there's a few other relational database management systems out there. Now where does SQL Server stand in competition to these two? Well, I would say it's somewhere right in the middle, if you ask me. Oracle, on the other hand, is usually considered to be like super up there, like enterprise level. And MySQL is kind of considered to be user level. Now, I might be generalizing a little bit too much because in reality, you could use probably any three of these for any application. So if you're working with an app that is small but might get large and still needs to manage a lot of data efficiently, SQL Server might be the best choice for you. But even if not, I have videos over both of these topics, so my recommendation is just learn them all, and then you're going to know the differences between them, and you're going to know which ones are right in which situations. Well, that's about all I got to say about SQL Server in this video. Hopefully that gave you a really rough overview of what SQL Server is, and I know this had a lot of information in it. If it's a little overwhelming or if you're just completely new to this topic, what I would recommend is just to keep watching this series, as we're going to be breaking down more and more information about SQL Server and learning some of the SQL commands. And at that point, you're going to start grasping things, and all of this information is just going to make sense. So if you've liked this video, please click like, be sure to subscribe, and I will see you all in the next video where we will be downloading SQL Server. Thanks, guys.
Yo guys, welcome back. In this video, we're going to be downloading SQL Server. So now I'm just going to search it because, URLs change all of the time. We're going to be using SQL Server 2016, but we're going to be looking for the Microsoft.com website. And then here's the URL as of now. And then we go to downloads. Now here we are shown different versions of SQL Server, and the one we're going to be looking for is Developer Edition. And what this is a fully featured free edition. So that means we can do everything. Now, if you want to actually do this in production, you might want to consider the Express Edition. And that one is basically a slimmed down version, but the benefit of that is that it's free for production. So obviously we're just learning, so I'm going to go with the Developer Edition. Now it's going to ask you to sign into your Microsoft account. If you don't have one, it's really easy to make one, so I'm not going to go through that whole process. Alright, so we're here. Now when it's your first time opening this app, you'll have to agree to kind of like a license agreement or whatever in order to join Visual Studio Dev Essentials. Now I already did that, so it's not showing that for me. Essentially, that's going to give you access to all of these panels here. But the one we are most interested in is Microsoft SQL Server. So we're going to click download on that. That's going to start the download. All right, let's open that. Yes. Now, of course, you're going to be presented with even more options. We'll go with basic just because, that's the easiest one. But if you want, you can customize things. Yeah. Whatever. I totally read that. Yep. And there we go. Now it's going to start downloading a bunch of junk. Just let it do its thing and come back in a little bit. All right, so it's done. Now they're actually working on a release of SQL Server that works on Linux and Mac OS. So if you guys want to give that a try, I would encourage you to do that and let me know how it goes. And all of this stuff that popped up is pretty important. So I'm going to actually copy all of that. And I'll just use a tool known as the snipping tool. Shablam, and then you can just save that. It says a restart is required, but basically everything is installed. Down here it says install SSMS, and that's what we're going to be talking about in the next video, but for now, let's click this connect now button. And you can see here we are now connected to our database. So I think we can do stuff like select 5 plus 5, for example, and then type in go. There we go. But I don't really like working with the database in this command prompt kind of thing, so I'm going to be installing a visual tool. Now we're still going to be learning SQL. I'm just going to be typing the SQL inside of this visual tool. So I'm not teaching you guys the cheating method, doing everything visually. We're going to learn SQL in this series. We're just going to be typing it into a different tool known as SSMS. Or SQL Server Management Studio. So that's what we're going to be talking about in the next video. Be sure to check that out, guys. If you've liked this series so far, please be sure to click like, subscribe, and share it with all your friends and everything like that. Thanks, guys. Hey, welcome back, everyone. It's Caleb from Caleb the Video Maker 2. And in the last video, we talked about installing SQL Server 2016. And I said the next step was to install SSMS, or SQL Server Management Studio. But before we do that, I wanted to talk a little bit more about what we already have installed. So once you install this database, there's a cool tool you can use. If you open your Start menu and go to All Apps, you will find something known as SQL Server 2016 Configuration Manager. Now within this tool, you can do all kinds of configurations, but one of the ones I wanted to point out is under on the side here, SQL Server Services. So services are things that run in the background on your computer. So, for example, when we start up our computer, it's automatically going to start our SQL Server database, and it's just going to continue running as we are using our computer. To see all of those services, you can go to the Start menu and type in Services, open that, and if you scroll through here, and you can see we have SQL Server right here. And there's actually two types. There's Microsoft SQL Server, and then SQL Express. SQL Express is basically a smaller, slimmed down version of the full SQL Server that you can use free for production. Here you can stop the service and start it again, but you can also do the same thing in the SQL Server Configuration Manager. So up here we have SQL Server, and we'll go to the full version, and right here you can right click, and for example, we can restart it if for any reason we need to restart the server. So that is how you restart your SQL Server if you ever need to do that. But let's put that down for now and let's click install SSMS. We will go with this one right here as that's the most stable release. So we're going to give this a run, and it's really simple. I mean, you guys probably don't need a whole lot of help learning how to install things, but I just want to make sure I cover all grounds so that way no one's lost, no one has no idea what's going on. I want to make sure we're all on the same page, so once we start studying this in the next video, we can just go through it and not hit a bunch of walls. So we're gonna have to let this install, and it might have to go through and install a bunch of other stuff. We'll just let it do its thing, and we'll be back in just a little bit. All right, so it's done. Close that, and now we can open up all apps. And here's the shortcut, Microsoft SQL Server Management Studio. I'm gonna pin that to the start menu so I can find that. And now let's open that. When you first open it, you're going to need to connect. So I connected to localhost, and where did I get that from? Well, when we installed it, there was a bunch of information that popped up at the end, and that was part of it. That's why I took a snapshot of it. So you can see here, localhost. So this is the app we are going to be using to type our SQL statements. Now to actually write some SQL, we go to the new query. And we can do anything in here, such as select 5 times 5. And it gives us the result, 25. So over here inside a localhost, you can see our databases here. And within each database, you're going to have tables and a bunch of other good stuff. We'll be getting into all of that in the upcoming videos, but I just wanted to make sure you guys get this application running because that is what's important for the upcoming videos. If you, by any chance, have another server you want to connect to, you can click this little green button over here, and you can type in whatever you need over here. So as you can see, I just connected to the dot, which is another way to say localhost. You can see in here, we're gonna have the same databases. These are all called panels, and if you, by any chance, screw everything up, there is a way to reset your panels to the default. So all you gotta do is click Window and then Reset Window Layout. And there you go. So I think that's enough to get you all started. Obviously, there's a whole lot more to learn, but on the bright side, we're not going to have to figure out how to install everything again. We got that done, so now we can start working on actually studying SQL statements. So thanks, guys. Be sure to check out the next video, and I will see you then. And as always, please be sure to click like and subscribe.
Welcome back, everyone. Now, if you want to be an extreme success in databases, you need to speak the right language. And I ain't talking no SQL or any other fancy programming language. I'm talking terminology. And what I mean by that is it's important to know some specific terms so that way when you communicate with other experts in the field, you know what they're talking about. You don't just want to be like, you know, that one thing that one guy talked about that helps things be unique. I forget what it's called. You don't want to be like that. So I think it's important to know some of the most common terms. Just studying these terms alone will help you get a better grasp of databases, how to structure them, how to make them, all of that good stuff. The first term you should know is data. Not data, that seems pretty simple, but we're going to get gradually more complex. Data is facts, information, anything you want to store for later use. When we collect a bunch of data, it's known as a database. So think of data as information and a database as a collection of a bunch of information. Now when we have a database, we need a way to interact with that database. And that's where a database management system comes in. Now the database management system is a software that allows us to use the database. SQL Server is an example of a database management system. Now, the distinction between all of these terms is kind of cloudy, so often people will use things interchangeably. So, someone might say, oh, SQL Server is a database. Don't be like, psh, no, it's a database management system. Just because they're so similar that there's not fine lines between these terms. In fact, there is another type of database management system known as a relational database management system. Now the R in this word stands for relational. A relational database presents our data in tables. Essentially, the database management system's job is to take data that could be scattered on the computer's hard drive or solid state drive and present it in a beautiful way. So let's go classic, we'll go with the hard drive. Let's say this is the hard drive, right? And you have data just stored all in this thing, right? Well, you want to look at this data in a certain way. The database management system will take all this data and present it to you in a nice, beautiful table. That's what a relational database management system is. SQL Server is also a relational database management system, but not all database management systems are relational. So if you had this circle that represents databases, this might be relational databases. All relational database management systems are database management systems, obviously from the name, but not all database management systems are relational. For example, we still have all of these ones out here that are not relational. Now, the important thing to take away from these words is relational. That's a fancy word that means table. Now, what exactly is a table? Well, you can think of it as a square, and this table is going to have a name, and inside of the table there's going to be columns. So each column is going to have a header of what that column is called. So it really depends on what the table is about. But you could have a table to store recent orders, for example. So the name of the table might be orders, and the columns might be like order ID, date ordered, who ordered it, stuff like that. Now this is just an example. As to how to actually structure this data, that's something that requires database design, which we'll talk about that in upcoming videos. But let's just say this is the perfectly designed table, and we want to store information in this table. That's where the term row comes in. So a row is a record of information that goes this way and gives a value for each one of these columns. Now this is a really bad example of the kind of data you would store in here, but essentially every single purchase is going to be entered into this table as a row. So this would probably be called the purchases table, and every single row would be an example of a purchase, or you could think of it as an instance of a purchase. So we could have another one in here with the ID of 8. This guy bought a house, $300, cheap house. Who bought it? The guy with the ID of 112. Date purchased. So the two key words here you really need to know are column and row. There are a few other terms you will come across, including record. A record is essentially another name for a row. You'll also hear the term field, which I use that to represent one value within a column. And you can also hear that called a cell. There's a lot of different terms that you need to become familiar with. Now, when you are inputting data into this table, sometimes you will leave a field blank. For example, we can have the ID of 10 stuff. We could have them buy a poodle. And the poodle costs $300,000. Who bought it? The dude with the ID of 96. But the date purchased, we don't put that information in. When we do that, that is called a null or a null. A null is essentially the absence of a value. So I'll just continue my list down here. Some people think nulls are acceptable, some people don't think they're acceptable, and it ultimately depends on what column it's in. For example, having the stuff null would be not okay because it's a purchase. How can you have a purchase without buying anything? And even in this situation, the date purchased would probably want to have a value every single time. So making those decisions of what's allowed to be null and what's not allowed to be null brings up the idea of database design again. Now, for those of you who've seen my other series, you know I really focus heavily on database design. So the start of my series are almost all identical because we go through the whole database design process. But I find that it's very, very, very important because your database design decides how your database is going to work. What kind of tables are we going to create? What are we going to store in those tables? What are we going to name our tables? What columns have what attributes? All of that information is decided by our database design. And the database design helps us to protect data integrity. Now, I'm not going to write that one because that's actually the term we are going to start with in the next video. So thanks, guys. Hopefully all of this information was somewhat useful. These are beginner terms, so you're going to come across a lot more as you go on. But it's very important that you understand this foundation and have it in your brain. So thank you guys for watching. I really appreciate it. Be sure to click like and subscribe. And as always, I will see you in the next video. Hey, welcome back to your SQL Server tutorial series. Now, in this video, we are going to continue our discussion of different terms you are going to come across when we're working with databases. Now, the very first term we are going to start with is known as data integrity. What is data integrity? Essentially, data integrity means the data in our database is correct, as up to date as possible, and describes what we are trying to describe. How good is a database if the information is confusing, it's not up to date, we have conflicting data, or we have missing data? All of that stuff is going to make our database a pain in the butt to work with. So data integrity is something we strive for to prevent things like that. We don't want duplicates, we don't want conflicting information, we don't want missing data, we don't want data that you can't associate with what it's trying to describe. And that's a big thing that a lot of people don't think about. That's because it doesn't seem like it's going to happen, but it is actually pretty easy to come across when you have a bunch of data, but you don't understand what is that data trying to express. What is it talking about? So this brings up two important terms, entity and attribute. So an entity is a pretty cool word to describe something. So an entity is something. Yeah, super vague, not helpful, I know. But it helps if we go through an example. In the last video we talked about a table that represents sales or purchases. So in that situation, the entity is the sale. This is going to be the table name. So we have a table. We can name the table either sale or sales, and every single row is an example of a sale. So the entity in this case is the sale. The attributes are the columns. This is a pretty good start when it comes to database design. That's because we already have the entity as the table name and the attributes as the columns. That way we always know what the data is describing. Each row has data for each column, and that data describes that sale. But what happens if you tried to store every single thing in your database in one table? Well, in that case, it's going to be a really super long table, and we're going to have a ton of columns. And we might have columns that are unrelated to the sale. For example, one of our columns might be customer, right? And then all of this data might be describing the customer. Now, when you grab an individual row and you take all of this data, how are you supposed to know what is describing the sale and what's describing the customer? See what I'm saying now? This is going to sacrifice, I said that weird, this is going to sacrifice our data integrity. Now we are going to discuss data integrity in depth in future videos, but just to start off, one way you could really improve the way your database is structured is separate tables by entities. Sales are an entity, customers are an entity. So why not split this table, have two separate tables, one for sales and one for customer. That will bring our data integrity back. Now it's best to start with data integrity because it's easier to start with it than try to force data integrity on already bad data. If your data is already bad and you're trying to improve the data integrity, you have to go and correct a bunch of garbage. But if you're starting with a database that enforces data integrity, you don't have to worry about those issues. Now I'm going to remove the customer table here, but we're still going to focus on the sales for a little bit. We have the sales table and we have all of these columns describing these sales. And let's say we have two rows inside of this table. One here and one here. And these are describing two individual sales. I'm working on my drawing skills. I know they need improvement, but it's a work in progress. So this guy made two purchases at this store. And one, he bought a car. The other one, he also bought a car. And he just happened to buy the same kind of car. So we might have the person who bought it, okay, let's say his ID is 7. He made two purchases, and he bought a car. And as we get into more specific database design, we'll get a little bit more specific with our data. But for now, car's fine. And this car might be a certain model or something, but anyways, the data is the same for both of the rows. How do we distinguish this row from this row? This brings our data integrity into question. To fix this, we need to introduce something known as a primary key. A primary key is a column that can force every single row to be unique. If we don't have a primary key, we don't know if this is two purchases by the same guy purchasing two of the same things, or is it one purchase accidentally put into the database twice? Ooh, we can't really tell. So we need to introduce something known as a primary key. And this can distinguish different rows. So for example, we could give this an ID of 1 and this one an ID of 2. Or if you don't want to use just random numbers or IDs, you can find something that you can use in the real life to distinguish these things. For example, the cars might have some kind of item ID or something like that you can use to distinguish, oh, these are two different cars, they just happen to be the same model. Now we're getting into a ton of detail that we don't need to go into right now. That's because the focus of this video is database terms, not how to design a whole database. So might be going a little off topic, and because of that, I'm going to end this video here. In the next video, we're going to be talking about some of the more advanced terms you might come across. So I will see you then, guys. Thanks for watching, and as always, click subscribe. Oh, don't forget to click like. Hey, what's up everyone? Welcome back to your SQL Server tutorial series. Now, I'm going to keep this one short, because I got to go eat some grilled cheese. But let's get started. The very first term that I'm going to introduce to you in this video is foreign key. Now, a column inside of a table can be labeled as a foreign key. And when you do that, you're telling the database that every single row for this column has to have a value that is in a different column. It's much easier to visualize, so let's draw that out. Here we have two tables, and let's say we label this column as a foreign key, and we say that it references this column. That means every single row inside of this table has to be a value inside of this column. So for example, let's say this is 8, 12, 10, and 11. The accepted values here would be any of these, but 13 would not work because it's not in this table's column. The reason we create foreign keys is to create relationships in our database. Relationships are when two tables are connected somehow using a foreign key. Now, almost always, a foreign key is going to reference a primary key. So in this situation, this would be the PK, this would be the FK, primary key, foreign key. And the foreign key references the primary key. Now, both the primary key and the foreign key are known as constraints. A constraint is something that prevents certain data. In this situation, we are preventing the value 13 because it's not a value in the parent table. That is a perfect example of a constraint. Now, constraints are a very important thing when it comes to protecting our data integrity. Now, there are numerous constraints. Primary and foreign keys are just examples, but there's some other options that you can use. We will be getting into all of the constraints in upcoming videos. Now, when you create a primary key, it's automatically indexed. When a column is indexed, we can select data and use that column much faster. Literally just think of like an index in a book. It helps you find information much faster. Primary keys are automatically indexed. Foreign keys, on the other hand, are not automatically indexed. We'll often be using foreign keys and primary keys together, so it's usually beneficial to manually give the foreign key an index. And we'll get into the details of indexes too in future videos. But this is kind of like a video just to kind of give you a feel of everything that's going to be coming. That way when it comes, it's not, bam, here's a bunch of new information. Yeah. Another thing regarding foreign keys is that when you're referencing another column, both of the columns have to have the same data type. Put simply, a data type is just the type of data. There are a couple different categories. We have numeric data. That would be a number. We have string data. Then we have what some people call temporal data, and that's just dates and times. Then there's a couple of other data types that don't really fit into these categories. A data type is used to tell the database how to work with our data. So this is completely different than this. In this situation, this is numeric data, and this is string data. String data is essentially data that is enclosed in quotes and is just a sequence of characters. So a number is an example of a character. So a string is alphanumeric. And that means alpha as in alphabet and numeric as in numbers. But they don't work like numbers. When you store this as a string, you're not planning on doing math with these numbers. This is a number in the database, therefore you can do math stuff with it. Math stuff. Temporal, those are dates, and we'll get into all of those details later. But just so you guys have a rough overview, there's three main categories: numeric, string, and temporal. Memorize those. Now, when you're talking about database constraints, you don't usually mean data types because that's kind of like a separate topic, but you can kind of think of them as constraints. Because if you labeled a column one of the numeric data types, and you tried to put something in like pi, that's going to be rejected. So a data type is another way to protect our data integrity. And you can see all of this comes back to data integrity. The most important thing in your database is data integrity. Because of that, the upcoming videos are going to discuss data integrity, database design, relationships, normalization, all of that good stuff. Check out the next videos. If you've enjoyed these, if you've been learning, please click subscribe. It really helps my channel and it means a lot to me too. Be sure to click like, and I will see you in the next video. Now with some mighty fine grilled cheese. And now I'm back. So, what are we talking about today? We're talking about relationships. Straight up dating advice from Caleb the Video Maker 2. Here it is. Good luck. That's all I got. Psych, guys, you know what I'm talking about. Database design relationships. Oh man, that joke never gets old. So we are going to be talking about 1, 2, 1 relationships. Now there are 3 types of relationships: one-to-one, one-to-many, and many-to-many. And we are going to dissect all of these in the upcoming videos. And each one has a certain way you're supposed to design it. Therefore, I think it's appropriate to separate them out into their own videos, so that way I'm not overwhelming you. I thought I could discuss all of this in one video one time, and the video was 30 minutes long, so I decided it's probably good to, break things up a little bit. So let's go through an example of a user and a username. And just to follow the whole theme of relationships, let's go for an animal dating site. No kidding, I thought of the most ridiculous example, and I planned a whole series around it. And then I looked it up, and these things actually exist. This might actually be practical for something. Anyways, this website, animals can go on, and obviously they might need some help from their owners, but they can create an account, they'll have a username, and they can date other animals. So a user has a one-to-one relationship with a username. Now this is talking about database design relationships. The username is exclusive to the user, meaning that if your username is sexy chick 123, get it? Because it's an animal dating site, chick. And then this, I can't draw a chicken. This is the chicken that this username is referring to. There is a level of exclusivity here in that this chick doesn't have 2 usernames, and this username does not have 2 chicks that it's describing. Now, let's compare a one-to-one relationship with a one-to-many relationship. In this, we're going to need a new design. So we are going to start with a blogging website. So let's say this dating website also has blogs, right? And you can post your blogs on there. Now this blog post posts the author's name up here. So this chick, this is the most ridiculous example ever. This chick can write multiple blogs. But in this situation, each blog can only be written by one individual. In that situation, this would be a one-to-many. We will discuss one-to-manys in more detail in the upcoming video, but essentially, there is only one side that has exclusivity, meaning that this blog is exclusively authored by one person, animal, individual, entity, whatever. This one too, it just happens to be the same animal, but it could have been a different one. It has one author. Now until the next video, let's disregard one-to-many relationships and let's focus on how to design one-to-one relationships in a database. One-to-one relationships are the easiest ones to design. That's because you only need one table to do it. This brings us back to the terms entity and attribute. In this situation, the entity is the user, and the attribute is the username. So we can just have a user table, and one of the columns could be the username. Now this forces every user to only have one username. That's because when we enter a new user, we'll put a row, we'll give it one username, and then the next user is going to have one username, and there's no more columns for another username. So a one-to-one relationship, you can just think of it as an attribute describing an entity, and you can store the attribute as a column within a table that describes the entity. So for this situation, we would have sexy chick 1, 2, 3, and then all the other data about sexy chick 1, 2, 3 can go over here, and a new user would be a new row with only one username. Now there is one other way you can store a one-to-one relationship if you want, and that's to break something off into a new table. So an example for this might be an image. Let's say a user can have one image, and that image is used for their profile. This image could be placed into a new table called images. And what this will do, it will separate the images from the user just a little bit, and then this images table is going to have a foreign key that points back to the user. What's the benefit in this? Well, it actually just allows some separation. You might not want all of the images in the user table just because you don't think it's relevant, or you don't want it stored there, or you're just trying to make things faster, anything like that. Now, you only need to use the images table when you need an image, not all of the time. If you store the image inside of the users table, like right here, that data is going to always be inside of that users table, regardless of whether you want to use the image or not. And that's just an example. Either way would work. You could put it in the table, you could make a new table for it. It all depends. If you really want a table separate for images, that would work fine. The only thing to remember here is that in order for this to be a one-to-one relationship, there only needs to be one image per user. That means if you have a foreign key, every single row would have to be unique. So you'd have like 6, 8, 9, and then if you gave the value 6, that would be 2 images pointing to the same user. This would no longer be a one-to-one relationship. So to enforce that, you need to use a unique constraint, and we will talk about that in an upcoming video. But as for that, that's all I got for one-to-one relationships. Hopefully that was helpful. As always, please click subscribe, support this channel, and I will see you in the next video. Hey, welcome back everyone to your SQL Server tutorial series. This video we are going to be oh, my throat Welcome back everyone to your it's not Oracle. Welcome back everyone to your SQL Server tutorial series. Oh gosh, really? Claire! Welcome back everyone to your SQL Server tutorial series. This video we are going to be discussing one-to-many relationships. The last video we discussed one-to-one relationships, and we briefly mentioned one-to-many relationships. The example I gave in that video was a blog posting website. So we're creating a website where people can write blogs about themselves and their lives or whatever. And we made it to where a user can write as many blogs as they want. But that blog is exclusively owned by that one user. So this chicken wrote a couple blogs, and in this situation, the blog is exclusive to this chicken. This is the perfect example of a one-to-many relationship. The reason this is a one-to-many relationship is because if you take one of these, let's say users, and then you compare that to these. So you would say, one user can have many blogs, but then you take one of these and compare it to this. So you say, one blog can be owned by only one user. This is the easiest way to figure out what kind of relationship we have. See, we have one user can have multiple blogs, but one blog can only have one user. If this said multiple users, then it would be a many-to-many relationship. That's what we're going to talk about in the next video. But for now, let's focus on one-to-many and learn how to design this in a database. Before we dive into the actual way to design this, let's go through some incorrect ways to design this that are common amongst improperly designed databases. This is the first incorrect way to design a one-to-many relationship. As you can see, we have the blogs as an attribute of the users. So you can think users as the entity, and then we have blogs as the attribute. And then you would just store the content of the blog inside of this column. So Caleb Curry posted a blog about me, and then I told my life story. Why is this a bad thing? For one, it doesn't give us separation of the attributes for the blogs. For example, this is the blog title, so we might think, oh, let's separate that out a little bit. Let's say blog title. And we'll make a new column, blog content, and then you could say whatever you wanted, and you can just store it as a string. This is also bad though, because now we are actually storing this as a one-to-one relationship. That's because we can only have one blog in here. So how do we add a blog if we did it this way? Well, we could say, let's just throw a comma in here and put the next blog name. So now I have two blogs, my life, and then we'll just put a comma or something to separate the contents, and then we'll write the next blog. Well, that is also just really bad because these values are no longer atomic. They're not their smallest indivisible pieces. If you had it this way and you did something like select everything from users, the blog title would be returned as just a comma separated list. So you'd have, and this is just awful. Now we don't know if this is one blog with a comma or if it's two blogs. It's just really bad design. So a way around this, let's add even more columns. So we could say blog title 2 and store that, and then you could have a blog content 2. But that's also really bad because now we're limited to 2 blogs. And plus, if someone only has one blog, that means all of this blog 2 stuff is going to be null. Wasted space is stupid. Don't do that. Now let's go on to the third bad way to do this. And that would be to actually add a row. So we would say Caleb Curry, and we would put the second blog in here. And in this situation, it's really not that bad because we only have one username column. But if we had some other attributes of the user in here, for example, we could have their phone. Well, now we have their phone number in here twice. This is just really, really bad because now we have redundant data. Bad. You just don't want to do that. So the 3 ways you don't store this is comma separating your values, adding extra columns, or adding rows with redundant data. 3 bad things you don't want to do. Now let's talk about the correct way to do this. Let's go back to just one blog. Accidentally erased it. And what we need to do is we need to take this blog and separate it out to its own table and name it blogs. Now in this situation, we would have a reference to the user, which in this case we could have a foreign key to the username, or we could use an ID if you wanted. And then we would have a column for the title and a column for the content. And that would work just fine. And now if you needed to add another blog, you would just add a row. So we'd have the first row, Caleb Curry, and then the about me in the title, and then the blog content right here. And then when you need another one, you just add a row. Another reference to Caleb Curry, another title, another blog content. As you can see, my drawing is awful. But in this situation, we don't have another column here that says phone, so we don't have redundant data. So let me just erase this and kind of make a cleaner version of this. Could have a users table, and one row could be like 7. Then we'd have the blogs table, kind of a blog ID, title, and content. And then each blog gets an entry inside of this table and is associated back to one user. So we could have user ID of 7, blog ID of 1. That would be one blog. Then if we had another one, it'd be 7, 2. That would be another blog. And you can see we don't have any redundant data. That's because the blogs table has the bare minimum required to describe a blog. If we stored the blogs in here and we added rows, we would have the username repeating, we would have the email repeating, and that's just not good at all. And one of the important things to remember here is that in a one-to-many relationship, you're going to need a foreign key. So in this situation, we have the user ID. This is a foreign key up to the user ID primary key in the users table. You could just as easily make this username and reference the username. It doesn't really matter as long as there is a way to associate it with one user. So that's that, guys. That's a one-to-many relationship. It's a little messy, I know. This is designed more for conceptual understanding, and once we start building databases, we will actually, program this crap. So hopefully by then, this will be a little bit more clear, and that's all, guys. So please be sure to subscribe, click like, and I will see you in the next video. Hey, what's up everyone? It's Caleb from Caleb the Video Maker 2. This video we are going to be talking about many-to-many relationships. In the previous two videos we talked about one-to-one relationships and one-to-many relationships. And the example we used was a blogging website. We had a users table and a blogs table, and the blogs table referenced the users table. That is how we allowed multiple blogs to be written by one person. In that situation though, a blog could only be authored by one person. So you could kind of draw it like this. User has a one-to-many with blog. Blog is on the many side. What if we wanted to alter this app though, so that a blog could have many users? Then it would look like this. The way we did it without the many side for the user is we had the blog table reference the user. Well, if we wanted to do the many side on this side, all we would have to do, right, is have the user table reference the blog table. But then there's a problem, because now we have a table referencing another table, and it gets really messy. For example, if this is the table, and let's say we just have different rows in these tables. Each line we could say is a user, and each line we could say is a blog. So this one user could have wrote numerous blogs, and this user could have wrote numerous blogs. And then you could also think of it the other way. This blog was written by this user and that user. So as you can see, it just kind of gets messy when we start working with a lot of data. The solution to this is to break this many-to-many relationship into two one-to-many relationships. So then what we are going to have is the users table with a one-to-many and the blogs table with a one-to-many. But how do these connect? Well, we're actually going to have another table inside of here to fix this conflict. Imagine that this disorganization is a conflict and we need someone to kind of break in and separate the fighting entities. So we are going to name this user blogs. By convention, I'm having the first one singular and the second one plural. It will look something like this. This table is known as an intermediary table, or a junction table. Essentially what this table does is it records the associations between the users and the blogs. So anytime a user has a blog, it's going to be listed in this table. So let's put some simple data in here. Let's say we have a few users and we have a few blogs over here. And we'll just write some IDs, let's say 6, 7, and we'll have another person down here. So these are the 3 users inside of the users table. And we'll have 3 blogs over here too. And we'll give them all IDs. Now anytime there is a user authoring a blog, that association is going to go in this user's blog table. So let's say this guy right here, he authored these 2 blogs. All we would have to do is for every blog he's associated with is create a row. The columns in here are going to be the IDs. So we could say 6, 7, and then we have another row, 6, 12, and that shows the combination of this user with these 2 blogs. If you want to reverse the thinking a little bit and say blog users, you can do that too, but in this situation it's not quite as clear. That's because on the application, a user creates a blog. It's not so much the other way where a blog creates a user. That's why I decided to put users first, but if you wanted, you could flip these tables and do it the other way. You could say blog authors, for example, and you would have blogs and then the users table over here. Any way you want to design it is fine as long as there's only 2 one-to-many relationships. In this situation, we have a one-to-many this way and a one-to-many this way. That's because we have only 1 6 here, but we can have as many 6s as we want here. Same for this side, we can have the blog 7 one time here, but we can have as many references to blog 7 as we want here. So for example, this lady could work on the blog with the ID of 7, and now we have 2 references to the blog with the ID of 7. So that is your introduction to intermediary tables and designing many-to-many relationships. You are always going to want to break many-to-many relationships up into one-to-many relationships. Hopefully that is all clear for you guys. Hopefully you enjoyed the video. If you're enjoying this content, please click like, subscribe. What's coming up next? Well, I think I'm going to do an overview of all of this. Not to be redundant, but just to kind of wrap it all together and express the 3 different ways to design tables. And that will just kind of make it more concrete in our minds before we move on. So thanks guys, I will see you in the next video. Bye. What is up everyone? It's Caleb from Caleb the Video Maker 2. This video is going to conclude our conversation on relationships. We've discussed 3 relationships: one-to-one, one-to-many, and many-to-many. These are the 3 types of relationships you are going to come across when we're starting to work with data. The important thing to know is how to design each one of these. We've talked about these in detail in the last 3 videos, so the purpose of this video is not to teach you how to do it, but to conclude it all and make sure you get all of it in one video. So if you don't know what I'm talking about, make sure you go watch the previous 3 videos. The first one, one-to-one, there's 2 ways you can design this. The first is the simplest. All you gotta do is put a column inside of a table. Problem solved. The reason that is if something exclusively describes an entity, you can just use it as an attribute of that entity. So when we have an entity, and we have all kinds of attributes about that entity, you can say that these attributes have a one-to-one relationship with the entity. That's because they're exclusive to that entity. The example we gave was a username. A username is not repeated by multiple people, usually. In the example we gave, it was not repeated. That means one entity can have one username, and a username is exclusive to one entity. The other way to store a one-to-one relationship is actually in another table with a column that references the primary key of the parent table. So we had the user table, and then we had a pictures table. And this was for a profile picture, and the picture was exclusive to a user. So if we had the user with the ID of 7, that pic would reference that user. The column that stores that user ID would have to be labeled unique. That's required if we want to maintain a one-to-one relationship. If you don't put unique, that's fine. It's just now going to become a one-to-many relationship. Speaking of one-to-many relationships, here is how you design them. You will have a column in another table that references the parent. You're not going to want to label it unique though, like I just said. That would force it to be a one-to-one relationship. If we did that, it would look like this: entity, attribute. But what we want is entity to multiple entities. But one of these is exclusive to that parent entity. And the way we do that is by having a foreign key. Think about it. If we have a foreign key column, and you only have one row to describe this entity, for example, you can only give one value for that foreign key, which means this would be the only parent for that child entity. We haven't discussed a whole lot on parent-child relationships, but essentially when you have a foreign key referencing a primary key, that's what's known as a parent-child relationship. The primary key would be the parent. So anytime you have a foreign key referencing another column, even if it's not a primary key, that foreign key is the child of a parent-child relationship, and the column it references would be the parent column. That's why I don't use erasers. If we want to have a many-to-many relationship, we need 3 tables. The middle table is what's known as the intermediary table, and that is basically the table that allows us to store a many-to-many relationship in a database. The connection between these 2 tables are both going to be one-to-many, and the many side is going to be in the middle. So we could have users in blogs. And then inside of the intermediary table, we would have user blogs. Perfect. So that sums up how to design each of the 3 relationships. Now, this brings up a question that I've been having, and I wanted to ask you and see what you guys thought. Let's say you have a users table, right? And one of the columns in here is first name. And we have 2 users inside of this table. One with the ID, here, let's add an ID. One with the ID of 7 and one with the ID of 8. And let's just say, by chance, both of their names are Caleb. is this a one-to-one relationship or is it a one-to-many? This is a very good question, and it's important that you understand why I'm asking this. Because you think about it, we have the name Caleb, and it's being used by two people. That's one way to think about it. And if you thought about it this way, it would be a one-to-many relationship. The other way to think about it is you have two people, and they just happen to have the same name. In this situation, it would be a one-to-one relationship. And in general, when possible, you need to go this route. It seems slightly confusing because we have the same thing twice. You'd think it'd be a one-to-many relationship. But you have to think about what a one-to-many relationship is. A name is used to uniquely define a human being. It just so happens that some people's names repeat. Therefore, because the name system is not designed as a one-to-many, it would be a one-to-one with some repeating data. And that's okay that that data is repeating because they're two separate names, they just happen to be the same. It's kind of confusing, I know. But let's just think about it if it was a one-to-many relationship. How would we store this? Well, we would actually need a names table. So we would have something like first name, and inside of this table we'd have IDs and values. And then inside of this table, instead of having the first name, we'd have the first name ID, and we would replace Caleb with 22. But this is just a really bad design. Even though it's connected all nice with foreign keys, it's just dumb because we're only going to have such a small minimal amount of repeating data if we have redundant data like this. Because then think about it, if someone comes and joins our app, and let's say their name's Amy, they are going to have to create a new row inside of the first name table because it doesn't exist. And overall, this is just a really dumb design. So if you're looking at it and there's only going to be occasional repeating data by chance, and the column itself is not designed to be like a list of things you can choose from, then I would stick with the one-to-one relationship design. More examples of things that would be one-to-one would be a phone number. Even if two people by chance had the same phone number, maybe they share a phone. Another example would be last name, and I'm sure there's a couple of others. You can also apply this to other kinds of examples. This is a user table example, but this could be applied to a comment table, for example. If we had a comments table, and we had two comments that just happened to have the same exact comment, like, great, would that be a one-to-one relationship? I would vote yes. That's because the comment value, or what the comment says, is not designed to be a one-to-many. It just so happens that they have the same value. So I know I kind of went on a rabbit trail with all this, but this is some important stuff to think through. What are the proper ways to store data? That's an important thing to ask yourself. Thank you guys for watching. Hopefully this content was helpful. If you've enjoyed it, as always, click subscribe, click like, and why not go watch the next video? It's going to cover something useful, and I'm sure it will be fun, and you guys will like it. So, see you then. Welcome back everyone to your tutorial series over SQL Server. I'm Caleb from Caleb the Video Maker 2, and this video is going to start our discussion on data integrity. Now I know we've been going over tons of conceptual stuff, but I see this as all foundational to creating databases. So instead of diving in and coding stuff, if we take a step back, focus on the concepts, when we go and code stuff, everything is going to be a lot smoother, a lot more fun, and just all together better. So that's why I focus so much on this stuff. And trust me, data integrity is one of the most important things in our database. What is data integrity? Data integrity is something we strive for. We want to have data integrity. Data integrity is essentially a word that means our data is correct, up to date as possible, not conflicting, no duplicates, and is describing what we think it's describing. Now, we categorize data integrity into 3 categories. That's just to make it a little bit easier to think about. The first is entity integrity, the second is referential integrity, and the third is domain integrity. I'm going to take one video to discuss each one of those, and that'll give you a good foundation of everything regarding integrity. So let's start with entity integrity. Now before we dive into all the depths of entity integrity, let's first focus on what is our goal when we store data. And that goal is to follow the rule of 1. Oh, Black, did you hear that? Blackie. You may also hear this as atomicity or things being atomic, and essentially everything is supposed to describe one thing. Even if we have a table called books, this here, even though it's plural, is describing one type of thing. This is known as the entity type. We wouldn't want this table to describe books and CDs. That would be breaking our rule of one. So that's the first thing we want to do. Get rid of anything that's breaking the rule of one. If you want to store CDs, that's fine. Just put it in a different table. But in general, if we get more specific, it's a little bit easier to work with the data because we know all the data is describing books. Now, each row describes one individual book. Each column describes one thing about that book. In addition to that, we should only have one record per book. So over here is my beautifully designed book, and we want to store that in our books table. First, it would probably have an ID, maybe a name, an author, and ISBN maybe. I don't know. Anyways, you can store any book in here. The thing that's important is that we only have one row to describe that individual book. Now you also have to consider, is this table describing individual books, like books at a library, for example? Or is it describing individual books that have been created or published? For example, if we had two of these books, would they both be inputted into the table? Or would it just be inputted into the table once because it's both the same book? That's kind of a design concept you're going to have to wrap your brain around. And it's not a huge issue in this video because we're just starting with the basics. But let's just say every single book gets a row. So we can put this book right here. This works out great because we have this ID. But let's say we got rid of that ID. We might have a table and it'll have a title, author, and ISBN. And this is very simply designed. Often you would take the authors and put them into their own table. But this is like a very simple example. And you have this book in here twice, right? Well, since it's the same book, the data is going to be exactly the same. So that brings up the question, do we have one book in the table twice? Or do we have two books that are different, both in their one time? It's kind of a confusing question, but it's important to understand why we are asking that. If we had to ask that with real data, we would be in a situation where we do not have good data integrity because we don't know what this data is describing. Is this describing one book or two books? I don't know. That's where the primary key comes in and saves the day. So if we add a column onto this and we label it as primary key, that is going to enforce every single row to be unique. And when we have a primary key, we should be able to expect that every single row is talking about a new book. The reason the primary key is so helpful is because it's both unique and not null. Why is it important that it's unique and not null? It's because that is what is required to force every row to be unique. So entity integrity revolves around primary keys. That's what it's about. To get entity integrity, you need to make sure every table has a primary key. Now, if you don't know what to use as a primary key, just create one. Say, whatever the table's called, let's say books, ID. So simple. If you're trying to store books, give it an ID of books ID. Boom. That simple. Now that's an example of a surrogate key. Surrogate means computer generated, no real world meaning. This book might have an ID of 9, but that means absolutely nothing in the real world. It's not related to the ISBN, it's not related to anything. It's just a computer generated number for the sake of the database only. That's in contrast to a natural key. A natural key is something that has real world meaning. For example, this library might give every book they ever get a code, and they could use that as the natural key. The only things that are very important is that the key is unique, not null, and in addition to this, it never changes. I mean, think about it. If we had this book with the ID of 8, and then one day it changed to 9 or 10, is it a new book, or is it the same book with a new ID? That's confusing. That throws our integrity into question. So you gotta make sure all of these three things are met when you're using a primary key. And if you're using a surrogate primary key, it's super easy. Natural keys can change, so it's a little confusing. Natural keys are more likely to change because they have real world meaning, but they should still never change if they are labeled a primary key. So so much chalk. So yeah guys, I know all that was kind of confusing. It's a bit messy, but that's because database design is a messy, confusing topic. There's a lot of questions you have to ask yourself, a lot of things to consider, and there's just a lot of questions you don't think about until you start designing a database. That's why I've been focusing so heavily on data integrity, so you guys understand, and when we start creating databases, I can just create them and I don't have to explain every single thing, like, oh, what the heck is this foreign key? Why are we labeling this unique and not null? And why is this primary key? And why is there 3 tables? And all of that stuff. So this is like the foundation. Don't neglect it. It's important and it's going to help you in your database career. So thanks guys. As always, click subscribe, click like, and I will see you in the next video. Welcome back everyone to your SQL Server tutorial series. I'm Caleb from Caleb the Video Maker, and we are going to be continuing our discussion on data integrity, specifically referential integrity. We've talked a lot about foreign keys and primary keys, and we haven't even got to the video devoted to them yet. That's because they're so fundamentally important to designing a database. When we create a foreign key that references another column, we are creating what's known as a relationship. And another word for relationship is a reference. Think of a foreign key as referencing another column. That means referential integrity is something we need to consider whenever we create foreign keys. Now, a foreign key has to reference a column that is unique. So this would include the primary key and any columns labeled unique. We'll be discussing how to do all of that stuff in syntax when we get to that, but for now, just think of it conceptually. All that is saying is that every single row for a column has to have a unique value. That way, every single row is a specific entity. That goes back to the last video where we talked about entity integrity. That's a prerequisite to referential integrity. Now we can make foreign keys in our head and not actually code out saying, hey, this column references this column. In that case, we still have references. The only problem is we're not enforcing references in the database. So that means we have a table over here and a table over here, and this table references this table, but we're not allowed to draw the arrow. It's divided from the parent, and you just have to assume or hope that all the data in here is correct, which the chances are it's not going to be if you're not using the right referential integrity rules, which we will discuss in just a moment. So for example, we might have an entity over here with the ID of 8, and we might reference that over here, and then this entity gets deleted. Well, guess what? This still exists, and when you look up 8 over here, nothing exists. Did 8 exist at one point, or did we just make up the number 8 on accident? What's going on here? And you're not able to go into the table structure and see that this column references this column or anything, because it doesn't. All you did was say, this column references this column in your head, but you never actually coded it out. That means you could throw a number in here like 138, and 138 doesn't even exist in this table. Nothing is forcing this relationship. All you are is putting data in 2 tables and trying to make them match. Some people create entire databases without ever using foreign keys. I don't know how that's even possible, but essentially in that case, you're just going off of the numbers and hoping that they match. It's like asking for something to go wrong in your database. When you're in that situation, you are sacrificing referential integrity. That's because you can't promise that this reference is actually referencing anything, because there's no connection. Even if there does happen to be 138 here, there's no association. They're just 2 values in 2 different tables. And then you yourself associate them in your mind. But we don't want to do things in our minds because we're humans and we make dumb mistakes. Computers are more predictable. So even though we can join these and basically create a generated table, the problem is they're not connected in any way in the database's eyes. So you can delete this, you can change this, it's all fine, it doesn't matter. This one is separate, it doesn't have any connection to that one. So how can you fix this? Well, obviously you need to define a foreign key. When you define a foreign key, you are telling the database, hey, this references this, or this column references this column. And when you do that, it's telling the database only to allow values that exist in the other table. So if I came in here and wrote 1337, but that didn't exist in this table over here, it'd be like, no, noob, that doesn't work. It's gonna pwn you. So just creating a foreign key is one step to protecting your referential integrity. Now, foreign keys have a couple of settings you can configure, and we'll get into those in detail when we talk about foreign keys. But essentially, we need to tell the database what happens when we delete the row that's being referenced, what happens when we update the primary key of the row that's being referenced, all of those kind of things we need to ask. We also have to consider things like, is the foreign key labeled not null? Is it unique? Making sure you have all of these constraints set up correctly are how you protect your referential integrity. And this is not a concept I can discuss entirely on a chalkboard. This is something we are going to have to code in SQL Server. This is more of an introduction so you understand the concept of what referential integrity is, so then when we start discussing all these things, it's not a slap in the face like, what? Don't obsess over it. We will get into the details. So if you want to make sure you see those videos, be sure to click subscribe and you'll get notified, hopefully, when I create new videos. If you like this video, be sure to click like, and as always, I'll see you in the next one. Oh, and this should say not null. Hey, welcome back everyone to your video over SQL Server. I'm Caleb from Caleb the Video Maker 2, and we are going to be covering domain constraints. This video is going to be pretty simple and to the point. That's because a lot of this information we've covered in the other videos coming up to this point. I'm just going to leave all this information here though, in case you need to come back and look up what a domain constraint is, or you just forget and you need to review. So before we talk about what domain constraints are, we need to talk about what domain is. The domain of something is the appropriate or accepted values. How do we know what's acceptable? This comes from what's known as the business rules. Now there's a fine line between business rules and domain, so don't take it all too seriously and try to divide one, just learn them both. But essentially, business rules are the English or spoken language equivalent of domain. So your boss might be like, hey loser, do this or you're gonna get fired. And then you take his commands and convert that into domain. So he might say, yo punk, we need to restrict this data from here to here, nothing higher, nothing lower. And your response is to convert that into domain using SQL. Now SQL Server is awesome when it comes to domain constraints. That's because we can get very specific on what data is allowed, and it's very easy to do. We'll talk about how we can do that in just a moment. But first, let's talk about some of the more general ways we can restrict data. Obviously, we can use data types. What that does is force the data to be inputted in the database to be of a certain format. That means if it's a numeric column, it's going to reject string data. We will cover the data types in an upcoming video, but just understand what they are for now. The other way is using constraints. So we could say the unique constraint and the not null constraint. Unique is going to force every single value for a column to be unique. Not null is going to say every single row has to have a value for that column. So we can use these to be a little bit more strict on what's allowed. So let's say a value has already been entered of 17, for example, and that column's labeled unique and you try to put 17 in again, it's not going to let you do that. Or if you don't put a value in at all and it's labeled as not null, it's not going to let you do that either. These are the general ways how to restrict data. But SQL Server has something known as a check constraint. Now, a check constraint allows us to be very specific on the data that is allowed. So this allows us to do things like between. And then you can satisfy your boss by restricting the data to be between two certain numbers. That's really super cool. One of the other common database management systems, MySQL, does not have check constraints. So you gotta go an extra step and add database triggers or find some kind of workaround to make this work. So all of this is a way to protect our domain integrity. I wrote constraints up here, but more generally, this should be integrity. And then these are example of constraints we can use to force domain integrity. Making sure we have the right data type and the right constraints, as well as all of the specific check constraints, is really all we're going to need to make sure our domain integrity is being a-okay. That really sums up everything I gotta say in this video. If anything is confusing, I'm probably gonna have videos over each one of these things, so you can go check all those out. So hopefully that was helpful. As always, be sure to subscribe, and if you've enjoyed this video, please click like. Thanks guys, and I'll see you in the next video.
Stop.
I have a tongue mark on it. But there was a mark on it I licked off, so we're good. Welcome back everyone to your series over SQL Server. I'm Caleb from Caleb the Video Maker 2, and in this video we are going to discuss primary keys. Now, before we start, I had a question for you. Have you ever ordered like some really delicious food and you eat about 90% of it and there's about 10% left over for leftovers? And it frustrates you because 10% is just enough to make you want more and not satisfy you. You're probably wondering, where is this going? Well, throughout the series, I've kind of sprinkled some primary key stuff. So you've gotten a couple pieces of pizza here and there, but now this is the whole pizza. I'm basically putting it all together in one video so you don't have to look through the entire series to find all the details on primary keys. That means a lot of this might be review, but it's all in one spot, so it's a good review. Now, a primary key is a column that is added to a table that allows every single row to be uniquely identifiable. What that means is that every single row has to have a primary key. Not null means that nulls are not allowed. Null is just the absence of a value. In addition to the primary key being not null, every single row has to have a unique primary key, or else it wouldn't be able to uniquely identify one of the entities. That means the primary key also has to be unique. You can basically think of the primary key as a combination of not null and unique column attributes or constraints. Lastly, the primary key should never change. There's actually a way in SQL Server to force the primary key column to never allow changes. We will discuss that in just a moment, but for now, let's just think about why. Why is it that the primary key should never change? Within a table, we have a couple columns. It doesn't matter what they are. Let's just say one's a string and one's a number. And then we add a primary key column. So we'll just use a number. So we'll say ID, and this will have the ID of 7. So you can tell that this ID points to a specific entity. This one right here. Whoa, squeaky. But now we go ahead and change this 7 to an 8, just for some reason. Now this brings confusion because we don't know if the 8 is talking about a new entity or it's the same entity with a new number. You might think, well, obviously it's the same entity with just a different ID, but maybe it's not so obvious. It's obvious in this situation because we manually changed the number. But if you're just looking at data, you might not have that memorized or know that ahead of time, and it might be a little bit confusing. Especially when there's conventions that the primary key should never change, and then you see a change like that, your first thought would be that it's a new entity, because primary keys don't change. Therefore, since this one has an 8, must be a new entity. Additionally, there are two categories of primary keys: surrogate keys and natural keys. Surrogate keys are just computer-generated numbers. Often this will be some sort of ID. The reason we do this is that it automatically makes it super easy to make the column not null and unique, and actually it's pretty easy to make it never change. Natural keys, on the other hand, have real-world meaning. They are a column that stores actual useful information, and these columns have to as well be not null, unique, and never changing. Because of that, natural keys are usually a bit harder to come up with. It takes a little bit more thinking, but as a result, you'll often have data that's easier to read because you don't have all of these IDs everywhere you have to connect. Whether you use surrogate or natural keys, that's up to you. I'll probably be using mostly surrogate keys. That's just because I think it makes it easier to make things work. Natural keys can also work well too, it just might take an extra level of thinking. And it's also important to understand that these are categories that we use to make it easier to discuss primary keys, but the database does not know the difference between these two. It's not like you create a primary key and say, oh, this is a surrogate one. Oh, this one's a natural key. You don't do that. You just use primary key keyword. So when you create the database, you're going to say primary key, and you are going to use this right after you create that column. And once we get into the create table statement, that's going to make a whole lot more sense. But that's literally all you have to do. You don't have to say, oh, primary key surrogate or anything like that. So to summarize, surrogate keys are almost always IDs. Natural keys are something that can uniquely identify a row, but have real-world meaning. For example, an email address. Oftentimes, you'll want to use either surrogate or natural keys throughout the entire database, rather than switching to surrogate for part of it and switching to natural for part of it. because then it's kind of confusing because you don't know which tables are using surrogate keys and you don't know which ones are using natural keys unless you dive in and look through the columns. If you're just starting out with database design and you're not required to use natural keys for some reason, I recommend starting out with surrogate keys. That's because it's super easy to make the database create your IDs for you. You don't have to worry about the data changing or anything like that. Now, the way we protect the data from never changing is we use what's known as an identity. Now, an identity column is a column that automatically gives you a new number every time you insert a new row. Each table can have up to one identity. Also, a table can only have one primary key. Because of that, it often makes sense that the identity column is also the column labeled as primary key. It does not have to be that way though. You can actually have an identity on a different column. That would only really make sense though if you're using a natural key and you still needed a column that counts for you. In addition to counting, the identity will also prevent you from changing the data. So that is how we protect this one rule of never changing. We make sure that the column is labeled the identity column. When we start talking about primary keys, the concept of indexes needs to come up. Because we've already covered a lot of information and we still have to cover indexes, I'm going to break this up into two parts, and in the next video we will be discussing indexes relating to primary keys. So thanks guys for watching this video. Hopefully it was helpful. If you have any questions, just leave a comment. I'll try to help out, or someone else can leave a comment and reply. Be sure to click like, subscribe, and as always, I'll see you in the next video. Thanks guys. Welcome back everyone to Caleb the Video Maker 2. This video is going to continue our discussion of primary keys inside of SQL Server. The first thing we're going to talk about is something known as composite keys. Then we'll go into indexes related to primary keys. But first, let's just start with the composite keys and get through that first. Now, what is a composite key? A composite key is a key or a primary key that consists of multiple columns. So more than one column. It doesn't have to be two, it can actually be more than that. So you could have a primary key consisting of 10 columns if you wanted, I think. I don't think there's a limit, but you guys can try and let me know if there is. When would you want to do this though? You would need to do this if one column is not enough to make an entire row unique. Let's go through a little example that shows this in action. We have a table. So we'll go with the bare minimum number of columns just to keep it simple, but you could have much more data in here if you really wanted to. But to start off, we'll name this class students, and over here we'll have the class ID and the student ID. Now for a specific class, let's say the class with the ID of 7, it has the student with the ID of 3084. Could we use either of these columns to uniquely identify every single row? Well, as we have it now, no, we couldn't. That's because multiple students can take a class. So we could have 7 and then 3072. Now the class ID is repeating. So we couldn't use the class ID to uniquely identify each row. That's because there's repeating values. So if I said, oh, grab the one with the ID of 7, you wouldn't know which row to grab. So what about the student ID? Let's think about the same thing. Can a student take multiple classes? Yes. So that means we might have this student again, 3084, but this time taking a different class. Now we have repeating student IDs. So if I said, grab the row with the student ID of 3084, you wouldn't know which row to grab. So the student ID also will not qualify as the primary key. In this situation, a composite key is actually a really good thing we could use. Essentially, we're going to combine these two columns as the primary key. Now these are actually going to be foreign keys pointing to different tables, so we'll probably have a class table and a student table. And when we have two keys inside of a composite key, it's actually known as a compound key. But often people will use the terms composite, compound interchangeably, so don't worry about it too much, but I just thought I'd let you guys know that. If we made both of these IDs a composite key, the combination would have to be unique. So 7 and 3084 could only be in there one time. So then I could tell you, hey, grab me the row with the class ID of 7 and the student ID of 3084. And you would know it's always going to talk about this row. That's because we're not allowed to have repeating data. This would not work. Now you might also be asking, is it really necessary to use a composite key? Couldn't we just have another column right here and make it something like class student's ID? And then every single row would have a new ID, so we'd have 1, 2, 3. And then you wouldn't need to say 2, you could just say 1. Grab me the row with the class student ID of 2. And you would know it's always talking about this row. Well, actually, that does work. Some people actually prefer that. In this situation, you wouldn't be using a composite key, you would just be using a single primary key, and it would work just fine. On the downside, though, this introduces some problems because now we have to worry about repeating data. For example, 7 and 3084. So you might still have to make the combination unique. And if you're going to do that, you might as well just use it as the composite key for that table. But even so, some people still like to be able to refer to a row using only one primary key column, not a combination. So that decision's ultimately up to you. I'm going to try to go with this route using 2 columns, but if I need to, I will just go down to 1 column if I feel like that's relevant for the situation. Also keep in mind, you don't have to limit yourself to just 2 columns, you could have 3 columns. So for example, if the class ID and the student ID is not enough to keep each row unique, you can add a column. You could say semester, because, potentially a student could retake a class. That might not be the perfect example for this situation, but you guys get the point. If you can't make the data unique using only 1 or 2 columns, add enough columns until it is unique. But you always want to get the minimum amount of columns. So if you can use 2 columns to make these unique, why would you add a 3rd column to be part of the key when it's not needed? Always have the smallest key as necessary. Except for the situation which I discussed, we can use 2 keys here instead of 1 just because it makes more sense rather than having this extra column here. When you're looking at your tables, you might have to go through and look at all the different combinations of columns that could make a key, and these are going to be known as candidate keys. Then you have to go through this list of candidate keys and pick which one's going to be the most appropriate for your primary key. Sometimes it's not necessary to actually list all the candidate keys and you can just know, hey, this one's going to work as the primary key. But if you're working in an organization or in school, they might make you list the candidate keys and pick which one would be best for the primary key. Candidate keys also come up when you're talking about database normalization, which is a topic we're going to discuss in upcoming videos. But a lot of the normal forms of normalization talk about candidate keys and not just your individual primary key. You might also be able to guess if you're using natural keys, things can get a little bit more complicated because you don't just have individual IDs to identify rows. So you might have to combine a bunch of columns to make something unique, which can make normalization a bit more challenging, in my opinion. Let me know what you guys think, if you prefer primary keys as surrogate or natural keys. Thanks for watching. Oh wait, I gotta talk about indexes. When you make a column a primary key, that column is automatically indexed. Now an index allows your database to work with that data much faster. And there's 2 kinds of indexes, or 2 classifications. Clustered and non-clustered. Now we'll discuss all the details of this in another video dedicated to indexes, but since this video is about primary keys, I thought it would be relevant to say that primary keys are automatically clustered indexes. And what that means is that the data in the table is actually organized by the primary key. Unique columns, these are actually automatically non-clustered, which that's basically just lists all the data in order but then makes a reference to that data. And as a side note, identity columns, those are not automatically indexed unless obviously it's on a primary key. In that situation, it's going to be part of an index. But if you make another column, the identity, it's not going to be indexed. Just thought I'd throw that out there if you guys were wondering, which you probably weren't. Okay. So yeah, that's all I got to say about primary keys. Hopefully that was helpful for you guys. If you like this video, please click like. Be sure to subscribe if you want to support this channel. And as always, stay chill. See you guys in the next video. Peace. Welcome back, everyone. Oh, goodness. Hello? Okay. The mic's on. Well, welcome back, everyone, to your SQL Server tutorial series. This video, we are going to discuss foreign keys. Now, I know what you're thinking, and you're wrong. Foreign keys do not unlock locks from different countries. Just get that out of your mind, okay? This is databases here. Foreign keys reference primary keys, or unique columns. And primary keys are also unique, so you can just write unique, and that includes both of them. Why does it have to be unique though? Essentially, when we want to reference data in another table in a database, we want to be able to say exactly what row we are referencing. So if we have two tables, and this row, let's say these lines are rows, and this row wants to reference this row, it needs a way to say exactly what row it wants. And the only way it can do that is if all of these rows are unique. To do this, we need at least one column with the unique constraint. Now, oftentimes, this is going to be the primary key. So I would recommend you watch the previous two videos because these discuss primary keys in depth, and we discussed that primary keys have to be unique. Now, the word unique and also the word not null, these are example of attributes. Now, when I say attributes, I'm not talking about attributes in the sense of entities and attributes. These attributes here are a different type of attribute. So yeah, totally confusing, but just focus on this kind of attribute for right now. An attribute is essentially an extra detail we give the column to tell it how to act. A lot of the attributes are also known as constraints. So unique and not null are attributes, but they're also constraints. Now, we talked about constraints when we talked about data integrity. When we actually use these keywords, they're known as attributes. Now, you can call these constraints if you want, but just know that there are some attributes that are also not constraints. And that gets kind of confusing, so I'm not going to go into a ton of detail with that right now. That's because it's a little bit off topic still. But the reason I bring it up is that we have to consider what kind of constraints we want to put on our foreign keys. So in this situation, this is the primary key, and this is the foreign key. And the foreign key references the primary key. You'll make this association by column. So you might have one column inside of the table, and you say it references this column. That means a value for that column has to match a value for this column. So for example, 7 and 7. These values match. This one over here should always be unique, and we'll probably want to make it not null too. But these constraints are not automatically placed on the foreign key. That means we have to decide, do we want the foreign key to be unique? Do we want it to be not null? That's what we're going to be discussing in this video. Now that we're already like 5 minutes into it. To make the discussion of these constraints easier, it's easy to think in family trees. So a family tree shows how things are related, but you have to introduce the concept of parents and children. When we're talking about databases, the primary key is the parent, foreign key is the child. So rather than drawing things this way, we can flip it this way and put the parent up top and the child down here. So we get something like this. Now you can see that the child references the parent. And theoretically, the parent doesn't have any knowledge of the children. That's because the foreign key is in the child table, not the parent table. So within this parent table, there's nothing that references back to the child. It's alone, it's segregated, it doesn't know of the child. So because of that, I drew the arrows pointing at the parent and not both ways like that. When we draw it this way, it's a lot easier to think about these constraints. First, let's think of the unique constraint. If we use the keyword unique, essentially what that says is that a parent can only have one child from that column. So if we said unique on these children right here, 2 of these would be in violation. Sorry guys. That's because in order to reference the parent, you have to use the parent's primary key. So we'll just say it's a number. Let's say 7. So this child uses 7 to reference the parent. And if we have the unique constraint, that column right here is not going to allow 2 of the same values. So if we try to put 7 here again, that would be not okay. But if we have another parent, this one might have the ID of 8. And this child could reference that parent. And now we're okay. And it might make more sense if, we move the whole thing over there. So let's do that. This is okay. This child still cannot exist because of this unique constraint. Now what you also have to realize with this unique constraint, it's talking about that individual column. We might have another table that references the parent. So imagine it's turning into one of those crazy family trees with stepchildren and all that. Okay, we have a column over here that also references this parent. That means this parent could potentially have another child, but it'd be from a different table. So this unique is only for that column. Now I'm going to erase this a little bit, so get your last image of it. Now, let's discuss not null. We have this previous relationship. We have the parent from this table. One of the rows here has an ID of 7. And then we have a child, let's say right here, and it has the reference 7 in the foreign key column, pointing back to that parent. But now let's create a child over here, and we're not going to make a reference to anything. So that column for this row is going to be null. What that essentially means is that we have an orphaned child. As depressing as that is, you can do that in databases. So when would you want to do something like this? Well, if there's ever a situation where a row does not need to reference anything, but some of them do, then you would do this. It's kind of hard to think of really good examples, but imagine you had a car dealership or something. My car drives fast. And we are leasing the cars, right? You might have a column for leaser, which points back to the customer. Well, if a car is being currently leased, it would have a customer ID, such as 7. But if the car does not have an owner, then that would be null. So in this situation, although it's not the best example in the world, you can see that a null would be appropriate. So sometimes it's okay to have orphaned children. I'm sorry. If you don't like that idea though, and you don't want no orphaned children, you can use the not null constraint or attribute. And essentially that is going to force this child to have some value for the foreign key. So you could not use null, you'd have to say some value. You would do that if there's a situation when this row over here cannot exist without that parent. Think of like a comments table on a video sharing website. It wouldn't make sense to have a comment without a poster. So you would obviously make the poster column not null. So that's a good summary of attributes for foreign keys and how to design those. In the next video, we are still going to be discussing foreign keys, but we'll be discussing a little bit of a new topic. So thanks guys for watching, and as always, I'll see you in the next one. Thanks guys. Oh, and don't forget to subscribe and click like. What's up everyone? This video we're going to talk about foreign keys, specifically on delete and on update. This is Caleb from Caleb the Video Maker 2, but you guys know that, so let's not waste any time. Let's get started. On delete, why does it always look crooked? On delete is a way we can configure the way our foreign key works. So let's go back to the parent-child relationship concept from the last video. And last video is basically a prerequisite to this video, because I ain't going to waste all my time repeating all that information. So we have a parent row and a child row. And this child row obviously references the parent using a foreign key. So this table will have a column such as ID, and then this table will have parent ID, whatever the parent is. So it could be like user ID or whatever. And then that value references the parent. But what happens if we try to delete this parent row? Oh no! And I bet you cannot guess what clause is used to configure that. Yeah, didn't think so, moron. It's on delete. Okay, I'm so mean. Yeah, I'm keeping it in. So on delete can be added after we define our foreign keys, and we can say what happens when we delete the parent. And there's 4 main options in SQL Server: no action, cascade, set null, and set default. We're going to discuss each one of these in a little bit of detail. The first one is no action. That is actually the default. So if you don't say anything, and you just say this is a foreign key that references this column, this is the one that's going to be applied. What that means is if you try to delete a parent, it's just going to throw an error and say, you can't do this, you cannot do this. Essentially what that means is that once a child references a parent, that parent is locked into existence until that child is no longer there. No action is probably the most safe one you can use, because once you start having all these tables and all these references, and this child references this one, and this one references this parent. You got this huge network of connections, and when you have no action, you basically can't break any of those connections accidentally. But this has the downside, and that it makes it really hard to do anything. Because if you have this chain, for example, this row referencing this row referencing this row, you have to find the most childish of all the children. Because if you think about it, this child has a parent, which is this child, which has a parent, which has a parent of this parent. So it's like a literal family tree. You would have to start with this child, delete that row, then you could delete this row, then you could delete this row, and then finally you could delete the parent. So if you want to delete the parent, you're going to have to go through all of that work. Cascade, on the other hand, comes in handy, because if you delete the parent, it's automatically going to pass on those changes and just delete anything that references it. But as you can see, that could be very dangerous, because you have all these connections and you don't have all the connections memorized in your head. So you just think you're going to do something minor. It's not going to ruin much. You're just going to delete this one row. No one will even notice. Then all of a sudden you delete like 40 rows because everything's interconnected. So Cascade will delete all of the children referencing that parent. Set null, that one is going to set the reference and the child to null. So if this parent has an ID of 7, and in the foreign key column we have that reference, and then we delete this parent, this 7 is going to be replaced with null. That one's fairly simple, but you're going to have to keep in mind that this column that's storing this value has to be able to be set to null. Therefore, it cannot be labeled not null. If it was labeled not null, you wouldn't be able to do that, because then you'd try to put a null inside of a not null column. And that's just going to make your database explode. Finally, we have set default. And what that is going to do is set the column to whatever the default value is for that column. When you define the column, you can use the default attribute and give it a value. And then when you delete the parent, that value of, like, originally it was 7 will be replaced with whatever the default is. So the parent has a value of 7, the child references that parent, and let's say the default is 1. We delete the parent row, the child reference is replaced with 1. Now, when would this be beneficial? Well, a lot of people actually don't like set default, but some people really like it. A good use of this might be, let's say, in a situation where we have a website and people can post comments. So we could make a user in the user table with the ID of 1, and make the username deleted user, for example. And let's say we also have a user, Caleb, and his ID is 7, and deleted user ID is 1. Now the parent exists, his name's Caleb, the child is his comment, and this comment was posted by the person with the ID of 7, which points back to Caleb. But then once we delete the parent, the 7 is defaulted to 1, which points to deleted user. That's kind of a way you could use the set default. I'm sure there's a much more professional and technical explanation of how you could use set default, but that's all my little brain could come up with. So if you guys got some more better examples, post them in the comments below, and I'll consider them for future videos, and I'm sure they'll be helpful to other people. Now there is also an on update clause. This is going to work the same way because we also have these options. The only difference, it's no longer on delete, but what happens when the parent's ID in the situation 7 is changed. Now, if you used my guidelines on primary keys, they should never change. So the only time you're going to need the on update is if you're referencing a unique column that is not a key. For example, you might have a users table with an ID and a username, and this username is unique. Now let's say we have a username of Crazy Cat Lady 10, and this lady has an ID of 8. That is not an 8. And then let's say we reference this column, which we can do with the foreign key because it's labeled unique. Now instead of having an ID, we'll just have the username. Now the on update is going to make a lot more sense. So what would happen if someone tried to update their username? Well, let's go through the options. The first one, if we had our foreign key set up as no action, the database is just going to throw an error and say, no bro, you cannot do this. Is that appropriate? Well, in some situations, yes, but some websites let you change your username. For example, YouTube. So if we wanted people to be able to change their username, we would not want to use no action. Cascade would send the changes down the line. So if we changed this to Crazy Cat Lady 11, it would go down over here to the reference and change it as well. That would be more like what YouTube is doing. So that means any comment that references this username would change. Set null would change this username to null. And finally, set default would change it to whatever the default username is. So whatever this table is in, we would have a column, let's say username, and this could be in whatever table, it doesn't matter, and you would give it a default. So hopefully that kind of gives you a good summary of on delete and on update. It kind of gets complex, but if you just break it down piece by piece, you'll eventually get it. So thanks guys. If you like this video, please click like, subscribe, and send me some money to replace my lungs from all this chalk dust. Kidding, but I mean, still send me money. Okay. Thanks guys, I'll see you in the next one. Peace. Hey, what is up everyone? It's Caleb from Caleb the Video Maker 2, and welcome back to your SQL Server tutorial series. This video, we are going to prefix the next 3 or so videos. That's because the next 3 videos go into a new topic, and I don't know where to piece all this information in, and I don't really want to bombard you with a ton of information in those videos. So I thought it was necessary to pull out some information and just kind of make a foundation for the next few videos. So this video, we are going to introduce the topic of database normalization. Anytime you study databases, you will come across the term normalization. Guarantee it. It's basically this process that is used to improve the database structure. Think of like this X-ray that like scans your database and is like wrong, 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 and points out all the bad things and helps you fix it. Now obviously this isn't automated, although that'd be pretty cool. It's something we do. So we look at our database with our normalization glasses and scan for different rules. And when we find one of these rules that are broken, we fix it. It's a pretty simple concept, but it's kind of complex and complicated, so I'm going to try and keep it as simple as possible. That's because whenever you study this stuff online and you look up a definition, they'll give you like 40 different terms that you've probably never heard of, and even I am like, what? So that being said, this is going to be a pretty simple introduction to database normalization. Then maybe later down the road we can go into a little bit more detail with all of the functional dependencies and fancy terms and all that kind of stuff. But I will try to give you as many terms as possible. So don't think this is going to be like baby level. This will be like entry to mid level. Alright, so let's do this. As everything is in databases, normalization is broken up into sections. Basically, we have these steps we take. So we scan our database, and we find everything that's wrong with it. And then we're like, awesome, we got past stage 1. And then we do it again. And we find even more errors. And we do this as many times as we want until we get through all of the different normal forms. Normal forms, by the way, are what the steps are called. How many normal forms are there, though? Well, there is actually a lot of normal forms, but we, as beginner noobs, we are going to focus on first normal form, second normal form, and third normal form. And these are abbreviated as 1NF, 2NF, and 3NF. Consider these our X-ray goggles that scan our database, and each level is progressively more strict. So the first one might scan it and say, oh yeah, here's a couple things wrong, but it's, it's not a huge deal. We'll just get rid of those. But then the second one, it also has to pass all of the first normal form rules too, and additional rules. So this one is like, oh no, there's a lot of more errors, we gotta get rid of those. And by the time you get to third normal form, you have to have both first normal form, second normal form done, and then we scan our database, and we get more things wrong with our database than things right with our database. When we study this stuff, the concept of dependencies will come up. Now, what is a dependency? Essentially, a dependency is when a thing, oh, this is totally not helpful, but a thing depends on something else. And the simplest way I can explain that is using the idea of entities and attributes. And this goes back to way the beginning of the series. So if you don't know that, make sure you start from the beginning of the series. But essentially, an entity is anything we want to store data about, and an attribute is the data we store about the entity. So we kind of get this little diagram. So each one of these would be something describing this entity. You could, however, word it that the attribute depends on the entity, and this would be a dependency. Now there are numerous kinds of dependencies. Some are appropriate and some are not, but we will go over a couple. But just so you know, when you study normalization, they're going to talk about all kinds of different dependencies. And when you hear that term, I want you to think of an attribute describing an entity, or essentially a column inside of a table. So if we have a users table, one column might be the username. I always make it way too small. Let's try this again. Boom. Okay, there we go. Now this username depends on the user. That's because if we changed the username would also change. So to think about that, we can draw some users. Still am bad at drawing. Here's a user, and here's a user. And each one of these users might have a username. So the value of username changes based on the user that we're talking about. That is an example of a dependency. Now going beyond third normal form, there's Boyce Codd normal form, fourth normal form, fifth normal form, blah 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 normal form, and yada yada normal form, and just a bunch of other things. But once you get to third normal form, you can basically consider your database to be normalized. Normalized is a state where all of the normal forms have been done on our database and we fix all of the problems. This is obviously something that is subjective. That's because some people would consider third normal form to be normalized, or other people think you have to go farther down. And it really just depends on the application. I personally think third normal form is suitable for 99% of applications, so there's really not a huge reason to go past that, but occasionally there is, so it still might benefit you learning the other normal forms. Now, all of this is designed to help us get data integrity. And I know we've had like a crap ton of videos over data integrity, and you're probably sick of hearing that term, but as I said, it's very, very important in our database. If you go through the normal forms, you can basically assure yourself that your data has integrity. How exactly does this help our data integrity? It helps it by preventing anomalies. An anomaly is something out of the ordinary. There are different types of anomalies, such as insert anomalies and update anomalies and delete anomalies, but if you had to summarize it all, essentially, when you do something with your database, it does something that is not expected. And that stems from our data not having proper integrity. So if we can get rid of anomalies, then we can protect our data. How do we get rid of anomalies? By reducing redundancy. What is redundancy? Redundancy is when we have the same information in our database 2 times or more. You can think of if we had a user table, and let's say we have username, name, and phone. And when we insert data into this, we give a username, we give it a name, and a phone number. And now let's say we want to add a second phone number. Well, let's just add another row. And in this situation, we have data redundancy. That's because we have this username in here twice, and we have this name in here twice. Now, if these were foreign keys and they pointed back to one entity, that would be okay. But in this situation, it's not okay because we have the same data repeating. And if we were to try to update this data, let's say Caleb got a name change, well, now we go and say, oh, let's grab this row and update it to something else. So instead of Caleb, we're going to have John here. This is a perfect example of an anomaly. That's because now we have John and Caleb in here, and they're both the same person. So is this guy's name Caleb or John? I don't know. And there's no real good way to find out. So we do not want anomalies ever. When you study normalization, you're going to come across different terms such as candidate key. And there are a few others. Essentially what a candidate key is a combination of columns, or just a column, that can uniquely identify a row. So basically we're going to have numerous candidate keys, and then we have to pick which one is going to be the most best primary key. So let's say this one's the best. We could say, oh, this is our new primary key. When you go through these normal forms, it's going to be talking about all of the candidate keys. Now, candidate keys come in more commonly when we're using natural keys, which have real world meaning. That's because we have to find a good combination of columns to force something to be unique. But when we're using surrogate keys, we almost always just have an ID column. And if that's the situation, we only have one primary key. And because of that, I almost ignore the candidate key. Now, it's probably not like the world's best practice, but you know, it works. As long as we have a primary key that's unique, not null, and never changing, I don't see a huge reason in freaking out about all of the different candidate keys and all of that stuff. That means in the upcoming videos, I'm going to be talking about first normal form, second normal form, and third normal form relating to the primary key. I think that's an appropriate way to start database normalization, especially when we're using surrogate keys which have IDs. Let me know what you guys think. Do you think it's a huge deal to focus on all of the candidate keys? I guess it might be more helpful to go through the videos over the normal forms and then come back and let me know what you think. But people have different attitudes and different thoughts on all of this information. So hopefully all of that information was a good foundation for the next 3 or 4 videos. That way when you go in there, you're not going to be completely lost and I'm not going to have to do a 12-minute intro to first normal form. If you guys liked this video, give me a comment and let me know you liked it. Be sure to click like, and as always, be sure to support this channel by clicking subscribe. That helps me out, and it helps you out because now you'll get all of my new videos in your subscription feed. That is all, guys, so I will see you in the next video. Hey everyone, welcome back. It's Caleb from Caleb the Video Maker 2. This video we are going to be discussing first normal form of database normalization. If you're completely new to normalization, be sure to check out the previous video because that's where I give the foundation. Now to put first normal form into very basic, simple English, all we have to do is put our data in tables and don't design the tables like a noob. That's it. So we want to follow the rule of 1, also known as atomicity. When you start thinking about what kind of data do we want to store inside of a database, you start to separate things into entities and attributes. Even if you don't do this on paper, I know you do it in your mind. You just might not think about it. Entities are things we store data about. Here are a bunch of examples of entities we could have. And attributes are anything we want to store about them. So for example, on the orders, we could say who bought it, what they bought, where they bought it, when did they buy it. Why isn't really relevant in this situation, or how. But yeah, how could be like credit card, cash, all that stuff. So that is kind of how you separate data. Entities go into tables. Each one of these is going to be their own table. Attributes become columns. So for a specific order, inside of that table, we're going to have all of the columns I mentioned. Who bought it, what they bought, that might need to be separated a little bit, but who bought it, what they bought, where they bought it, if there's a store location, the date and time of when they bought it, all of that information becomes a column. But it's important that each attribute is one column, and one column describes only one attribute. This here is essentially how we describe atomicity. Every column is indivisible. So that's what atomicity is. I mean, imagine like atoms, you know, those things they try to teach you about in science classes. At one point, we thought we couldn't split them. So we come up with the great idea of saying this is all atomic. So that is how that term came to be. So let's kind of go into an orders table and kind of expand it and look at some data that might be inside of that table. Inside of the orders table, we could have an order ID, and this column is super important when it comes to first normal form. Just like how one thing is described by one column, well, each row needs to point to one individual instance or one individual order. So each row inside of this table is going to be an example of an order, one instance of an order. The way we distinguish orders is using an ID or some kind of primary key. So for first normal form, we need to make sure things are atomic and everything has a primary key. That means every table needs to have a primary key column. In this situation, we're using what's known as a surrogate key, and that's just an ID. It has no real-world meaning, it's just for the database's sake. We might also have a customer. Now this is a column that stores one thing, so we would have one customer. So let's say we have a website where you can buy stuff, someone places an order, it might be order of 1012, with the customer ID of 782. All we are doing is storing one customer. If we look at the value for an individual row, we are storing one customer. These seem kind of like the same thing, but for the column, we could have named it customer, comma, email address. And that just seems so not normal. Like when you try to design tables, I personally don't find it intuitive to break first normal form. It's intuitive to follow first normal form. That's why I said don't design tables like a noob. If you have a column, don't try to store a customer ID and an email, because that's two separate things. Obviously, each one's going to need to be put into their own column. Additionally, we don't have customers as the column title. Customers is plural, and that would imply that you could put multiple customer IDs in one row, such as 783 being somebody else. You don't want to do that. So we want to make sure the column header stores one thing, customer, and it only stores one of them. Additionally, an individual row talks about one thing. In this case, one specific order. So if we needed to add another order, we would have to add another row. And if for some reason we had to have two customers for one order, we would add another row. Now, in this situation, you can see there's a problem. That's because we have a repeating primary key, which is not okay. So in this situation, you have to break things off into a new table. We'll worry about that in just a moment. That's because I'm just trying to show you guys what it means to follow the rule of one. Everything describes one thing. A table is only talking about orders. Every row talks about one individual order, and every column header talks about one attribute for that order, and every value for that column stores one individual value for that attribute. It's a lot of stuff, but essentially all you got to think of is do everything singularly. You never want to store a set inside of one of these. A set would be like a group of things. So if you're storing a comma something else or a semicolon something else, you're probably breaking first normal form. Now this is just kind of like a rough example. Let's go over a more specific example that's going to require a little bit more explanation. In some of my other videos, I started to talk about this database we're going to work on. And this database is going to be a database for an animal dating website. So your little animals can go on to this website and find their love. These actually exist, by the way, just so you know. So in our situation, an animal goes on this website and creates an account. So that would be stored inside of a users table, essentially. We'll call it animals so it's a little bit more clear that this is for an animal dating site. We'll add a couple of different columns in here so you can see what data would look like. So here's our table. We'll have the animal's name, the species of that animal, the color of the animal, and the type of species the animal is interested in. Let's add some data to this. Sally is a bunny, color is brown, interested in, let's go with bunnies, just to keep this nice and simple. Now the column I'm going to be focusing on in this example is this one right here. So if we wanted to follow first normal form, we need to make sure that the column header is only storing one thing, interested in, which in this case it is, so we're following that. If we weren't, we could have it interested in, comma, not interested in this. And in that situation, we'd be storing two different types of attributes in one column, and that would be a no-no. You don't want to do that. We're already good with that. We're not trying to store two things in here at once. That being said, we also don't want to design this to expect a set of species that this animal is interested in. So, interested in bunny, semicolon, gerbil. In this situation, we are breaking the rule of one because we're storing two values in an individual field, which is not okay. So how do you notice this early? Well, just be aware if you are doing something like interests, plural, you might be designing your database in the wrong way because you're setting it up to expect a set, meaning multiple values. Interests is plural, so you would expect multiple values for it. So how do we fix this? Well, to start off, let's just add a row. So Sally is interested in bunnies and gerbils. So let's just add a row for another Sally, and then we can get rid of this old one. So this fixes our problem of having two values for a column. Let's put that back to interested in. But now we have the problem that 2 rows describe the same bunny. Gosh, I stink at drawing. This here is also very bad, and you don't want to do this in database design. That's because in this situation, it doesn't follow the rule of 1. Now, in some tables, it's okay to have repeating data. For example, if we have a comments table, a user could post 400 comments. That user is going to be inside of that table numerous times. But the table itself is describing comments. So each row would want to describe an individual comment, and we wouldn't want to have 2 rows describing the same comment. So this always points back to what the table's about. So in this situation, we have 2 rows describing one animal. That's not okay. To fix this problem now, we actually need another table. So I'm going to draw some room. That doesn't even make sense. We will name this table interests. Now it's okay to make a plural in this situation because we're going to be storing multiple rows, so there's going to be multiple interests. But always remember, each row is only one interest. Now we're going to have to be able to refer to a specific animal. And in this situation, there's not a really good way to do it, unless we made the name unique or something, but that's not the best way to do it. That means we need to introduce a primary key. So I'm going to erase this over here and add a primary key column. And we'll put an X there because we know that's not allowed. The primary key is a way we force that every row talk about only one entity. That's because we can't put another one in here because it'd have a different ID. For example, if it said 2, it would be a different animal. So let's put that back to an X. So always make a primary key in your tables. Now, inside of this interest table, we can reference that specific animal. So first we could say the animal ID. Then the other column could be this one here. Now the animal ID would be 1. The interest would be bunny. Then we could repeat that animal ID, 1. And it's okay to repeat it here. That's because this animal ID is not talking about the interest, it's talking about the animal. These here are 2 separate interests. They just both happen to be from the same animal. So that part's kind of confusing, but just think we can't have repeating interest because that's what the table is about. These interests are going to be distinct because each one is going to have a different animal. So in this one it'd be gerbil. And you can see that the combination is unique. That's because these, as a group, do not repeat. One bunny and one gerbil are different. So we're not breaking the rule of 1 here. Now back in our original table, we're not even going to need this column. And we don't even need to have any way to reference this table. That's because we're essentially designing a one-to-many relationship. And if you go back to our one-to-many video, you'll know that this is the parent table and this is the child table. And when we have that situation, the child is going to have a foreign key pointing to the ID, and the parent table is not going to need to know about the child. Now what about this row? Obviously we're not even going to need that row, so we can just get rid of it. So if we had to clean this up, which I guess I will, get rid of this column and get rid of this row. And the last thing when you're working on first normal form, make sure each column is actually about whatever you're trying to describe. These all depend on the primary key. But you wouldn't want something in here like the weather. Okay, the weather has nothing to do with the animal. So in this situation, this is not dependent on the key, and we always want every single column to depend upon the key. Now, all of that was a lot of information. So don't get overwhelmed. All you have to remember is to follow the rule of 1. When you're designing a table, just do it intuitively. Make things as singular as possible, make each row describe an individual entity, and in the end, you'll be good. Don't worry about it. Because once you get to second normal form and third normal form, that's going to take your crappy database and slaughter it. And then you're going to have something a little bit better. Thanks guys. If you like this video, please give it a like, and I will see you in the next video. Oh, and don't forget to subscribe. Please. Holy crap, that was a long one. Hey everyone, I just ate some cookies. Yummy. Welcome, my name is Caleb from Caleb the Video Maker 2. This video we're going to be discussing second normal form. Second normal form, oh dang it. Sorry, where was I? Okay. Second normal form. It's the second in the normalization process, as you probably would have guessed. Now, the prerequisites of second normal form is that you've already completed first normal form. So make sure you watch the previous video. That's going to tell you how to get to this point. Now, second normal form deals with something known as partial dependencies. Now, we've talked about when you have a value for a column, it depends on that entity. Partial dependencies come in when you have two or more columns for the primary key. So this always deals with compound or composite keys. When you have multiple columns that are part of the primary key, that primary key is known as a composite primary key. So let's say we have one key over here and one key over here. Now, this is where the partial dependency comes in. When you have a column, it depends on that primary key. So that means if we have a column down here, it's going to need to depend on the primary key. But when we have composite keys, it has to depend on both of them. But if we have a partial dependency, it depends on less than all of them. So for example, if we have 3 columns that consist of the primary key, it has to depend on all of them. If it only depends on 2, we have what's known as a partial dependency. So in the situation of only having 2, if it depends on only 1, we have a partial dependency. Now I know this is all conceptual, but give me a couple minutes, I'll give you some examples. But for now, just know that partial dependencies are bad. The entire goal of second normal form is to get rid of partial dependencies. And what that means is if you don't have a composite key, you don't even have to worry about second normal form. That being said, some of the principles inside of second normal form can still be applied and can help improve your database. The reason that is you actually never have to use a composite key. You can force yourself to always use a single column for a key. For example, if this is named column 1, it's a really awesome name, and this one's column 2, instead of having a composite key, in theory you could just have column 1, column 2 ID, and then just give it a number. And then this would not be a composite key because it's just one column. That being said, the data in this table should still depend on both of these because that's how the table is set up. You're just gaming the system by adding a new column. It doesn't improve your database any, it just makes it worse. So only add a column if you already know how to design the database, and don't just add a column to avoid second normal form, because that's going to defeat the whole purpose. Second normal form is a good thing, not a bad thing. So if you see yourself trying to kind of squeak through the cracks and avoid having to do the rules of the normal forms, then the chances are you're adding a layer of complexity, and that complexity is layered on top of a bad designed database. So don't be obnoxious. Don't try to game the system. Follow the normal forms and everything will work out just great. Now that we talked about the concepts, let's go over some real examples. Really practical examples. Back to our animal dating site. I ate that cookie and now my throat's all like... But first, I wanted to explain one more thing. Second normal form comes up more often when you have natural keys. The reason that is because when you have natural keys, you often have to think of more columns in order to force things to be unique. Not always, but in general, you can just add an ID to whatever table you have, and you're good to go. Which is kind of funny because I was kind of just yelling at you guys not to do that just a minute ago. But essentially, that's what surrogate keys do. Oh, I'm such a hypocrite. Essentially, if you're using single column surrogate key columns, that's good. But there are circumstances when you're going to have multiple ID columns inside of a primary key. For example, when we design a many-to-many relationship in databases, we break that up into 2 one-to-many relationships. So to do that, we need what's known as an intermediary table or a junction table or a... I got nothing else. And when you do that, you're going to have 2 columns in there. At least, it depends on how many tables you're joining. And the group is going to have to be unique, not just one column. In that situation, you have 2 IDs and you're still using surrogate keys. The primary key is the combination of the 2 columns. In that situation, you are required to understand second normal form. What I am advising against is adding a 3rd column to, say, the combination of both of those IDs. So I guess there's a fine line between making it easier on yourself by using IDs and making it harder on yourself by adding too many IDs. And that's a fine line that you're going to have to find because it's a little bit subjective depending on you, the database management system, and also the project you're working on and the team you're working on. Some people like to have that third column just so you can reference an entire row by one ID rather than a group. But some people prefer not to, just so you don't have that extra column for no reason if they don't need it. Now, moving on to super practical examples. We are starting an animal dating site, and we need a way to express relationships between one animal and another animal. I personally think one of the easiest way to design databases is to start with the wrong way to store data and then start picking away all of the obvious things that are wrong, and you end up with something a little bit prettier. That's kind of how the normal forms work, so we'll start with a bad designed database, go through the normalization process up to second normal form, and then we'll be good. In that situation, we still might need some improvement, but that's what third normal form is about, which we will discuss in the next video. But for now, let's start with the animals table. Now, I'm not going to spend a whole bunch of time writing out all of the columns. That's because there's only one column I'm really interested in, and that is the column of who the animal is in a relationship with, whether it be dating or marriage or betrothal or whatever. So there might be a column in here such as relationship with. So we'll have an animal ID, because we always need some kind of primary key, and then we'll have relationship, and let's put some data in here. Let's say there's one animal with the ID of 3, and an animal with the ID of 4, 5, 6, and 7. So these are all different animals. And now this is actually a foreign key. But how does this work? It's actually a foreign key that references the same table. It just references a different column. So this relationship with column references the animal ID column. I don't know where I was going with that. So we could say the animal with the ID of 3 is in a relationship with the ID of 4. But that means that the animal with the ID also has to be in a relationship with the animal of 3. Because you have to update 2 rows every single time you want to store one relationship, this isn't the best way to design it. This can introduce anomalies. For example, 3 could be in a relationship with 4, and 4 in a relationship with 5. And now it's this chain, and that's not the way I envisioned this dating website to work. So because there's an association here, you can see 3 is associated with 4, and 4 should also be associated with 3. This would be a good example of when we should use an association table, or a table inside of a many-to-many relationship, an intermediary table. The odd part of this, though, is that there's only going to be a total of 2 tables rather than 3. So imagine it like this. We have a table for animals, and then we have the intermediary table, and then we have a third table, which is also animals. Now, obviously, these are the same exact table, so we don't need to draw it twice, but that's essentially what we're going to do when we're thinking about this, but when we actually design it, we'll only use 2. So we could say we have an animal over here with the ID of, let's go with 3, and an animal ID over here with 4, and we combine them of 3, 4 inside of our table. But since we're only using one table, and this references the same table, we only need 2. So let's draw a table, and this will be named relationships. We actually haven't really talked about second normal form in this example yet. This is kind of just to prepare us for a situation where we might run into second normal form. So inside of this relationships table, we can make an association between 2 animals. So we would have animal 1 ID, animal 2 ID. And now we only have to put in 1 row for every relationship. So we could say the animal with the ID of 3 is in a relationship with the ID of 4. The animal with the ID of 4. And now we don't have to go and put 4, 3. That's because that association is already made. So that means we have to assume that this is a back and forth relationship. So 3 is in a relationship with 4, and 4 is in a relationship with 3. If you wanted to make it to where 3 could be in a relationship with 4, but 4 doesn't have to be in a relationship with 3, if you wanted to do that for some reason, then you would need to think of actually adding rows for each direction. So we could say 4 is in relationship with 5. But as I said, that's stupid. I don't want to do that, so we're not doing that. Because we have this association now, we're not going to need this column. And now this table would just have data on the animal. So we'd still have the animal ID, the animal name, the animal species, all of that stuff. This table is devoted to just the relationship. If we wanted to add a different relationship, we would have to use different data. That's because this dating website is not going to allow one animal to be in a relationship with multiple animals, because that's just messed up. I'm gonna teach these animals purity. Okay, so that means 5 could be in a relationship with 7, but we can't use 3 again in this column. What that means is that this column can be unique and this column can be unique. You could also make the group as a whole unique. That way we don't have any repeating data. Now something I don't know is how to enforce uniqueness this way. So that way if we had 4, 3, it would be a violation. So if you guys know how to do that, please leave a comment and let me know how to do that. But for now, we'll just leave it at this. So that way we can have 3, 4, but we couldn't have 3, 5. You sick animals. Gosh. And you're probably wondering, where in the world does second normal form come in with all of this crap? Well, it comes in with this. That's because we have a combination of IDs as the primary key. And when we have that, we have a composite or compound key, and there's a potential for partial dependencies. So where does a partial dependency come in? A partial dependency in this situation would be any data describing the animal. For example, if we had a column here, running out of room, so it's going to be a really small column. And if there were any attributes describing one of the animals. So let's say we had animal 1 species. That's really good information to have in the database. The only thing is it doesn't belong in this table. That's because the A1 species is dependent only on animal 1. That's because it's only describing 1/2 of this table, the first animal. So if we had a normal many-to-many relationship, let's say it looks something like this. Beautiful, I know. And inside of this table, we had information related to this entity. That would be a no-no. The only information to go inside of this table has to be relevant to both of the primary keys. The way you can tell if it depends on both keys is if you change one of them, is the data able to change? For example, in this situation, we have A1 species. If we changed animal 2, let's just say we change this to an 8, right? Well, this data is always going to be the same. That's because there's no connection to animal 2 at all. So if you have another many-to-many relationship, just ask yourself, if we change this half of the table, is this attribute going to change whatever attribute it is? If there's a column in that table and you change one of the primary keys, is it able to change? In this situation, if we change this column is unable to change. Therefore, we have a partial dependency. That's because it only depends on part of the primary key. Now you might be asking yourself, if we can't store this here, what kind of information could we store in a table with a composite primary key? Any kind of data that describes the connection of the two entities. So let's say we have these 2 rabbits and they are in a relationship, right? Well, any data that describes this relationship could be stored in that intermediary table. For example, we could have a column establishment date. That would be the time or date of when this relationship started. We could also say type of relationship. For example, we could have, dating, married, engaged. It's complicated, and so forth. This data all describes the relationship. So this would not be in violation of second normal form. Hopefully that describes second normal form pretty well. Just be careful of those intermediary tables because that's where it'll sneak in on you. Thanks guys, hopefully it was helpful. If you like this video, click like, and as always, click subscribe on my channel because that really helps me out and encourages me to make more videos. So thanks guys, in the next video we will be talking about third normal form. Thank you. I know I've said that like 4 times, but I'm really thankful. Do you guys like my drawing? It's better than usual, so I thought I'd ask. Welcome back everyone to Caleb the Video Maker 2. Wait, that's like 4. 2. Every stinking time I make a video, my dog drinks. Welcome back to Caleb the Video Maker 2. This video we are going to be covering the third normal form of database normalization. Now, the first rule of third normal form is that it's already in second normal form. So go make sure you watch the previous video and also the video before that. Before we dive into third normal form, let's refresh our memories on the term dependency. This is when something depends on something else. The example I gave to describe a dependency is when you have an entity and an attribute describing that entity. You can say that this attribute is dependent on the entity. So this entity will have a primary key, let's just say it's an ID, and then an attribute of, I don't know, name. You'll often see these dependencies drawn with an arrow like this, meaning that when you change the ID, the name will change as well, because it's a different person or a different whatever. So 7, Caleb. 8 might change it to something else. That's because we're talking about a different entity. So essentially, all we're saying is that all of the columns inside of a table depend on the primary key of that row, or whatever the table is about. So if we have a users table, you can say that all of the columns depend on the user, and we'll often describe the user using the primary key. So we would say all of the columns are dependent on the user ID. That kind of dependency is okay. There's other kind of dependencies that are not okay. For example, in the last video we talked about partial dependencies. Well, in this video we are going to discuss a type of dependency known as a transitive dependency. A transitive dependency is when something depends on something which depends on the primary key. So you get this bouncing kind of arrow thing. So I know that made no sense at all. So the easiest way to explain this is just to go through an example. We are going to continue to use the example of our animal dating site. And going back to first normal form, we set up a small database where we had animals, or basically user accounts on this website, and then we also had interests. So a animal could sign up and then say the different types of animals that they're interested in. So the structure was something like this. We had the animals table, and then we had an interests table. One of the columns in here was an animal ID. The other column was an individual interest. So the columns might be ID, name, species. And then let's give some data for this. So we'll have an animal with the ID of 16, named Sally, and the species will be bunny. And this bunny has interest in other animals, so we add a row to this interest table referencing that ID. So it'd say 16, and this thing is interested in bunnies. And then also 16 and gerbil. So this is our table structure so far, and there's really not anything wrong with this table structure. So where does third normal form come in? Well, if we were to add columns to this interests table, you might run into some transitive dependencies. For example, here we have a species name, but it's really just a friendly species name, because you know, if you looked up different species specifically, they're going to have these long scientific names that describe them. So let's say we want to store the actual species and the friendly name. So we're going to alter this table a little bit, and we'll say interest species, then we'll say the friendly name. So we can move these friendly names over here to this column. Then in here we can put some crazy scientific names. Ornithologus cuniculus. Oh, my biology teacher would be so proud. Merionus ungulacatus. And there we go. Now we can know exactly the species that this animal is interested in. Because, you know, you say bunny, that's very vague. There's like 4 trillion bunnies. So if we say Orictigus cuniculus, then we know exactly what the bunny's interested in. This is where we introduced a problem, though. That's because there's a transitive dependency in this table. This friendly name actually depends on the interest, and the interest depends on the animal ID. So you can see there's like 2 dependencies in a row. And by this, the friendly name still depends on the animal ID. Think back to math class when they say something like, A is less than B, which is less than C, therefore A is less than C. That's kind of how it works. So this friendly name is dependent on the animal ID, but it's dependent through another column. So you can see the way we have our database set up is just messy. How do we go about fixing this? What you need to do is take the column that this column depends on, in this case interest species, and break that off into its own table. And specifically, we could just take the species because that would be more useful. Because why limit the table to species that animals are interested in when we could just make a table for species? So we need to do that over here. So we'll say species, and inside of here we'll have a species ID, and we'll store just the genus and the species. So we'll say genus species, which that's what that is. This is the genus and that's the species. And then we'll say friendly name. Now we can add this as a row in this table. Now in here we can replace this with a reference to the species. So we can get rid of this column and this column for now. And now we'll have a column species which references the species this animal is interested in. So we would just say 1 and 2. And if by chance we were to add more rows to this, all we would do is just add whatever species we... Onyx, would you be quiet? Gosh! So we could say 7... Oh, noob! I love you, but be quiet. So we could say 17, 2. You can see that this fixed our transitive dependency because we're not having any data about the species in this interests table. And you can see up here, this might be an issue. That's because if you have like quadrillion species in here, this might be very redundant because it's a very vague name. So you might want to break that off into like a friendly name table or something along the lines of that. In addition to fixing this problem, we have the added benefit of improving this table. That's because this species column can be replaced with a reference to one of these rows. So this is a bunny, so we could replace species with 1. And now this just points to this row right here. And there you go, guys. That is third normal form. Hopefully that was nice and helpful and you enjoyed that. So if you did, be sure to click like, and as always, subscribe to this channel because that really helps me out. Thanks, and I'll see you in the next video. Welcome back, everyone. It's Caleb from Caleb the Video Maker 2. This video, we are going to continue our discussion of normalization. Now, we've discussed the 3 normal forms, so I'm not going to go back and explain all of that information again. That's what the previous videos are for. The point of this video is to kind of summarize it so you can look at the big picture. Now, I'm sure you know that the big picture is to help our data be correct, or essentially to improve the integrity of our data. But still, I think there's a couple things I can add to help you understand why we do normalization and why it's important. If you had to summarize normalization and say what these 3 normal forms do, you could say it helps us better describe an entity. It helps us make sure our data is describing what we want to describe. That means that all of these relate to the key in some way. So the first normal form, the purpose is to make sure everything's atomic for one, but ultimately we want to make sure that the attributes describing the entity are appropriate for that table. So we want to make sure that everything in that table describes the key in the smallest way possible, meaning columns are singular and each row only stores 1 value for that column. So for first normal form, we need to make sure that all of our columns depend on the key. So a key is just a way to describe the entity. So we say user ID would be the way we talk about a specific user. Because think about it, we have to pick an attribute that allows us to talk about an individual thing. We could use a picture, we could use something else. We decided to use an ID. This is the primary key. And all of the columns in this table need to depend on the primary key. And each attribute needs to have its own column. Now with second normal form, things get a little bit more complicated because we no longer just have this simple dependency. We have what's known as a partial dependency. Essentially what second normal form says is that every column needs to depend on the entire key if we have multiple columns. So this is most common in many-to-many relationships. That's because we'll often have a combination of columns here as the primary key, which means any data in this table needs to depend on both. If it doesn't depend on both, it's what's known as a partial dependency. So second normal form, everything describes the entire key. Now when we go into the grounds of third normal form, we're talking about columns that do depend on the key, but they depend on the key transitively, meaning through another column. So if we have a table and we have 3 columns, for example, you have to have at least 3. This column might depend on this one, which depends on this one. So you could say this column depends on this one through this one. This is a transitive dependency. So in this situation, this column right here depends on the key transitively here, but it also depends on this column too. So in this situation, there's 2 dependencies. It might be a little easier to think about this if we switch these columns. So let's say this one depends on this one, which depends on this one. So if we had to label these A, B, C, we would say C depends on B and A. So third normal form gets rid of these transitive dependencies. Another way to word that, though, is to say that every column depends only on the primary key. So in this situation, C doesn't only depend on A. That's because it depends on the key and another column. So third normal form makes sure that every column describes only the key. So to summarize, first normal form, every column has to describe the key, singularly. Second normal form, every column describes the entire key, and third normal form, everything describes only the key. Or some people say nothing but the key. So they'll say the key, the whole key, and nothing but the key. So that's a pretty good summary of all the 3 normal forms. Hopefully that was helpful. If you guys want to learn more about normal forms, I do have a database design series where I discuss some more examples. And also you can research online Boyce-Codd normal form and some of the other normal forms. We might get into some of those later, but for now I think this is adequate for what we are trying to accomplish. Let me know what you guys think. Be sure to click like and leave a comment. And as always, be sure to subscribe to this channel because that really helps me out. Thanks guys, and I'll see you in the next one.
What is up, everyone? It is Caleb from Caleb Video Maker 2. This video is going to introduce you to the concept of queries. So we're going to run a couple of queries in SQL Server. Now, we haven't really done a whole lot of on-screen content, so we're going to start kind of slow. But be patient because we are going to speed up as we go. So I'm not going to bore you for the rest of this entire series if you are not a complete beginner. Now, I did want to mention to you guys, this is video number 23, and I decided starting with video number 23, I am going to do a competition between SQL Server, MySQL, and Oracle. You know, just to see which series you guys like the most. So if you like SQL Server, be sure to click like and view all of the rest of the series because I'm going to add up all those points and see which one gets the most points. And the winner is going to get 50 extra videos for the series. So I ain't going to waste your time anymore because it's already been like a minute. So let's connect to our database. Now, when you first connect, all this crap's over here. We're not going to worry about that right now. What we want to do is click New Query. This is where we put all of the commands that we want to tell the database. For example, we can create a database using the create command followed by database, and then we can give it a name. And then to execute that, we just press F5. Now we can go over here and look at our databases, and boom, look at that. We got a subscribe database. But the focus of this video is not creating databases. I actually want to talk to you about expressions. An expression is essentially anything that can be evaluated by SQL Server. What do I mean by evaluated? Well, remember back to math class, you'd have, these problems and they'd be super hard, like 5 plus 5, and you had to evaluate those to an answer. So you could say 5 plus 5 is an expression. So we can have SQL Server evaluate expressions for us. The way we do that is use the select keyword, and then we give it an expression. 5 plus 5. Now, the semicolon at the end of these is actually optional, although I am going to try to use it because it's recommended, and if you have 2 select statements in here, for example, select 5 plus 6, you can run both of those at the same time. This is known as a delimiter, and it tells SQL Server that there's going to be another command after this one. But if there is not a command after this one, for example, let's just say we had this, you do not need it. You can put it, so this would work, but it's optional. If you have 2 statements and you want to run them both at the same time, it is required. So essentially, the last semicolon is optional, but as good practice, you should probably put it in there. All right, but I'm getting off topic. Let's go back to queries. All right, so let's run both of these. So press F5, And you can see the first one returns 10 and the second one returns 11. And you can see here I actually did not put a space after the 5 here. That's because SQL is not white space sensitive. So what is white space? White space includes spaces, it includes tabs, and new lines. So you can see I just put a space, tab, and a new line, and when I run this thing, it's going to work just the way that it did before. Now there are some limitations to this. For example, we can't put white space between a keyword. For example, when we do that, it's no longer a keyword. Additionally, when we are working with string data, for example, if we have that, if we put a space here, that's actually a different string. And I'll show you that, because we can actually put a string inside of a select to return it to us. So this here can actually be returned back to us. So we can tell the database, hey, we want you to give us this string back. So to do that, all we have to do is say select followed by that string. So this is a string, and a string is just a collection of characters. Each one of these is a character, and it's surrounded by single quotes. So let's run this, and you can see it returns that string. Now what I was saying about white space is that when we delete this white space here and then run it again, you can see that it returns the same thing that's put here. So the white space inside of these quotes makes a difference, but the white space here makes no difference. You can see that the result is exactly the same. One other thing that I wanted to mention in this video is comments. A comment is something we can put there for our use, but SQL Server just ignores it when it runs the query. To put a comment, you put 2 minus signs, and then you can put whatever you want. So you can see here, this is a different color, and SQL Server is actually going to ignore it. So if I execute this, you can see makes no difference. Now these 2 minus signs, this is an example of a single line comment. What that means is when we go down to the next line, we are no longer in a comment anymore. And you can tell because it's a different color. So down on this line, we can put other commands. And I'm just going to add that semicolon there to get into my good practice. The other type of comment, though, is a multi-line comment. And the way you do that is a / asterisk / and then in between these 2 asterisks, that's hard to say, you can put whatever you want. And now you can see this entire section is ignored by SQL Server. Now you don't have to put these on multiple lines. For example, this is all on one line, but it still works as a comment. So yeah, that's a pretty good rough introduction to queries. Now, we never dived into all of the keywords and everything you can do. That's just because there's too much to cover in one video. I'm already feeling a bit scatterbrained because I'm trying to explain so much and But essentially, everything's going to piece together as we learn more about SQL Server. But for now, just know that you can use the select statement to have the database give us back some data. But what we need to know now is how do we get data from tables? And that actually requires another keyword known as from. And we will talk about that in upcoming videos. So thanks guys, be sure to click subscribe and like this video, and I will see you in the next video. Hey, what's up world? It's Caleb from Caleb's Video Maker 2. This video we are going to talk about the create table statement in SQL Server. So the very first thing is you want to click new query. Now, the create table statement is used to create tables, obviously. So this video is going to walk you through that process and tell you everything you need to know to create a table. Now, the very first thing once you're in this query window is that you want to click this little drop-down box and choose the database that you are working with. The previous video, I created this database called Subscribe. You know, I gotta advertise, right? And that's the database I'm going to be using. So I click that. And then inside of here, I want to create a table for animals. Now, the command to create a table is actually very simple. All you literally do is say create table and then pick a name for that table. So we'll say animals. And then you put parentheses. Now, what are the parentheses for? Well, these are actually where the columns go. So I usually space this out and tab in. That way it's a little bit formatted a little better. And then each column I put on a new line. But before I do that, there's a couple things I wanted to discuss. The first thing is conventions. Conventions are these things that programmers follow to help them write more readable code. It's an agreed upon way on how to write something. SQL is very easy to work with in that you're allowed to type things basically however you want. So this create word, it could be create in lowercase, and it works exactly the same way. But by convention, I put it in uppercases. That's because, can't type. That's because that's what most people do. And that way, when I'm having a problem and I post my code online, people aren't like, what the crap is this? They can actually read my code because I follow a common convention. In addition to that, all database objects are written as Pascal casing. And what that is each word starts with a capital letter, and then the rest of the characters are lowercase. So for example, if we had 2 words, we could say animal profiles. And you can see that there's a capital for each word. So that's basically all I wanted to talk about for that. So let's move on to creating the columns. Now the very first thing I do is I think of the name of the columns. After that, I think of the data type for the columns. And then lastly, I think of any constraints for those columns. So let's go with the names first. We'll have an ID, and then I put a comma to say there's another column coming. We'll have a name, and then we'll have a species. So these are 3 columns we could start with, but we need to consider what data type we want each of these columns to be. I haven't discussed data types in a lot of depth, but I'm going to introduce you to 2 of the most common data types. The first one is int. Now an int is short for integer, and that means a whole number. This is used for numeric data and is almost always going to be used for the ID column. Now moving on to the name, this one's going to require character data, so string data. That means we need to use a data type like varchar, which stands for variable length character sequence. Well, it might not stand for that whole thing, but that's essentially what varchar is. The thing with varchar though is that we want to say how long we want the name to be able to be. So we need to give it a max length. So you need to ask yourself, what is the longest name I want to allow in my database? Now I'm going to use 50. I think that's more than enough characters for a name, and if your name's longer than 50 characters, you should get a nickname or something. You want to make sure you put that number within parentheses. Now I'm going to use the same data type for species. Later though, you could replace that with a foreign key to a species table. And what that would do is it would reduce redundant data and also help protect against mistakes. But for now, since we're just focusing on creating one table, I think that is more than good. Then we're going to want to end that with a semicolon, of course. This is actually all you need to create a table. It has all of the columns and has all the data types. Earlier, I mentioned constraints. Well, constraints are actually optional. So this should work if I run this create table statement. And you can see that it worked. And you can see it over in your Object Explorer if you go to Databases, Subscribe, Tables. Then let's try refreshing this. And you can see it right there. Now you can expand it and see the columns right here. Now you might be thinking, what about the constraints? Just because they're optional, we can't leave them out. They're important. And I would have to agree. It's always important to have a primary key. Because in this situation, we have an ID, but you can see it's labeled null, and also it's not unique. And therefore, it's really just not suitable as the primary key. So we need to go back to this table and add some constraints. That's what we are going to be talking about in the next video. Thanks, guys, and I'll see you then. Also, please be sure to subscribe and click like on this video. Hey, what is up? It's Caleb from Caleb's Video Maker 2. This is going to continue your Create Table video for SQL Server. Now, so far, we are in the process of making this animals table. And you can see here, there's a little red squiggly saying this table already exists. So I already created this table. So that means when I run this command, it's not going to work. Oh, see, it didn't work. Like I said. Gosh, if you just trusted me. So now you might be thinking, how in the world am I supposed to change this darn table? Well, you can't just go in here and change things. For example, this was originally 50 and I changed it to 30. Well, that's just not going to work. So there's 2 options on how you can do this. The first is alter the table, and then the second is drop the table and recreate it. Altering the table is a little bit more complex, and that's actually something we are going to cover in a lot of depth in the upcoming videos. But for now, I think the easiest way is to drop the table and recreate it. So the term drop means to delete. So we are just essentially getting rid of the entire table. This is different than just deleting the data in the table. It's going to delete the entire thing. So what that means is all of your data in the table is going to be utterly destroyed. So make sure you look through the data, make sure there's nothing important, and if needed, you can back up the table or whatever, but we'll deal with that in another video. We don't have anything in this table, so it's not essential that we worry about the data. So the command to do this is very simple. All you say is drop table animals. Now the thing here is that we want to make sure we're talking about the right database. You can see here this is on master again, which is kind of annoying that it goes back to that a lot of the time, but just make sure you are on the correct database or things aren't going to work out right. So we are going to drop this table. That's all you have to put. You don't have to put parentheses or pass anything into this. You can think of it as just a modification of the create table because it's kind of the same. Create table animals, drop table animals. So let's run this. And it works. And now that's going to allow us to go in here and edit things. So we can make this 20 characters, for example. And you can see it allows us to recreate that table. So this is pretty cool. We can, delete things and recreate them. But now if we try to run this drop table command, see what happens. Oh, yeah, it's going to work because I just recreated the table. But let's run it again. Okay, there. It does not exist or you do not have permission. So now this is giving us a problem. So you kind of have to check to see if the table exists. You have to run this, and then if it works, you drop the table. If it doesn't work, then you need to create the table. Essentially, it's super annoying. It would be nice if we could do some kind of if statement saying, hey, if this table does exist, drop it. If not, don't worry about it. And that's actually very easy to do in SQL Server. All you got to do is go after this drop table and say if exists. That's literally all you have to do. So now I can take literally the entire script and just run the whole thing, and you can see it works. And if we drop that table and then run the whole thing again, you can see it still works. So what's going on is it goes here and it says drop table if exists. It checks if it exists and it doesn't, so it doesn't drop it. And then it moves on to the create table. So that is how you can do that conditionally. That'll improve your scripting and you don't have to worry about executing sections like this or having errors show up here annoyingly. That's all, guys. Hopefully that was helpful. And in the next video, we'll be covering something pretty delicious. So I will see you then. Thanks, guys. Oh, and be sure to click like and subscribe. Yo, welcome back. In this video, we are going to be talking about primary keys and a couple other constraints and how to add them to the create table statement. The reason being is because we have these columns in here, but we haven't told SQL Server which one's the primary key, and we haven't really described any of the columns in any detail. The very first thing I want to do is start with the primary key. But first, I'm going to change this back to varchar 50, and that way everything's back to how it was. Now the column we want to be the primary key is this ID column. And there's a couple different ways you can add constraints, but one of the easiest ways is to add them as a column attribute. So when you have an attribute, it describes the column. And we put these right after the column. And you don't use commas or any kind of punctuation. All you do is put a space. So it's really simple. Just go after this int right here and say primary key. Primary key. There we go. Oh, there we go. That's literally all you got to do to say it's the primary key. But the downside to just leaving it at primary key is that it's not going to automatically generate new numbers. And the way to do that is to say that this is the identity column. And you can also see that when we have multiple attributes, we can just separate them by spaces. As well as that, when you say primary key, it's automatically going to be not null and unique. But we might want to add some of those attributes to some of the other columns. For example, this name here, we might want to say a name is required. So to do that, you can just say not null. Same for the species. Another attribute we can use is unique. The thing is, here we don't really have a good column to use this attribute on, so let's add another column. We'll add an email address for us to contact this animal or the animal's owner, if that would be more appropriate. So we'll just say contact email. And we'll need to add a comma after the previous column. And for this one, we'll say not null and unique. And obviously we're going to want to throw in a data type here too. We'll just go with varchar 50. Now something about emails is that emails can actually be longer than this, but in the practical world, most emails are going to be way under 50 characters. So if you make a larger varchar, you increase the probability of people putting fake, huge emails into your database. So generally I think 50 characters is just fine. Now you can see that we've described a lot of the other stuff in this table, and the table becomes a lot more like what we imagined when we were designing this. So let's run this and just make sure everything works fine. Okay, commands completed successfully. Now let's go to our Object Explorer and see how these things show up. So let's go to Databases, Subscribe, Tables, Animals. And you can see all the columns right here. You can see that this is the primary key. That's what that little key symbol is. And you can find all of our attributes right here. Not null, not null, not null. The unique actually goes in the keys. So unique key right there. And then there's the primary key as well, which is the same as this one right here. So that's a pretty rough introduction to column attributes and how to use them. There are some other attributes you're going to want to use eventually, including foreign keys, default, which is actually going to give a default value if you leave something out when you insert data into this table. And then there's also an attribute known as sparse, which can be used for nulls. So if a lot of the data for a column is null, you can use the sparse attribute and it will help save storage. But we will talk about all that in the upcoming videos, so don't worry about it for right now. Just focus on what we did here, and in the upcoming videos, we'll be adding some more to this table, and everything will go well. So thanks guys, and I'll see you in the next video. And as always, please be sure to click like and subscribe. Hey everyone, welcome back to Caleb the Video Maker 2. This video we are going to be continuing off of the last video. So in the last video we created this table animals. And you can see here one of the columns here is species. Now this column is going to give us some problems. And the reason that is because all we are is storing the species as plain text within a varchar column. That means if we have, I don't know, 2 million animals sign up for this app we're working on, well, in that situation, we might have the same value for the species 30,000 times. So you can see that the data becomes very redundant. Redundancy is one of the leading causes of anomalies, so we want to get rid of all redundancy. And the way we need to do that is actually turn the species column that's varchar into a foreign key referencing a species in another table. So how do we do that? Well, we actually have to have that other table created. Now, when you reference a column from another table, you have to label it as foreign key. Sorry guys, my dog keeps sneezing every time I try to talk. Now, when you reference a column from another table, the column that is being referenced is known as the parent. The column that's referencing it is known as the child. Now, when you create these tables, you always need to create the parent table first. So in this situation, the species is going to reference another table. So this would be the child. We need to create that parent. So I'm going to put it up here. We will just say create table, and then we'll say species. And the columns we are going to put in here are the ID. That's going to be an int, primary key identity. The next thing we're going to add is the species. And this is going to be essentially the same value that we would have stored here. So we can even copy that data type, varchar 50. And we are going to make this not null and also unique. It's going to be unique because each species needs to only be in this table one time. And then we can have unlimited references to that individual species. Additionally, I'm going to make a column for now called friendly name. And essentially that's going to be a friendly name of the species. So if you have a family, genus, species kind of thing. It's not exactly the most easy thing to read. So this could be something simple like bunny. Now this could actually introduce some redundant data here because, there could be 20,000 species of, maybe not 20,000, I don't know. There could be 20,000 species of bunnies and the friendly name is bunny for all of them. So the solution to this would be to make some kind of animal categories table and then we could reference that with the foreign key here. But for now, the amount of redundancy is nothing compared to having this species column down here. So I'm not going to worry about it right now. So what we need to do is give it a data type, and we'll just say varchar 50. And we are going to make this one not null, but we're not going to make it unique because we just said we will have redundant data in here. Multiple species could all have the same friendly name. So overall, this looks pretty good for the species table. I'm getting an error here, I think probably, yeah, so I was dorking around with this at one point, so let's just add this drop table if exists. Now, what about this table? We actually need to replace this column with a reference. So the very first thing when you're creating a foreign key, you need to make sure that the data types match exactly. So what are we going to be referencing? Are we going to be referencing the species column of the species table? Or are we going to be referencing the ID column of the species table? Well, you could do either one because this is labeled unique, but in general, it's best to reference the ID. So that means we are going to change this to species ID, and then the data type needs to match exactly. So this needs to be an int. Now we created the column, but how do we tell it to reference this column over here? Well, we just add a couple words right here. It's real simple. References. It's one of the hardest words to type. And then you say species, and then in parentheses you say the column ID. So everything should be good. We just have to make sure to switch this to the right database, of course. All right, let's run this and make sure everything works. Boom, there you go. That is how you create a foreign key in SQL Server. Thanks guys, hopefully that was helpful. If you like this video, be sure to click like and subscribe to this channel. And I will see you in the next video. Yo everyone, welcome back to Caleb the Video Maker 2. So in the last video, this is where we left off. We are in the process of creating an animal dating site, and we have a table to store all of the animals that sign up, and a table to record all of the available species. And then the animal can reference one of these species. But you know, that's really not enough for an efficient dating site. The animal needs a way to say other species that they are interested in, right? So we need to create an interests table. Why do we need a third table? Well, it's because one animal can be interested in multiple species, and an individual species can be labeled as an interest from multiple animals. Therefore, we have a many-to-many relationship. And you know, many-to-many relationships don't go well with databases, so we break this up into two one-to-many relationships. So this becomes an intermediary table. And this kind of breaks that tension between the two tables. By now, you're probably an expert on the create table statement, so I'm not going to waste your time explaining it all. But now I'm wasting your time talking about how I'm not going to explain it all. Oh. And the two columns in here are literally just going to be a species ID and an animal ID. That's because we are associating one species with one animal. We'll start with the animal ID though, because an animal is interested in species. It just makes more sense to put it that way. You could flip it and say, here are the animals interested in this species, but this is more clear to me. And then we are also going to have the species ID. Now, what data types are these going to be? Well, as you learned in the last video, the foreign keys always need to match the data type of the column we're referencing, which means we need to make these both int. We are also going to make them not null, but we are not going to make them unique because that would defeat the purpose of this table. The point of this table is to allow an animal to be interested in multiple species. But if we made the animal unique, for example, then we could only have this animal in this table one time, which would limit the animal to only one species. So each individual interest is going to get one row. That means an individual animal ID might be in here 20, 30, 40 times, depending on, the character of the animal. Now, what about the primary key? Well, we've talked about this. There's two ways we could do a primary key for this table. The first is to have a compound primary key. The second is to create an ID column. And this would be a unique ID to describe a specific interest. Now, these both have their ups and downs. The ups for the compound is that we don't need to add any columns, but the downside is that it becomes more complex. Anytime we want to talk about this individual interest, we're going to have a compound foreign key, which that just makes things more complicated. The benefit of this column is that we can avoid that. Now, when we reference an individual interest, all we have to do is have an individual ID as the foreign key. To expand our learning, I am going to go with this route. So we are going to create a composite primary key. Now, how do we do this? We can't just add it to a column like this. That's because this is a column level constraint. It can only talk about this individual column. So this is a problem. We actually have to add the constraint at the table level. So that means we add it as if it's its own column. So we just come past here and add a comma, and then we just say primary key, and then in parentheses we can actually add both columns. So we could say animal ID, species ID. So that is how you create a compound or composite primary key. Last thing, I wanted to add a drop table statement for this table. So let's go up to the top. And one thing about the drop tables is you always want to try to delete the children first. Because, for example, if we try to drop this table, here, I'll show you. You can see it says it's referenced by a foreign key constraint. That's because we didn't use the onUpdate clause when we created this foreign key. That means we need to try to delete all the children first. So this new table, it actually references both tables. So it's like the child of all children. So we need to drop it first. So let's add a line here, drop table if exists. Interests. All right, so everything should be good. Let's run it and make sure it all works. And there you go. Now let's go to our Object Explorer and find that database, subscribe, go to the tables, and then go to interests and then columns. You can see that they're both labeled the primary key. But if you go to keys, you can see it has this disgusting name. It's this gross. All right, we need to fix that. So in the next video, we are going to learn how to name our constraints. So yeah, guys, thanks for watching. Hopefully that was useful. If you need to look over this, here's the entire code. And yeah, thanks guys. I'll see you in the next one. And be sure to subscribe. Sup YouTube, it's Caleb from Caleb the Video Maker 2. In this video, we are going to be talking about naming our constraints. So I'm an idiot and I forgot to do something important in the last video, and that is make these columns foreign keys. So we will do that in just a moment, but for now, I wanted to talk about this primary key. And if you go to the Object Explorer and expand that database, we'll go to subscribe, tables, interests, keys. You can see there's one primary key. And we talked about how disgusting this name was, and we want to change that. That's what we were going to do, and then I'll talk about naming foreign keys, and that's when I'll put the foreign keys on the other columns. So this is at the table level right now, and you can see it's right here, and it's very easy to add a name. All you have to do is add the constraint keyword and then give it a name. Now, what do you name it? Well, that is up to you ultimately, but there are some conventions. There's something known as Hungarian notation. And what that is where we put what the thing is inside of the name. So for example, we could say PK underscore and then give it a name. And that PK is a prefix that says what the thing is. Some people like this, some people don't like it, some people prefer at the end. That is ultimately up to you, but I'm going to follow this convention for right now. So I'll say PK, and then I will put the table name. So that way we know this is the constraint for the interests table, and specifically it's a primary key constraint. You can figure that out just by reading the name. So let's run the script. I'll make sure I am on the subscribe database because I forget that every stinking time. And now let's run this. All right, and you can see that it executed successfully. So let's go back to our Object Explorer, go to keys and refresh. There you go. You can see that it's nice and beautiful. Now let's talk about how to do that with foreign keys. It's very similar. We're going to put the foreign keys at the table level. So I'm going to start right here and I will say constraint, give it a name, FK underscore. Now what are we going to name it? Well, we will name it the first table, so interests, and then the second table, which is the table it references. So interests, and this one is going to be for the animal ID, so I'll say animals. Then you have to say the constraint type, which is foreign key, and then you have to say what column it is on in parentheses. So this is on the animal ID, and then you have to say what it references. First you put the table, so it'll be animals, and then in parentheses you say the column. And there you go. You can see this is a little bit more long than the primary key, but overall it's not too complicated. Normally all you have to do is put references animal ID up here with the column, but if you want to put it at the table level, this is what you need to do. Let's add another column for the species ID. It'll be pretty similar. And there we go. Now let's run this and make sure everything works. Awesome. Let's check the Object Explorer, do a refresh on our keys. And you can see these foreign keys have such beautiful names. Why do we care that much though? The reason is that when we try to insert data into these tables and for some reason something's incorrect, it's going to give us an error and say the constraint name. And if we have these nice beautiful names, it's much easier to figure out what constraints it's talking about. And we will talk about that in the next video when we learn about the insert statement. So hopefully you guys are enjoying these videos and I'll see you in the next one. And as always, be sure to click subscribe and like. This is Caleb from Caleb the Video Maker 2. Peace out. Man, my outros just get longer and longer every time. Welcome back everyone to Caleb the Video Maker 2. This video we are going to be talking about the insert statement. So this is a very good milestone in SQL. We've talked about all the create table garbage, and now we're moving on to putting data into those tables. Now, what are we going to do with all of this junk though?
We want to keep that. So what I want to do is save it as a script. So you can click File and save it. I obviously already saved it as animal dating site, which that works fine for me. Now I'm going to actually create a new script by clicking New Query. And then I'm going to save that. This will allow us to have a level of separation from the stuff we use to create the tables and then the stuff we use to insert data into those tables. So the insert statement, as you may have guessed, it starts with insert. And then we have to say into and then put the table we want to insert data into. Now before I start typing stuff in here, we need to figure out what table is the most parent of them all. So let's go back to our create table statements. You can see in here we are creating the species table first. That's because the other tables are going to reference this table. It works the same way with rows. We need to create the parent rows before we create the child rows. So let's go back to our insert statement. And then we are going to say species because that is the table we need to start with. The next thing you do is use the values keyword. And then in parentheses, you pass in values. This is going to require you to know what columns are in this table. So the easiest way to do that if you do not have this available is to go into your Object Explorer and then find that table, species, and then click columns. We have an ID, species, and a friendly name, int, varchar, and varchar. So let's put some data in there. Let's go with one, this, and then the friendly name, which will be bunny. Notice that we separate each value by commas. Here's a comma. And here's a comma. So just like when we create tables, we separate columns by commas, the same thing happens when we are inserting data. So to go over these, this is the ID, this is the genus, and this is the species, and this is the friendly name. Now you might look at this and say this is a violation of things being atomic. That's because we are storing the genus and the species inside of one column. But you know, YOLO. Oh, great excuse. Just don't say that if you're at a job and they ask you why you did something. Please don't say YOLO. Anyways, let's insert this. But wait, I wanted to show you something. You can actually get rid of this one here. And that's because that is the identity column and it will know that we want to automatically generate a value for that row. So let's run this thing. 1 rows affected is the response. So now we can go into our Object Explorer, find that species table, and then we can right click it. You can see that there's 2 options. Select top 1000 rows and edit top 200 rows. So you can click either one. And you can see the data pops up and it automatically generated an ID for us, which is 1. So that's pretty cool. Now let's go back to our query and we will end that with a semicolon. And now this is the perfect time to show you how foreign keys help protect our integrity. Let's try inserting data into the animals table. Insert into animals, values, and once again, we don't need the ID, but we do need to know what columns go here. So let's go to our Object Explorer, click animals, columns. We need an ID, skip that one. We need the name, the species ID, and the contact email. If you want, you can dock this, so that way you can see it as you're working. So let's go through these. First one is ID, which we can skip. The next is the name, which we will say is Sally. Then we will give it a species ID, which we will say is 2. And then finally a contact email, which is going to be this. Now note, strings start and end with a single quote, and numbers do not have quotes. Let's run this little section and see what happens. And you can see here, there is an error. The foreign key protects us from inserting invalid data. You can also see here that the constraint name shows up. That is why some people like to name their constraints, so when an error is thrown, they know exactly where to look. So a lesson you can learn from this is to always use foreign keys. Now, what if we want to insert 2 values at one time? Let's say we want to insert 2 animals into this table. Let's try that. But first, I'm going to correct this ID so it'll actually let us insert some data. But the way you do it is just put a comma after this, and then you can put more data in another set of parentheses. So I'm going to break this down to the next line just so it's a little easier to read. We will say Franklin, and maybe someday we can add a ID for turtles, but for now we'll just use a rabbit. There we go. Now we should be able to insert both of these values at one time. Let's execute this, make sure it works. 2 rows affected. So you can see that they were actually both inserted. And the way you can see this is by right-clicking the animals table and clicking Edit Top 200 Rows. You can see here we have Sally and Franklin, and the IDs were automatically generated. Note that the ID of 1 is not in here. It's perfectly okay to have missing numbers for the IDs or for them to be out of order, as long as they're all unique. So that is all for the insert statement. If you want one last look at it, here it is. Nice and beautiful. So thanks guys for watching. In the next video, we will be talking about something even cooler. So thanks guys, I will see you then. Also, be sure to click subscribe and like. Sup everyone, it's Caleb from Caleb Video Maker 2. This video we're going to be talking about the select statement. This is one of the key statements in SQL, so you want to pay attention. The way it works is very simple. All you have to do is say select, and then what you do is say the columns you want to select. That ultimately depends on what table you're going to select from, but let's select from our animals table. So let's go over to our Object Explorer and expand that table to see what we got in there. Subscribe, tables, animals. We can look at the columns here. We will start simple and we'll build our way up. So I'm going to select the ID, name, species ID, and the contact email. And then say from, and say what table you want to select this from. Animals. Let's run this and see if it works. Great, it works. You can see it returns all of the data that we want to see from this table. As you can see, the syntax is really not that hard, but there's actually some things we can do to make it simpler. The first thing, rather than going into our Object Explorer to see what kind of columns we have in there, what we can do is we can prefix each column with the table, and it will tell us what columns are available. Here, I'll show you what I mean. Let me erase this. We can say animals, dot, and here are all of the columns that are available to us. So this makes it super easy for us. The way you want to do it is ultimately up to you, but I'm just going to show you that this does work. And then let's run that. And you can see it works exactly the same. In this situation, we are selecting every single column. There's actually an easier way to tell SQL Server we want everything, and that's to replace all of these columns with an asterisk. And you can see it works just like normal. Additionally, you can put expressions in your select statement. So let's undo that, and I'll show you what I mean. So let's say instead of having the contact email followed by the name in 2 separate columns, we wanted to put that in one for easier reading or something like that. What we can do is literally just put plus signs to do what's known as concatenating. So we can take animals.contact email plus animals.name. And this is going to be returned as one column. That's because there's no commas to separate the columns. Additionally though, we are going to want to put a quote in here with a space, maybe a hyphen, and then another plus. That way it just looks a little prettier for us. Let's try this. And there you go. You can see that it says Sally at calebcurry.com -Sally. So that is your introduction to the select statement. Hopefully that was nice and juicy. Oh goodness. My outros. If you like this video, please be sure to subscribe. And as always, click like. I will see you in the next video. Hey everyone, welcome back to your 30-second SQL Server tutorial. My name is Caleb from Caleb the Video Maker, and this video is going to cover aliases. Now an alias is a name you can give something to refer to something. An alias is essentially an alias for nickname. Oh, you see what I did there? When you give something an alias, you can refer to it by that new name you give it. Why would you want to do this though? Well, there's 2 primary benefits that I can think of. The first one is if you have a complicated name and you give it an alias, whatever it is, it'll be easier to refer to it by that new name. The second reason though is that it can actually improve our presentation. So for example, these columns down here, we can change the names of these columns. In the last video, I talked about concatenating data, and I'm going to do that in this video, and then I'm going to give that column an alias so the presentation looks a whole lot better. So right now, I'm just selecting everything, but what I want to do is I want to select a new column that I'm going to generate, and it's going to be a combination of the person's name and email. So we want to select animals.name plus, and then in quotes, a hyphen, plus animals.contact email. All right, let's run this. And you can see that it returns the data with this nasty column name. So an alias allows us to replace that no column name with something specific. And the way you make an alias is with the as keyword. And then you say what the name is going to be. So let's give this column a name contact. And now let's run this. And there you go. So if you need to present some beautiful data to your boss so you don't get fired,
What you can do is give all of your columns an alias, that way it can explain exactly what they're looking at. You can also do this for other columns, it's not just for generated columns. So for example, we could also return animals.speciesID, and then we could say species ID. Now in this situation we have a space, so I think we need to quote this. Let's run it. And there you go. This allows us to decomputerize our data and make it a little bit more user-friendly. Now, aliases are not just useful for presentation, they can also be useful for us as developers. For example, we can give an alias to a table, and then we can reference that table by that new name. In this example, we are working on an animal dating site. So essentially, each one of these animals is going to be a user in our site. So we could rename animals users if we wanted. And it's just for this query, so it's not actually changing the table at all. And now when we type that out, you can see a bunch of things turn red. That's because we have to address it by its new name here. Select users.name, users.contact email, and users.speciesID. Now the entire query is going to give us the same results. So what exactly is the benefit here? Well, if we have a super long table name, for example, we can shorten it, and then it's easier to reference it. Or when we are doing things such as joins, it just makes life a lot easier because we can shorten our queries down a whole lot. Some people like using aliases, other people think it adds a layer of confusion. The decision is ultimately up to you and the people you're working with. So hopefully everything you learned in this video will come in useful for you someday. Even if you're not using aliases yourself, I can guarantee you at some point you're going to come across this as keyword. So now you know what it means. So thanks guys for watching. Hopefully you've enjoyed this video. Please be sure to click like and subscribe to the channel. Thanks guys, I'll see you in the next one.
Hey, welcome back everyone. In this video we are going to be talking about indexes. Yeah! Now we've briefly talked about indexes in this SQL Server tutorial series, but in the upcoming videos we are going to be creating these indexes, so I thought it'd be appropriate to, go a little bit more in depth with these things called indexes. It's been a little while since I've made a video, so it might take me a couple seconds to get back in the rhythm of things. Also, I apologize ahead of time if I throw up because I've been sick for like a long time. But that's enough about throw up because no one really wants to talk about that. So let's get on to indexes. What is an index? Well, in databases, an index is when we tell the database we are going to use this column or a group of columns for a bunch of stuff. It improves the speed of our database. Essentially what I'm saying is that we create a column index. Now that SQL Server knows how to treat that certain column because we labeled it an index, it improves the speed of our select statements and also joins, which are part of select statements. So literally, the easiest way to think of an index is to think of a book which has an index. So an index is something usually in the back that you can look at and it'll tell you where they talked about certain topics. Of course, the one book I grabbed does not have an index. Anyways, pretend that the back of this book has an index. And what that index does is it lists different topics that the book talks about and where to find those topics in the book. It works similarly in databases because we can define a column as an index and then that database knows how to grab that data quicker. Now there are two types of indexes when we are working with SQL Server, and those two index types are clustered and non-clustered. I'm going to give you a rough overview of what both of these are, that way you are prepared to make legit indexes on your database. The essential difference between these two is how the data in the index is structured. The first one we are going to talk about is clustered. Now, I don't know about you guys, but back when I was a young lad, we had these things called phone books. And what these things do is they list phone numbers of, all the people in your local town or your city. Now the way these phone books are organized is that when you look someone up, all of the information about them is right there. So let's say the phone book is organized by name. You could say that the name is a clustered index in that phone book. So in databases, clustered indexes determine the way the table is actually laid out. To better think this through, let's go through a simple table to see this. Here is the table, and we have an ID column and a name. Very simple table. Doesn't really matter if it's useful for anything. The thing you're going to notice here is that these are ordered by an ID. So in this situation, we probably put a clustered index on the ID column. The names, on the other hand, they are in no particular order. That's because they don't have an index. So if you were to tell the database, yo, give me the dude with the ID of 3, Well, it's easy. All you gotta do is go down to the ID of 3. Boom, right there. But if you say something like, yo, give me the person with the name Mark, well, now the database is going to have to go and scan through every single row to try to find Mark. So you can see that it can be much more time consuming. When the things are in some logical order, the database can find that data much quicker. Now moving on to a non-clustered index, it works very similar in that it organizes the data like this, but the actual data that's associated with it is stored somewhere else. So it kind of just tells you how to find the data. The best illustration for that is using an index in the back of a book. So let's say I look up something like joins in a database development book. It'll say joins, page 4082. It points you to where the data that you're looking for really is. So let's say we wanted to order the first name. We could put a non-clustered index on this data, and the end result would be something like this. You can see that these are in a procedural order now, and if there is any other information associated with this row, for example, a last name, since this data is in order, the database can find the data much quicker. So you could say, yo, give me the person with the last name of Mark. Boom, right there. Then it is easier for the database to find the data relating to Mark. And there you go, there's Mark Smith. So another way to think about it is that the non-clustered indexes organizes the data, but does it separately than the way the table is actually structured. The table is actually structured by ID here, but the database does some additional work of keeping some kind of system of ordering for the names. Then the database can use that system to find the data related to that name or whatever the index is on. Now, indexes work the best when you're grabbing the data that is indexed. So what that means is that if you have some kind of index and you are selecting data, it'll probably be faster if you just select the columns that are part of that index. But that doesn't mean you have to do it that way, and generally indexes can help with a lot of things. So if you're running into the problem where your queries are slow, you'll probably want to look into adding indexes. And in fact, you should probably design your database to have indexes to begin with. So what do you want to index? I know this video is kind of running long, so I'll try to keep it simple. Essentially, you want to index anything you're going to commonly use for a select and also joins, which we will discuss joins in more detail as time goes on. So this generally includes the primary key, which by the way, anything labeled primary key is going to be a clustered index by default. So you usually do not have to worry about the primary key. The next thing you'll want to consider is any foreign keys. If you're using joins and you're joining foreign keys to primary keys, you'll probably want to make a non-clustered index on those foreign keys. Lastly, the third type of thing you're going to want to index is any other columns you are continually selecting. So if you have some website that continually selects the same data and over and over and over again, you might want to consider adding an index on there and seeing if it improves the speed any. The last thing you guys need to know is that you can only have one clustered index. Only one. And why does that make sense? It makes sense because this determines the table structure. You can't have the table structured in one order and also in a different order. Only one index can determine the order. You can have as many non-clustered indexes as you want. I mean, there's a limit, but in general, the number of non-clustered indexes is not a concern. The only concern you might want to have is that the more indexes you have, the slower the database becomes. That's because anytime you update data or insert data, it's got to update it in all of the indexes. So for example, let's say Mark changes his name to Mark with a C. Well, now this has to be updated in all of the indexes referencing that column. So there's a good balance. And obviously this is a lot of information for one video, so we can't cover it all. But this is a pretty good overview, and in the next videos we'll be creating indexes in SQL Server. So thanks guys for watching, and if you like these videos, please be sure to click like and subscribe, and I'll see you in the next one. Thanks guys.
Hello everyone, welcome back to Caleb the Video Maker 2. This video we are going to be talking about creating indexes in SQL Server. Now, in the previous video, I discussed the concept of indexes. So if you're really unfamiliar with them, you'll want to make sure you go back and watch that video. But if you have a rough idea, this video will be fine for you. It's not going to be too complex or crazy or anything like that. So right here on the screen, you can see the tables that I've created. And we need to think what columns would benefit from an index. But the very first thing we should know is that some columns are indexed by default. And those columns are any columns labeled primary key or unique. So you can see that this column is going to be indexed, this one, this one, this one, and this one. So we really don't have to worry about a whole lot, but there might be a couple other columns that we want to pay attention to. And the ones that usually jump out to me are foreign keys. That's because we use foreign keys for so much, but we often neglect them in that we don't give indexes to them. And remember that we want to give indexes to any columns we're going to continually use for joins and also for selects. What that means is that foreign keys are basically perfect candidates for indexes. The column I am specifically interested in is right here, species ID. It's a foreign key referencing the ID of the species table up here. The reason I want to index this so bad is because once we have all of our data in the tables, we will often want to select all of the animals and list the species name, not just the species ID. But the species name comes from this table up here. And in order to do that, we have to join the tables. That means we're very often going to use a join on this column. So let's open a new query so we can make some indexes. The syntax is very simple and probably pretty familiar to you once you understand how the create table works. The way we create an index is with create index, and then we give it a name, just like in create table we give a name. Now, what do we name it? That's ultimately up to you or your boss, but I'm going to follow the convention of ix underscore and then whatever I want to name it. So the ix is a prefix that stands for index. So whenever you see ix, you automatically know it's talking about an index. The next thing I'm going to use is the table name that the column is located in. So going back to our other page, you can see that it's in the animals table and the column is species ID. So we are going to name this animals and then species. You could name it species ID if you want, but I think this is fine. But this here is not enough. We have to tell SQL Server what table and what column this index is going to be on. So we can go down to the next line and say on animals species ID. So the column goes in the parentheses and the table goes after on. Let's run it and make sure it works. And there you go. Now occasionally it's going to come up where you need to delete an index. And the way you do that is you say drop index. So drop is the command we use to delete. Then you say the index name. This alone is not enough though. You actually have to say what table that index is on. So the way you do that is say on animals. And you can see that it worked. So the syntax is very similar to the create index. The only thing different is that you don't need to specify a column because that index already exists on that column. Additionally, you can make indexes on multiple columns at one time, and this is going to be a combined index. It's not a bunch of individual indexes on each column. It's one index on multiple columns. So for example, if we go back to our structure, you can see in the animals table we have a name and contact email, and we might use that a whole bunch. So let's say I wanted to make an index on that. Here's how we do it. Create index, and we could just say animal contact on animals, and then in here we put in both of the columns. Let's try it. And you can see that works. Now, when you have indexes like this, it adds a layer of complexity, and that's something we are not going to dive into right now, but that is something we may address in future videos. The last thing I wanted to mention is unique indexes. So if you have a column that's always going to be unique, you can use the unique keyword. So for example, we could do something like this. Now in this situation, we are telling the database that every single species in the species table should be unique. So let's go back to our structure. You can see this right here would have to be unique. And it's actually already labeled unique. So in this situation, you are not going to need to make this index. And I will address that a little bit more in the next video as to the difference and everything like that. But for now, that's your introduction to creating indexes and dropping indexes. Hopefully that was helpful for you guys. If you've enjoyed this video, please click subscribe because that really supports my channel. Thanks guys, and I'll see you in the next video. Later. Or I should say, peace.
What is up, my peeps from the intertubes? It is Caleb from Caleb the Video Maker 2, and this is your first video over DB2. Now, DB2 is a database that was created by IBM. Historically, it's been marketed largely towards enterprise customers, so think, companies that have more data than they would ever possibly know what to do with. But lately, they've been focusing a lot more on developers. So they've given new features and new additions to meet the needs of developers like me and you. To make sure we are all on the same page, let's answer the question, what is a database? The classic example of a database is a user using some application. And just be warned, I literally have the worst drawing skills of all time. So here is some user using an application, and when he types information in there, it's going to get stored inside of a database. And this is kind of like the typical drawing for a database, except way better. So he inputs info, and that's stored in a database. So the database is usually hidden from the user. And then, when this user comes back and accesses that application at a later time, we can actually get that information back from the database, display it on the application, which will be seen by the user. So this kind of setup here is good for transactional data. So if I said something like we're doing transactional processing, I want you to think input, output, updating, deleting. So this user inserts data, he gets that data back out. The other use for a database is analytics. Analytics looks at all of the data or parts of the data rather than just one insert or one select. So the analytics are used to make business decisions. Running analytics will give us averages, trends, all of that good stuff, and we can use that to shape the direction of where we're taking our company. If customers like one thing but don't like something else, well, we can match our company and our content with what they like. So these are the two primary uses for databases, and fortunately, DB2 is suitable for both of these. We're going to start with transactional processing, but DB2 is awesome when it comes to analytics. Generally though, if you're new to databases, you will want to start with transactional. So that's learning how to work with data. How do we insert data into a database? How do we get the data back out? How do we update it? And how do we delete it? DB2 is well known as a relational database. And what that means is it works with structured data. The other kind of data out there is unstructured data. Just like DB2 works well with transactional and analytical processing, DB2 does support both structured and unstructured data. And if you're new to databases, that's probably not going to make any sense at all. So the easiest way to illustrate this is with a very simple example. When we are working with a relational database, we represent our data in tables. So this is a table and it's going to have a name, for example, users. And then we're going to have columns. These columns define the structure of our data. Every single user in here is going to have the structure made by this table. So a user ID, first name, and last name. This is structured data. Unstructured data does not follow table rules. We are going to start with treating DB2 as a relational database, so we are going to learn about creating tables and the columns, the rows, and how to connect tables and all that stuff. But as you get more advanced, you can work with unstructured data inside of DB2. It's generally well known today that if you're going to have any successful application or business, you are going to need a database. That being said, I do just want to take a couple seconds to focus on the basics and really think, why do we need a database? And I have two good reasons. The first one is security. So the security capabilities with a database are tremendous. A general rule in computer science is that you don't trust anyone ever for anything. So with a database, you can be very specific about who gets to see what. The other thing is scalability. This refers to the capability of expanding your data layer of your application or business. So as your company grows, DB2 has many additions that allow you to scale up to even an enterprise edition. So we talked about a couple things for general databases, security and scalability, but now let's talk a little bit about DB2 and why you would want to use that. The very first reason why I like DB2 is that there's a free version, and as you all know, I'm a total tightwad. The other reason is something called Blue Acceleration. This deals with the analytics side of DB2. I mentioned a little bit ago that DB2 has some awesome things when it comes to analytics. Well, this is specifically what I was referring about. This is an in-memory processor. So essentially we bring our data into RAM, and then we can run crazy fast analytics on our data. There's a plethora of other reasons why I think DB2 is a good database. So if you are starting a project and you're trying to decide what database to go with DB2. On top of that, this series is going to give you the foundation needed to build a DB2 database. If you guys have any questions, concerns, or comments, just leave them in the comments below and I will do my best to get back to you. On top of that, I created blog posts for these videos, so I will put the link to that in the description. Finally, if you actually want to give DB2 a try, I'll put the link to get that in the description as well. Be sure to subscribe because there's going to be a lot of great content coming out. We're doing some concept stuff up here and then some coding down on the computer, so we get, the concepts and the practical. We get, the comp. Super excited. Hopefully you guys are as well. And as always, be sure to subscribe and I'll see you in the next video. Peace! Welcome back, guys, to your second DB2 tutorial. Now, I'm going to go a little bit into the basics of DB2. So I'm not really going to go into how to install it and all that, because that's really super boring. But I am going to tell you where to install it. So I made this handy dandy link right here. Just go to bit.ly/DB2 Community Edition. And that is a very convenient link. Secretly, I want to track you. That'll take you to this page, and you can see my beautiful face. Anyways, you can click this download now button, and as you can tell, my internet is extremely fast. Once you get to this page, it's going to ask you to sign in, and then it'll give you some options. And just download the full thing. When you are deploying, you can get smaller versions of DB2 without all the extra tools and stuff. But since we're developing, we're just going to get everything. So once you're here, sign in. If you're a first-time user, click yes, and then make sure you read that good book, and then click I agree. Then what you want to do is download the version according to what operating system you're on. So I am going to go with the Mac version right here. When you download it, you're going to go through the installation process. It'll ask you for a DB2 user and also a user for something called Data Server Manager, which I'll talk about all of that, but just make sure you write all that information down. Going through the installation, you're going to install something called Docker, and it has this cool little boat whale logo thingy. And this is a container software. If you don't know anything about containerization, well, we're on the same page. But essentially, it's just a way to have a consistent infrastructure for your applications. It's kind of like a virtual machine, except it doesn't have the entire operating system, if that helps you understand it any. Anywho, I think I'm getting into way too much detail. The most important thing is that you get to this page here. So when you get here, you'll want to use your Data Server Manager username and password. Once you get in, you're going to want to put your DB2 credentials, so I believe it was db2inst1, and then just whatever password, and then you can click Save Credentials to Repository and click OK. There are all kinds of things you can do with this tool. Generally, Data Server Manager is the tool used to manage your database, so there's all kinds of administration, monitoring, and all kinds of other fancy things in here. I just wanted to point out a couple things. So if you go into Administer and then Tables, you're going to see all of your tables. So if you click a specific table, you can go in here and click this data button. That's going to show you the data of the table. So this will allow you to see the columns and the data types and all the data inside of it. This will help you see the way our data is represented in a relational database. Another thing you can do is run SQL or SQL. This is where you're going to type in all of your commands to communicate to the database. A couple other things is you can click this little hamburger panel thingy-majig, I don't know. Click that and click Data Studio. Now this Data Studio is an optional thing you can install, but I would highly recommend it, especially if you're going to be doing anything with stored procedures. When you open it, you're going to get prompted with this right here, and you can think of this as kind of like Eclipse. And if you don't know what Eclipse is, it's just an IDE used for programming. So you can click OK. It looks kind of funny because we're in this virtual machine sort of thing, but once you have it open, you get used to it and it's really not so bad. So you can go in here and you can connect to your database here. So you can use this tool if you want to get more into the development. I'm sure there are a ton of tutorials online. This is not going to be the start of my focus. I just wanted to show you that so you know what it is and how to get into it. So let's go back and let's look at the connection details. One interesting thing here is if you scroll down, you can click this little link here. And this will allow you to use Data Server Manager in the browser. There you go, and you can change your database up here, so I can go back to the sample database. And yeah, that's that. Let's go back to the windowed version. And that's basically all I really have to say to start you off. In the upcoming videos, we'll be running all of our commands in this Run SQL panel, so you are good to go. Thank you for watching, guys, and I'll see you in the next video where we'll start talking about some more concepts, and then we'll come back and learn some hands-on things. So, see you then. Welcome back to your third DB2 tutorial. In this video, we are going to be talking about data structure. So, we've gotten our hands and feet wet a little bit in the previous video, but now, before you go making a fool of yourself, you should have some general things in your mind so that you don't make yourself look like an idiot, right? So that's what this video is for, to make you not look like an idiot. Essentially, the goal is to teach you the very basics of data structure and data types. Let's start with data structure. Now, in the first video of this series, we talked about structured and unstructured data. That's not exactly what I'm talking about. I'm talking about if you just zoom out a little bit and you look at the big picture of your database. So if we represent our database here like this, and now I just want you to envision zooming in on the database. Okay, sort of like, you know, those movies where they zoom in on someone's arm or something and then it goes into their cells and all that cool stuff. That's what we're doing here. So you zoom in. Well, all of our content is going to be organized in schemas. So this is a very important word in DB2, and it's basically just a super fancy word for groups. So we can have multiple schemas in our database. These are just logical groupings. We can decide how we want to organize our tables by putting them in different schemas if we so desire. All right, now we're zooming in and we zoom in onto this schema. Well, now inside of this schema, we're going to have multiple tables. All these tables share a schema, but the tables themselves don't necessarily have to be related. Some of them might be using relationships. So when you have tables where the data is connected between tables somehow, this is known as a relationship. We are going to get into all the boring details of relationships, but we'll save that for another video. For now, just know that our data can be connected using relationships. Now, the way you structure these tables, well, generally a table describes one thing, and it's going to store multiple of those one things. So for example, users or vehicles. But you never combine multiple things in one table. For example, putting the users and the vehicles in one table, you just don't do that. You'll understand why later, but for now just understand that every single table describes one individual kind of thing. So we'll see that more as we zoom in on a specific table. Well, let's say we zoom in right here, and I'll bring that down here. Well, we might be looking at this table right here, and we'll say this is the users table. Inside of this table, we're going to have columns. So the columns go this way. And generally, we're going to have a column header, the name of the column. So for example, we can have the user ID. And now, every single entry in this table is going to be a new user. So we can have one, some data, and so forth. That is one specific user. And then we can have another user. These that go this way are called rows. I don't really know what this zooming illustration's helping with, but I just like to visualize zooming deeper and deeper into the structure of our database. When we zoom into this column, I'll make it extra big. Well, this is going to have a data type. A data type is just a type of data, as you could probably figure out from the name. Essentially, there are restrictions on what kind of data we allow in this column. So there are different categories of data types that we are going to discuss in this video. There are a lot of data types, and it's important you don't spend years and years studying the data types before you really understand databases in general. So what I recommend is you learn the basics of data types, then learn all the other things with databases, and then come back and learn all the details with the data types. The very first thing you're going to want to start with is the data type categories. So these are the general categories for data types. This is pretty universal, so any kind of relational database is going to have data types in these categories. So when we talk about numeric, that means anything dealing with numbers. Strings, on the other hand, are characters, you know, like things you type on the keyboard, spaces, tabs, all that good stuff. And generally you represent these using quotes, either a single quote or a double quote. Generally for databases we use a single quote, so I could say something like this. This is an example of a string. Temporal, this deals with dates and times. Once you got these categories down, there are some very specific data types that go in these categories that you should know. I'll be explaining some of the data types we'll be using in the upcoming videos. That way when it comes up, I don't have to spend a lot of time explaining what everything means. The very first data type that I would like to share with you is called int. So int is short for integer. Anytime we're dealing with integers, we are talking about whole numbers. So like 16. If you had 16.07, for example, that's not a whole number because you have a fractional part. So this is not an integer. This, though, is. So integer, whole number. The next is char and varchar. These deal with strings. There is a minor difference between char and varchar in that if you're dealing with a char column, all of the data for that column is going to be of the same length. So for example, 5 characters. Varchar, on the other hand, is designed to store variable length character data. So just think variable character. So that might be, you know, a comment or something that's not always going to be the same length. The next is Boolean, or Boolean. This is designed to store something in 2 states. So usually this represents true or false. But you can interpret it how you want. On, off, yes, no, high, low, strong, weak, however you like, as long as it has 2 states. The next data types are date, time, and timestamp. These are the temporal data types. Date just stores a date. Temporal data types, history or in the future. Time will store a specific time of some day. It doesn't actually store the date part, so the date is irrelevant for this data type. Or you can have kind of like a combination of both in what's called a timestamp. So this is kind of just like an instant in time, past, present, or future. That is a general overview of data structure and how we are going to approach the next videos. Now that you have this under your belt, you will understand what it means when you have what's called a fully qualified name. So a fully qualified name looks like this. Schema.tablename. Now this obviously is an example, so it's general, but this is going to be some table name such as users, and then this is going to be whatever schema that table is a part of. This allows us to be very specific about what table we're talking about. That way the database knows what schema we're in. So once again, this is called a qualified name. And in computer science, or maybe in real life, I don't know, when you qualify something, you basically prefix it with some more information so you know what we're talking about. So if you didn't qualify this table, it would just be users. But if you qualified it, you'd put schema.users. That's all I got for you guys, so thanks for watching. Be sure to check out the blog for this video, give DB2 a try, check out my website, subscribe, and as always, have a great day. Actually, I think that's the first time I've ever said that. I don't know. Well, in these videos, not ever. Okay, I'll see you in the next video. Please be sure to subscribe, and yeah, that's all. Welcome back, it's Caleb from Caleb the Video Maker 2. This video is going to be a pretty simple video on how to create tables and drop tables. So when we're talking about deleting tables, we use the keyword drop, not delete. So they are both keywords in SQL, so you gotta make sure you understand the difference. Drop is part of the structure, so if you drop a table, you are getting rid of it from the structure. Delete, on the other hand, is used for data, and that's to delete data from a table. Just a little tip there so you understand the difference. So we are going to start with creating a table. Now because we're just starting and we don't have a lot of SQL skills under our belt, I'm going to paste a little script in here and then just explain it rather than type everything from scratch. So here's an example of how you create a table. We are creating a table called users, and this syntax is very simple. You just say create table and then the name of the table, and then inside of parentheses is all of the columns that you're going to put in the table. Then you end the statement with a semicolon. This allows you to go put more statements after this statement. Each one of these here is a column. And the syntax is the name of the column followed by the data type, which is just what kind of data we want to store in that column. Overall, the statement is pretty simple, so if you're having any issues, I think over time you'll just kind of get used to the way we write SQL. Once you have the statement finished, you can hold Control and press S, even on a Mac. And okay, we have an issue. Let's figure out what it is. I bet you it's because I already created this table at one point. So I will give you a sneak peek and show you how to drop tables. Just like that. All right, I ran that and you can see it worked. Now let's go back and create this table. And you can see that worked. If you ever do have an error, you can click this little arrow. And let me just expand this a bit so you can see. You can click this little log button, and that's going to give you some more information where you can learn about this error, and that will open a web browser.
When it loads, it's going to open the IBM DB2 docs, specifically for Linux, Unix, and Windows. You gotta be careful when you open any document pages on the internet to make sure you're on the right version of DB2. So let's go back and let's just learn a little bit more. The first thing is that SQL is not space sensitive. The more technical term is it's not white space sensitive. So white spaces include tabs, spaces, and enters. So you can structure this however you like and it's going to work just the same. So just to show you this, I'll drop the table, then I'll rerun this create table statement with all the extra white space, and you can see it still runs. Now there's obviously some rules to this. You can't split keywords like this, and anytime you're dealing with something like a string, any extra spaces in here are going to be part of that string. So it doesn't always work that way, it just depends on the context. If you are writing SQL and you're not dealing with splitting words or strings, then everything should be fine and you can structure it however you like. So if you prefer everything to be on one line, go right ahead. As a sneak peek towards the future, when we start talking about primary keys, you're often going to have one column designated as the primary key. And that is a special column that is always going to be unique and determines how the table is stored. So if you make this ID column the primary key, when you go and get the data from the table, it's going to be sorted by the ID. So to make something the primary key, it's really super easy. You just add in here primary key. Now there is one other thing you need to do, and that is label it as not null. So that means you're not allowed to have nulls. Nulls are the absence of values. So when we say not null, we're literally just saying every single row has to have a value. So let me drop this table and recreate it with the primary key. There we go. So now if we go to administer and then tables, we should be able to find our user table. There you go, and you can see it's part of the DB2 inst1 schema. So I didn't specify a schema, so it just defaulted to DB2 inst1. If I wanted to specify a schema, I would just prefix my table with a name of a schema. So let's go to the users, and then we can go to columns. We can see all of the columns and their data types. We can also look at the data, and you can see that there's nothing in here. So yeah guys, that is your introduction on creating and dropping tables. Hopefully that was helpful, and in the next video we'll be doing something else that will also be extremely exciting. So be sure to check that out, and thank you for watching. And be sure to subscribe. Check the description for any notes or links or anything cool like that. Welcome back everyone. This video we are going to be discussing inserting data into a DB2 database. So we created this table, and I just left it there so you can see the structure of how we created it, just in case you jumped in the middle of the series and you need to create the table. Just run this SQL and you should be up to speed. So when we insert data into a table, it's very important that we know the table structure. So there's two real ways you can do that. You can go to the table in here, and you can find it in the table explorer, users, and then go to either columns here or going to data here and seeing the names of the columns. And this will also tell you the data type, so you know what kind of data to put into the column. So let's go back to SQL and I'll teach you the other way. Select star from users. And just so you guys are aware of the capitalization standards, anytime we have keywords, they're in all capital letters. So create, table, varchar, all of those are capital. Anytime we're referring to something we created, we use lowercase letters, users. Now let's run this, and this is going to select every column from the users table. You can go down here and click results set, and you can see the columns right here. This is a little bit more handy if you do not have Data Server Manager to help you find the columns. This will help you do it in code. So once you have that table structure, we can coordinate our data that we're inserting into the table with those columns. So to insert data, what we do is we use an insert statement. So let me just get some extra space here. And the way you do this is insert into, and then you say the table name, so users. Then on the next line, I usually go to the next line, but you don't have to. Values, and then parentheses. This is the general structure. Inside of these parentheses is where the data is going to go, and it has to match this structure. So the very first thing is going to be the user ID, and it's a number, so we don't quote it or anything. The next thing is going to be the first name, Caleb, and we separate all of these data pieces by commas. Then curry, and we'll go with caleb@email.com. is verified. This is going to be a Boolean, which is just true or false in this case. So, comma, and then we can actually get a timestamp value very easily by using the keyword current timestamp. And then lastly, I'm going to put a semicolon at the end of our statement, and let's run it by holding Control and pressing S. And you can see it worked. Now if we go back up and run this select statement again, boom, there you go, there's our data. I'm not quite done though, I want to do a couple more insert statements, so let's go back down here. The next thing I wanted to show you is that you can explicitly say what columns you're inserting into. And you'll see why that's useful in just a minute. So what you do is say insert into users, and then in parentheses what you do is you type the column names. And then you do the values again and you put data. And then a semicolon. And now let's run this, make sure it works. And you can see the insert did work. So the reason this is useful is because you can actually rearrange the columns now to say exactly how you want to insert the data. The end result is the same, but this might be for personal preference if you want to rearrange the columns. So to show this, we're going to do a third insert statement, but we're going to change the order of the columns. Just to make this easy, I'm going to take all of these columns and I'm going to paste them right here, but now I'm going to rearrange them. I'm going to take these last two columns and I'm going to paste those right here. All right, let me just clean up a little bit. There we go. Now we can insert our values according to that column structure. So we could say, so 3, true, current timestamp, Leah Smith, and then Leah, and then we'll give her an email, leah@email.com. Put the semicolon, and now we run this, and it worked. So you can see how versatile this is. We can do it just like we like. Another great reason for having the columns explicitly typed out like that is because sometimes you don't want to insert data into all of the columns. So I'll show you an example of that now. Let's just say we want to put the user ID, first name, and last name. So we'd say insert into users, and then we just say the columns that we want. And now we only have to put values for those columns, just like this. And it worked. But how does that work when it comes to viewing the data? Well, that's going to give us nulls. Nulls are the absence of values. This is how you make a comment, by the way, 2 hyphens. So expect to see that word in the future because it's very common and very popular in databases. So let's go back up to our select statement and see our data. There you go. So that is how you insert into a DB2 table. Thank you guys for watching, and I will see you in the next video. Peace, and don't forget to subscribe. Check the description for links and all that good stuff. See you in the next one. Welcome back. In this video, we are going to talk about selecting data from our DB2 tables. Now, what good is a table if you can't get the data back out that you put into it? That's why there is the select statement. So just to get some vocabulary correct, the select is an example of a statement, and the from is an example of a clause. So the clause kind of gives more information to the statement. Without this from, DB2 would have to just guess what table you're going to get your data from. And that requires mind reading, and unfortunately mind reading is only available in the enterprise editions, so you're going to have to settle with using that from clause. So the general structure is here goes the columns, and we just have a star, which in computer science this is known as a wildcard, which means basically anything. Anything goes when you have a star. The data right here is the table you are selecting from. So columns, tables. If there is any ambiguity on what table you are referring to, you can prefix it with the schema, db2inst1.users. And you can see it works just the same. Check the result set. Yeah, there you go. But now instead of using this wildcard, I want to be specific on what I want to select from this database. So to do that, it's really super easy. Just go here and delete that star, the asterisk is what it's called, and just type the column names that you want to select. And you can actually do this in any order, so I could start with the email if I wanted. And now when we view our result set, you can see it only gives us the email first name and last name. Now you look at these columns and you think, oh, that's disgusting. Who would want to look at an underscore and blah? So there's actually ways you can change the way that these columns present themselves. And that's with what is known as an alias. So an alias is just a nickname for nickname. That's confusing. So we'll see that in practice and it'll make sense. So let's go up to our select statement and we're going to change the way this looks a little bit. I'm going to bring each column down on a new line so it's very easy to see. And then what you do is you use the as keyword. And then in double quotes, you say what you want it to show up as. So I'm just going to say first name. So I got rid of those nasty underscores and it's going to look really beautiful when I do my reporting. My boss is going to love me, give me a promotion, and so forth. So in conclusion, always be sure to use the as keyword. Oh, we run that and we see we got an error. And let's look. I accidentally deleted the comma after email. There we go. Beautiful. Oh, that's so delicious. Now that is how you make a good select statement. Oh, this should be a comment, by the way, which takes 2 dashes, not 1. Now the select statement is extremely powerful. Honestly, without the select statement, databases would be useless. Some people focus their entire career on just select statements. So it's a big topic, but it's extremely valuable. So that's all I got for select statements in this video. Pretty simple, but nice and to the point. So thank you for watching. Please be sure to subscribe. Check the description for any links. And also, be sure to check out the next video. Thank you, and peace out. Welcome back to Caleb the Video Maker 2. So far, you've created tables, you've inserted data, you've selected data, but how do you actually go about updating data? For example, what if this Caleb Curry here wants to change his email address? How do we go about doing that in SQL? Well, it's actually pretty simple. We use an update statement. So the syntax is easy. You just put the column name, and then generally on the next line, you say set the column name equal to some value. And let me just scroll down a little bit so we can see a little better. And here is where we type the new value for the email. So we could say new email at email.com. Now, before you run this, please be careful, okay? If you run this, there's like a 50% chance you'll get fired because this will literally update every single email address in the entire table. So you always have to do one more thing, and that is use a where clause. So now we specify which rows we want to update, and we have to do some kind of comparison. So we can do something like where email equals, oh, and also these should probably be in single quotes, and say Caleb at email.com. So what this is going to do is update the person who has the email Caleb at email.com. So let's run this and make sure it works. Put semicolon. And it ran, so now we can select everything from users. Check the results. And the email is now new email at email.com. So it worked. Great. We could use this to our advantage to fill in some of this null data. Let's say we wanted to give Dylan an email. We might write something like this. Update users, set email equal to Dylan at email.com. But how do we go about actually deciding which row? Well, he doesn't have an email, so he can't do this. So you might think, let's use his first name. So we'd say where first name equals Dylan. This will work for now, but this has a very serious problem in that in the future we might have multiple Dylans. And even if you made this where clause more complex to say, where the first name is Dylan and the last name is Johnson, well, we could have multiple Dylan Johnsons. So this is why the primary key is so essential. Instead of using this where clause for the first or last name, we can use the user ID. So what we could say is where user ID equals 4. So when we're doing an update statement and we're just doing it on one row, we always want to use the primary key or a unique column. So we can be very specific about what row we're trying to update. Let's run this, make sure it works. Okay, it ran successfully. Now let's select from the table. And now Dylan has an email. Awesome, Dylan. Now you fit in. How does it feel? And that is a general summary of the update statement. I know it's super simple, but that's always a great thing, right? So one thing I wanted to mention to you is the term data manipulation language. And that is what we've been focusing on these last couple videos with the insert, select, and update. But there is one more piece that we need to cover, and that is the delete. This is how we get rid of data inside of a table. That's what we're going to be talking about in the next video. So thank you guys. Be sure to subscribe, check the description, click like, all that good stuff. Thank you, and I'll see you in the next video. Peace! Welcome back to Caleb the Video Maker 2. This video we are going to be talking about one of my favorite things, deleting data. I don't know why, but I always get this satisfaction when I delete a bunch of stuff. So I'm going to express that satisfaction in excitement to teach you guys how to delete stuff. So it's very simple. All you do is say delete from, and then say the table, users, and then what we do is use the where clause immediately, and we make some kind of condition to decide what rows we want to delete. Now, just like I mentioned, you're likely to get fired using the update statement. Well, you're doubly like to get fired with the delete statement, so be extra super careful. Here, we want to make sure it's something that's going to only delete what we want to delete and not delete everything. So if you just do this, well then, I hope you enjoyed your job. So we need to make sure we have that where clause. So who do you want to delete? Yeah. He has some null data, and that bothers me, so I'm going to delete you, Dylan. I'm going to delete you. So we'll just say user ID equals 4. It ran successfully, so my thought is that he is deleted. So I'm going to run this statement up here to select the data. And you can see, he is gone. That's what you get for having nulls in my beautiful null-free table. You ruined it. Okay, let's do some other stuff. Let's make a where clause that's a little bit more complex. So let's insert some data, and this is going to teach you guys something new. You can actually insert multiple rows at one time using this syntax. So let's insert that data. Just to make sure it's in there, we will select from the table. All right, there we go. And what I want to do is delete everybody who does not have a verified email. So we say delete from users, where, and then we say is verified equals false. And you can see it ran successfully. Let's run the select statement just to make sure they got deleted. And they're gone. Please be extremely careful for this. There is no undo button. So you gotta be very cautious. Now, if you remember what I mentioned in the previous video with this here, the data manipulation language, we have covered the big 4 pieces of data manipulation language. So now you're basically a database pro. Go apply for tons of database jobs. But if they ask you why you don't really know that much, don't tell them it was because you watched my videos. This is literally just the basics. There's so much more, but this will get your feet wet, get you started, and now you kind of have a little bit of experience with all of the pieces. Now we're going to go back into some conceptual stuff for a while, because now we know how to create tables, but we want to make sure we create tables in the proper way. So we're going to get into database design, which is a pretty general topic. It applies to most database management systems. So once you learn it, you can apply it to all the other database systems out there that are relational. So yeah, guys, that's all I got for you right now. Thanks for watching. Hopefully you enjoyed it. Be sure to subscribe, click like, check the links in the description, and I'll see you in the next video. Peace out.
Welcome back to your DB2 tutorial series. Now this video is going to begin our discussion on database design. Now those of you who have been subscribed for a while, you know I love database design and relationships. So dating advice 101, here we go. The very first thing when we're talking about relationships is what in the world is a relationship? Why do we want to learn about it if we don't really understand what it is? I think a lot of people forget that part. They just start explaining the different types of relationships, but they don't really explain why or what for or anything like that. So let's just take a step back and learn a little bit more detail before we go in and start explaining things. One word that is essential to know when it comes to databases is entity. An entity is just a thing. Now, when we store something in a database, it's called an entity. But the thing is we store about that thing, like, you know, the attributes of that thing, those are called attributes. So the attribute describes the entity. And in fact, we can have multiple attributes describing one entity. This is obviously very general, using entity and attribute and all kinds of fancy words, but essentially what you need to know is that sometimes we are going to be storing something as the object, and other times we're going to be storing things as something describing the object. Trust me, that'll make more sense. Just give me a minute. So a relationship is when some piece of data depends on another piece of data. So in this situation, if we're trying to store some data about something, you can say this data depends on the entity. If you wanted to make this, you know, a little bit more concrete, we could have a user, and one of his attributes could be his username or his email. These obviously describe the user. The email that we're talking about depends on what user we're talking about. The username depends on what user we're talking about. So that kind of breaks down the whole dependency thing inside of databases. Now, what is a relationship? Well, a relationship is just describing different ways we can structure these dependencies. So the three types of relationships are one-to-one, one-to-many, and many-to-many. The first type of relationship is just a one-to-one relationship, and it's actually very easy. The other two get a little bit more complex because then we're talking about relationships between tables. So for example, if we have a users table, and let's say these users can post comments on some kind of shopping website or something, well then we might have a comments table. Well, we need a way to associate who posted the comment, and that is where the relationship comes in. That is a more advanced relationship, and that's what we'll be talking about in the next two videos. But let's start now with just the one-to-one relationship. So yeah, I'm using the technical words like one-to-one without really explaining what that means. But I'm going to explain that now, and then when we talk about one-to-many and many-to-many, you already have that foundation and it'll make a lot more sense. Okay, seriously, this is like super easy. You might even be disappointed. A one-to-one relationship is literally just an attribute describing some entity. So in the example we had earlier, we had a user and an email. That's a perfect example. This email depends on the user. So let's just make this a little bit more concrete by giving it an actual user. And let's just say his email is caleb@email.com. The term one-to-one comes up because we have one attribute describing one entity. This one entity is being described specifically in email terms by only one email. So in a one-to-one relationship, you can only have one email for one user. That means if we have another user over here, it would not follow one-to-one rules if this girl also shared this email. That is not allowed. Additionally, we cannot have Caleb have two emails. This would be illegal in a one-to-one relationship. And you might think, well, hey, what if I want my users to be able to have multiple emails? Well, that is actually what the one-to-many and also going further, the many-to-many relationships are for. A lot of this just depends on how you want to structure your database. Sometimes it's a yes, no, black, white kind of thing. Other times it's a gray area where the database designer or the customer who's giving you the rules makes the decisions. So for example, you could design your database as a one-to-one with this, where a user can only have one email and that email can only be used by one user, or you could have it a different way where a user can have two emails or three emails or unlimited emails and so forth. Once you understand how to design the different relationships, it allows you to decide how to structure your database. And actually later on when we start talking about something called database normalization, well, a lot of this relationship stuff is foundational to that normalization, and if you get the relationships right, the problems with the normalization goes away. Now, if you haven't studied normalization, that's totally fine. Don't worry about it. We'll get to that soon. But you might be reviewing and you might have already had some experience with normalization, so I'm just giving you that as, little teaser. So if we want to design a one-to-one relationship, meaning that this is illegal and this person cannot share an email, as you set up a table and you put the attribute as one column in this table. So now that we have the table, we can put a row in this table to describe this specific entity. And that is how you design a one-to-one relationship. Now once you get into some more of the advanced database design, you can tinker with the uniqueness of this column. So for example, if you wanted to allow another person to share an email, well then you could do it that way, or you can make it to where all the emails have to be unique. All of those things are things you can customize. So don't freak out about all of the details right now. What's important is that you get the general structure. And when I say one-to-one, you should think of one table with a column. That means this here is also a one-to-one relationship. So the first name depends on the user, the last name depends on the user, and the email depends on the user. As I mentioned with the more advanced stuff, well, even though a first name might be repeated a couple times, in general, you think of a name as describing one person, so you don't have to be like super anal with everything. It would be totally okay to have some repeating data here, because if I have another Caleb with, a different last name, well, this is describing a different person. So this Caleb is like a different Caleb. But we're getting into some detail that is, way beyond 101 database design. So don't worry about all that for right now. The most important thing is understand entity attribute. Boom, there you go. Now, in the next video, we're going to be talking about the one-to-many relationship, and that gets a little bit more complex, but that's going to be a lot of fun, so I'm excited. Be sure to check it out and be sure to subscribe. Check out the description where I'm going to have a lot of useful links, including a link to a blog post that describes this with some beautiful illustrations and all kinds of cool stuff. So check it out, be sure to subscribe, and I will see you in the next video. Peace. Welcome back to your DB2 tutorial series. This video we are going to be talking about one-to-many relationships. This video and a lot of the upcoming videos are general database design concepts and just database concepts in general, not necessarily relating to design. And all of these things are important when you're working with a database system. Fortunately, this information is very universal, so once you learn it with a DB2 database, you can apply it to any other database system out there that is relational. That being said, I am trying to teach these concepts in the context of a DB2 database. So some of the specific details might vary a little bit from database to database. The overall concepts are very universal. So as we go through these videos, even though we might not be talking specifically how to do something in DB2, all of this is extremely foundational for successfully working with a DB2 database. So let's get started with one-to-many relationships. As a review from the previous video, a one-to-one relationship is a relationship between an entity and an attribute. Well now, in a one-to-many relationship, we're having relationships between multiple entities. Generally, this is going to be structured in a way that there is a parent. In this situation, we have a parent entity that's going to be referenced by multiple child entities. This is the structure of a one-to-many relationship. And the reason it's one-to-many is because there is one entity up here and potentially many entities down here. There are some restrictions when it comes to one-to-many relationships. So this entity could not reference another parent. This would be illegal and just can't happen. So that'll make a little bit more sense once we go into a little bit more detail, but just for now know that a one-to-many relationship is many entities referencing one entity. So let's say we have a premium website where you can buy these memberships. And generally when you go to a membership website, they're going to have 3 tiers. One that's really super cheap but has like no features. One in the middle where you get a little bit of everything, and that's usually the most popular. And then you got like the premium one that costs a whole lot. Well, let's kind of mimic that and see how we would design that as a one-to-many relationship. You see, there are 3 different options when it comes to the membership, and this user gets to choose one. So let's say he picks bronze. Well, this other user, she might pick gold. The important thing to realize though is that one user can't pick multiple membership levels, and 2 different users could, if they wanted, reference the same membership level. So in this situation we have a one-to-many relationship. That's because we have one entity over here, which would be the parent, and then 2 children entities that are going to reference that parent. How do we actually structure this in a database? Well, this is where primary and foreign keys come in. The parent is going to have a primary key, and let's just say that value is 1. Well, each one of these children are going to reference that primary key using a foreign key. So the value of that foreign key is going to be 1. And that makes that association between this one and this one over here. And that's how you kind of connect things. If we wanted to structure this in tables, it would look something like this. Every single table has a primary key, which forces every single row to be unique. So these are the columns. So if you were to actually look at data, it would be structured like this, where the columns are here. But for simplicity, we kind of design it where the columns are one after the other, and this is generally known as an entity relationship diagram, and it just allows us to structure the columns of our tables. So the user table is going to have a primary key, and the membership table is going to have a primary key. This here is a foreign key that references this primary key. And essentially what that means is every single value for this membership ID column has to be a value from this column over here. The membership rows would look something like this, where we have the ID and we have the value of whatever that ID is. Then over here you would have one user with a membership ID. So the user with the ID of 1 references the bronze. Or you could have a user with the ID of 2 reference gold. And it's impossible to put something like a 4, because you see this value here has nowhere to reference. So that would not be allowed to be put into the database. And that's the benefit of having foreign keys, is that they add those restrictions. That's all I got for you for one-to-many relationships. In the next video, we are going to be talking about many-to-many relationships. And that's actually a problem in databases because it's not very easy to design a many-to-many relationship. But I'm going to be teaching you the trick, so that way you know what to do. So thanks for watching, guys. Please be sure to subscribe. Check out the links for some important links. Check out the description for some important links. Thank you, and I will see you in the next video. Peace. Welcome back. It's your many-to-many tutorial series for DB2. Now, like I said in the previous video, a lot of this concept stuff is generalized, so there's not a whole lot of DB2 specific things in here, but it's just good to learn it in the context of some database system. So let's get started with many-to-many relationships inside of DB2. The previous two videos talked about one-to-one relationships and one-to-many relationships, and those are easy, okay? Many-to-many relationships is where things get complicated. Unfortunately, it's one of the most common relationships you're going to find when you analyze the real world and the data that you're going to need to store in a database, so you need to get familiar with how you do it. In the end, you're going to have 3 tables. So if you think back to one-to-one, we had 1 table. In a one-to-many, we had 2 tables. In a many-to-many, we have 3 tables. The reason that is because when you have a many-to-many, what we're going to do is break that up into 2 one-to-manys. And if you remember from the previous video, one-to-many uses 2 tables. So how does this add up exactly? I said a many-to-many is 3 tables, but we're going to break it into 2 one-to-many tables. It seems like 4 if you ask me, but the reality is one of these tables is going to be shared. So it's going to be sort of like this. One of the 2 tables over here, and then the other one in the middle, and one for over here. So I know that's kind of confusing, so just ignore that. I'm going to draw this out and it's going to make a whole lot of sense. To illustrate a many-to-many relationship, I am going to give you a completely made-up example. Let's say we're working with that website and you have users. This is one of them websites where you can put your interests in and it changes the content accordingly. So what that means is the database needs a way to keep track of what stuff people are interested in. So there might be some categories out there like technology, science, art, and so forth that people can choose from this list of categories and receive content related to those things. So to start, we're going to have a user table. This will have a user ID. And now the question is, do we store the interest in here? Well, no, you don't. And here's the reason why. If we store the interest in here as a column, well, what if you had multiple interests? You'd have to store them as comma-separated values or some other weird hack, which is not going to work well, because then it's not easy to say, oh, give me all of the users interested in technology, because when you get their interest, it's just a huge list of a bunch of interests. So you need to break that off into another table. So let's go over here and make an interests table. So this is going to have an interest ID and then the actual interest value. So now, did this really fix anything? Because now we can go in here and say, oh, let's say we have an interest ID. This is still going to be a problem because you can only put 1 interest ID in there if it's a foreign key. Or if you make it to where you can put multiple, it's still going to be a comma-separated value. So you'd have like, oh, I'm interested in 1, 2, 5, and 7. But that's not super helpful because you still have the same exact problem as just listing them out by name. So how do we get around this problem? Well, this is where the third table comes in. We're actually going to make a table that goes in between these two, and this is known as the intermediary table. This is going to have at least 2 columns, and these columns are going to represent the parent. So we have 2 parents here, and that is going to be the one side of a one-to-many relationship. This is what I meant earlier when I said there's going to be a shared table. The parent is going to be 2 parents in 1 table. And the way we're going to name this is we're going to take whatever table this is, and let's say we're going to make it singular. So it would be user underscore and then interests plural. And what this table is going to do is just list all of the associations between certain users and certain interests. The reason this works is because we can have one user in this column as many times as we want. So this is going to be the user ID column. And let's just kind of list these out the normal way as both of these have them. We'd have a user ID, and then we'd have an interest ID. The user ID can be repeated as many times as you want, and the interest ID can be repeated as many times as you want. So essentially we have it where we have users and interests. We can have it to where one user has multiple interests and a specific interest has multiple users interested in it. Let's just look at what this might look like inside of this table. We might have it where user 1 is interested in interest number 1. User 1 is interested in the interest number 2. User 2 is interested in interest number 1, and user 2 is interested in interest number 2. So if you want to see this a little bit more clearly, we could say this is this guy over here, and this is this gal over here, and we have 2 interests over here. So this 1 is going to reference the science, and the 2 is going to reference the art. This kind of shows the many-to-many relationship, and this is the proper way to structure it. Well, that's kind of a general overview of the one-to-one, one-to-many, and many-to-many relationships. If you have any questions at all, please leave them in the comments below. Please be sure to subscribe, check out the description for some useful links, and as always, subscribe, and I'll see you in the next video. Peace. What's happening? This is where we start talking about database normalization. Now, when it comes to database normalization, you have to understand that there is a continuum. So a continuum is basically an entire range of possible values, I guess. Over here we have undesigned, and then over here we have completely designed. So when we're talking about databases, you need to realize that there is a happy medium in here that you try to go for. Generally, when you get over here to completely designed, your database is extremely complex. But if you go over here to undesigned, well, then your database is a giant piece of garbage. So a lot of the stuff we're going to be talking about in the next 3 videos is up to you to decide how far we want to take this. So we design our databases in these stages called normal forms. And if we were to put these normal forms on this continuum, you would have first normal form, second normal form, third normal form, and then there's some extra normal forms down here which make the complexity a lot higher. So generally I like to stop here at third normal form. I think that's like the perfect place to stop, where your database is not too complex, but it's also extremely well designed to avoid bad data. So that's what we're going to be doing in the next couple videos. First normal form, second normal form, and third normal form. Now I know I've been blabbering about these normal forms and I haven't really even explained them that well. So let's just start from the beginning with first normal form. What is first normal form? Well, it's the very first step of database design. Now, make sure you watch the relationship videos and the previous videos because the normal forms kind of build upon that, and a lot of the problems with these normal forms are basically automatically fixed when you design your relationships properly. Not everything is going to be perfect, but if you get the relationships down, doing the normal forms is a lot easier. So let's get started. First normal form has some rules that we need to follow. The first rule is that every column in a table describes only one thing. The next thing is that every value for that column contains only one piece of data. So if we had a column interests, this is like a dead giveaway because it's plural. So this does not meet rule 1. So rule number 1, columns describe one thing. This is breaking that rule. So let's say we try to fix that and we just make it interest. So now we have this table, and one of the columns in here is interest. So we have a users table and we're only allowed one interest here. Well, let's say someone, goes in there and inserts multiple interests for one single column, just like that. Well, this is actually breaking rule 2. So rule 2 essentially says there can only be one value per row for that column. And an additional rule is that you should only have one row per entity. So this refers to one specific user. So essentially, if you wanted to encapsulate everything for first normal form, you would say it follows the rule of 1. So columns describe one thing. There's one value per row for that column, and every single row describes only one entity. if you find that you want to store multiple interests or something in here, well, that's where I said the relationships are going to help you because you'll understand how to structure that. A more common example that breaks first normal form is having a column name. So name, is that one thing? Well, the other term for being one thing is atomic. So think indivisible, because you know, atoms can't be split, right? Okay, so this is really broken up into two things. We have the first name and the last name. This is an example that you might want to split up into two columns, or three if you want the middle. Some people decide, hey, I'm just going to put it in one column and we can't query by last name. But if you break it up into first and last name, you can do queries saying like, select everything from the users where the user's last name is blah blah. That kind of thing is harder to do if you store the first and last name inside of one column. Another common example is the address. So the address is actually not atomic. If you think of what an address is, it's usually a street or a street number, a state, and then a zip code. Well, if you wanted to get all of the data within a certain zip code range, it wouldn't be easy to do if you just stored one column address. So you always want to try and break things up into the smallest pieces as possible. This follows the first rule that I mentioned of first normal form, where a column describes only one thing: a street address, a state, and a zip code. Pretty good. If you want to extend that rule of one thing a little bit more to make your database really good, well, then just apply it to some other things. A table should describe only one thing, or one type of thing would be a better word. So users. The table is kind of the exception. Usually I make tables plural. And it's controversial, but I like to have them plural. So we are describing one thing, the user. Then every single row is unique, describing only one user. You can kind of enforce that by having a primary key. So a primary key is just a unique value for every single row. Well, that means every value of the primary key is only used one time. Additionally, you're only going to have one primary key column. That one primary key value describes exclusively one entity. So if you tried to put one entity in the table twice, that's not something you want to do. You just don't do that. Okay, stop. Don't do it. One entity gets only one primary key, and a primary key describes only one entity. So yeah, guys, that's first normal form. Pretty super easy, I know, but that's okay. We're gonna go on to second normal form in the next video, and that's gonna amp up the difficulty. So put on your big boy pants because we're just gonna dive in and have some fun. So thank you for watching. Please be sure to subscribe and check out the description for any useful links, and I will see you in the next video. Welcome back to your DB2 tutorial series. A couple of videos ago, I discussed many-to-many relationships and how they need an intermediary table. The example I gave was users listing things they were interested in. So we had a table like this. And these are both foreign keys referencing another table. And you're probably wondering why I'm going all over this. Well, this is where you're going to run into second normal form problems. It's when you have something known as a composite primary key. Now, a composite primary key, the word composite is just a fancy word for humans to use, but the database doesn't actually use that word. So just know that when I say composite, that's not a keyword, okay? It's just a word to describe the type of primary key. And that type of primary key is the combination of multiple primary keys, or just columns. So, for example, we can make the combination of these be the primary key. And the way that works is that the user ID, it can have repeating values all at once. Because you know, primary keys, you're not supposed to have repeating values, but this here is actually a foreign key. And foreign keys allow repeating values because you can have multiple references to the same primary key. And this down here is a foreign key as well. So we could have multiple interest ID in the table. The trick though is that you have to keep the combination of a user ID and the interest ID unique. So if we write out this data, we might have a 1 and a 1, 1, 2, 2, 1, 2, 2, for example. So these both reference one entity, these both reference one entity, these both reference one entity, and these both reference one entity. So there's repeating data in both columns, but the thing is, the combination is never repeated. Once we have 1, 1, you can't repeat that. Once you have 1, 2, you can't repeat that. So that is how a composite primary key works. And when you define a composite primary key in DB2, you're going to put that at the bottom of your create table statement as if it was another column, but it's not. So it would look like this. This comma here is telling DB2 that we're going to have 2 columns in our primary key. This has to be done at the table level. So that means you're going to have your other columns up here. We haven't done a ton of SQL in these videos, but I did put a lot of examples on my website, so make sure you check that out. The link is going to be in the description, and it'll update continually, so if you go there and you're finding not a ton of content, well, always check back regularly because I'm always updating it with new content. Alright, I'm getting a little off topic though. We're talking about second normal form. Second normal form deals with something called partial dependencies. If you think back to the one-to-one relationships video and the other relationships videos, we talked about attributes depending on an entity. They describe an entity. Well, the same thing comes up here when we're talking about partial dependencies. We're talking about things describing the primary key, but only part of the primary key. So if that doesn't make any sense at all, that's okay. Essentially, imagine we have another column in here, but that column only really describes the interest section and not the user ID. It only describes part of that primary key. So let's say these interests have categories. We could say in here, interest category. And when we do this, we introduce a partial dependency in our database. Because if you think about this, the user really doesn't matter at all in this situation. Let's say we go in here and change the interest now from C++ programming to acrylic painting, for example. Well, the interest category might change from computer science to art. So there's definitely a dependency on this interest ID, but not the user ID. How do you fix this though? We've recognized we have a partial dependency. The way we fix it is that we break off into another table. If we don't already have one, in this situation we probably do, and that's going to be the interest table. This category here needs to be moved into this table. And just get that out of the middle table. You don't need that here in the intermediary table. It doesn't belong. So we fixed our problem here. Now this interest is going to have a category, which, you know, that could be referenced from another table, like a category table if we really wanted. So what kind of columns can we put in this table legally? Only columns that depend on both of the primary key pieces. So for example, if you recorded when this association between a user and an interest was started. So for example, you join the website, 2 weeks later, you say, hey, I'm interested in computer science. Well, then it puts a timestamp saying, oh, this guy became interested in computer science at this time. Well, that's actually relevant to both the user and the interest because it's recording when a user became interested in something. So anytime you have something that relates to both of these and wouldn't really make sense in the user table and wouldn't really make sense in the interest table, you can put it in here as a column inside of the intermediary table between the many-to-many relationship. So I know this is kind of super complex. Second normal form is one of the hardest normal forms, especially because it really doesn't come up a whole lot, only when you have many-to-many relationships and you're dealing with storing things in the intermediary table. If you want to be on the safe side, just try not to design your tables to where you have extra columns in an intermediary table. And there, you don't have a problem anymore. But then that means you can't store anything about this primary key. So, you know, you gotta balance. Once you figure it out, then you can go in here, put columns in here, and make sure that your data is structured correctly. So thanks guys. If you have any questions, please leave a comment and be sure to check out the description. I have links for downloading DB2 and checking out my website. DB2 has been a good database to me, so I would encourage you to try it out and apply what I'm talking about here to your database in DB2. Thanks guys, and I'll see you in the next video. Peace out. Welcome back to your DB2 tutorial series. This is Caleb from Caleb the Video Maker 2. This video is going to be over third normal form. So this is the last normal form I have enough energy to care about, so we're going to stop after this one and move on to something else. Once you get beyond third normal form, it's almost like nitpicking, like, oh, this thing's basically good enough, but I'm going to make you change it anyways. Personal opinion, just throwing that out there. So I think third normal form is more than adequate to consider your database normalized. Alright, I'll quit wasting your time. Let's get started. what exactly is third normal form? Well, if you remember in the previous video, if you watched it, I had an intermediary table for user interest. And one of the columns that I tried to put in that table was an interest category. And then I was like, oh, this doesn't really belong here. Let's move that to the interest table. What we have is an interest table that looks something like this. So we have 3 columns, the interest ID, the actual interest value, and then the category that the interest belongs to. Like I said in the previous video, this could be a foreign key to a category table if you want to set that up. For now, you can just leave it as a varchar, for example, and just type in your category. And now let's say we add a column to this. This is a violation of third normal form. But I actually haven't even explained what third normal form is, so I should probably do that first. Third normal form deals with something called transitive dependencies. Essentially what a transitive dependency is when a column depends on the primary key, as it should in normal database design, but it does so through another column. If you think about switching a specific interest, so let's think of an interest. I'm interested in computer science. That might be in the category STEM, science, technology, engineering, and math, right? Well, if we describe that, we would say like, oh, this is a category for all things relevant to science, technology, engineering, and math, including blah, 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 just a description of whatever the category describes. And you can decide whether that description is useful or not, but for this example, assume we decided we're going to have a category description. Now, if we change the interest we're talking about to something else, like, acrylic painting, well, now we're going to be talking about art. So the category might be art. And the description would say, oh, anything relating to the creation or production of whatever, that would be the description of the category. So you can see when we change the interest, the category description also changes, because we switched from the interest from computer science to acrylic painting, and in the process the category description changed. So this category description does depend on the interest, but it does it transitively, which means through another column, like this. So when you get this hop here, you have a transitive dependency. The way you fix this is by going from the entity and going up 1 hop, and whatever this attribute is, you're going to take that and make it an entity in its own table. And now you can take this dependency right here and move it over here, and now since it'll be referring directly to the category, it's not a transitive dependency. This is just a normal dependency. But how do we fix this mess over here? What you do is you replace this with a category ID. And that is going to reference this category ID over here. So that's your foreign key reference. Then you're just going to delete this category description because it's not needed in this interest table. And this makes sense. We don't want to have this in here because we're going to have the category description in here for every single interest. That doesn't make sense. We really only need the category description one time, once for each category. So that is how you fix third normal form and get rid of transitive dependencies. If you have a chain where you don't just have 3 dependencies, but you have 4 or 5, just follow that process through all of them. You start with just going up 1 dependency, breaking that off into a new table, and then move all the other dependencies that are connected to that into that table. And then you just repeat the process. Go to the next dependency, move that into a new table, and so forth. So yeah, there you go guys, that's first normal form, second normal form, and third normal form. So thank you for watching. If you've enjoyed these videos, please click like, subscribe, check out the description for some links, go give DB2 a try. I'm out of things to say, so I will see you in the next video. Peace. Welcome back everyone to your DB2 tutorial series. Now so far we have covered a lot of information when it comes to database design. I know some of you guys think I go into way too much detail when it comes to database design, but personally I think it is foundational to everything we do with a relational database. Because of that, I got a couple more videos for you on database design. Just the relationships and the normal forms are not enough. So these upcoming videos are going to teach you how to enforce certain rules on your database to have the most data integrity. So that brings up a term for you guys, data integrity. If you say somebody has integrity, you think of that person as an honest person. they're consistent. You know who they are, they don't act differently in different situations. Well, the same kind of thing can apply with data. So if we're talking about data having integrity, you can trust the data to be accurate. You're not going to have any kind of inconsistencies throughout your database. Essentially, with data integrity, you can just assure yourself that the data you're working with is the most up-to-date, it's correct, and it's trustworthy. This is an overarching term for a couple different types of data integrity. So that's what we're going to be talking about in the next 3 videos. And this one is the first one. So the very first type of integrity is entity integrity. A lot of this is going to be review and pretty simple if you've watched the rest of the series, so don't expect something that's completely breathtaking. But I am going to give you some extra tips just to make sure you truly understand the concepts and what you should do to your database to ensure your database is up to standards. So first off, let me show you a bad example of a database table. Here is an example table for users. Let's throw some data in here. Let's say we have an Amy. We'll give her the last name White. And we'll say her email is amy@email.com. Now let's say we have another row here. And this is another Amy White with her email amywhite@email.com. And this brings up the interesting question, is this the same Amy with 2 emails? Or are these 2 separate Amy's? And in this situation, you can't really tell. Now when we do our database design that we've done in the last previous videos, you should know that you should never have 2 rows describing the same entity. So my heart is telling me that these are 2 separate Amy's. From this table, there's not a very good way to distinguish them, unless you can say that all these emails are unique, and Amy's not going to be going in here and making multiple emails. Generally, to enforce uniqueness, we need a primary key. Now, a primary key is just a column that has unique data in every single row. It also determines how the data is structured in your table. Often it's going to be sorted by the primary key. Now generally, I suggest just using an ID field or a column. So I'd have like a user ID and then just use generated numbers that count upwards. Alternatively, you can use what's known as a natural key, which has real world meaning, such as an email. You could make all these emails unique, meaning you could individually pick an Amy using their email. If you didn't have this user ID here or this email and you wanted to talk about a specific Amy White, you can't because there's not enough information to distinguish the Amy Whites. So you always need a primary key for the primary purpose of making sure every single row is unique in your table. Now generally, primary keys are going to follow these 3 rules. The data is going to be unique, which I just mentioned. The next thing is the data must be not null. And what that means is you can't have the absence of a value. So let's say we brought this column back and we had a 1 here, but we didn't have anything right there. You would say that this entry is null. Well, that's unacceptable for primary keys. So you can actually label a column as not null, and it will prevent you from leaving that blank. Additionally, you're probably going to want to pick data that doesn't change. With this, I generally avoid natural keys such as emails because Amy might want to go change her email, and that's just going to ruin everything. So generally, I like what's known as surrogate keys or generated keys, but if they do change, it's not the end of the world, it's just generally frowned upon. That concludes entity integrity. In conclusion, it's literally just saying we need a way to say this is an entity and this is an entity, not the same entity. You need to be able to uniquely identify each entity inside of a table. If you want a 1-sentence summary of all of that, give a table a primary key. Boom, done. You understand entity integrity. Thank you guys for watching. In the next video, we are going to be talking about referential integrity. This is one that is extremely important if you're going to be working with complex relational database systems that have multiple tables. DB2 gives you a lot of ways to protect the relationships between tables. So that's what we're going to be talking about in the next video. So catch you then. Oh, and don't forget to subscribe and check out the description for some good links. There'll be a link to download DB2 and also check out the next video. See ya. What's up, everyone? It's Caleb for Caleb the Video Maker. In this video, we're going to be talking about referential integrity. Okay, so yeah, let's just think about this. If we didn't have referential integrity, what horrible things are going to happen with our database? So you go through the database normalization, you break your tables up and all that good stuff, but then the problem is you don't go through the effort to make foreign keys, and you just hope that everyone's going to use your database correctly. Or you say, oh, well, the software is going to use the database correctly. You are setting yourself up for failure or a miserable life or death or both. Wait, that was 3 things. Okay, anyways, let's go through an example. So I gave you this example a little bit ago. Let's say you have users and you have members. Now, one specific user has the ID of 1. Now, there's 3 types of memberships. 1 is going to be bronze, 2 silver, and 3 gold. Well, this user is going to reference one of the memberships. So let's say this user puts a 4. The problem is there's no membership with that ID. So this is literally pointing to nothing. With foreign keys, this kind of thing cannot happen. And that's what referential integrity is. All of our references have integrity. When you look at this here, without any kind of references or without this membership table, you can be assured that that 4 references something. It has integrity. You get rid of a foreign key, now you got problems. And you don't want problems, so make sure you use foreign keys. Foreign keys are going to be like, no bro, you can't use a 4 because that doesn't exist over here. So that whole concept is called a referential constraint. A constraint restricts the data to certain values, specifically values that exist over here as the primary keys, if that's the column we're referencing. So if this column references here, well now we're only allowed to use 1, 2, or 3. But that's not all referential constraints do. Referential constraints also dictate what happens when you go and delete data. For example, if this here was a 3, what happens if we went and just deleted this row? Do you know what happens? What is DB2 going to say? Honestly, I have no idea what it's going to say, but I do know that it's going to not let you. I think. Anyways, the 3 cannot be deleted because we have a child referencing it. These kinds of rules can be configured when you create referential constraints. So when you make a foreign key, there are some default rules that are applied to your references. Well, you can configure those. Specifically, there's 2 kinds of referential constraints. There's on-update constraints and on-delete constraints. So when you make a foreign key, if you created this column as a foreign key, I have code examples of how to do that on my website. That is going to configure the on-update to do something and the on-delete to do something. So both of these are packaged inside of a foreign key. So it's not like you have to make a foreign key for the updating and a foreign key for the deleting. You just make one foreign key and then you can do all this stuff inside of that. So this example of deleting this 3 refers specifically to this delete. What happens when we delete? The same thing happens with an update. What happens if we change this 3 to a 4? Which generally primary keys should never change, but that's besides the point. The on-update is going to kick in then. What happens to this value over here? You see what I'm saying? For example, it could update it. That would be cascading. There are some specific options that I'm going to talk about, so let's do that now. So once again, the 2 categories were on-update and on-delete. There actually is a third one, on insert, which I actually described already, I just didn't give it a definition. So when you insert data, it verifies that there is a parent with that value. So if you remember, the user ID had to reference a membership ID. So there's on insert, on update, on delete. Now let's talk a little bit more specifically about, let's go with on delete. A lot of these things are going to apply to the other ones, so you can kind of move these around. But let's start with on delete, and it'll make a lot of sense because that one's the most easy to think about. So the first option is restrict/no action. So these are 2 separate ones. There is a minor difference that if you want to know, you can look it up, but it's over my head, so I'm just going to move on. Essentially, these do basically the same thing. If you try to delete a parent when on delete is set to restrict, it's only going to let you delete that parent if there's no child referencing it. So if you have an entity here, and it's not referenced by anything, and then you try to delete that row, it will let you. But if you have another entity down here, this would be the child, and it references this entity, well now it's not going to let you because it's saying, hey, you can't delete this entity because it's being referenced. So it would say, nope, you can't delete that row. You could delete this row though because it's not being referenced by anything. The other option is cascade. This is one of the most dangerous things of all time, so be warned. If you want to lose your job, make sure you use cascade. Essentially, with cascade, is if you delete this parent, it's going to delete any children that reference it. The problem is you don't always know everything that's being referenced by everything. So you might delete something intending just to make a minor change, and that might cascade through your database, deleting all kinds of important information, you know? The last option is set null. And what this will do is it will set this reference to null when we delete the parent. So if we have columns, you know, like let's say it's in the user table, so we have a membership ID, and let's say this value is 1 and this value is 1. Well, over in the membership table, if we deleted the row with this ID, in the user table, this would just be replaced with null. In the user table, this show up as this. Now this is okay if you allow orphaned children. So this is called an orphan row, this right here. In some situations it's appropriate to have orphaned rows, other times it's not. That's a decision that is going to be up to you, or your boss, or someone else, you know? So, make sure you're careful to understand how your tables are going to be used. Does it make sense for a user to not have a membership? Well, maybe they signed up and, you know, they got rid of their membership and they still have an account, but they just can't use any of the stuff. Well, then it would make sense to allow nulls here, and you might set it to set null when you delete. Otherwise, you might set it to restrict if you don't want orphaned rows. Now, if you don't want nulls in this ever, then you're going to want to set this foreign key as not null. And this is basically saying this child has to have a parent for that column. That's a summary for onDelete. You can apply it essentially the same way to onUpdate, but now you guys just get an overview of how the referential integrity works and different ways you can configure it. Thank you guys for watching. Hopefully that gave you a great introduction to referential integrity. The next video is going to be talking about a new type of integrity, so be sure to check that out unless you're super lame, and in that case, you should check it out anyways because you need to learn the material. So please be sure to check that out, subscribe, like the videos, and check the descriptions for some useful links to download DB2 and to check out my website. Thank you, and I'll see you in the next video. Peace out. What's up, everyone? I think this is literally the first time I've ever started a video on this side, but I don't really know why I'm telling you that. Anywho, this video is going to be over domain integrity. So the very first thing we need to discuss is, what is this fancy domain word? You know, like, is that like a web address, or what is that? Well, essentially, domain is the rules for data, what is allowed and what's not allowed. So there are numerous ways we can enforce what data is allowed in a specific column. Some of these are very general ways that are allowed in most database systems. For example, data types are a very great way to have domain integrity. So let me take a step back. If we have domain integrity, what we are saying is that our data is within the allowed values. If we do not have domain integrity, then we cannot trust our data to be in a set of different values or within a certain range of values. So the data types, these are a very general way to restrict data. So for example, you can have a numeric data type and that's going to reject string data. You can have a date data type and that's going to force every single value to be of a date format. You can get very specific on what kind of data you're looking for by using the appropriate data type. So as you get into some more database design and some more advanced database concepts, make sure you understand the data types. By having the correct data types, you can make sure your data has integrity. The other way are some general rules. You could use not null. This is an example of a constraint. That would basically force every single row to have a value for that column. You could use unique. That's going to force every single value for that column to be unique, meaning once a value is used, another row cannot use that value. Now, additionally, you can use what's known as a check constraint. So check constraints are pretty awesome and they're not available in all database systems, so I'm pretty psyched that DB2 has them. But check constraints allow us to be extremely, extremely specific on what data is allowed inside of our column. So if you want to be specific on, oh, we can only use values in this range or only these specific options, well then you might want to look into a check constraint. Now, if you are not using check constraints, there is kind of like an old-fashioned way of doing something similar to a check constraint, and that's generally called a lookup table, also known as a validation table. A classic example of this is having the states in a table and then referencing them. So if over here you have a state table, and then in this table every single row is a state that someone could live in, well then you could only allow those values using a foreign key. So this kind of goes back to the one-to-many relationships. If you decide to set it up this way, you can force a column to have a value in that state table. So over here you could have a state column, and you could say this references the state table and then the state ID column. And now every single value in this column is going to have to be a row in this state table. So that's an example of a validation table. Nothing too crazy in this video. I know it's really super short, but those are your general guidelines on how you get domain integrity. I didn't go into a ton of detail on how to do all of it, but the point is here is to teach you the basics so then you know where to look if you are trying to do something specific. If you want something more to research, definitely highly recommend the check constraints, because that's going to allow you to be very picky with what kind of data gets in your database. So thank you guys for watching. Please be sure to subscribe. Check the description for some links. I'll give you a link from my website and also to download DB2. Be sure to subscribe for upcoming content, like this video, and I'll see you in the next one. And yeah guys, that's all we got for database design, at least for now. It's been a journey, but we made it. We made it together. We made it. So thank you, and I'll see you in the next video. Which actually, I lied. The next video is going to be applying some stuff we've been talking about in the last previous videos. So after that, we're good. Welcome back everyone to Caleb the Video Maker 2. This is going to be an on-screen video just talking about some of the different constraints we can apply to tables. I'm kind of just going with it right now, so I don't really have a whole lot planned. Thus, if my examples are kind of pretty awful, I apologize ahead of time. The very first thing is I wanted to talk about some of the column level constraints. Essentially what that is, it's an attribute you apply to a column that changes what kind of data is allowed. This is referring to domain integrity. So let's just create a table, and we are going to call this table parent, and you'll see why in a minute. So the very first thing you're going to want to do when you create a table is create a primary key, which we've discussed in previous videos, but just as a refresher, you can do something like this. And then give it a data type, we'll just give it int, and then you say not null, and then primary key. So this int is a data type that restricts the type of data allowed in this column. That is the first layer of defense. Not null is another attribute we can apply that further restricts the type of data, so now we're not going to be able to insert nothing. We always have to insert a value for this column. And obviously the primary key is going to add the extra constraint of every value being unique. So this is an index, and we haven't really talked a whole lot about indexes, but indexes are an extremely important part of databases. And once you get the database design down, I'd say the next thing to learn are indexes. So when you create a primary key, you're automatically indexing this column. And what that means is that it's optimized to use this column for joins and for all kinds of different queries. Another thing you can do is just say unique. So if I run this, you can see it works, and this is going to make a unique constraint, which also is going to create an index. So let's go to the administer and then go to tables, table explorer. Going to give this a refresh, and there's our table right there. So we click that, go over here to indexes, and then there's a bunch of information about this index here. So I click that, and you can see this is a unique index. Now if I go back to the SQL, and what I'm going to do is I'm going to drop this table, and then I'm going to recreate this without that index. Now what I'm going to do is go back to my tables, go back to my table, do a refresh, and you can see there is now no indexes on that table. So when we add the unique constraint, we're actually adding an index. Very similar to adding a primary key, slightly different. The primary key actually determines the way the data is retrieved. So to see that, if we go to this table users, let's go to the data here. So here's some data we had in the previous example. Often this is going to be sorted by the user ID. What that means is if you go and select something by the ID, it's very easy for the database to find it because it can just go to that number. Rather, if you selected something by, the last name,
Well, it has to do a scan of the table. So I'm kind of getting a little bit off topic onto indexes, but they're extremely important, and essentially what I wanted you to know is that sometimes when we do a little column attribute here like unique, we're doing a little bit more than we might think. This is actually indexing our column. But I'm going to go back to primary key. Now what I want to do is create another table and teach you guys a little bit more about foreign keys. So we're going to say create table, and we'll name this one child. And in here we are going to have a child ID. So this will be int not null primary key. And we're also going to have a foreign key which references the parent. This will be of type int, and I'm going to make it nullable, which means I'm not going to use the not null keyword. And then what I do is I say references, and then I put the table name, parent, and then in parentheses, I am going to put the column name, parent ID. Run that, and you can, oh, it failed. Why did it fail? I think it might be because of the names, so I will name this parent table, and then I will name this one child table for consistency. And down here, I will change this to parent table. Okay, create that table, and then create this table. Great, haha. Okay, I got it working, sorry. So this creates a foreign key constraint. So now if we go into administer and then look at the tables, get rid of all this junk. Let's look for the child table. Give it a refresh. Child table right there. What we can do is go to the constraints, and you can see we have a primary key and a foreign key. We're also going to have an index because we created a primary key. So if we go into this foreign key, we can get a little bit more information about it. And you can see on the delete, it's no action. On the update, it's no action. Meaning you're not able to delete the parent without deleting all the children manually yourself. Now you understand a little bit more about indexes, constraints, and viewing that stuff inside of Data Server Manager. You can also go to administer and look at all your constraints here. Obviously this is not going to be nearly as helpful because you didn't give your constraints fancy cool names like the rest of these in here, which you can do that if you want. Just look up how to do that if you need. But until then, we're just not going to worry about it because I think we're doing very good. Thank you guys for watching. Hopefully you enjoyed the content, and be sure to subscribe, like the video, and peace out.